Hey everyone, it's Jose here, and welcome to the course overview lecture. I'm super excited that you're starting your journey to learn Python. I know it's sometimes tempting to just skip these intro lectures and go straight to the technical material, but I have one favor to ask of you as you go through this course, and that is to please don't skip this lecture. We're going to cover a lot of important material in this lecture, such as where to find the notebooks, how to approach the course, how to ask questions, so please watch this entire lecture. That way you can get the best course taking experience possible. All right, let's not waste any more of your time and let's get started. In this lecture, we're going to talk about useful tips for going through the course, how to get help during the course, general advice on how to approach the course, where to find the course notebooks, and how to use the student chat channel. So some general tips as far as your course taking experience. When you're using the video player, you can use the gear setting to either speed up or slow down videos. So if you're like me and you like watching videos a little faster, maybe on 2x speed, you can use the gear setting for that. Or maybe English isn't your first language, you can slow down the videos, and you can also do things like turn on closed captions, or you can also change the streaming quality. You can use the Udemy app to download videos of the course lectures, and for more information on the Udemy app, you can check out the Udemy support pages for it. Also, make sure to use the Q&A forums. There's lots of previous discussion available there to help answer any questions you may have. Let's talk about getting help in a little more detail. Let's talk about the best series of steps to take when you have a question that arises while you're taking the course. If you're coding along with the videos, it's sometimes really easy to make a typo, which is why we provide course notebooks with explanatory text and the Python code for every single lecture. So if you ever get an error due to code that you thought you were following along with in the video, you should double check your code against our course notebooks. You can always just download the notebooks directly and run the notebooks, or copy and paste from the notebooks themselves. That way, you can make sure that your error isn't due to some typo while you're watching the video. Now, not every single question is going to be directly related to following along with our code. And if you do have a question, sometimes a quick Google search or a Stack Overflow search will get you the answer faster than anyone else could. So I would always recommend doing a Google search or Stack Overflow search, especially if you actually end up getting an error code in Python with maybe some of your own code that you were trying out. Just copy and paste that error code into Google, and a lot of times the very first hit is going to answer your question. Now let's say that still doesn't help you. What you should do is search our Q&A forums in the course. We've had over 250,000 students go through this course, so you can almost imagine that any question possible has already been asked and answered by either myself or our teaching assistants. So you should definitely search the Q&A forums before posting there. Now let's say you have a question on just general course things like how to get a certification or where the Udemy app is. Those kind of things are answered in our FAQ lecture. So we have an article lecture with frequently asked questions that you can check out for useful links and more information. Let's say you did all those steps and you're still confused on something. That's absolutely no problem. We're here to help you. The way to do that is to submit a new question to the QA forums and make sure you provide details on what you've tried, screenshots of your error code, and really as much detail as possible. That way we can help you as quickly as possible. Now let's say you have some sort of platform level issue. For those kind of things, you should email support@udemy.com or go to the Udemy support page and open a new issue there. So platform level issues are things like having video playback issues, questions or issues with your certification, or questions or issues with payments. Those are platform level issues and we can't really help you out. So email support@udemy.com to quickly get help on that. Finally, let's talk about how to approach the course. The best way to approach the course is to really review the notebooks along with the video. The videos are really great, but we want you to leverage the power of the notebooks we have for you. And both beginners and experienced users can really use the notebooks to best suit them. For beginners, I would recommend that you read the extra notes in the notebook as you go along with the video guide. If you're more experienced, what you may want to use notebooks for is to quickly review them and see which parts you may already know or may already quickly feel comfortable with. That way you don't feel slowed down by the videos. So beginners, really use the notebooks, read them well, go along with the video. Experienced users, check out the notebooks first and see if you really need the video. Or it allows you to maybe skip certain parts of the video and go to where you need a little more drilling down in. As far as these course notebooks that we keep mentioning, you should check your automated welcome message for the link to the notebooks. Later on, we're going to review how to actually download and open them in the Running Python Code lecture. These notebooks are actually a special file type meaning when you download them, you're not able to just double-click them and have them open. We discuss in a lot more detail throughout the course on how to actually open these notebooks that you've downloaded. The notebooks are hosted on GitHub though, so you'll be able to view them at any time, even without downloading them. The link to download them is also in our FAQ lecture. So either check your welcome message or go to the FAQ lecture for that link. Now let's talk about the student chat channel. There's also a link for our student chat channel in the automated welcome message to join our Discord server. This is a chat channel that's shared between all our courses, so you'll be able to interact with students learning about data science, finance, SQL, R, Scala, and more. In the automated welcome message, there's also a link to a YouTube video describing further information on how to use and log into our chat server. It's actually super easy, but we have that YouTube video in case there's any confusion. Something to keep in mind is that the purpose of that chat channel is to connect students with other students. Technical questions related to the course material are still best suited for our question and answer forums. So you should use that chat channel to have fun, engage with other students, but if you're having a problem with a lecture or a topic or concept in the actual course, those questions are best suited for the question and answer forums. And remember, you can always search the question and answer forums for previously posted questions. All right, last but not least, a huge thank you for enrolling in this course. I'm humbled by all the students that have enrolled, and I'm privileged to be your instructor for Python. Okay, let's get started and take you from zero to hero. Hello, and welcome to the course curriculum overview. In this video, we're going to be getting a brief overview of all the content in this course. Let's go ahead and get started. First, this course starts off with an introduction section, including this overview, a discussion on Python 2 versus Python 3, and a lecture on how best to approach this course to maximize your benefits from taking this course. After that, we'll get started with a Python setup section. We'll learn how to install Python on your computer. We'll learn about environment selection. We'll learn about the Jupyter Notebook system. You'll get access to additional learning resources online, and then we'll have a brief overview on Git and GitHub. Next, we start with the live code sections. We'll learn about object and data structure basics, including numbers, strings, lists, dictionaries, tuples, files, sets, and booleans, all in Python. After each of these individual lectures, there's quizzes to test your understanding. And at the end of this section, there's an assessment test, so you can check your knowledge on each of these topics. Afterwards, we'll get a section on comparison operators. We'll learn about both basic operators and chain comparison operators, with this section ending with a quiz to also test your understanding. Then we'll move on to Python statements, including if statements, for loops, while loops, the range function, and list comprehensions, all in Python, with an assessment test at the end to test your understanding. Next, we'll learn about methods and functions, what they are, how to create them. We'll also learn about lambda expressions, nested statements in Python, and scope in Python. We'll top it off with a homework assignment to test your understanding about methods and functions. Then, you'll have your first milestone project, where you will create a game with Python. Then we'll move on to object-oriented programming, where we'll learn about objects, classes, methods, inheritance, and special methods, all in Python. Then you'll get a homework assignment to test your understanding. After that, we'll learn about errors and exception handling in Python, including what errors are, what exceptions are, and how to use try, except, and finally to handle errors and exceptions. Then, we'll top it off with a test to test your knowledge and your understanding so far in the course. Then, you'll come up with your second milestone project, where you're going to create a more complex game all in Python. Afterwards, we'll learn about modules and packages in Python, how to create them, how to install them from the internet, and we'll explore the Python ecosystem in general. Then we'll move on to built-in functions in Python, such as map, reduce, filter, zip, enumerate, all and any, and even how to deal with complex numbers. At the end of this section, we'll have a final assessment test where you can test your understanding for built-in functions. Next, we'll learn about decorators in Python, a 3-part series ending with a homework assignment. Afterwards, we'll learn about Python generators, including iteration versus generation discussions, how to create generators, and a homework assignment, again, to test your knowledge about Python generators. After that, we'll put together everything you've learned in a final capstone project. But that's not all. There's advanced bonus content, including an entire section about advanced Python modules and advanced Python objects and data structures, so you can level up your knowledge. There's new content regularly added to this section, with dozens of lectures. You'll also get access to community forums and a dedicated help from me, your instructor. So, that's the entire course curriculum overview, so let's go ahead and get started with the course. Thank you, and I'll see you at the next lecture. Welcome back, everyone, to this Python overview lecture. In this lecture, I'm going to do a brief overview of what Python is and a little bit of its history, why you may want to choose Python for programming, and what you can do with Python. And this lecture in particular is really geared towards people who are new to programming and Python is their first language. As a beginner, it's often unclear what you can actually do with Python and what the difference between base Python is versus lots of additional libraries. So hopefully this lecture can clear that up for you. Let's start with just a very brief history of Python. It was created in 1990 by Guido van Rossum, who is pictured here, and Python 3 was released in 2008, with subsequent releases happening after that, such as 3.1, 3.2, and so on. Now, Python, when developed by Guido van Rossum, was specifically designed as an easy-to-use language, with a very high focus on readability of code. And these are just a few of the things that have really allowed Python to explode in popularity. Readability and ease of use was something that was set ever since the start of the creation of the language. So why would you want to choose Python? As I mentioned, ever since the beginning, Python was designed for clear, logical code that is easy to read and easy to learn. Lots of other programming languages use braces and brackets that can make code convoluted and maybe hard to read. But Python makes use of something called whitespace and indentation that we'll learn about later on in this course that makes its code very accessible. Even if you don't know Python but you know another programming language, you can usually read Python without knowing the real syntax behind it. That's how readable it is. Now, lots of existing libraries and frameworks are already written in Python as well, allowing users to apply Python to a wide variety of tasks. Another reason that Python has really become popular in recent years. Another reason to choose Python is it really focuses on optimizing developer time rather than a computer's processing time. Usually, a developer's time is much more valuable as a person rather than just the computational processing time. So the whole language of Python is designed for users to really get prototyping up and running very quickly. It also has fantastic documentation online and lots of helpful resources if you just Google Python help. So the official documentation is fantastic, and you can check it out at docs.python.org/3. Okay, so what can you actually do with Python? This course really first focuses on what I'm going to call base Python, which consists of the core components of the language and writing scripts and small programs. Python is often referred to as a program that comes with, quote, batteries included, which means even the base version of Python actually comes in with lots of additional modules that you can use for writing scripts. And as an example of that could be something like the random module that comes with Python, which allows you to quickly create random numbers, or the math module of Python, etc. Now, once we learn about base Python and its base modules, what we can do is later learn about outside libraries and frameworks that greatly expand Python capabilities. These are frameworks that are not included with base Python, but you can easily download and then work with your basic Python skills. So what can you do once you start using those outside libraries? Well, a really useful part of Python, especially if you're someone who works in an office or as an analyst, is automating simple tasks. You can do things like have Python automatically search for files and then edit them, scrape information from a website automatically. It can read and write Excel files, work with PDFs. It can even automate emails and text messages and fill out forms for you. Python is also extremely popular in the data science and machine learning world. It can do things like analyze large data files using libraries like NumPy and Pandas. It can also create visualizations using outside libraries like Seaborn and Matplotlib. There's also machine learning tasks, and they can create and run predictive algorithms using outside libraries like scikit-learn and TensorFlow. So lots of outside libraries have actually been developed for data science and machine learning, and Python is the most popular language in that field. Now you can also create websites. So if you're interested in web development, people have developed web frameworks such as Django and Flask to handle the back end of a website and user data that can communicate with the front end of a website. You can also do things like create interactive dashboards for users using Python libraries like Plotly and Dash. So once you begin to understand base Python in this course and begin working with a few libraries, I think you'll quickly begin to see the vast potential Python has for you in your own projects. So keep in mind, this course really starts from the basics in base Python, and then as you get more and more skilled, we'll begin to introduce these outside libraries to perform tasks such as working with PDFs or web scraping sites. So let's go ahead and get started with setting you up for the course. Thanks, and I'll see you at the next lecture. Hey everyone, welcome to this crash course lecture on using your command line. Before we install anything, including Python, it's actually really important to have a very quick overview of how to work at your command line. And the command line basically allows you to programmatically move through your computer's directories. That way, you can run Python scripts at your command line. What we're going to cover in this short lecture is how to find your current directory, how to list all the files in a directory, how to change a directory, and then how to clear the command line screen. Something you need to understand though is that the commands are going to be slightly different depending on what your operating system is. So for macOS and Linux users, go ahead and jump to this time in the video in order to go through your set of instructions. If you're a Windows user, go ahead and jump to this time stamp at the video to jump to your specific instructions. And then once you've gone through your command line crash course, go ahead and move on to the next lecture. Again, this is just because the commands are slightly different for Linux and macOS users versus Windows users. Okay, go ahead and jump to the correct timestamp and we'll meet back there. Alright, so let's go over the Windows command line operations. At your computer, to find the command prompt, all you need to do is search for the term CMD, and you should be able to find command prompt as the best match. If command prompt doesn't show up when you search CMD, instead just search for the whole phrase, command prompt, and then you should see command prompt desktop app. Once you've opened up your command prompt, you should see something that looks like this. Let's start off by finding out where are we currently located. Basically, what's our current directory? I can use the command line to interact with my computer, but to actually perform those interactions, I need to know where I'm at on my computer. You can think of this as basically programmatically moving around through files and folders on your computer. You can type out CD, hit enter, and this will report back your current directory. Now you'll notice the command prompt actually basically gives you the file path of where you already are, but sometimes if the file path is really long or you're dealing with more complex things like virtual environments or installations, it's always a good idea to check your current directory by typing CD. Sometimes things like the Anaconda prompt will have other directories in parentheses. You can always confirm your current directory by typing out CD, hit enter, and that reports back where you are. So I can see right now I'm under this particular user's folder. If I wanted to figure out what all the files and folders located in my current directory were or are, I can type dir, hit enter, and that reports back the contents of my directory. I can see here that there's the desktop, documents, downloads, as well as some hidden files denoted by starting with a dot. But basically, this is everything that's in this folder, C users Marcial. I can scroll down, see CSV files, pictures. Now let's imagine I wanted to actually move into one of these subfolders. What I can do is type CD and then the name of that folder. For example, if I wanted to change directories to my desktop location, I can type CD, change directory, space, and then desktop, hit enter, and now I'm at my desktop, and I can type CD to confirm that I'm at my desktop. If I want to go back up a directory, all I need to do is type CD, space, dot, dot, or period, period, hit enter, and now I've moved back up a directory. Now you don't actually need to type in the entire file path if you're moving around. What you can do is say CD, begin typing, such as the letter D, then hit tab, and you should be able to see it autocomplete for you. So as I hit tab, I get the various options of everything that starts with a capital D. So I can go to Documents, hit Enter, and then if I wanted to see all my documents, I can type dir, and we can see all our documents here. Again, if I want to go back, cd space ... And if I ever want to clear my entire command line screen, I can type cls, and I've cleared the entire screen. All right, that's really all the basics we need to know for right now. Just to review, cd for current directory, dir to list everything in my directory, cd and then the name of the folder that I want to jump to. For example, if I want to go to downloads, cd downloads. Again, you can hit tab to autocomplete. And if we ever want to jump back up, cd ... And if we ever want to clear the screen, it's cls. That's the basics you need to know. We'll see you at the next lesson where we discuss how to install Python. All right, so let's go over the macOS and Linux command line operations. And your command line in macOS and Linux is known as a terminal. So these commands work on both of these operating systems the exact same way. Let's get started. To begin working with the command line on a Linux or macOS, you first need to open up your terminal. Search your computer for terminal, either on macOS or Linux, it's called the same thing, and then open up your terminal. You should eventually get something that looks like this. The colors or font may be slightly different, but the basic idea is the same. The terminal gives you a command line interface, and the command line interface allows you to move around different files or folders on your computer. And with some more advanced functionality, you can also make new directories or remove directories. We don't really need to know that right now. All we really need to know is how to understand what our current working directory is, change directories, and just move around. This basically allows us to move around the computer at the command line. The first thing we want to know is where we're currently located. To know that, type pwd, hit enter, and this will print your working directory. This is where you're currently located at the command line. If you want to understand what files and folders are located at your current location, type ls and then hit enter, and you should see a list of different files and folders at your current directory. If you ever want to move to one of those files or folders, what you can do is type cd and then whichever file or folder you want to go to. However, it should be in the list that was just printed. For example, let's move to our desktop. So I will come back down here and type cd desktop, hit enter, and now if I type pwd and I hit enter again, I'm now at my desktop. If you ever want to clear your screen, just type clear, hit enter, and now you've been able to clear your command line. If you ever want to go back up a directory, it's just cd space ... hit enter, and now we're back up a directory, which I can confirm by typing pwd. That's really all we need to know as far as the commands are concerned. Let's have a quick review. To print your working directory, it's pwd, and this reports back where you're currently located. If you want to know the files and folders at your current location, type ls, and this will list all the files and folders. If you want to clear your command screen, type clear, hit enter, and this will clear your command line. If you want to change directory to a subfolder, type cd, and then you can even begin typing the name, such as desktop. And if I just hit desk and then hit tab, it should autocomplete. If you do not get an autocomplete by hitting tab, that's probably a good indicator that it's not a direct subfolder of your current directory. But then you can type cd, the name of the subfolder or subdirectory, and then we can see now we're located here by typing pwd. If you ever want to go back up, type cd space ... Okay, that's the basics of moving around through the command line. We're going to be using that later on when we run Python scripts at the command line. We'll see you at the next lesson where we discuss how to actually install Python onto your computer. Welcome everyone to this lecture where we're going to walk through the process step by step of installing Python with the free Anaconda distribution. Now, there are many ways to actually run Python code, and we have another lecture later on called Running Python Code, where we're going to be exploring the difference between running a python.py script or running Python code in a notebook environment such as Jupyter Notebook. Either way, before we actually learn how to run that Python code, we still need to install Python locally on our computer. So in this installation lecture, we're going to do the following. First, and the main thing about the lecture, is we'll install Anaconda distribution for Python. The Anaconda distribution is going to install the Python programming language and an easy-to-use development environment and Navigator launch tool. That's why for this course, we choose the Anaconda distribution instead of just going to python.org and only downloading Python. The Anaconda distribution will install the language and a bunch of really useful tools, especially if you're a beginner in programming. Then we're going to briefly run Jupyter Notebook, the development environment we use throughout the course. Keep in mind though, we'll have later lectures that dive much deeper into the details of actually programming and running Python code. This is mainly an installation lecture. After all that, we'll explore these no install online options. So a quick note on these no install options. There are actually now many online, no installation necessary Python environments that can be run directly in the browser. So as long as you have an internet connection, you actually don't need to install anything. You can just visit a website and run Python code. While these are not officially part of the course, because these websites can change and sometimes go from a free plan to a paid plan, we are going to give you a brief tour of these online no install options at the very end of this installation lecture, just to give you an idea of what's out there. To begin, we're going to install Python with the free individual Anaconda distribution. It's actually free and open source. There's nothing you need to pay for here. And as I mentioned, this distribution includes Python as well as many other useful libraries, including the Jupyter Notebook environment, which is where we do our coding in this particular course. And Anaconda can also be easily installed on any major operating system, Windows, Mac OS, or even Linux. To begin, we have to first go to the downloads website. You can go to www.anaconda.com/downloads, and it should take you to the individual product download page, or you can just do a Google search for Anaconda download, and it should take you to that page as well. I'm going to head over to my browser and go to anaconda.com/downloads, which should redirect me to the individual downloads page. Okay, here I am at Google, and what you can do is just search Anaconda download, hit enter, and it should take you to anaconda.com products individual. And this is the download page we're looking for, the individual edition. Or if you directly type in anaconda.com/download, it should also redirect you to this page. Keep in mind, Anaconda does change the look of this page from time to time. So at a certain point in the future, it may look slightly different to you, but overall, there should be some sort of download and install option on this page. The individual edition is free and open source. There's nothing you need to pay for. And you'll notice that eventually there's going to be a download button on this page. What you do is you can just scroll down here. It's going to talk about the various aspects that are included with Anaconda. Really, it's not just the Python programming language, although that's definitely the biggest part of it. It includes a bunch of libraries and really useful tools, especially if you're just a beginner. So what I'm going to do here is I'm just going to scroll down until I get to the Getting Started with Anaconda section and the Anaconda installers, which is really what we're looking for here, this Anaconda installers, and it's probably going to be at the bottom of the page. Also, if you just scroll all the way back up here and click download, it will automatically take you to the installer section. Now, depending on your operating system, you'll want to download the Windows installer, Mac OS installer, or the Linux installer. It's kind of up to you depending on which operating system you're actually running. Now, I am running a modern Windows 10 software, and if you're running a just relatively recently made computer, you're probably going to want to install the 64-bit graphical installer. If you're on an extremely old computer, you may want to check if you have a 32-bit graphical installer, but it's highly likely that if you're on a modern computer, you're just going to be installing the 64-bit graphical installer. If you are on Mac OS, install or download the graphical installer, not the command line installer. They're technically the same thing, but graphical installer comes with an easy-to-use Windows that's going to match up with exactly what we show on the Windows installer. And if you're on Linux, you can download the 64-bit installer here. Okay, since I am on a Windows computer, I'm going to click and download the 64-bit graphical installer. And once you click on that, it should begin the download, and it will also take you to a thank you for downloading web page, which you can pretty much ignore. There's a little getting started here, which is a 12-minute tutorial. You may want to take a look at that. There's also a documentation quick start guide where you can click learn more, and it takes you to this user guide about Anaconda of some more details. But really, what we're going to talk about is just the installation part in this lecture. In fact, if you click on that user guide, you can click on installation, and it has written out step-by-step instructions for installing on Windows, installing on Mac OS, or installing on Linux. So depending on what operating system you have, if you really want step-by-step written out directions, you can go to docs.anaconda.com/anaconda/install, and it will take you to the documentation for a variety of setups, which we're really just going to show here. And again, there's not too many steps here. You just click next and click all the defaults and hit I agree. Let me fast forward until this executable file is done downloading so we can walk through the installation procedure together. Once it's running, what we're going to do is set up Anaconda. So we'll click on Next here, go ahead and agree to the license agreement, and then depending on whether or not you have admin permissions on your computer, you could do just me or all users. I'll do just me. And then I'm going to install it here under Anaconda 3. I would also suggest that you use the default destination folder. Alright, and here's a very important step for Windows users. You'll notice it has this checkbox and it says that it's not recommended to check it. If this is your first installation of Python and you intend to use this distribution of Anaconda as your main source for actually running Python code, then I would actually recommend that you install it and add it to your path environment variable. Basically what this means is that if you were to open up the Windows command prompt and type Python, it would come first and search for the Anaconda version of Python before looking at any other pre-installed Python. And if you're following along this course and you intend to use this as your main distribution, then we actually do recommend adding Anaconda 3 to my path environment variable. If later on and you decided not to check this box and want to add it to your path, what you can do is open up Anaconda 3 with the Windows Start menu and then select Anaconda 64-bit, and then this Add to Path option will essentially be the same thing as clicking this box here. For simple use cases, I actually do recommend that you click this box, so I will go ahead and click that box and just add it to my path environment variable since I want Anaconda 3 to be found first. So then we'll hit install. And my Anaconda installation is now complete, so I will go ahead and click next. And you'll notice it says working with Python and Jupyter Notebooks is a breeze with PyCharm Professional, etc. We don't actually need to worry about installing PyCharm. It's just another development environment option for you. There's pretty much a wider range of environments you can choose from. We'll be using the Anaconda and Jupyter environment just because we feel that is the most accessible to someone learning Python for the first time, and it's free and open source. So we'll go ahead and skip this little kind of advertisement there. And then what we're going to do is we're also just going to skip the tutorial and then skip learning more about Anaconda. Those are actually the first two links that we showed you earlier. And then hit finish, and you should be good to go. Okay, now that we've finished installing Anaconda, let's show you the two ways to run it. One is through the Anaconda Navigator. To do this, search your computer for Anaconda Navigator. So I'm going to search for Anaconda Navigator. So I'm going to open up the Anaconda Navigator app, and you may need to run this as an administrator on some computers, specifically on some work computers, but go ahead and open up and click on Anaconda Navigator in order to run the application. Upon clicking that, you should see it beginning to initialize, and sometimes this takes a while, especially on the first time you're running Anaconda Navigator, so be patient while it loads, but eventually you should see this graphical interface pop up for Anaconda Navigator. Okay, here we are at Anaconda Navigator. It'll ask you whether or not you want to send reports to Anaconda. Feel free to send the reports or not send the reports. I'm just going to hit OK here. And right now it's loading a little bit more content. And there we go. So now we have Anaconda Navigator, which is essentially a graphical interface for the various development environments that Anaconda comes with. You'll notice that it has Jupyter Lab, Jupyter Notebook, a PowerShell prompt for you, as well as Qt Console, Spider, GlueViz, Orange 3, and even RStudio. So Anaconda is essentially packaged not just Python, but a bunch of development environments for you. For the course in general, we are using Jupyter Notebook, not Jupyter Lab, although it's extremely similar, but Jupyter Notebook. Just something to keep in mind. Alright, now before we actually launch Jupyter Notebook, what I want to do is finish this tour of Anaconda Navigator. On the left-hand side, you see the Home tab. There is also the Environments tab. Environments, in this case, actually stands for Virtual Environments, which you may be familiar if you've programmed before. It essentially allows you to create a little virtual environment separate from your base environment to install particular versions of libraries. We'll talk about this later on in the course. You can see that I have some environments already. You should probably just have your base root environment and maybe one more, like a new environment. But for right now, you can go ahead and ignore and skip this tab. And finally, there's the Learning and Community tabs. Learning is just a bunch of links to documentation and some training videos you can check out. It's really leaning really heavily towards data science and machine learning because Anaconda is really popular with that community. And speaking of community, you can click on the Community tab, and it's a bunch of links to events and forums you can check out. Again, highly skewed towards data science and machine learning. Let's come back home. And once you're home, what you're going to do is hit the Launch button underneath Jupyter Notebook. We won't be working with Jupyter Lab for now. It's really similar, but for right now, Jupyter Notebook is the simpler of the two. It's easier to get started with Jupyter Notebook. So click on Launch on Jupyter Notebook. It's going to load for a little bit, but then it's going to redirect you to a Jupyter Notebook in your browser. And don't be alarmed if you notice it automatically opens your default browser. We highly recommend Chrome as your default browser when working with Jupyter Notebook, so you can check that out, but it should automatically open the default browser on your computer. So for example, you can see off screen, it actually did this for me. It went ahead and opened up Jupyter. So Jupyter does not require the internet to run. It's just using your browser as a visual interface for you to write code in. And you notice that it's typically going to launch in your C drive or in your main user drive, depending if you're using Windows or Mac OS, in which case you should see a directory of all your folders and files. So notice in my C drive, I can see my desktop folders, documents, downloads, etc. So then if I click on one of these, like desktop, it actually shows me everything I have underneath my desktop folders and different files there. I can come back up, and this is essentially allowing me to explore files and folders across my computer, whether they're in documents, downloads, favorites, games, music, etc. What I can also do is create new folders and new notebook files from here as well. Let's quickly explore that. I can click on New, and you'll see the option for a new notebook and the option to create a new folder, as well as a terminal connection and text file. We'll ignore those for now. We can click on New Folder, and if you click on New Folder, it should create a new untitled folder, essentially at the bottom of this list of folders. So if you scroll down here, eventually you should see something that says like untitled folder created just a few seconds ago. And then if you open it, it's completely empty. So this would allow you to actually create notebooks inside. So it says the notebook list is empty because this is just an empty folder. What I can do then is I could come back up a directory, scroll down and rename this folder. I can click the checkbox here, untitled folder, and if you scroll up, it'll say, do you want to rename it? So let's go ahead and rename it. Let's call it My Python Stuff. Hit rename. And now let's open it up again. So it says My Python Stuff. I'm going to open up My Python Stuff. It says the notebook list is empty. Let's create our first notebook. Notebook is what we're actually going to be writing code in. I will select New. It says Notebook, hit Python 3, and this will automatically launch and connect to a new notebook. We're going to be discovering notebooks in a lot more detail later on in the course when we talk about running Python code, but just as a really quick tour of what a Jupyter Notebook is, it's essentially an environment where there's individual cells where you can write Python code. Let's run our very first piece of Python code just using Python as a calculator. I will say 1 plus 1. And then what I can do is I can run this cell. I could say cell, run cells, and it will run this cell with the input as 1 plus 1 and the output as 2. I can also type in, or actually do Shift Enter. I'm not just typing it in, this is just to show you what I'm about to do. If I hit Shift Enter on my keyboard, it will run this cell and then create a new cell underneath it. So I'm going to do Shift Enter on my keyboard again. It runs the cell and creates a new cell underneath it. This is the main way we're going to be learning how to program throughout the course. Keep in mind, we do show you how to run .py scripts using something like a text editor like Sublime Text to give you the option of running Python code however you prefer. But for the majority of the course, we use notebooks because it allows us to write notes and just organize our data and learn better using Python. And all the course notes are organized in notebooks. In fact, if you go back to the very first lecture of the course or check your automated welcome message as well as the Q&A forums, you'll see that we have this Purion data link with the Complete Python 3 bootcamp with all the sections and notebooks that correspond to those sections. So I can click on something, for instance, like the milestone project 1, click on warm up project exercises, and these are notebooks hosted on GitHub for you. And later on, we'll actually show you how to download these notebooks. But you can see that the notebooks allow you to post images, post explanatory text, and code all in one single interface. This is why they're so useful for learning Python for the very first time. And we're going to talk a lot more about using Jupyter and running code later on. But for right now, you should have been able to create your first notebook, run some code, and keep in mind, there's a whole help tab here for a user interface tour. This user interface tour, super helpful. If you just click on it, it actually takes you through a kind of left and right code tour on file names and stuff you can do within the notebook. So I highly recommend you actually just click help and take that user interface tour now before heading on to the next lecture. Once we're done with this notebook, we can simply close this tab. Notice the notebook is actually still running, noted by the green little icon. You can simply check the box and shut down the notebook. If you shut down the notebook, the code and text is all saved there, but it's not deleted. If you do want to delete this notebook completely from your computer's memory, check the box and then hit this little trash icon. And then it's going to say, hey, do you want to permanently delete this notebook? Go ahead and hit delete. And now it's permanently removed. Same thing for the folder. If you go back up a directory and for some reason you will now want to delete this My Python Stuff folder, simply check this box, scroll back up here and hit the trash can icon. It's going to ask you, do you want to permanently delete this folder? Keep in mind, Jupyter only allows you to delete folders that are completely empty. This is a safety concern. That way you don't accidentally delete a whole folder permanently. Go ahead and click delete here, and you should have been able to delete that folder. All right. So in this lecture, we were already able to install Anaconda, launch Anaconda Navigator, and launch our very first Jupyter Notebook. Coming up next, we're going to discuss how to run Python code, both as a .py script and within the Jupyter Notebook. To end this lecture, I did mention there were some no installation options. We're going to do a very brief tour of this if you're interested. If not, go ahead and move on to the next lecture. Let's give you a brief tour of all the no install options available on the internet at this time. All right, so let's quickly check out some no installation options. The ones we're going to cover just briefly here are the official try option from jupyter.org/try. That will actually allow you to run a Jupyter Notebook with nothing to install directly in your browser. Then we'll also check out Google Colab online notebooks. You do need a Google account like a Gmail address in order to access those, but it's a pretty cool feature provided by Google. And then we'll also check out Repl.it or repl.it. And that's a website that allows you just to write some Python code, have it interpreted, and run. I should mention there are dozens of these sort of websites, and you can find them by just doing a quick Google search for Python interpreter online, and you'll get a ton of options, including the ones shown here. But for a very brief note, why would you not want to just use one of these options instead of installing something locally? For one thing, it can be hard to upload your own code, data, or notebooks on one of these free no installation options. And also, sometimes they have the free tier that doesn't save your code, and then you have to actually pay in order to have your code save and run on their service. So keep that in mind. And then the third thing is, we're not officially supporting any of these no installation options as part of this course, since they could change in the future. All right, I'm going to head over to my browser and just give you a brief tour of these options. Okay, the first option is jupyter.org/try. It's essentially the exact same thing I just showed you locally, but hosted here for free on the cloud. So you can try the classic Python notebook. You can also try it with things like R and Jupyter Lab to try it out. You click on Try Classic Notebook, and it's going to upload just a temporary instance of a Jupyter Notebook. I actually often use these when I don't want to run Jupyter Notebook locally, and I do want to run just a quick piece of Python code and have this run a temporary cloud-hosted Jupyter Notebook. Nothing you put here is actually going to get saved, so keep that in mind. It's just a temporary notebook being hosted in the cloud. All right, so once that's fully loaded, it's going to look something like this. This is essentially a Jupyter Notebook. It's going to tell you your memory limits. Keep in mind, locally, you obviously don't have memory limits like this. It's just the memory limit of your computer's RAM or hard drive space. You can just insert a new cell or say, insert cell below. Here's the new cell. Type in something like 1 + 1 or print 1 + run, and then run these cells, and you'll get to see the output. And this is jupyter.org/try. Really nice to just quickly run a notebook hosted online. And nothing here is actually going to get saved permanently. You can click save, and it will save your changes, but you can't come back to this website and expect your notebook to be here. Another option for downloading it here is, if I zoom out just a little bit, you can click here on File, Download As. You can download this as a notebook, Markdown, LaTeX, HTML, tons of options here. There's even JavaScript slides, reveal.js if you're familiar with that, but that allows you to download it locally in case you really wanted to save any changes there. Okay, I'm going to close out of this option. Next option is Google Colab Notebooks. This is a free notebook service from Google, really focused on machine learning and data science, and you do need a Gmail account to access this. Go ahead and just Google search Google Colab Notebooks and then go to collab.research.google.com, and you can click on one of these already pre-made notebooks, or you can click on New Notebook, and it takes you to this new Google Colab Notebook. And here, what's really cool, if you have a Gmail account, it will actually save your notebook, and you can do things like load up data to a Google Drive. The downside is it's not exactly a Jupyter notebook, it's kind of a specialized Google version of it, but you can say something like 1+1 here, click run or hit Shift Enter, and it's going to run that code and then output the results. And actually right now it's connecting and initializing. Now that it's connected, you can see it ran to here, 1+1. You are limited on your RAM and disk space, but there's a paid tier in case you decide to do really huge machine learning or deep learning data sets later on in your Python career. This could be an option for you. Now I'm going to close this one. Last one I want to show you is this Repel. It's a browser-based IDE. It is collaborative and do have a free tier you can check out. So if you click on Start Coding, you do have to make an account, log in, and sign up. And if you check out the pricing on this, there is a starter edition that's totally free. So if you want, you can use this. It doesn't give you a whole lot of CPU power though compared to something locally, so keep that in mind. And really it's kind of meant for collaborative coding environments. And if you go back here to the Google search of Repel, you'll notice there's a little Python link here. And you can click here, go to repel.languages/Python3, and you should be able to actually just kind of give it a little test run. So I can do something like print 1+1, hit run here, and it's going to give me the output 2. Again, there's limits here. Nothing's going to get saved unless you make an account, log in. For the best experience with this course, I do recommend that you work with a local installation. It's much easier to follow along that way, but I do want to give you some options in case you're on a computer where for some reason you don't have full admin permissions to install anything. Okay, with that being said, let's move on to the next lecture and really dive into running Python code. I'll see you there. Welcome back, everyone. By now, we've learned about the command line basics, and we also have installed Python onto our computer. It's time to actually run our first piece of Python code. Before we do that, I want to discuss the several different ways you can run Python code and the various options there are for developing environments for Python. And there's three main types of environments, and what I mean by environments is the actual thing you're going to be typing Python code into. And the three options are text editors, full IDEs, which stands for Integrated Development Environment, and then there's notebook environments. So let's start off with text editors. Text editors are just general editors for any text file. And that is to say they're designed in a general format where they can open a .text file, a .py script, a .html file, a .js file for JavaScript, just any variety of file types, you'll be able to open them up and edit them. And they can also be customized with plugins and add-ons. And because of that, and their general format, they actually aren't designed with only Python in mind. So you're going to sacrifice a little bit of Python-specific functionality. Things like autocomplete for Python or looking up things in the documentation automatically for Python. Those typically won't be included directly with the text editor. Instead, you'll have to download them with a plugin or some other add-on for text editors. Keep in mind, there's tons of plugins out there, and Python is such a popular programming language that you can pretty much find any plugin you want already created for you for the text editors you're working with. And the most popular text editors on the market are Sublime Text and Atom, and those are both free. Technically, Sublime Text is an unlimited use free license that you can eventually pay for if you like the product. Atom is an open source text editor from GitHub, which is completely free and it's open source. And later on in this lecture, we'll be showing you how to download Sublime Text and running Python scripts with Sublime Text. So that's one option, the text editor. Another really popular option, especially if you're working at a company, is a full integrated development environment. And these are development environments that are designed specifically for use cases with Python. And they're larger programs. What I mean by larger is that it's a larger file size. The text editors from before, those are actually very lightweight programs that you end up adding more and more to them as you want more plugins. IDEs, they come with everything already, so they have larger programs. And because they're IDEs, it means there's actually a team of developers or a company behind it being paid to add new features to the environments. And because of that, there's typically a pro version and a community version where only the community edition is free, and the pro version that has more features, maybe they'll have more features for Django web frameworks or web development help, those you have to pay for. The community editions are free, however. And the pro about this is that they're designed specifically for Python. They have lots of extra functionality to help with your Python code. But they are a little more bloated, a little larger, and it kind of depends on what your workflow style is, if you like this approach or not. The most popular IDEs for Python are probably PyCharm, that's definitely the biggest one out there, and then Spider is another popular one. Spider is really popular for people coming in from MATLAB into Python. Finally, let's talk about notebook environments. And notebook environments is the environment we're going to be using for the majority of this course. Later on, we'll move away from notebooks and move towards larger scripts. But to start off with, we'll go with the notebooks, and that's because, in my opinion, they're really great for learning. And the main thing here is that you get to see your input code and your output of the code right next to each other, and you get to see multiple inputs and multiple outputs all in one nice notebook. And this is because notebooks use blocks of code that are referred to as cells. So you can split up your code into different cells and then run pieces of your code by running individual cells, and you get to immediately see the output. That's different than the approach taken with a text editor or development environment where you have to develop kind of a larger script first and then run that script at the command line. That's really great when you do have larger pieces of code that need to interact with each other, but when you're just starting off, you kind of want to quickly be able to type something in and see the output, which is why a notebook environment is really great for learning. The other things that differentiate a notebook environment is that they support inline markdown notes. So you can write yourself different pieces of notes. So just normal text is what we mean by markdown notes. And actually the notebooks we provide for this course have a lot of explanatory text for you. So you essentially get a book along with the videos that go with this course. And they also support things like visualizations, images, videos, and a lot more. And because they support all these extra things, they actually have their own special file format that are not a .py script. And because of that, typically if you see a .py script on your computer, you can double click on it and some sort of text editor will automatically open the .py script. Because notebooks are able to support all this extra stuff, they have their own notebook format, which is extension .ipynb, that stood for IPython notebook. And because of that special format, you can't actually double click on a notebook file. You need to launch it using the Jupyter Notebook launcher. So the Jupyter Notebook is pretty much the most popular, and it's almost the only notebook environment for Python because of how popular it is. But it's getting more and more popular, especially in fields of data science and machine learning, because you can see visualizations and your code input right next to the output. So we're going to be using that at first to start learning. But the most important note here is that development environments are actually a very personal choice, and it's really highly dependent on your personal preference. So if Python's not your first language and you're already used to using Sublime Text Editor, or maybe you've already used PyCharm at work and you have the pro version there, and you want to prefer to use those development environments, please feel free to do so. All the code we show is going to work in any development environment that you choose. So really, after you see this lecture, choose whichever development environment you prefer. We provide the notes as .ipynb files, but you can easily convert them or download them as HTML files or .py scripts, and all the code we show in the videos runs the same regardless of what environment you're using. Okay, so let's now explore how to run Python code. We're first going to start with an editor, so we'll download the Sublime Text Editor, and we'll show you how you can create a simple .py script and run the file at your command line. Then we're going to show how to run the same code with a Jupyter Notebook. So to do all this, we first need to download Sublime Text Editor. So go to www.sublimetext.com and we'll see you there. All right, here we are at sublimetext.com, and typically it will auto-detect what operating system you're on, and it will have a little button for you saying download for OS, Linux, or Windows. It's a very simple text editor, and it's probably the most popular text editor in the world. And it has a really interesting pricing scheme. It's technically not free, but they give you an unlimited free trial where they will just have a little pop-up every once in a while asking you if you're ready to upgrade to buy it. So again, it's technically not free, but it has an unlimited free trial for the rest of your life. It will just have a little pop-up asking you to purchase the full license. So click here on download and then select the download for your operating system, either OS X, Windows 64-bit, or Linux. So typically what you should do is just go to the home page and then click whatever download that it auto-detected for you. Once you've downloaded it, we'll go ahead and open the Sublime Text Editor. Once you've downloaded and installed Sublime Text, you should be able to search your computer for Sublime Text, click on it, open it up, and it will look something like this. Next, what we're going to do is actually type out some Python code and then save this as a .py script. Go ahead and type print, open and close parentheses, and then in single quotes or double quotes, hello world. And this will be your first Python script. And then select File, Save As. And the reason we're doing that is if you notice, right now, there's no syntax highlighting. That is to say, everything is the same color for this font. So Sublime Text Editor doesn't actually know that this is a Python script. What we want to do is save it as, and we're going to call this file my example. And you'll notice if you click on all files, you have lots of extensions to choose from. We're going to choose to save it as a Python file. So you're going to say, my example, save it as a Python file. The other option you can do is just select all files and then say, my example, and yourself write .py. Either way is fine. Go ahead and save it, making sure it's a .py file. Hit save. And now you'll notice Sublime Text Editor understands that it's a Python script file, and it's performed syntax highlighting to help you read this. Print is a function, hello world is a string. And we're going to be learning a lot more about that and Python in general later on in your training. For now, let's see how to actually run this script. Remember that we've saved it to our desktop, meaning at our command line, we need to change directories to our desktop so we can run this actual .py file. Go ahead and open up your command line. Since I'm on Windows, I will open up a command prompt. If you're on Mac OS or Linux, you'll open up a terminal. Then you'll want to change directory to your actual desktop or wherever you saved this .py file. So type cd and then desktop to change directory to your desktop. And then what you should be able to do is type out Python space, and then begin typing out the name of your file. In my case, it was example.py, and to prove to yourself that we're in the correct location, you should be able to hit tab and it will autocomplete. So here we say Python myexample.py, and this is how you can run a .py script at your command line. Hit enter, and you should be able to see hello world. Now you successfully created a Python script in your text editor, and you ran that script at your command line. What you can also do is just type Python by itself at your command line, hit enter, and this is a very simple direct connection to Python, allowing you to type Python code directly at your command line. We won't really be using this throughout your training because it's only one line at a time, and eventually we'll be using and learning about writing more than one line at a time for code, but you can also just check it out, type print hello, enter, and you'll notice you have hello as the output. So this is basically one line at a time. You can write Python code. Then we can type quit, open and close parentheses, hit enter, and we've quit out of the Python interpreter. All right, so we just learned how to actually run a Python script at your command line. Now let's explore the Jupyter Notebook environment and see how that works. To do so, we'll go to our Anaconda Navigator. So search your computer for Anaconda Navigator, open that up, and then once you've done that, go ahead and launch the Jupyter Notebook. Once you click on that launch button, you should notice that your browser automatically opens up to localhost either 8888 or 8889 or some other series of numbers. Keep in mind that while Jupyter Notebook does operate inside of your browser, it does not require an internet connection. Everything is happening locally. There's no internet connection between Jupyter and some other server somewhere. It just happens to open up and operate in your browser as a convenient graphical interface for you to program in. So once you launch Jupyter Notebook, you'll notice that you can view all the files on your computer. For example, we can click here on the desktop folder, and now I can see that my example.py script we had just created earlier. And using the Jupyter Notebook system, you can actually add on and edit .py files. So for example, we could add on another print statement here, new, and then save this change. So we could say save, and then we could also download or rename the file and a bunch of other stuff. But we're not going to be using Jupyter for this sort of text editing. It's probably better to use Sublime Text Editor, but again, it's personal preference. What we're really going to be using Jupyter for is the notebook system. So you can click here where it says new, and under notebook, you should see Python 3. Sometimes it says conda root or something else, but click on what it says under notebook. Typically it says Python 3. And then you'll notice that we just started a new notebook. So let's have a quick overview of what this actually is. Here it says untitled, and that's because this notebook that we just created doesn't actually have a title. And if we click back here to this other tab, you'll notice we just created an untitled.ipynb file. That stands for IPython notebook file. Jupyter Notebooks used to be called IPython notebooks, so they kept the file extension name. And if we want to change this name, all we have to do is go back to this tab, select untitled, and give our notebook a new name. So we will say my first notebook, hit enter, and we've renamed the notebook as well as the actual file. You'll notice now it says my first notebook.ipython notebook extension. So coming back to this notebook, the notebook uses a cell-based system, meaning you write code in a cell, you run the cell, and then see the actual output right below the cell. So let's try running our simple print statement. Inside of a cell, type print, open close parentheses, hello, and you'll notice that Jupyter auto-completes some things for you, such as quotes or parentheses. And then we can run this cell. So you can click here on the run button, and it will run this cell, and you will see the output directly below. This is a great system for people who are just starting to learn about Python because they can quickly iterate and fix mistakes because they have their code and they can see the output directly. They don't have to be constantly going to the command line and running their scripts. Again, it's definitely a personal preference, but this is a nice feature of the notebook for people that are learning Python. And you'll notice that we automatically create another cell below, which you can type more Python code in. For example, print new. And if you don't want to have to click that run button every time, all you have to do is do Shift Enter, and that will run a cell. Again, that's Shift Enter to run a cell. If you just hit Enter by itself, you'll just create more new lines. So it's Shift Enter to run a cell. There's lots of other useful hotkeys where you can click on Help and then hit keyboard shortcuts, and it will list all the keyboard shortcuts. The most useful ones we'll be teaching you later on, but you can always explore that yourself. Now we also discussed that the notebook system can actually hold markdown text. That is just normal text that is not code that you can just use for yourself to type out notes as you're learning throughout this bootcamp. So if you click on a cell, you'll notice here it says code, and that's because this is currently a Python code cell. If you want to make it into just a normal markdown cell, select from this dropdown, Markdown, and now this is no longer a code cell, it's just a cell that will just have normal text in it. And you'll notice that it no longer has this in right in front of the cell, so that also indicates that it's just for normal text. So here you can write yourself just notes that will help you understand, and if you do Shift Enter, it will then display them as just a normal text. So again, this is no longer code, it's just text for yourself. And a lot of the notebooks we provide throughout your training will have markdown text as explanation. And if you ever want to write another code cell, you can just hit on a cell and then make sure that it's selected code. And you should be able to print whatever you want here. Shift Enter to run it, and that's the very basics. We'll be talking a lot more about notebooks later on throughout your training, but that's really the basics. The last thing I want to note is that this special extension of the notebook file, this .ipynb, means that you actually can't double click on this file on your computer and expect it to open. So let me show you what I mean by that very quickly. You'll notice that if I come to my desktop, I can see here my example.py, and if I double click on this, it will actually open up in whatever default program I have for it, typically Sublime Text Editor or whatever other editors you have on your computer. So you can double click on .py files, edit them, and work with them. However, if you try double clicking on a .ipynb file, you'll end up getting something asking you, how do you want to open this file? Or it will just kind of open up and you'll just see a bunch of scrambled code. That means that you can only open these special notebook files through the Jupyter Notebook system. So you'll have to open up Anaconda Navigator, launch a Jupyter Notebook, and then actually find it throughout your computer and click on it. All right, that's the very basics of running Python code. It's time to actually learn Python. Hi everyone, I just wanted to take this lecture to very quickly show you how you can download the course notebooks and open them on your computer in case you're having any issues with that. If you've already been able to do that just from the links from the FAQ lecture or the course overview lecture, feel free to skip this lecture. But basically all I'm going to do here is show you how you can actually download the notes from our GitHub page. So you should have seen a little blue pop-up with a resource link, and that resource link will take you to the GitHub page for Purian Data and the Complete Python 3 Bootcamp. So go to this resource link. You can either type it in manually, Google search it, or just use the little blue pop-up that happened when you were watching this lecture. So let's hop over to that link. Okay, so here we are at that GitHub repository, and this is basically an online repository that you can access in order to get the actual course notes. You'll see here how the course notes are organized. We basically have it numbered off by section, and then inside of these sections you'll see the notebooks themselves, and the notebooks are titled both so that their lecture title matches as best we could with the notebook title, and then we also have them kind of numbered so you can go through them in order. So for example, when you're learning about for loops, you'll go ahead and click here on for loops, and this will eventually load up the notebook. Notice how it's a .ipynb file. But once you have the notebook loaded, you should see lots of useful information here, and then the actual code itself. Now, if you want to run these notebooks onto your computer, what you need to do is download this repository. So we'll come back here, click on Complete Python 3 Bootcamp, and there's different ways you can download this repository. If you're already familiar with Git, you can feel free to fork this repository and then have it on your own GitHub. Keep in mind, we are constantly updating this. But what you can do also to just get the files locally is click here where it says clone or download, and then click on download zip, and that will download a zip file which you can then unzip, and that will have all the .ipynb files that you can then access using your Anaconda Navigator, as we showed in the Running Python Code lecture. All right, that's just a very quick overview of how to get the notes. If you ever have any questions on this, feel free to post the Q&A forums, but definitely check out the FAQ lecture where we have more detailed instructions on how to do all this. Okay, thanks everyone. We'll see you at the next lecture. Hello everyone, and welcome to the Git and GitHub overview lecture. So in this lecture, we'll just get a quick overview on Git and GitHub in general. So what is Git, G-I-T? Git is a free and open source distributed version control system, and it can handle everything from just a small project to a really large one pretty well. So you can go ahead and go to git-scm.com to learn more about Git, and you can try it in your browser for free by clicking this try Git link on the Git page here. And it'll take you to this link at try.github.io, and it'll teach you Git pretty quickly in your browser. So it's actually a really useful tool. So what kind of companies are using Git, this version control system? Pretty much all major companies, such as Google, Facebook, Microsoft, Twitter, LinkedIn, etc. There's a whole list of companies. Many companies use Git. And you might be wondering, what's the difference between Git and GitHub? So GitHub is a web page where you can publish your Git repositories and collaborate with other people. So as I mentioned before, Git's a version control system. So it basically has a series of snapshots of your code, which are known as commits. And as you see the path of the snapshots, you can check what order they're created in. So can you use Git without GitHub is another question people ask. And yes, so Git runs locally if you don't use GitHub. An alternative to GitHub might be using Git with your files and then hosting them on Dropbox. But GitHub is the de facto and most popular streamlined service that's designed especially for Git. So I encourage you to make your own GitHub account and check it out. I have my own GitHub account, and that's where I commit the repositories for the notebooks, and that's how you're able to view them. It's because I'm pushing them to GitHub. If you're interested in working how GitHub works, you can go to guides.github.com/activities/hello world. Again, this link is in the lecture text. And you can check out their Hello World document. It's all in browser, so again, you don't need to download anything. You can just check it out all there. And then another great website for learning Git in general, just Git Git, is gitimmersion.com. And it works for both Mac and Windows. Okay, so that's just a brief overview on Git and version control in general, the links and resources you need to learn more about them. Don't worry if you don't want to check that out right now. Later on in the lecture, we'll touch again on this topic when we talk about modules and importing and creating your own libraries. Alright, that's it for this lecture. Up next, we'll finally get started with Python object and data structure basics. Thanks, and I'll see you at the next lecture. Welcome back, everyone, to this section on Python object and data structure basics. So in this section of the course, we're going to start off by discussing basic data types. And these are your basic building blocks of code when constructing larger pieces of code. And we're going to quickly discuss all the possible data types that we're going to talk about in this section, and then we'll have lectures that go into a lot more detail about each one. So don't worry about memorizing all the information shown here. This is more just a quick overview, and there's going to be a lecture on each of these data types as we go on throughout this section. So the data types that we're going to be discussing are the following in this table. Here we have the name of the data type on that left-hand column, and then there's the type. So what that means is just Python has an internal keyword for this name, and you're not going to get the whole word integer, the whole word floating point. Instead, Python has kind of a shortened keyword. So that's the second column, such as int for integer, str for strings, etc. Then we have the description column, and that's just going to be what the actual description of the data type is. So let's quickly go through these. We start off with integers, and those are just basic whole numbers, such as 3, 300, 200. Then we have floating point numbers, and those are numbers of a decimal point, 2.3, 4.6, 100.0. And notice here that even if you have 100.0, that still counts as a floating point number. That's no longer an integer because it has a decimal point. Then after that, we have strings, and strings are an ordered sequence of characters. You can think of these as just kind of words, but you should also note they can be numbers as well as foreign characters inside of a string. The main thing that denotes a string is that it either has double quotes or single quotes. Here we can see we have hello in double quotes, Sammy in single quotes. We have the digits of 2000 inside double quotes. That makes it a string. It's no longer just an integer because it has double quotes around it. And then you can also see we have some Japanese characters inside double quotes. Then we come to data structures, and data structures are a little more specialized than basic data types and data objects because they can actually hold data objects in some sort of sequence or in some sort of mapping. So here we have lists, and these are an ordered sequence of objects. Here we can see that we've been able to use square brackets and commas to have a sequence of other objects, such as the number 10, the string hello, and then the number 200.3. Dictionaries are another data structure that can store other data types, except in this case, instead of having an ordered sequence, they have unordered key value pairs. And we'll be discussing in a lot more detail how dictionaries work, but here we can see that we have a key, then a colon, and then a value, and it's denoted by curly braces as far as if it's a dictionary instead of just being a normal list, which has square brackets. But then we can have something like name, and then colon, and then the value of that name is Frankie. Again, we'll be discussing dictionaries in a lot more detail. After dictionaries, we have tuples, sometimes they're also called tuples, and these are ordered immutable sequences of objects. They look a lot like lists, except they have parentheses, and they're immutable, meaning you cannot change an object that's already in that sequence. So we'll be discussing what immutable means in a lot more detail when discussing tuples. Then we have sets, which are an unordered collection of unique objects. And again, we'll talk about that in a lot more detail. They're a little similar to a dictionary, but they don't have key value pairs. Instead, they're just unique objects in some unordered collection. So you don't have that colon key value pair. Again, we'll discuss it in more detail later on. Then finally, we'll talk about booleans, which are just logical values indicating true or false. Notice how we have capital T and capital F. That sort of syntax is necessary for Python. So those are all the basic data types. Again, don't worry if you didn't understand any of this or didn't want to memorize any of this. We're going to have a lecture on basically each of these topics in a lot more detail and show you how you can use them to write your own code. Okay, let's get started. I'll see you at the next lecture. Hey everyone, welcome back to this lecture on numbers in Python. We already briefly mentioned that there's two main number types that we're going to be working with throughout the course, and that is integers, which are whole numbers, and floating point numbers, which are numbers of a decimal. We're going to be exploring a little bit of basic math with Python, and then we'll also discuss how to create variables and assign them values. Let's open up a Jupyter Notebook and get started. Alright, so before we actually start typing any code, I wanted to briefly mention that if you ever want to toggle this toolbar or this header on or off, you can just come here, click View, and then select Toggle Header or Toggle Toolbar to turn them on or off. And typically, during the lectures, I'll have them off, so we have as much space for coding as possible. Let's start off by just going over some basic math, which is pretty straightforward, and it's basically just using Python as a calculator. If you want to do addition, it's just an addition sign or a plus sign, 2 plus 1. If you want to do subtraction, that's just a dash or a minus sign, 2 minus 1. You can use an asterisk for multiplication, so 2 times 2. And if you want to perform division, that's just a forward slash, so 3 divided by 2 is 1.5. Okay, now let's take a little bit of time to discuss a mathematical operation that you may not have seen before. It's the modulo or mod operator, and basically what this does, it returns back the remainder after a division. For example, if we were to do 7 divided by 4, we get back 1.75. And if you were to do this, kind of using elementary school mathematics, you would say 7 divided by 4, 4 goes into 7 one time with a remainder of 3, because 4 plus 3 is 7. Let's imagine you actually just wanted to know that remainder, the actual number 3. In that case, you can use the mod operator, which is a percent sign. So we're going to say 7 mod 4, and it returns back 3. Because 7 divided by 4, it goes in one time evenly with a remainder of 3. So for example, we could do 50 mod 5, and if 5 goes into 50 evenly, then we get back a remainder of 0. Which is nice because it's a way to check if a number is evenly divisible by another number. That's a really convenient check when you want to check if a number is even or not. So let's imagine we have an odd number, 23, and we want to know if it's even or odd. Well, I could just look at it, but maybe sometime in my code, it's disguised as a variable, and I really need to quickly check if it's even or odd. One way I could do this is simply with a mod 2. And I know that if mod 2 results in something other than 0, then we have an odd number. Because if I have an even number, then when you divide it by 2, there should be no remainder, or the remainder should be 0. So that's the mod operator. Again, it just gives you back the remainder after you perform a division. Let's continue with everything else about arithmetic. You can also perform powers, so you can do something like 2 to the power of 3, so that's just 2 asterisk signs in a row. So 2 to the power of 3, that's 8. And then we can also perform order of operations. Let's imagine that I have the following equation. 2 plus 10 multiplied by 10 plus 3. If I run that code, I get back 105. But what if I wanted to actually have 2 plus 10 occur first, then multiply that by the result of 10 plus 3? Right now, we're following basic order of operations with math, which is going to perform this multiplication first before it does this addition. So it's performing 10 times 10, 100, plus 2, plus 3. So to have our operations happen first, the way we want them, we can use parentheses. I can say 2 plus 10 multiplied by, and in parentheses, 10 plus 3. And if I run that, I get back 156 the way I want it. Okay, so that's the basics of arithmetic and using Python as a calculator. Hopefully it was pretty straightforward. Coming up next, we're going to expand on this by showing you how you can perform variable assignments. That is to create your own variable name and then assign an object to it. We'll see you there at the next lecture. Welcome back, everybody. In this lecture, we're going to be discussing variable assignments. Now, we just saw how to work with numbers, but what do these numbers actually represent? We had integers and floating point numbers, but we don't actually have a variable name assigned to them. So it'd be nice if we can assign these particular data types a variable name to easily reference them later on in our code. For example, I could say a variable name my_dogs is equal to 2 because I have 2 dogs. Now there are a couple of rules for choosing a variable name in Python, and these rules are that names cannot start with a number. There can also be no spaces in the variable name, so you should use an underscore instead, And you also can't have any of these symbols in a name. And if you accidentally forget this list of symbols, if you were to type one of these symbols out in a variable name, Python would quickly complain and you'd have an error. So you don't need to worry about memorizing all these. You'd get the error as you're typing along. A few more rules about variable names. It's generally considered best practice, according to PEP 8, that names are lowercase. Now, there are situations when you become a more advanced programmer where you're going to want to have kind of global variable names in all caps that are used throughout your code. But right now, in general, we'll want to keep all our names lowercase. And we'll also want to avoid words that have a special meaning in Python. And these are built-in keywords like list or str for string. You may be wondering, well, how the heck am I supposed to know what are the special built-in keywords? Luckily, any development environment that's designed to work with Python will have syntax highlighting that will alert you that you're using a built-in keyword by highlighting it a different color. And we'll see an example of that in just a little bit. Before we actually jump to the Jupyter Notebook, though, I want to mention that Python uses dynamic typing. And this means you can reassign variables to different data types. And this makes Python very flexible in assigning data types, and that's actually different than many other programming languages that are statically typed. So let me show you an example of what I mean by this. In Python, something like this is totally okay. Here I've assigned my dog's variable name equal to 2. And then later on in my code, I went ahead and reassigned the same variable name, my dog's, to a completely different data type, a list, Sammy and Frankie. Now that's totally okay in Python, but in other languages that would produce an error. And that's because these other languages are statically typed. Meaning, in the other language, such as C++, you'd have to say int for integer, and then say my dog is equal to whatever integer value you want, such as 1. And then later on in your code, you would not be able to assign it a different data type. You would not be able to say my dog is equal to Sammy because that's no longer an integer, and that would result in an error. So there are some pros and cons to dynamic typing in Python. The pros is that not having to write out the actual data type saves you a lot of time and makes it really easy to quickly produce Python code. And it also makes your code very readable because you're just reading that variable name. Now, this is kind of a double-edged sword here because the cons is that this may result in bugs for unexpected data type. Because you're not having these restrictions of data types, especially when you're dealing with user input, you may have unexpected data types show up and that can cause problems later on in your operations. So you should be aware of the data types as you're coding, and you can use the special type function that's built into Python to quickly check the type of any variable. And we'll show you how to use that in just a little bit. All right, let's explore all these concepts by jumping to a Jupyter Notebook. Okay, now that we've seen how to use numbers in Python as a calculator, let's see how we can assign names and create variables. We're first going to create a very simple variable called a and set it equal to 5. And now that I've run that, anywhere in my code, when I call a, it's now assigned the variable 5. And I can reassign it simply by saying a is then equal to something else like 10. And now if I check a, it has 10 there. And I can also add now objects together. I could say a plus a, and that's going to result in 20 because 10 plus 10 is equal to 20. And Python also allows you to do reassignments with a reference to the same object. Let me show you what I mean by that. I could say a, which is still equal to 10. I could reassign it to be, say something like a is equal to a plus a. So what that is saying is take the current value of a, which is 10, and reassign it to a plus a. So that's 10 plus 10. So after I run this, a is now going to be equal to 20. And keep in mind, if I were to run this cell a second time, so notice the in operator here, it's going to go from 40 to 42. If I run a again, it's 40 now. And you can keep doing this again and again, and you'll keep seeing it essentially double each time. So keep that in mind. This is a little different than in a script environment. If you're running a .py script, you won't really see that effect because you'll just have that line once. In a cell environment, you'd have to run that cell over and over again. Okay, so let's imagine that we don't know what type is a. What you can do is use the built-in type function, so that's type, have open and close parentheses, and we'll learn how to create our own functions later on, but pass in the variable there, do Shift-Enter, and you'll get back Python's built-in keyword for what the type is. And in this case, it's int because it's an integer. Let's reassign it to be a floating point number. So we'll say 30.1. Let's check the type of that, type of a, and it returns back that float. So these are the same keywords that we saw when we discussed that table of basic data types. Now, as we previously mentioned, you want to avoid using built-in Python keywords as variable names. And the way you could know if that's happening or not is, let's say I wanted to start assigning int equal to 4. So notice what's happening here. I have syntax highlighting on int, and I didn't get that before with a. So that means that int here is a special built-in keyword, and you shouldn't use it for something like this. So if you ever see that your variable name is having some special highlighting that a normal variable name it doesn't have, then you should avoid using this. So definitely don't ever run that. And if you accidentally ran that as you were following along, or maybe you made some other reassignment mistake, you can always come here to kernel and select restart the kernel, and that will restart the kernel, and it will kind of delete all the variables. So all variables will be lost. So if you ever have some weird kind of error happening because you reassign something like list or int, you can hit restart here. It will restart the kernel, and then you'll need to run these cells again if you ever want to define anything, because if we say a here, it'll say, hey, a is not defined, so you need to rerun these cells, and then you have 5 again. Okay, so last thing I want to note is a simple example where we use variable names. So I will say my income is equal to 100. And then in this cell, I will say my tax rate is, let's say I have a 10% tax rate, so 0.1, and I want to figure out what my total taxes paid are. I will say my taxes is equal to my income times my tax rate. So I have that, and now let's check what my taxes are. How much do I owe? I'll check my taxes, and there I have 10.0. So now I can perform logic with variable names. And this is a lot more readable than just using integers or floating point numbers, because now I have this nice, almost English sentence that says my taxes is equal to my income times my tax rate. Okay, so we've learned some basic numbers in Python, we've learned how to do arithmetic, and we've wrapped it up by learning how to do variable assignment in Python. Up next, we're going to learn about strings. I'll see you there. Welcome back, everyone. In this lecture, we're going to be discussing strings. Strings are sequences of characters using the syntax of either single quotes or double quotes. Here we can see 3 examples. First, we have hello with single quotes, then hello with double quotes, and then what's nice about having both options of single quotes or double quotes, it means that if you have a single quote in your string that you want to keep and not have that end your actual string, you can wrap it in the other type of quote, such as double quotes or vice versa. So here we can see I don't do that has a single quote in there, but we don't want that single quote to suddenly end the string, so we can wrap the whole thing in double quotes. And we'll see an example of that later on in the Jupyter Notebook. Now what's important to note here is that strings are ordered sequences, and that means we can use indexing or slicing to grab subsections of the string because we know each character has a specific position to be in. And indexing notation, it uses that square bracket notation after the string, or the name of the variable assigned to the string. And we're going to see lots of examples of indexing and slicing in just a little bit. So indexing is the term used when you want to grab a single character from the string. So the way this works is that every single character has an index position assigned to it. So you start at 0. That's another important note in Python, that indexing starts at 0. So H has the corresponding number of 0, E has the corresponding number of 1, L2, L3, O4. So if I wanted to grab the E, what I would use is inside the square brackets, I would pass in a 1 after the string, and then it would return back E. And we'll see examples of that later on. What's also interesting about Python is you can actually use reverse indexing. So maybe you wanted to grab the last letter of a string, but you didn't actually know how long the string was. All you knew was you wanted to grab the last letter. Well, luckily there's reverse indexing available to you, so you can go just grab -1, and it'll grab the last letter of the string regardless of how long that string actually is. Slicing allows you to grab a subsection of multiple characters, otherwise known as a slice of the string. And this has slightly different syntax. Again, it's going to be in square brackets, but because we're grabbing a subsection, we're going to be able to define 3 parts of this. We're going to be able to say start, stop, and step. So again, this goes in square brackets with a colon separating each of these 3 terms. Start is going to be the numerical index of the slice start. Stop is going to be the index you will go up to, but not include. So that's an important note there, and we're going to really focus on that in the examples we'll see in just a bit. And then step is the size of the jump you take from start to stop. Okay, so let's explore all these concepts. They're going to make a lot more sense when we actually see the code examples. Let's hop over to a notebook. Okay, let's quickly show a couple of examples of a string. Again, we can use single quotes, hello, or we can use double quotes. So here I say double quotes with world. You can also have an entire phrase, doesn't need to just be one word. So we can say this is also a string. So we have a whole phrase there, and the white spaces count as characters inside of this string. Now, something we should note here is that we can mix single quotes and double quotes. So if I'm going to say something like, for instance, I'm going on a run. So note what's happening here. Because I'm using single quotes on the outside, only part of this is getting highlighted with the syntax. So this is going to confuse Python because it thinks that you're trying to end the string here, when really I'm trying to end the string here. So if I try to run this cell, it'll say an error here, invalid syntax. What I really want to do is wrap this in double quotes, and that way I won't have an error when I have this single quote in here. So then when I run this, Python has no problem. It says, okay, I get what you're trying to do here, trying to have a single quote there stay, and that's actually not part of the definition of the string. So now let's discuss actually printing out a string. So far, we're actually just asking the string to be returned. And that's the reason we see in and out with these cells. And that's also the reason we actually see the quotes in the output below the cell. But we can use the print function to actually print out a string. So we're going to say print hello. And if we run this, note what we actually get back. We no longer see the out in the cell, and instead we no longer see the quotes themselves. We're actually just printing out the actual string. And the reason this is important is because let's imagine I wanted to say hello world 1, and then I also wanted to say hello world 2. If I were to run this, what ends up happening is I only get back that last string. In order to see everything, I actually have to print out the results. So I will say print, and wrap this in parentheses, print hello world 1, and then I'll say print, and then say hello world 2. And then when I run this, I get to see both strings printed out. So I no longer see that output, I'm actually just printing the results. Now something else I want to mention is that there's actually escape sequences, and escape sequences allow you to kind of have special commands inside of your string. So let's just go ahead and say print hello world, and if I run this, I see hello world printed on one line. But I can actually add an escape sequence, so it's going to be a \n, and what this does is it basically tells Python, hey, this n right here, that's no longer the character n. I actually want you to, because of this backslash, treat this as a new line. So if that escape character there, it's going to say print hello, space, then a new line, and then space world. So that's what we see here, hello, space, and world. If I wanted world to be lined up with hello, I could actually just touch it like this, run that, and then I see hello world. And Python knows not to include this letter n there because it's essentially attached to that backslash. So another popular escape sequence is T for tab, and if I run that, I get back hello, tab, so 4 spaces, world. And we'll be talking a lot more about this when we discuss print formatting coming up next. For now, another built-in function that I want to show you is the len function, or the length function. So this allows you to check the length of the string. So I can say hello, and if I run this, I get back length of 5 because there's 5 characters in that string. If there happens to be a space in the string, so I will say I am hungry. Let's make it more obvious. We'll just say I am. And we run this. Here we can see there's 4. So we have I space am, so that counts as a length of 4 characters in the string. All right, we'll stop it here for now, and in the very next lecture, we'll pick up right where we left off, discussing string indexing and string slicing. I'll see you there. Welcome back, everybody. In this lecture, we're going to continue right where we left off last time, but we'll be discussing string indexing and slicing. Indexing, where we grab a single character, and slicing, where we grab a subsection of that string. Let's jump to the Jupyter Notebook and get started. Okay, so to start this all off, I'm going to create a variable called myString, and I'm going to set it equal to the string hello world. So notice there's a space in there between hello world. I run this, and let's check to make sure. Okay, so we have hello world there, ready to go. Now, let's imagine I wanted to grab a single character from this string. In that case, I want to use indexing. So what we do is we call the variable name, we have square brackets off of it, and let's imagine I want to grab the first character, that is capital H, then I pass in a 0 because indexing starts at 0, and that allows me to return that first character, H. Let's try to grab another character. Let's say we want to grab R, so let's count this out. My string, and we want to count from 0, so that's 0, 1, 2, 3, 4, 5, so notice the space counts, 6, 7, 8. So if I pass an 8 there, it should return R. Perfect. So again, this is known as indexing. Now let's imagine we wanted to grab this letter L. Well, there's two ways I could actually do this. I could say my string at 9, because that's right after that R. The other way I could do it is using the reverse indexing we previously mentioned. So starting at 0 from H, I can go backwards in the string, so that D is -1, and that means this L is -2. So if I say my string -2, I will actually get back that L. And then if I keep going backwards in the string, I'll get back that R, which is right before the L. So I will get back this R right there. So you can use both positive index positions and negative index positions to grab elements or characters from the string. And that's really useful again because oftentimes you'll have a variable string, maybe it's someone's name, and you don't know how big that name is, but for whatever reason you want to grab the last letter of their name, then you can always just use -1, and you know that's the last letter of the string. Okay, let's go ahead and continue to discuss slicing. So slicing is a little more complicated because we're grabbing a subsection of the string. So that's more than one character typically. Let's review our string. Oops, my string here is hello world. And I'm going to redefine my string, just so this is a little easier to follow, as A, B, C, D, E, F, G, H, I, J, K. So just kind of a string of the alphabet there. We'll redefine it. And now I have this string of the alphabet. So let's imagine that we wanted to grab a subsection of a string that started at a particular index and then went all the way to the end. Well, the way we could do that is we would say my string, square bracket notation, and then we would say the starting index, let's imagine we want to start at the letter C and then go all the way to the end. So C is at index 2 because it's 0, 1, 2. So what I do is I pass in 2, and if I just do that, it gives me back the letter C. But if I want from C all the way to the end, I can say colon, and that indicates starting at index 2, colon, go all the way to the end, and there we have CD all the way to K. Okay, now let's imagine kind of an opposite situation where I want to grab everything up to a particular index. Then I could say my string, colon, and let's say I wanted to grab A, B, and C. So starting at the very beginning, go ahead and grab all the way up to essentially letter D here. So we'll say 0, 1, 2, 3, pass in 3 there, and then we run this and we get back A, B, C. Now this is sometimes confusing for students because if we check out my string, technically we have the D at index position 3 because it's 0, 1, 2, 3. What you should note here is that the stop index, this term right here for 3, which only returns back A, B, C, that stop index is basically saying go up to, but not including that index position. So go up to the letter D, but don't include it, which essentially says A, B, C. So keep that in mind as you're kind of playing around with slice notation. This stop is up to, but not including. Okay, let's combine these two ideas of a starting index and a stop index by trying to grab a subsection of a string that's in the middle. For example, let's try to grab D, E, F from the middle of the string. The way we can do that is we say my string, open square brackets, and then we start off with our starting index position. In this case, it's at letter D, so that's 0, 1, 2, 3. Then we say colon, and then it's going to go up to the index position of G here, because I just want D, E, F, so we're going to go up to, but not including G. So that's 0, 1, 2, 3, 4, 5, 6. And now if I run this, I get back D, E, F. So let's practice this one more time by trying to grab another subsection of the string. For example, let's try to grab just B and C, these two letters, B, C. So the way we can do that is we'll type out my string, open and close square brackets. Our starting index position is at 0, 1 for B, colon, and then it looks like we want to go up to but not including D, so that's 0, 1, 2, 3. We'll run this, and there we have BC. And I would encourage you to try to grab a subsection. So choose the subsection of the string and then see if you can grab it. You can go ahead and pause the video and try that out. Okay, to end our discussion, let's quickly discuss step size. Let's imagine that I wanted to grab everything from the beginning of the string all the way to the end. Well, technically, that's just the string itself, but I could also use colon notation for this. I could say colon colon, and that basically says from all the way to the beginning, go all the way to the end. Now, you don't often see this because you might as well just call the string itself, but this is technically valid syntax. The reason you might see something like this is if someone wanted to specify the third parameter, and that is the step size. So right now, we're saying go all the way from the beginning to the end in a step size of 1, A, B, C, D, E, F, G. So that's the default step size of 1. However, I can change that by providing a number such as 2, and that says go in jumps of 2. So from A, go to C, to E, to G, to I, to K. So if I run this, I get back A, C, E, G, I, K, because I'm jumping in a step size of 2. And we can increase this to be a step size of 3, and then we'll get from A, jump to D, jump to G, jump to J, and then there's no more letters to jump to because we're jumping in a larger step size. So that's how step size works, and you can combine this with a start and stop as well. So we could say something like starting from index 2, go up to but not including index 7 and a step size of 2, and we get back C, E, G. So C, then jump to E, then jump to G. So notice how this all works in combination. You have a start, a stop, and then a step size. Something that you may commonly see is using a clever step size trick to reverse a string. And what you can do is say my string, and then say from all the way to the beginning, all the way to the end, take a step size of -1. And what that does is it actually reverses your string, because you're saying from all the way to the beginning to all the way to the end, go and take a backward step, which is then K, J, I, all the way to the end. So this is kind of a little Python trick. Often in interviews, people ask you to reverse a string, and they kind of get annoyed by Pythonistas because they quickly just do this nice kind of slick one-liner instead of doing a for loop. But I just want you to be aware of that. Typically in our code, we won't really be using this too much because it's more of a trick, but again, a very useful one at that. Okay, so that's it for slicing and indexing. Coming up next, we're going to discuss a little bit about some useful string properties. We'll see you there. Welcome back, everyone. In this lecture, we're going to finish off our discussion about strings by talking about string properties and string methods. Let's jump to a notebook and get started. The first thing we're going to discuss is the immutability of strings. And immutability, it stems from the word mutate, basically means immutate, or you cannot mutate or cannot change. I'm going to show you an example of this. Let's create a variable called name and set it equal to Sam. Now let's imagine we want to change this name to Pam, so change the S for a P. Well, you may think that you would do something like this. Say name, index at 0, and then just set it equal to P. Now for strings, unfortunately, you can't do this. If you try to run this code, you'll get an error because strings are immutable, meaning a string object or str object doesn't support item assignment. So you can't grab one of these characters, one of these elements in the string, and then try to reassign it this way. Strings just don't work that way in Python. Later on, we'll learn about other data types that do support item assignment. All this means is that if we do want to reassign this S to be a P, we basically have to create a new string. And we can do that with concatenation, that is kind of merging two strings together. So I'm going to comment this out, and to create a comment, you just put a hashtag in front of it. And if you run this, you won't get anything out. So basically anything with a hashtag is just commented code that doesn't get run. Let's explore this example of trying to create the string Pam using what we already have about name. So the first thing we want to do is try to grab A and M. So let's use the slice notation that we learned about earlier. We're going to start at index 1 and then go all the way to the end. So let's check that. Okay, so that's AM, perfect. So we'll assign this to something like last letters is equal to name 1 all the way to the end. So then if I take a look at last letters, again I can use tab to autocomplete here. It says AM. And now what I can do is I can concatenate P to last letters. And the way you do that is with the plus sign. So we can say P plus last letters, and then we get Pam. So this is known as string concatenation. Let's explore a couple more examples. I'm going to say X is equal to hello world, and then I could say X plus it is beautiful outside. And then if I run this, I can see hello world, it is beautiful outside. Something to keep in mind is note that there's no space here because there was no space at the end of world and there's no space at the beginning of it. So what would be nice is if you add a little space there, so when you run this again, hello world, it is beautiful outside. Now if I do this multiple times with a reassignment, so I could say X is equal to X plus it is beautiful outside. Now when I run this, I've redefined X, so I can see now, hello world, it is beautiful outside. If I accidentally ran this cell more than one time, I'd add in it is beautiful outside a second time. So if I run this again, notice how my in numbers are going to change right next to the cell. Now it says, hello world, it is beautiful outside, it is beautiful outside. And we could keep doing this, and you keep adding it on. So this is string concatenation, and it allows you to quickly put strings together. There's also multiplication you could do to kind of do multiple string concatenations at once. Let me show you what that looks like. So far we've used a plus sign to kind of concatenate two strings together or merge them together. But if you had the letter equal to Z and you quickly wanted 10 Z's, what you could do is say letter times 10. And there you could see essentially someone sleeping here, Z, 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 10 times. So that's using multiplication with letters, and then that's using a plus sign with letters. Something to keep in mind when you're performing string concatenation or string multiplication is that you're going to get errors if you try to concatenate a number with a string. I want to show you what I mean by that. Imagine we're doing 2 plus 3. If we run this, we get 5. That makes sense. If we do 2, the string 2 plus the string 3, now that they're strings, it's not going to add them together. Instead, it's going to perform concatenation. So here now we get back the string 23. And this is a callback to dynamic typing where we had to be really careful about the data types. So keep this sort of problem in mind that your user may end up putting in strings, and then later on in your code, if you start adding them together, you may end up with an unexpected result like 23 instead of 5. So this is a really prime example of both the good and bad of Python's ability to be very flexible. So it's very flexible, meaning you're not getting an error here, but maybe it's a little too flexible because you expected 5 and it gave you back 23. Later on, we're going to learn about a lot more ways that we can kind of prevent these sort of mistakes or errors. Let's continue on by discussing some built-in string methods. So objects in Python usually have built-in methods, and these methods themselves are essentially functions that are inside the object. And later on, we're going to learn how to create our own functions and our own methods. For right now, let's go over just a few useful methods. I'm going to create a new string. Let's call it X and say it's hello world. And if I hit X dot and then hit tab, I should see this list pop out in the Jupyter notebook. And this is a list of all the attributes and methods that are available on this string object. Now again, make sure you've already defined X, otherwise you won't see anything. So make sure you ran that cell that says X hello world, and then in a new cell say X dot, hit tab, and you should see this list. So as you can see, there's tons of methods here, and we're not going to go over all of them right now. We're just going to go over the most useful ones that you'll be using later on in this course. So to quickly uppercase everything in a string, you can say dot upper, open and close parentheses, and it will uppercase everything in the string. Keep in mind, this method is not in place. That is to say, it doesn't actually affect the original string. If you did want it to affect the original string, you'd have to reassign it. You'd have to do something like X is equal to the upper version case of X. So keep that in mind. I'm not going to run that right now because I want the original X string. And if you accidentally did a reassignment, you can always just say X is equal to hello world again. All right, so we have the upper method. Something that's really common for beginners as a mistake to make is that they accidentally just do upper and they forget those open and close parentheses. And if you run this, it'll just say, hey, this is a function string.upper. And basically what Python is saying is, oh, you haven't actually executed this method or function yet. Instead, you just asked me what it was. So when you call it without open and close parentheses and you get something that looks like this back, it means that you haven't actually executed that method or function to occur. Instead, you just kind of asked Python, hey, what is this? So because there's an upper method, there's also a lower method, which is going to lowercase every letter. Notice here now H and W are lowercased. Then there's also the split method, and the split method allows you to quickly create a list off of a string. So here we can say we have hello and world. Now we haven't really discussed lists yet, so they are coming up. So all I want you to think about right now is that if I use .split, it will split a string based on the white space or based on the letter you pass in. So let me show you what I mean by that. So I will say x is equal to, hi, this is a string. Run that. And then if I say x.split, I get back everything split by the white space. So I get, hi, this is a string, nicely organized in a list. However, I could pass in any sequence of characters that I want to split on. So by default, split will split on the white space, but I could actually split it on any letter I want. So now it's going to split on the i's. So if I run this, we should get an interesting result. And here it's essentially removed all the i's because it's splitting on them. And now the white space is included. So I get h, and because there's an I there, it removes it and then gets everything until the next I, so space th. And then there's an I there, removes it, gets everything until the next I, which is an S space. So notice that's here, and then so on. Again, another I, and a big portion of string, get an I, and then an NG. So that's how you can use split to quickly create a list out of a string. And we're going to be covering lists in a lot more detail later on. Okay, coming up next, what we're going to talk about is string formatting for printing. There's a lot of useful methods you can use to quickly print out other objects along with your strings. So far, we've only learned how to use print as a basic function where we say print hello, but there's a lot more power to the print function that we haven't actually seen yet, as well as the .format method. So let's go ahead and cover that in the next lecture. We'll see you there. Welcome back, everyone. Let's now discuss string formatting for printing. Often, you're going to want to be able to inject a variable into your string for printing. So we already learned about concatenation. For example, you may have a variable called myname equal to Jose, and you want to print the phrase, hello, Jose. So what you may end up doing is say print, and then inside of that print function you say hello, and concatenate it with the myname variable. Now there's actually multiple ways to format strings for printing variables in them, so you don't have to constantly be using this concatenation or plus sign. And this, in general, is known as string interpolation, which is basically just a really fancy way of saying stick a variable into a string. So we're going to explore two methods for doing this. One is the .format method, and the other one is the fstrings method, which stands for formatted string literals. And this is a newer method for some newer versions of Python 3. I personally prefer the .format method, but let's go ahead and show you both of them, and you can decide which is more your style. Let's get started. Okay, let's begin by discussing the .format method. And the basic syntax for this is you're going to have your string defined, and then inside of your string, you're going to have special curly braces as placeholders for the variables you're going to insert. And then right after the string, you call .format, and then inside of this, you're going to call the strings or variables that you want to insert into your string. Let's walk through lots of examples here. We're going to start with the most basic example, which is just saying this is a string, going to set open and close curly braces there, and right after the string, we're going to call .format. So notice how the dot is touching the string there, and then whatever string you want to insert. So to make it really obvious, I'm going to go put in all caps inserted. Run this, and now I see this is a string inserted. So what the .format method has done is it's grabbed this string and inserted it where it saw those curly braces. So there's several advantages here, and we're going to go through all of them. One advantage is that strings can actually be inserted by index position. Let's imagine that we want to insert many things. We're going to say the curly braces, curly braces, curly braces, then say .format, and say the fox, brown, quick. Now what happens is basically .format is going to insert these strings in the same order you supplied them and into these curly braces. So right now we have the fox brown quick. What would be nice is if we actually have this make grammatical sense, which is going to be the quick brown fox. What we can do is based off the index position inside of this format call, I can supply those numbers in the order I want. So the very first word I want is actually quick. So this is at index position 2 because it's 0, 1, 2. So I'm going to say, okay, 2 goes first here. And then the next word I want is going to be brown. So that's at position 1, so 0, 1. And then the first word, fox, at index 0 here is going to be the last one I want. And then when I run this, I get back the quick brown fox. What's also really nice is I can actually repeat these. So if I wanted to say the fox, 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 I could just say the 0, 0, 0 here, run this, and now I have the fox, fox, fox. So I can play around with this in case I ever want to work based off of index position. Now what's also nice is that not only can I call things off the index position, I can also assign them keywords and then just call the keywords. Because here, as I'm working with this, there's no real indication that 0 is fox. Instead, I have to look over here and say, okay, what was the first word? What I can do is assign them keywords. So let's do this. We're going to say the curly braces, curly braces, curly braces, say .format. And then inside of the .format call, I'm going to say f is equal to the string fox. So you can kind of think of this as a variable assignment. And then we'll say b is equal to brown. And we'll say q is equal to quick. And then I can use these variable names here, f, b, and q, to insert them. So it's basically using these keywords as variable names here and inserting them that way. So inside of this, I'm going to say the q, b, f. And then when I run this, I get back the quick brown fox. And this is even nicer than previously because it's a little more readable to someone using it like, oh, okay, Q stands for quick, instead of having to look back and ask yourself, okay, well, what was index position 2? And then coming over here to format. So this is able to use these keywords, and I actually really prefer it this way myself. And what's also really nice about this, if again, for some reason you wanted to say the fox, 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 you could just type in F here into each of these braces, and you would get back the fox, fox, fox. So again, using keywords, you can use repetition easily. Okay, to finish off our discussion of the .format method, I want to briefly talk about float formatting with the .format method. And basically, this allows you to adjust the width and precision of your floating point number. Let's start with an example. We're going to say result is equal to 100 divided by 777. So as you may expect, this result is a number with a ton of decimal points after it. What we can do is we can actually, when we're printing this out, change the level of precision we want and even change the width of the number itself. So we're going to start off by saying print. The result was, and then open and close curly braces, say .format, and then here we'll say result, run this, and we see the result was, and it's basically this kind of large precision number. What I can also do is say R is equal to result, and then pass in an R inside these curly braces, and I get back the same result. So the way the formatting works for float formatting, as far as the .format method, is you pass in the value that you're referring to. So in that case, it's R here, that's the actual value name. Then you write a colon, and then you write in the width value you want, dot, and then the precision value you want, and then an F. And often what you're really going to care about is the actual precision. The width just allows you to kind of add in some white space if you have a really large width value. So let's do the following. We're going to say value, so that's R colon. We're going to set our width just equal to 1, then a dot, and then the level of precision we want. So this is mainly what you're going to be playing around with, this precision value. Let's imagine I only want 3 places past the decimal point. So I want 1, 2, and then 9, because 8's going to be rounded up to 9 due to the 7 right next to it. Then I would say 1.3 F. I run this, and I get back 0.129. Now, if I play around with this width value and make it really large, what ends up happening is you end up adding white space. And the reason for that is because the width basically describes how long or how wide you want this entire string number to be. That's not terribly useful because you end up writing a ton of white space, but there may be certain situations where you kind of want to edit that. So it is available to you here, but often what you're going to be playing around with is really the precision here. So we can make this 5, and here we can see now we're taking up less of the total width because with white space, because we have more numbers past the decimal point. And you can just generally keep it as 1, but let's go ahead and show you another example. We're going to say result is equal to, let's say 104.12345. Run that, and we can see here that even with 1 on the other side of the decimal point, that's essentially just the same thing, and we can edit around and play with this floating point value. Okay, so that's float formatting with the dot format method. Again, it's the value, your width, and really your precision followed by F. And you can check out the notebook for a lot more examples on this. Finally, what we're going to talk about is F strings, and these are formatted string literals. These were introduced in Python 3.6, so they're still very new, and they offer several benefits over this older dot format method. I generally prefer the dot format method, but a lot of people prefer this string literal method, especially if they're coming in from other languages. And what it allows you to do is basically skip this step of using dot format and instead write result, or whatever variable name you want, directly inside the string. So the way we do that is the following method. I'm going to create a couple new cells here. I'm going to say name is equal to Jose, run that, and then typically what I would have to do is say, hello, his name is, and then I would say dot format, name, I run this and it says, hello, his name is Jose. What you can do is replace the dot format call by just typing an F in front of the string here, and then you can pass in name directly into the string itself. And if you run this, you get back the same result. So this is called F strings, or formatted string literals, and this is new with Python 3.6. And a lot of people have been requesting this feature for a long time because it's quite common in other languages. Again, because I'm a little more old school, I got really used to this format method, which is why I like it so much. But if you're coming in from other languages, I would definitely suggest you check out the F strings. A lot of people think it's a huge improvement over the previous method, and you can see why it's actually really convenient to just be able to write that variable name directly inside these curly braces. And this works with multiple variables. So let's say name is Sam, age is 3. What we can do is say print F to let Python know it's a F string. We'll say in curly braces, name is, in curly braces, age, years old. And if we run this, we see Sam is 3 years old. So this is a really nice way to very quickly do string interpolation, which is just injecting these variables into the string itself. Okay, those are the very basics of string formatting. We have a lot more examples in the notebook in case you're interested. And we also have examples of some older string formatting methods that technically still work in Python 3, but I would really recommend that you either use the dot format method, or if you like this new fstring method, use that as well. I'm going to briefly just show you what the notebook looks like for this lecture. So you can see here we have a ton of string formatting examples for you, formatting with placeholders, which is something we didn't talk about this video lecture because it's quite an older method and I wouldn't really suggest you use it. But you can also see how we can use precision and padding for floating point numbers. We also have a lot more examples with the dot format method, inserting objects by index position, reusing them. We also have alignments, precision. So all this stuff, a lot of this stuff we're not really going to use throughout the course, but it is available to you in the notebook in case you want to dive really deep into this topic. So we have lots of examples for you there. Okay. Again, all you really need to know about string formatting for this course is that you can use fstring literals to inject and interpolate strings this way, or you can use the dot format method to inject variables that way. Okay, hope that was useful to you. We'll see you in the next lecture. Welcome back, everyone. Now let's begin discussing lists in Python. Lists are ordered sequences that can hold a variety of object types, and they use square brackets and commas to separate the objects in the list. For example, here we can see a list of numbers 1, 2, 3, 4, 5. And lists, just like strings, support indexing and slicing. And lists can also be nested and have a variety of useful methods that can be called off of them. Let's explore all these concepts in a Jupyter Notebook. Let's begin by defining a variable called myList, and we'll set it equal to the numbers 1, 2, 3. So here we can see that a list is defined by these square brackets, and then we have every object type separated by a comma. We just created a list of integers, but we could have also created a list of mixed object types. So the first one could have been a string, the second one could have been a number or a floating point, and this list has no problem. So we can see Python lists are very flexible in the data types they can hold. And if we ever want to check the length of a list, just like we could check the length of a string, we just use the len function that's built into Python and then pass in myList, and it returns back how many elements or items are in that list. So here we have 3 items, string 123.2. Now, just like a string, because a list is an ordered sequence of elements, we can use indexing and slicing. And this works just like a string. So let's show you what I mean by that. I'll say my list is equal to, let's say 1, 2, 3, run that. And then if I wanted to grab the element at index 0, so that's the very first element, I would just say my list 0, run that, and I get back 1. And if I wanted to grab everything starting at index 1 all the way to the end, well, it's just like string indexing and string slicing. I would say, hey, start at index 1, colon, go all the way to the end, and then we have 2 and 3. So this slicing and indexing works just like a string. And you can also concatenate lists together. So let's see this right here. I have my list right now, which is 1, 2, 3. I'm going to create another list, which is equal to, let's say 4, 5. And I can say my list plus another list, and it will concatenate to a new list, 1, 2, 3, 4, 5. Notice here, I'm not actually saving this result. So if I were to call back my list or another list, I can use tab autocomplete here. I still have those 2 separate lists. If I actually want to save this, I need to assign it to something. So we can say new list is equal to my list plus another list. And then if I check out new list, now it's 1, 2, 3, 4, 5. Okay, so those are the basics of lists. So notice right here we have the indexing, slicing, and concatenation. Should feel pretty similar to a string, except what's different than a string here is that we can actually mutate or change around the list. Remember back when we were trying to change letters around in a string, it wouldn't let us. A list has no problem in that manner. So if I check out my new list, it's 1, 2, 3, 4, 5. Let's go ahead and change one of these elements. Let's change 1 to be in all caps. What I could do is say new list at position 0 is now equal to 1 in all caps. Now let's make it really obvious that we're changing it. So I'm going to say 1 all caps. And now if I take a look at my new list, I have 1 all caps, 2, 3, 4, 5. So that's a way you can actually mutate or change the elements that are already in a list. And that's something that differentiates it from a string, besides the fact that it's also holding different element types in braces and commas. So again, strings, you can change them and affect elements inside of them. Another common operation that you may want to perform is to add an element to the very end of a list. And the way we can do that is we say new list dot and hit tab here, and you should see all the various methods that are available to you in a list. The one we're going to show here is the append method. An append allows you to append a new item to the end of a list. So we'll say append 6. And after running this, what we're going to see is that if I check out my new list, I have 1 all caps, 2, 3, 4, 5, and I have 6 now. So notice how append does actually affect the list, and we call this affecting it in place because it permanently changes that new list to have an element at the end of this. So this is known as append, and again, it allows you to place any item at the end of a list. Let's try it one more time. We'll say new list, append, let's say 7, run that, and let's check our new list, and I can see 1 all caps, 2, 3, 4, 5, 6, and then 7. Just because I'm very zoomed in here, it's kind of cutting it off, but if you were to zoom out, you'd start seeing it in a more normal fashion. All right, so we know how to add things onto a list. Let's talk about removing items from a list. To do that, we can use the pop method. So pop is actually going to pop off an item from the end of a list. Let's show you what we mean by that. We're going to say new list dot pop, open and close parentheses. Remember, for a lot of these method calls, if you don't have parentheses there and you just run them, it's going to report back, hey, that's the pop function inside of this new list object. If you actually want to call it, then you need open and close parentheses. And later on, we'll discuss the differences between methods and functions. You've probably heard me use those terms a little bit interchangeably right now. We'll go into a lot more detail about them later on. But right now, we saw that we said new list.pop, and it's popped off the 7, and it's actually returned it as well. And if we take a look at what new list is now, it no longer has the string 7 in it. Now it just goes up to the string 6. So let's actually save the result of a pop. So we can say popped item is equal to new list, and I'm going to say dot pop, and when I run this, what's going to happen is this popped item is now the item that was at the end of that list. So I can copy and paste this, popped item, and now I have 6 saved as the pop item, and it's no longer as part of my list. Now, a common question that arises here is, hey, I don't want to remove something from the end of the list. I want to remove it at a specific index. For instance, I want to remove the one all caps at index 0. Well, it's actually no problem. You can pass in an index position into the pop. We can say new list dot pop and then just pass in the index position of what you want to remove. We can see here that one all caps is at index position 0. So let's pass in 0 there, run it, and we can see that we've popped off one all caps. And if we see new list now, we have 2, 3, 4, 5. So again, pop basically removes items from the list at whatever index location you provide. By default, the index location is -1, the very end of a list. So reverse indexing also works with a list, just like it worked with a string. A few more methods that I want to discuss besides pop and append, which are going to be really common methods you're using, is sort and reverse. So to do this, I'm going to create a new list. Let's zoom in here. Or I'll redefine new list. And I'm going to redefine new list to be a couple of letters here, but we're going to have them sorted out of alphabetical order. There we go. And we'll also make a numbers list. So we'll say num list is equal to, and let's make this just a bunch of numbers out of order as well. Okay, so we have 2 lists. If we ever want to sort these lists, what we can do is call the sort method off of them. We can say new list, sort, and you can use tab autocomplete to do this, open and close parentheses, and this is actually kind of a special in-place method because it doesn't actually return anything. Instead, what it's doing is it's going to sort new list in place, meaning that it doesn't return anything. Instead, when you call back new list again, it's now sorted in alphabetical order, A, B, C, E, X. And that's an important distinction to make because a lot of times beginners will do something like this. They'll say, oh, my sorted list is equal to new list.sort. But what's going to happen here is because new list.sort occurs in place, it doesn't actually return anything for you to assign. So when you call my sorted list, you get back nothing or none. And you can actually check the type of this, and it's going to say that it's a none type. And what none type is the type for a none object. So there's actually a special object in Python called none. Notice the capital N there. And this is just something you can use to indicate no value. And a lot of times people hold it as a placeholder, but really what it is, it's the return value of a function or a method that doesn't actually return anything. So it's a common default return value for functions that maybe search for something and may or may not find it, for example. So that's an important distinction to note here, that when you're using this .sort method, it's actually occurring in place, so you're not going to be able to reassign the result to something else. Instead, if you did want to do that, what you'd have to do is say new list .sort and then say my sorted list is equal to new list. And then when you run that, you can have my sorted list. I'm using tab autocomplete there. and you'd get back your sorted list. So let's try that num list again. So right now num list is unsorted. If I call the sort method off of it, and I check num list again, now it's sorted. All right, let's also discuss the reverse method off a list. As you may have expected, it's going to reverse everything in your list. So it's just reverse, open close parentheses, run that, and it's also in place, meaning it doesn't return anything. And when you call your reverse version of your list, now you have 8, 4, 3, 2, 1. All right, that's really the basics of lists. And the most important methods to understand are the append method and the pop method, as well as the sort and reverse method. And just like strings, we're able to perform indexing and slicing. So if we come back up here, we're able to say indexing as well as slice notation like up here. So that works just like you would expect it to work as it did in strings. The only thing to note here is, unlike strings, we're able to do reassignments like we did up here with a list. Okay, that's the basics of a list. Coming up next, we're going to discuss dictionaries. I'll see you there. Welcome back, everybody. Now it's time to talk about dictionaries. Dictionaries are unordered mappings for storing objects. Previously, we saw how to store objects in an ordered sequence using a list. But now, dictionaries will allow us to store objects using what's known as a key-value pairing instead. And this key-value pair allows users to quickly grab objects without needing to know an exact index location. Instead, you just call the key and it returns the value associated with that key. And the dictionary syntax uses curly braces and colons to signify the relationships between a key and their associated values. So here we can see the curly braces, and then we have the string key, so key 1, then colon, and then whatever value is associated with that. In this case, we just have a string called value 1, and then we have a comma for the next key value pair. Now the question always arises, when do we choose a list and when do we choose a dictionary? Well, dictionaries have objects retrieved by a key name, and dictionaries are unordered and cannot be sorted. So a good time to use a dictionary would be when you want to quickly retrieve a value without needing to know its exact index location. Now that's a really nice feature of a dictionary, the fact that you don't need to know where something is in the actual dictionary to call it, you just need to know the key value pair. However, that comes with the con of not being able to sort a dictionary. Because a dictionary has a key value mapping, it means that it's going to insert new key value pairs wherever it deems most efficiently. Lists, on the other hand, can retrieve objects based off locations. So that allows the actual list to be indexed, sliced, and then sorted. So you kind of lose that functionality when using a dictionary, so you're basically trading off ease of calling and grabbing something from a dictionary very quickly with a key value pair, and you're losing the ability to sort things or have an index location off of them. Okay, let's explore these concepts a little closer by jumping to a Jupyter Notebook. Let's begin by showing you how you can construct a dictionary. We'll start by saying, or create an object, my dictionary, and then we'll have curly braces, and we'll define a key. So keys should be string, and you can call them whatever we want. So we have key 1, and then we have some associated value with that key. For now, we'll stick with basic strings. Then we have a comma, and you can insert a new key value pair. So a colon, and then another value for that. Okay, so we have our dictionary here. And then if we call it back, we'll end up getting the entire dictionary. But really what we want to do is grab values from this dictionary. So instead of using index locations, we still use the same square brackets, but now to get a value back, we just pass in the key that's associated with that value. So we can say in my dictionary, pass in key 1, and we get back that value itself. So a good example of a use case for a dictionary may be something like prices in a store. So we can say I have a dictionary called prices, and we can even call it price lookup. So we have this prices lookup dictionary, and we can have different items in the dictionary, such as apple, and then their associated price. So we'll say apples are, I don't know, $2.99, maybe per pound, whatever. These are made up prices. We can have oranges. Those can be $1.99, and then we can have, let's say chocolate. Well, let's say milk, because it's a little shorter type. We'll say milk, and that's going to have a price of $5.80. And there we go. So then, with my dictionary, and remember this dictionary could be huge, prices lookup, I would just want to know, hey, what's the price of an apple? I'd pass an apple, run it, and it returns back the actual price. And now, without needing to know any sort of index location, I can easily get the prices of any of these objects using the key value pairs. So that's a really good example of why you would need a dictionary instead of something like a list, because here I have two values that I want to associate with each other and quickly look up the value of one given its key. Now it's important to note that dictionaries are actually super flexible in the data types they can hold. I just showed you how they can hold integers or floating point numbers as well as strings, but they can actually hold lists or even other dictionaries. So I'll just show you this as an example. We'll say D is equal to, we could have K1 be equal to a key, and it could have a number associated with 1, 2, 3. Or the other thing I could do is say K2, and I can actually have a list associated with it. So I can say 0, 1, 2, and then I can even do another dictionary inside of this dictionary. This is not that common, but it is supported. So we can say inside key, and then have some other number here, 100. So the dictionary itself has no problem dealing with all of this. And if we ever want to grab elements from this, let's imagine I wanted to grab this list 0, 1, 2. Then I just call D, pass in its key, K2 in this case, whoops, it should be a string. Run this and I get back the list. And then if I wanted to grab this number 100, what I could do is say D, find the associated key for that, K3. And when I run that back, I get back this dictionary. So off of this, I can make another key call. So then I could just say inside key, copy that, run that, and then I get back 100. So notice what's happening here. I'm basically stacking either index calls or key calls to get back the values I want. So let's imagine that I wanted to grab the number 2 here. What I would need to do is say D, K2, which returns back a list, and then I want the item at index 2. So then I could just say 2, and then I grab back 2. And this whole thing can be a little confusing at first, so let me walk through one more example just to make sure this is clear. I will say my dictionary has a key 1, and associated with this key is a list of lowercase letters, A, B, C. I run that, I check my dictionary, key 1, A, B, C, and let's go ahead and try to grab the letter C and make it uppercase because it's a string. What I could do is through various steps do the following. I could say my list is equal to D at key 1, and then if I check my list, I have that, so then I could say letter is equal to my list at index location 2, and then if I check out my letter, I then just say letter uppercase, and then I have capital C. So notice all the steps here that I did. I first grabbed the key, then I made that into a list, then I did the indexing off that list to grab the letter, and then I said uppercase off that letter. But I can actually do this all in one step because of how flexible Python is. I could say, okay, grab that key, which returns back the list. So then off of this, instead of reassigning it, I can just keep calling what I want. So then I want to index by 2. There I have the letter C, and now that this is a string, I can call .upper, and there I have uppercase C. So you could do it this way as well, instead of having to do each of these steps. Now you're not going to be doing something like this so often, but you do sometimes leverage the power of dictionaries to be able to hold lists inside of them. Okay, so I just want you to be aware of that you can kind of stack calls like that on a singular object. If we ever want to add new key value pairs to a dictionary, it's pretty straightforward. So let's make a new dictionary here. We're going to say K1 is 100, and we'll say K2 is 200. So here I have my dictionary, K1 and K2. Let's imagine that I wanted to add K3 is 300. All I need to do in that case is say D, assign a new key, so K3, and set that equal to 300. And then when I take a look at the dictionary, I now have K3 300. All right, so we just saw how we could add a new key value pair to the dictionary. We can also use the same method to easily overwrite an existing key value pair. We can say D of K1 and set that equal to some new value. So to make it really obvious, we'll just have a new string there, new value, and then if we call D, we see K1 now has that new value associated with it. Finally, I want to discuss just a few useful dictionary methods, and those are methods to grab all the keys, values, or items off a dictionary. So we have our dictionary right now, K1, K2, K3, new value 200, 300. I'm going to reassign it to be the old one. So let me copy this right here and say D is equal to that version of the dictionary. If I want to see all the keys of a dictionary, I can say D.keys, and that's going to return back all the actual keys. If I want the opposite and I want all the values, all I need to do is say D.values, and that returns back the values. And then if I want the actual pairings together, I can say D.items, open and close parentheses, run those together, and it returns back the pairing. So K1 goes with 100, K2 goes with 200, K3 goes with 300. And these, you'll notice, are actually in parentheses, and that means this is actually a tuple, which we're going to learn about very soon. Okay, that's really the basics of dictionaries. Let's do a very quick overview of what we just learned. Dictionaries, their main syntax is defined by curly braces. You have a string key, colon, and then a value. And Python's really flexible as far as what this value can be. It can be another string, another list, another dictionary, floating point numbers, integers, etc. And then you can have another key value pair, and you just separate these by commas. The keys themselves should always be strings. And then we can easily look things up by just a key lookup. Again, it uses that same bracket notation we saw earlier with indexing, except now instead of passing in an index position, you pass in the key itself. We also saw how we can call nested objects inside a dictionary by just basically piling on these key and method calls. Then after that, we saw how we could call the keys, the values, and the items off a dictionary. All right, that's the basics of dictionaries. We'll dive into more detailed aspects of dictionaries later on. We'll see you at the next lecture. Hi everyone, and welcome to this lecture on tuples, or tuples as some people like to call them. And in Python, tuples are very similar to lists. However, they have one key difference, and that is they have immutability. So they're immutable, meaning they cannot be changed. And that comes from the term mutation, so they cannot be mutated or changed. And that basically means once an element is assigned to an index position inside a tuple, you can't grab that element and then reassign it to something else like you could with a list. And the way you construct tuples is very similar to a list, except instead of using square braces, you use parentheses. Let's explore tuples a little more in a Jupyter notebook. All right, so let's get started. Hopefully you'll have quite an intuition as far as how to use tuples based on what you've learned about lists. We're going to create a tuple called t. We'll say t is equal to, and then in parentheses we'll write 1, 2, 3. And I'm also going to create my list, which is going to be very similar. We'll say 1, 2, 3, but notice it's square braces, so it's a list. And you can always confirm this using the built-in type function. So if I say type t, it returns back that it's a tuple. And if I ask type my list, it returns back that it's a list. Okay, so you can check the length of a tuple just like you could with a list. So length of t is 3 because there's 3 elements in that list, 1, 2, and 3. And just like a list, it's also fine to mix object types. So we can have a string inside of a tuple along with a number. That has no problems there. And also, just like a list, you can use slicing and indexing. So let's say I wanted to grab that string 1. I could just say, give me what's at index 0, 1 there. I can then also do -1, and I have 2 as a return because it's the last item in that tuple. So far, very similar to a list. There's also 2 basic built-in methods for tuples, and that is the index method and the count method. Let me show you an example of that. We're going to say t is a tuple with a, comma, b. And let's imagine we wanted to count how many times the letter A shows up in this tuple. I can say t, and then if you hit tab here, you should see the 2 options you have, either count or index. So right away, you'll notice that there's way less methods available for tuples than there are for lists. So we're going to say t.count, and then we'll pass in a, and it returns back how many times a occurs in that tuple. And then what you can also do is say t.index of a, and this returns back the very first time this appears in your tuple. So notice that if it appears more than once, it'll only return back the index location that it appears at first. And if we do the same thing for b, the very first time a b occurs is at index 2. So if we take a look at t, it's right here, AAB. Later on, we'll learn how to use control flow logic like for loops to grab all the index locations of repeated elements. And finally, let's get to really what makes a tuple different, and that's the immutability. And I really can't stress enough that this is what makes a tuple different than a list. So let's check out our tuple right now, and let's also check out that list we created, my list. Let's reassign the first element of my list to be the string new. So right now, my list has no problems with that. It says, okay, I'll reassign the first element to be new. If I try to do the same thing with the tuple, and I say new here, it's going to say type error, tuple object does not support item assignment. And that's basically what makes a tuple different than a list. Now I'm sure you're wondering, well, why would I even bother using tuples when they have fewer available methods and they don't have the flexibility of a list? And to be honest, as you're beginning to program, you're not going to be using tuples that often. It's only as you become more comfortable with Python and become a more advanced programmer that you'll begin to see the benefit of tuples. And what you're going to be using tuples for mainly is when you're passing around objects in your program and you need to make sure that they don't accidentally get changed. And that's when the tuple really becomes a great solution. So it provides a very convenient source of what's known as data integrity. The fact that we can't do reassignments like this by accident, we'll get an error instead, is going to be really useful when you want to make sure that elements don't get flipped or reassigned later on in larger pieces of code. So kind of keep this in your toolkit, and later on I'm sure we'll be pulling out the tuple again so we can use it and really let it shine. For now, just remember that it has immutability and it looks really similar to a list, except we use parentheses instead of square brackets. Okay, that's it for tuples for now. Up next, we're going to show you how to do basic file input and output. We'll see you there. Welcome back, everyone. In this lecture, we're going to very quickly cover what sets are. And sets are unordered collections of unique elements. And this basically means that there can only be one representative of the same object. So you can't have the number 2 in there more than one time, or the letter A in there more than one time. Let's see some examples of how to work with sets in the Jupyter Notebook. To begin, let's create a set, and we can do that by saying my set, or whatever variable name you want, is equal to set, and then open and close parentheses. So right now we have my set, and it's just an empty set, so it returns back set. If we actually want to add an object to the set, I can say my set, and then call the add method, and we can add one object to this. So let's add the number 1. And now if I take a look at my set, I see it has the number 1 there. Now notice it looks like it's a dictionary because of these curly braces, but it's not because it doesn't have key value pairs. It's just unordered collections of any items you want. So let's add in another object here. We'll say my set, add in the number 2, and then if I call my set again, whoops, if I call my set, I get 1 and 2 there. Now let's try adding 2 a second time and see what happens. If I call my set, it still just shows 1 and 2. It doesn't show 1, 2, 2. And this is basically what a set is. It has to be unique values in there. If you try to add a value that's already in the set, it won't repeat it. It'll just say, hey, we already have that value in there. I only accept unique values. So when you're working with sets, it may not be super useful to add them in this manner. Instead, what it's really useful for is maybe casting a list to a set that we only get the unique values. So for instance, we'll say my list is equal to, and I'm going to place a bunch of repeated values in here. A bunch of 1s, a bunch of 2s, and a bunch of 3s. I'm going to run this, and then I'm going to cast this as a set, and now I get back only a set of the unique values. Keep in mind, sets don't technically have an order to them. Since we're dealing with very small sets here of just a few items, it looks like they have an order, but in reality, sets don't have any particular order to go in. For now, that's all you need to know about sets. We won't really touch upon this object or data type again until much later in the course. Since we're just beginning, it won't be very useful to us now, but later on we'll be able to see different use cases for it. Again, remember just that sets are unordered collections of unique elements. Thanks, and we'll see you at the next lecture where we discuss Booleans. Hey there, welcome back. In this lecture, we're going to briefly discuss Booleans. Booleans, in case you're unfamiliar with this term, is basically a term to use for operators that convey either true or false statements. And these are really important later on when we deal with control flow and logic, because lots of times we want to check if a certain condition has happened. In other words, if a certain condition is true in order to execute some code. For example, you may want to check, hey, is my pool empty? If that is true, then go ahead and turn on the water to fill up the pool, or other things of that nature. So that's why Booleans are really important. And a lot of times we won't be dealing with Booleans directly in the terms true and false, but we'll actually have comparison operators and logical operators that return a Boolean value. So let's very quickly show you what these actually look like, and then we'll explore them later on in a lot more detail when they become more useful to us. Let's hop over to a Jupyter Notebook. Okay, so Booleans, there's true and false, and in Python you need to make sure that you have capitalized T in order for it to be true. Otherwise, if you have lowercase t, it's just going to complain, hey, you didn't define this term true because it thinks you're calling a variable. Instead, make sure that you have capitalized T, and it's the same for false. You're going to need to capitalize F for false. So here we have true and false, the main Booleans, and we can check their type by saying type, oops, make sure I capitalize that T, type false, and it says BOOL for Booleans. And Booleans is what we're going to be dealing with when we're dealing with logical code. And a lot of times what we're going to be doing is working with comparison operators to create Booleans. And we're going to go over all the comparison operators later on in this course, but to show you a very simple example, there's comparison operators that check if something is greater than something else. So we can say, hey, is 1 greater than 2? So it's just a simple mathematical expression there. And it returns back a Boolean false. 1 is not greater than 2. And then you can do other things like check for equality with 2 equal signs instead of just a single equal sign. So is 1 equal to 1? Run that and it returns true. So these are called comparison operators, and we'll be showing you all of them later on in this course, but we first have to tell you what they actually are returning, which are Booleans. Alright, so those are Booleans, just simply true and false, and the type is BOOL. They'll be critical later on in this course. And finally, I want to mention that we can use the none keyword as a placeholder for an object that we don't want to assign yet. So maybe later on I want to assign B to something in my code, but for right now I just need to have a placeholder for it so I don't get this error of, hey, B is not defined. What I can do is say B is equal to none, notice the capital N there, and it's a none data type. And we've actually seen that before when we were dealing with in-place methods off a list. Remember that when we sorted a list in place, it returned back none, so when I type B here, I don't see anything out, but then what's nice is I also don't see that error of it not being defined. Okay, that's really the basics of Booleans. We're going to work on this a lot more later on in the course. I'll see you at the next lecture. Welcome everyone to this lecture on files. And before we finish off this section of the course, we already learned about all the basic data types. I now want to quickly go over how to perform simple input and output with a basic text file. And the methods we show here will also expand further to working with other file types, whether it be an audio file, text file, emails, Excel documents. A lot of what we cover here is going to be really relatable to those more advanced functionalities. Now keep in mind, for some of those other topics, you may need to install certain libraries, which we're going to discuss later on in this course. For right now, we're going to deal with just basic.txt files. So we're going to create one using the Jupyter Notebook, and we'll also discuss file paths on your computer. Let's get started. To begin, what we need to do is create a text file to work with. Now, if you downloaded those notes, there's actually already a test.txt file. So in your folder somewhere, there should be a test.txt file in the same folder as these notes are in. So keep that in mind, but I'm going to show you how you can use Jupyter's magic functionality, or so it's called, in order to quickly write a text file. So this only works in Jupyter Notebook. So write %, write file, space, my file.txt, or whatever you want to call it. So this has to be on the first line of the cell. And then here you can just write plain text of whatever you want is in the cell. So I can say, hello, this is a text file. This is the second line. This is the third line. Let me make sure I spell that right. So again, this only works in a Jupyter Notebook. If you don't have Jupyter Notebooks, maybe you're working in Sublime Text Editor, go ahead and just write this into a file and save it as a .txt file in the same location as wherever your scripts are running. So we're going to run that, and you should see successfully wrote my file.txt file. And now what we can do is actually open up and play around with these files. Now it's a very common mistake to accidentally either write the wrong name of the file or save the file in the wrong directory. So let me show you what that typically looks like. We'll say my file is equal to, and we use the open function. And in this case, I know my file.txt is there because I can just write my file.txt, and we need to write this as a string. So write that, and then we'll get no error because it happens to be there. If I ask for a file that is not there, we'll say my file is equal to open, and we'll say whoops, wrong txt. So I definitely know there's no file there. If I run this, we'll get a file not found error. So this is a really common error. It's called error number 2, no such file or directory, whoops, wrong.txt. So there's really only two possible ways to get this error. One way is that we accidentally passed in the wrong file name. So in this case, I wrote whoops wrong txt file. So that's the wrong file name. The file name should have been myfile.txt. Now, the other possibility is that I actually didn't provide the correct file path. And we'll discuss that more later on in this same lecture. But maybe you have whoops wrong.txt on your computer, but it just doesn't happen to be saved in the same location as your Jupyter Notebook. To know where your Jupyter Notebook currently is, you can type pwd into a cell, run that, and that will print your working directory. So this directory is where this notebook is currently located, and that's the same location that any .txt files you want to work with should be saved. Later on, we'll show you how to call a text file from any location on your computer, but for right now, make sure that the text file you're working with is saved to the same location that is output when you type pwd. All right, continuing on, we know that myfile.txt is in the same location because we use this special command to write it there. And if you don't want to use a special command, you have the test.txt file from the zip file of notes. So let's continue on here. We'll say my file is equal to open, and we're going to open that text file we just made, which was called myfile.txt. Myfile.txt, run that. And now there's several methods I can call off of this. One method I can call is the read method. And what this does is it returns just a giant string of everything that's in this text file. Sometimes that's good, sometimes you don't want that, but it is a method that's available to you. You'll notice here that we have this \n, and what this does is it indicates a new line. Because you asked for everything as a single string, the string somehow needs to represent where the new lines were in your text file. Because remember, we wrote, hello, this is a text file. Here on a second line, we wrote second line, and on a third line, we wrote third line. So in order to represent that, we have these escape sequences that we discussed earlier in the string lectures, and \n represents new line. Now, if I try to read this file again, you'll notice something funny happens. You get back an empty string. So a lot of times beginners are scratching their head thinking, well, what the heck happened? I just read it, and now when I try to read it again, it's no longer there. The reason this is happening is because you can imagine that there's a cursor at the beginning of the file, and when you read it, the cursor goes all the way to the end of the file. And you need to reset the cursor or seek it back to 0 in order to read it again. So to do that, you can say my file seek 0. That resets the cursor. You should see some 0 output there. And now if you call read again, you'll be able to see this. Keep in mind, if you ever want to read again more times, you'll have to reset that. You'll have to say my file seek 0. And then you say my file read, and let's save this as contents. And now if I check my contents, that's just one giant string. So that's the read method, and it allows you to grab everything as one giant string. Sometimes that's not really useful because you'd actually want to have a list where each single element in the list is one line in a string form of the actual text file. And to do that, it's actually quite simple. You can use the read lines method. So we're going to seek back to 0 and then say my file read lines, and note what we get back here. Now we have each line as a separate object or element in this list. And a lot of times this is more convenient to work with because now I can loop through this list, which we'll learn about later on, or I can index off of this list for the lines themselves. All right, so those are the basic methods of reading a basic text file, which is .read to grab everything as a string, or read lines to grab a list where each element represents a line. Keep in mind, you still have that \n there at the end of that. Let's move on to discussing file locations. Now previously we just showed you how to open a text file that happens to be in the same location as your Python script or Python notebook. But what if you want to open a text file that's saved in another location on your computer? It'd be really annoying to have to constantly be moving around your Python scripts or your notebook location to be at the same location as that text file. So to open a text file that's at any location on your computer, all you need to do is provide the full file path. Keep in mind, however, the syntax for a file path is slightly different depending if you're on Windows or if you're on macOS or Linux. So for Windows, the typical file path is going to look something like this. You'll say C:, and then note that we have the double backslash, and this basically is an escape character so that Python doesn't confuse this first backslash as an escape character. Because imagine if your username had a lowercase n, you don't want Python suddenly thinking you mean new line. So that's why we have double backslashes here. So this is for Windows, and it looks something like this. And you just pass in the whole file path as a string to your text file. If you're on macOS or Linux, it looks a little different. You have forward slashes here, and it goes users, your username, whatever folder, and then to the text file. If you ever want to check what this actually looks like, all you need to do is use that handy pwd into a cell again, and you'll notice that I already have kind of the format of what it should look like. I'm running this on a Windows computer right now, so it shows me what the format is, and then from there I can copy paste and then play around with this, add folder paths, etc. in order to grab the right text file. To finish off this discussion of files, I want to mention best practices for opening files. Right now we open this file and we called it my file, but technically because it's open we actually have to close it. We have to say myfile.close in order to not get any errors, because let's say you opened this file somewhere else on your computer and you were trying to delete it, you'd get an error saying, hey, Python is still using this file, and you'd have to actually manually close it once you were done working with it. To avoid any such errors, what you can do is use the special with statement. And it looks like this. You'll say, instead of saying something like this, let's first see the old way, which was my file open test.txt. So that was the old way of doing things. And I believe it was called myfile.txt. What we can do is say with open, and then we'll say as, and then whatever you want to call this. You can say my new file. So this is the variable name you choose. And then you have a colon there. And then notice what happens here. When I hit enter, I have an indentation. And basically what this means is that any code here that's within this block, this indented block of code, is going to use my new file as the variable of this text file. So then I can say contents is equal to my new file read. And when I run this, I no longer need to worry about closing the file. Let me quickly check that that was the right text file name. We'll come up here and confirm that, and we were right. Okay, so let's run this and see what happens. So I run that, and now I no longer worry about closing the file, and I can still grab the contents that were in this block of code. And we're going to get used to this idea of these indented block of codes a lot more in the next section of the course. Okay, let's finish off this discussion by talking about reading and writing to a file. Right now, you may have noticed that we've basically just been reading files, but we can also write to files and overwrite files. And that's a key difference that we need to appreciate. So we're going to say with open, and I'm going to say with open myfile.txt, comma, and what I'm going to do here is right with my cursor right next to open, I'm going to do shift tab. And what this does is it opens up information for functions that have already been defined. So later on we're going to define our own functions, but you'll notice open is a built-in function. So you can see here some documentation, and this is why I love using the Jupyter Notebook for teaching Python, because just with the term shift tab right next to the function, you get all this really useful information. You can have plus here to see even more stuff. So you basically have the documentation right here in your notebook without needing to go online. All right, so notice here there's a mode, and it's set by default equal to R. So we're going to copy this, and paste it right here. Say mode is equal to R, and then say as my file content is equal to my file read. So when I run this, there's no problem. I see the contents, and there it is. Now let's switch this to W, which stands for write. If I try running this cell again, it will say, hey, unsupported operation, not readable. And that's because depending on what mode you choose for opening your files, you may only choose to write to a file instead of being able to read to a file. And this is basically known as permissions. Sometimes you're going to want certain scripts to only have permissions to write to a file or only have permissions to read to a file. And sometimes you want them to have both. So what we can do here is the following options. We can use R for read or W for write, and this will overwrite files. Or we can use A to append to files, and append is basically just adding more lines to the end of a text file. Okay, so let's take a little bit of time to discuss the reading, writing, and appending modes. So we just showed you that you can edit that mode. Let's discuss all of them very quickly one more time. If you set mode is equal to R, that's read only. If you set mode equal to W, that's write only. So this will overwrite files that already exist. Or if you try to open a file that doesn't exist already and you open it with mode W, it'll actually create a new file, and we'll see that in just a second. And then mode A is to append only, and this adds on to files. R plus is for reading and writing, and then W plus is opening a file for both writing and reading, and that again will overwrite the existing file if the file exists. If the file does not exist, it creates a new file for reading and writing. So to play around with these, let's create a new file, and I'll do this from the Jupyter Notebook. You can do this from any text editor as well, but I'm going to write my new file.txt, 1 on first, 2 on second, 3 on third. I'm going to run that to confirm that I've just created my new file.txt. In this case, I overwrote it because I'd run this more than once. But let's do the following. We'll say with open, and we'll say my new file. And you should be able to actually tab autocomplete this. So my new file.txt, mode, we'll say read only, as f, and then I'm going to print f.read. And there I can see 1 on first, 2 on second, 3 on third. So that's the read mode, which is quite useful for reading. Let's say I wanted to add a new line to this. I could say with open, my new file.txt, I will say mode is equal to, and in this case I'm going to say A because I want to append a new line to this. We'll say as f. And if I want to write to a file, all I have to do is say f dot, and as you may have expected, instead of read, you say write. And let's write a new line to this. We'll say 4 on fourth. So notice what I'm doing here. Because I'm using append, that means the cursor is all the way at the end of this text file, and then it's going to append or add on a 4th line to it. So I'm going to run that, and then let's rerun the code up here. I'm going to copy and paste this to a new cell. And if I run this again, now I see 1 on first, 2 on second, 3 on third, 4 on fourth. Something I didn't actually take into account here is that I forgot to add in a new line. So what I could have done is say \n here to actually insert a new line. So if we run these two cells again, now we see 4 on fourth. Now unfortunately I still have this 4 on fourth here, so I'm going to reset everything by coming back up here and overwriting that file one more time. So let's run these again, run this cell again, and then run this cell again. And now I can see 1 on first, 2 on second, 3 on third, 4 on fourth. So that's the difference between reading and appending. Now let's explore W for writing. I can say with open, and here I'm just going to make up a bunch of letters, .txt, and I'll say mode is equal to W. And remember, with this W mode, it's going to overwrite an existing file, or if the file doesn't exist, it will actually create it. So we can make up a name there, say as f, and then say f write. I created this file. Run that, and there's no error. It's because even though this text file doesn't exist, since we opened it with mode W, Python went ahead and created that text file for us. If we had tried to do the same thing with a different mode, such as just R or just A, we would have gotten an error there. So then we'll go ahead and read this file. We'll say with open DHF, and I really encourage you now just to do tab autocomplete so you don't have to memorize all that. We'll say mode is equal to read as F, and let's print out f.read. And there we can see I created this file. So those are the basic ideas of opening files in either append mode, write mode, or read mode. And you can see a lot more examples of this in your notebook that goes along with this lecture. Okay, thanks everyone, and I'll see you at the next lecture where we actually begin testing you on a lot of the topics that we discussed here. Welcome back everyone. Now that we've gone over the basics about objects and data structures in Python, we're going to have an assessment test to quickly check your understanding. So we're going to do a quick overview of your first test in this lecture. And as a reminder, you can download all the notebooks that go along with this course from GitHub or as a zip file from the course overview lecture. So check out those first couple of lectures. We explain how to get all the information, all the notebooks there. And then you have the option of either downloading the notebook and then answering the questions directly in that notebook, or you can just open up the link and then open up your own notebook locally and answer the questions there. So let's very quickly show you how to do this. I'm going to open the GitHub link right now. Okay, so this is what the GitHub page looks like. We've already shown you this before in the early lectures in this course. Come to Python Object Data Structure Basics, and as a reminder, you can click on here and then download zip to download everything as zip file. You unzip it, you have those notebook files, and then you can use Anaconda Navigator to go to wherever those zip files or those unzipped files were saved. Click on Python Object Data Structure Basics, scroll down here until you get to Assessment Test. Notice there's also a solutions file. In the very next lecture, we'll go through the solutions. So all the tests here that are in notebook form, you can do a self-assessment against the solutions lecture or the solutions notebook. Let's click on that assessment test. And this one's going to be pretty straightforward. Because you don't know a whole lot about Python right now, we can't give you too many technical questions. Later on, as you learn about functions and object-oriented programming, the questions are going to get a lot more technical, and there's going to be kind of a right answer and a wrong answer. But right now, these are pretty basic questions. The first one, I just want you to write a brief description of the following object types and data structures that we've learned about: numbers, string, lists, tuples, and dictionaries. This is really just for you to quickly write down, make sure you understand what the differences between a list and a dictionary are, for example, or the differences between a list and a tuple. So as a reminder, you can click on any cell and then change the cell type to Markdown in case you want to write yourself some notes. Up next, we have just a couple of questions about the numbers lectures. So I want you to write an equation that uses multiplication, division, and exponent, addition, and subtraction that when you put it all together is equal to 100.25. So this is just to make sure that you remember all these arithmetic signs. Should be pretty straightforward. And this is just to test your memory. Again, you can just work backwards from 100.25 to actually grab the numbers that makes that work. Then I want you to answer these three questions without typing any code, and then use code to check your answer. So I want you to see what's the value of this expression, and this expression. So this is testing order of operations, see if you remember that. And then here's an interesting question. What is the actual type? So that's the data type of the result of here. So as a hint, we have an integer being added to a floating point number being added to an integer. So what would the type of that be? Then I want you to find a number's square root as well as its square. So find its square root and then figure out what its square is. So to the power of 2. Okay, then we have strings, and for the given string hello, give an index command that returns the letter E. So you're going to enter your code below right here, so print out E using indexing. Then I want you to reverse the string hello using slicing, so we kind of showed a quick way to do that later on, or earlier in the course I should say. Then given the string hello, give two methods of producing the letter O using indexing. So notice O is the last letter in the string S, so there's two methods of grabbing that last letter. See if you can figure them out using indexing. Then lists, I want you to build the list 000 two separate ways. Go ahead and review the lists lecture to figure out how to quickly build out the list two separate ways. Then I want you to reassign hello in this nested list to say goodbye instead. So using indexing, grab hello and then reassign it to be goodbye. Then I want you to sort this list below, so see if you remember that method call. After that, we have dictionaries. So this one's going to be a little tricky because first off, we start off with just simple grabbing the keys and value pairs. So for this first dictionary, or really all the dictionaries, I want you to grab the string hello. The first one should be pretty basic. You see here you have a simple key, and then you have hello. So it's just D and then simple key. So I kind of gave you the answer for that one. The second one's going to get a little more complicated. So let's zoom in and really look at it here. Notice that we have a dictionary nested inside another dictionary. So you're going to need two calls there. And I recommend that you break this down in steps. Then we have something that's even a little trickier. And just as a quick reminder, these are pretty unrealistic expressions of dictionaries or lists. This is just for you to practice indexing and key calls. So again, try to grab hello from this. And if you're able to do it, then you really understand indexing and lists. And then finally, this is the last one. This is going to be pretty hard and annoying, but just break it down step by step by grabbing keys and then index key and then maybe another index, etc., until you get to hello. Then I have a quick little question here that we've probably asked you before. Can you sort a dictionary? Why or why not? Then we have tuples. So what's the major difference between tuples and lists, and how do you create a tuple? Then we have sets. So what is unique about a set? What makes a set different than, say, a dictionary? And then I want you to use a set to find the unique values of the list below. And then finally, we have a section on Booleans, and this is a bonus section, so you don't really need to do this if you don't want to, because it uses comparison operators, which is going to be the very next section of the course. So consider this kind of a bonus section for you to read through, because in the very next section, we're actually going to cover a lot of this. But what we see here are operators. So these are comparison operators, the description of the operator, and then an example of the operator. And I want to see if you can kind of teach yourself what these comparison operators are in order to answer what the outputs are here. And even if you don't really know comparison operators formally in Python, it should be pretty obvious what something like this would be. Is 2 greater than 3 if you've done some basic mathematics before. Again, this is an optional section because we haven't officially gone over comparison operators. We're going to do that in the very next section of the course, so kind of think of this as a bit of a preview before that. Then we have one final question. What is the Boolean output of the cell block below? So again, a bonus question here for you. Okay, so best of luck, and in the very next lecture, we're going to go over the answers for all of this. Again, these are more kind of open-ended questions. Later on in the course, we're going to get a lot more technical in our questions as you learn more. We'll see you at the next lecture for the solutions. Welcome back, everyone. In this lecture, we're going to quickly go over the solutions for the Objects and Data Structures assessment test. So first off, we had that first question which just asks you for a brief description of all the following object types and data structures. We're going to go through that first and then head over to the notebook. So numbers, pretty straightforward. There's basically two types of numerical information that we can store. Those are integers for whole numbers, and floating points are numbers of a decimal. Then we have strings, which are an ordered sequence of characters, lists, which are an ordered sequence of objects, and lists are mutable, meaning you can change items that are in a list. Tuples, very similar to lists, except that they're immutable. They're still an ordered sequence of objects themselves. And then dictionaries, those are key value pairings, and remember those are unordered. So now let's hop over to the other questions in the notebook. Alright, here I am at the solutions lecture. Pretty straightforward stuff. We just went over the first question, which was just answering about the data types. Then we have numbers. So all we had to do for this one was write an equation that uses all the various arithmetic methods we just discussed. And your answer is probably different than mine, but all you had to do was use multiplication, division, exponents, addition, and subtraction to somehow get back to 100.25. So a lot of this is just practicing order of operations, and you can just work backwards from 100.25 to make up your equation. All right, so your answer is probably different than mine, but here's an example answer. Then we wanted you to answer these three questions without typing any code. So what's the value of this expression, and this one, and this one? This is just to make sure you understand order of operations. So in this one, this first one, we're going to add these together before multiplying. In this one, we're going to multiply these two together before adding 5. And in this one, we're going to multiply these together before adding 4. And then the next question, what is the type of the result of the expression 3 plus 1.5 plus 4? So the answer for that one is a floating point number, because once you introduce a floating point number into this equation, it doesn't matter how many integers there are there, we're going to get a floating point number. Now the question, what would you use to find a number's square root as well as its square? So to get a square root, you can just mathematically say something to the power of 0.5 is the square root of the number. Later on, we're going to introduce the math library that will allow you to actually import a math function for doing the square root automatically. But in this case, this is a way to use a clever trick with exponents to get the square root. Then for the square, well, you know that's just asterisk, asterisk, and then 2. Next up were the strings questions. So for this one, given the string hello, we wanted you to list out the index commands to grab the letter E. So in this case, if we just count over from 0, let's zoom in one more level so we can clearly see this here. So 0 is at H, that means E is at 1, so we just had to say S of 1 returns E. Then we wanted to reverse the string hello using slicing. So we showed you this trick, but basically it means go from the beginning all the way to the end in a step size of -1. So a nice little trick there that'll reverse the string. And the reason that it's working is because you're going backwards through the string because your step size is a -1. Then we wanted you to give 2 methods of producing the letter O. So the ways to do that is using S to the negative, or S indexing at -1 to grab the very last letter of that string, or just counting from the beginning up to index 4. So those are 2 different ways of doing that. Then we had lists, and for this one we wanted you to build the list 0, 0, 0 in 2 separate ways. So the first way you probably did it is actually the second method listed here, which is just actually constructing the list using square brackets, pretty straightforward. But we also mentioned that you can use multiplication of a single list earlier in the course. So here we have this list 0 multiplied by 3, and now we see it here 3 times. Up next, we wanted you to reassign hello in this nested list to say goodbye instead. And the way you do that is you had to use indexing twice. So here we go 0, 1, 2 to grab the entire list, and then we go 0, 1, 2 to grab hello. And this is why we have 2, 2 reassigning to goodbye, and we get back the result here. After that, we wanted you to sort the list below. So there's different methods you could have done. One method that we showed you was this dot sort method, and then you just call the list again. But there's also a built-in function that I want to just introduce to you now, which is called sorted, and that allows you to pass in the list, and this one actually returns the list itself. So notice what's happening here. This dot sort method does it in place, meaning you need to call the list again in order to see the results. The sorted function will actually not do this in place, but instead return the sorted version. So that's the difference between using sorted and calling .sort. Moving along, let's talk about dictionaries. So using keys and indexing, grab hello from the following dictionaries. And this starts off simple, but then gets harder and harder. First one, pretty straightforward. You just pass in simple key to get hello. And in the second one, you have 2 key calls here. So first you do K1, and that brings back this dictionary. And then to get hello from this dictionary, you just say K2. Then this one's getting a little trickier. So first we have to call K1, which brings us back this entire list right here. Then we have to call 0 on that list, because notice, and this is kind of the really tricky part, is that this is a list of 1 element. So in order to grab that dictionary, you had to call 0 there. So that one's really tough. And then the next one is nest key. So from there, you're just kind of dealing with a normal dictionary. And then you have that list coming out. So we want to grab the second item in that list. And a lot of people get tripped up by this last one. Why is there a 0 there? And that's because, just like before, we have a list of 1 element there. So if we just want to grab that 1 string element, we can say 0 and then get back hello. And then finally, the really tough one, which was, this is hard and annoying. So this one's a little crazy. And again, don't worry about real life code. Hopefully you never have to deal something with that. And if you do, this is really bad programming, but it's a pretty good question for practice. So what we do here is we say, grab the first key, then grab the second item from the list that returns, then grab K2 from that dictionary in here, grab at index 1, this dictionary right here, then we say grab tough, and then we just do some more indexing to finally grab hello. And again, there's a 0 at the end because this is a single item in a list. And what's really useful for you, if you need to kind of break this down and understand it, is just build it out step by step in some cells. So first run this, just d of k1, then run the next step, dk1 with 2, then run the next step, dk1 with 2 of k2, and so on until you get the result. Then can you sort a dictionary? Why or why not? The answer is definitely no, you cannot sort a dictionary because normal dictionaries are mappings and they're not a sequence. And if you're a beginner and you're dealing with really small dictionaries, this definitely isn't clear at first, but I can't stress enough that normal dictionaries are mappings and not a sequence, and they cannot be ordered. Later on, we're going to learn about some special libraries that do allow us to use kind of a dictionary-like object, which is called an order dictionary. But right now, normal dictionaries, you cannot order them or sort them. Then we have tuples. What's the major difference between tuples and lists? Well, tuples, as we learned, are immutable. And how do you create a tuple? Just with parentheses, as shown here. What's unique about a set? The answer is that they don't allow for duplicate items, so kind of a hint there just with the word unique. And then we wanted you to use a set to find the unique values of the list below. So here you have this list, and then you pass it in through the set, and now we get all the unique elements of that list. Finally, we have booleans, and we had a little table here for operators. This is a bonus section because basically the very next section of the course is going to discuss comparison operators and logical operators. So you can see here the operators we have. We're going to explain this in a lot more detail in the very next lecture, but you have a description here and then an example. A lot of these are pretty straightforward. This is checking for equality, inequality, greater than, less than, greater than or equal to, and then less than or equal to. So hopefully just by learning that little table there, you can see that 2 is greater than 3, that's false. Is 3 less than or equal to 2? Well, that's false as well. Is 3 equal to 2.0? That's definitely false. And this one's kind of interesting. Is 3.0 equal to 3? Well, that's actually true. So Python, in this case, doesn't actually care that this floating point, and this one was an integer. As long as they hold the same value, it says they're true there. And then finally, is 4 to the power of 0.5 not equal to 2? Well, remember, to the power of 0.5, that's the same as the square root. So 4, square root of 4 is 2, so 2 is equal to 2, meaning the question is 2 not equal to 2 returns false. And then a final question here, also a bonus. What's the Boolean output of the cell block below? Well, let's take a look at it. L1, 2 of 0. So where's that? We have L1 at index 2, 0, 1, 2. We have another list. And then we want 0, so that's 3. So we know L1 right here at these indexings is actually asking for the number 3. So is number 3 greater than or equal to whatever this is? So let's take a look at that. We want 0, 1, 2, so 0, 1, 2 at key 1, so that's 4. So it's asking, is 3 greater than or equal to 4? And we know that's false. So that's the final bonus question. Okay, definitely these questions are a little more open-ended. They're not quite as structured. Later on, we're going to see a lot more structured questions that kind of have more technical right and wrong answers, and you're going to be able to kind of more efficiently program your way through the future tests. Thanks, everyone, and I will see you at the next lecture where we discuss comparison operators and logical operators. We'll see you there. Welcome back, everyone. In this lecture, we're going to formally discuss Python comparison operators. And we actually mentioned these at the very end of your previous assessment test. Hopefully they were pretty straightforward, but in case they were a little confusing, now we're going to formally dive into them and show you how you can return back Boolean values using comparisons. Let's open up a Jupyter Notebook and get straight to it. Alright, so here I am at a notebook, and before we get started, I want to briefly mention that in the comparison operators notebook that goes along with this lecture, it's underneath the comparison operators section, there's actually a table of comparison operators, same table from the previous assessment test that has the operator, the description, and then an example of it. So let's get started. Basically going to walk through all of them. Should be pretty straightforward. A little quick lecture here. Often you're going to want to check for equality. So to do that, it's just double equal signs. So 2 equals 2. Run that, and that's true. If we check it out on something else, for example, is 2 equal to 1, we get back false. And the reason we have 2 equal signs is because we don't want to use a single equal sign, otherwise Python's going to think you're trying to assign a variable there. And you can use this not just for numbers, but basically any objects. So I can check, is the string hello equal to by? And if I run that, it says false. And notice when you're comparing strings, capitalization counts. So you can't do something like this. And that returns false because one is lowercase b and one is uppercase b. And you should also be aware that Python is going to consider types. So for example, the string 2 is not going to be equal to the number 2 or the integer 2. For floating points, as long as they hold the same value, they will be true. So 2.0 is going to be the same as 2. So that's equality. For inequality, you can use the exclamation point equal sign. So if you're going to say, is 3 not equal to 3? Well, that's false because 3 is equal to 3. And let's show you an example of where it's going to return true. So is 4 not equal to 5? That returns true. So we have equality, we have non-equality or not equal. We also have greater than, so I can say, is 2 greater than 1? That's true. Is 1 greater than 2? That's false. Then we have less than, so basically the reverse. Is 1 less than 2? That's true. Is 2 less than 5? That's also true. And then we have greater than or equal to and less than or equal to. So I can say is 2 greater than or equal to the number 2. In this case, it's true because they're equal to each other. And then we can do a similar thing. We can say is 4 less than or equal to, for example, 1, and that's false. And you can see a bunch of other comparisons right here in this notebook. Pretty straightforward stuff. A lot of times what we're really going to be using is the equality. But coming up next, what we want to discuss is if you want to make more than one comparison at a time. So far, we've just been comparing two numbers or two objects, so 2 and 2, 1 and 0. But often, you're going to want to do multiple comparisons on the same line. And to do that, we're going to use something called logical operators, which will allow us to chain together comparison operators. So we'll discuss that in the very next lecture. I'll see you there. Welcome back, everyone. In the previous lecture, we learned about comparison operators. Now we're going to discuss how to chain together different comparisons. And we can do this with the use of what are called logical operators, and they allow us to combine comparisons. And the key logical operators we're going to be discussing here is the AND keyword, the OR keyword, and the NOT keyword. So let's explore how to use these keywords, as well as chaining comparisons without the use of these keywords. All right, let's imagine that we wanted to have a condition that executed when we actually did two comparisons. For example, we wanted to check if 1 was less than 2, and we also wanted to check at the same time if 2 is less than 3. So you can imagine that instead of these direct numbers, we'd be using variable names that maybe get changed somewhere else in our code, but to keep things simple, we're just using direct integers. So to chain these two together, what we could do is do the following. We could say, is 1 less than 2, and is 2 less than 3? So when we run this, we get back true because this chain comparison is true and this comparison is true. If we were to change one of these, so for example, if I switch this to ask is 2 greater than 3, we get back false because even though this first one is true, this second one is no longer true. Now you could use this sort of chaining together, but alternatively, you can use a logical operator. And the one you would use to basically rewrite this code here is the AND keyword. So instead of the following from above, I could say is 1 less than 2, and notice that syntax highlighting there, is 2 greater than 3. And that returns back false as well. And I could switch this to be less than, and then that returns true. So all the AND keyword says is, hey, is what's on my left true, and is what's on my right true? And remember, these could be any sort of comparisons. So I'm going to show you another example. We could do something like, is H equal to H, the string, and is 2 equal to 2. We run that together and we get back true. Sometimes when people are writing out their code, they like to add in a little more organization by kind of wrapping these comparisons in parentheses, and you'll see me do that from time to time. For some people, this is a little more readable. For others, it's less readable because you're inserting more stuff. It's up to you whether you want to use these or not. There are certain libraries that we'll talk about later on that do require you to have these parentheses. But for now, it's basically up to you. If you think with the parentheses more readable, go ahead and use them. If you like it that it's a little kind of sleeker without the parentheses, you can go ahead and do that as well. But just keep in mind the AND keyword says it's what is on my left true and is what's on my right true. And then it returns a Boolean based off that. Okay, so pretty straightforward so far with the AND keyword. As you may have suspected, there's also an OR keyword that we mentioned previously, and that just needs one of the conditions to be true. So again, we'll use numbers. We'll say is 1 equal to 1, or is 2 equal to 2. So we run that and we get back true. However, the OR only needs one of these conditions to be true. It just needs the one on the left or the one on the right to be true. So I can show you what I mean by that. I'm going to make one of these definitely not true, so 100 is not equal to 1. But if I run this again, notice my cell count, it still says it's true because it just needs one of them to be true. So is this statement true or is this statement true? And if we make them both false, then finally we get back the false. So that's the basics of chaining comparison operators with the AND keyword and the OR keyword. And I would recommend that you use these keywords instead of doing something like this because, in my opinion, they're a little more readable. So we always want to stress readability in our code. It's especially good because later on, maybe you come back to your same code a month later, you're going to want to be able to easily read the code. So we just discussed and then the or keyword logical operators. I finally want to discuss the not keyword. So to round out our discussion by showing you an example of the not keyword, that's not for not, it basically just asks you to return the opposite Boolean of what you just did. So I will construct this with an example first. So 1 is equal to 1, we know that's true. If we wanted to get, for some reason, the opposite Boolean off of that, I could do not, and then in parentheses, 1 equal to 1, and it'll return back false. Technically, you don't need these parentheses here, so you could just do something like this, not 1 equal to 1, and you also get back false. It's up to you what's more readable. But all not is doing is it's asking for the opposite Boolean of whatever was returned here. So for example, just to show you again, let's say 400 greater than 5,000. So that's false, but if I put a not in front of it, it's going to now ask for the opposite. So it's going to say true. So not sometimes useful when you're trying to write out your logic. It'll be a lot more obvious when we begin discussing control flow in the next section of the course, but keep this keyword in mind. At first, you won't be using it too often, but later on, you're going to see that sometimes bits and pieces of code become more readable with the not keyword instead of using something like the opposite, which, would have been just is 1 not equal to 1 there. All right, that's the basics of logical operators. Again, main things to realize here is the and keyword needs both conditions to be true. The or keyword needs just one or the other to be true. We'll see you at the next lecture. Welcome back, everyone. In this lecture, we're going to discuss if, elif, and else statements. So as I mentioned, in this lecture, we're going to discuss control flow in general. And control flow basically allows us to use logic to execute code only when we want to. So often you have a larger piece of code and you only want certain code to be executed when a particular condition has been met. For example, let's imagine that I'm trying to program a robot to feed my dogs. Then I could say if my dog is hungry, so that's the condition, my dog being hungry, then I'll have the robot feed the dog. It'll have the actual code execute or perform some action. So in order to control this flow of logic, we use some keywords. And the keywords we're going to be introducing in this lecture are if, elif, and else. So let's see the syntax for these three keywords. In order to understand the syntax, we have to understand that control flow syntax in Python makes use of colons and indentation, otherwise known as whitespace. And this indentation system is absolutely crucial to Python, and it's really what sets it apart from other programming language. This use of whitespace and indentation allows Python code to be easily readable and very quick to prototype. So here's the syntax of a basic if statement. We're going to say if, so that's a keyword, some condition. So some condition is usually some sort of comparison operation that we just saw in the previous section of the course. So that could be something like if hungry is equal to true, colon, and then notice that that blue line is indented further than the if statement. So that says anything along that indentation is going to be executed if that condition happens to be true. Now, on top of an if statement, we can add an else to this. So let's say that condition doesn't happen to be true, we can have another block of code execute. So in this logic, we say if some condition happens to be true, we execute some code. Else, meaning that condition didn't have to be true, we do something else. And notice how the else doesn't have a condition attached to it. It only actually executes if the conditions above didn't happen to be true. You should also notice that the if and else, indentation-wise, are lined up with each other. If you want to check for multiple conditions before that else statement executes, you can have an elif statement or elif statement. And basically you say if some condition execute some code, elif some other condition, do something different, and you can have as many of these elifs as you want, and then finally all the way at the end you can have an else statement to do something else. Okay, let's explore all these concepts by actually coding out some examples in a Jupyter notebook. To begin all of this, we're going to start with the simplest example we can do, which is a single line of an if statement with just a Boolean condition. We're saying if true, colon, and note what happens when I hit enter. I have this indentation automatically done for me. And if you're using any text editor and you have defined the file as a .py script already, you should see this indentation occur automatically for you as well. Then we're going to say print, it's true. So then I'm going to run this, we see if true, print it's true. So notice we're saying if some condition is true, print it's true. Now typically you won't have just a boolean like this, otherwise you'll always be printing that. Instead what you may have is something like a comparison operation. So we'll say if 3 is greater than 2, print it's true. We run that and we get back it's true. And then to make this even more realistic, we'll say hungry, set a variable there, we'll say hungry is equal to true, and then I'll say if hungry, print feed me. And if we run that, we see that we get feed me. We can also then set hungry to false, and now if I run this code again, notice I don't get back anything else. So I have some condition, and it happened to be false, meaning this block of code didn't execute. What I could do is add in an else statement to execute if this condition doesn't happen to be true. So we hit enter again, and then we hit backspace in order to line up our else block with that if statement. So if we want this else to be lined up with this if, they need to be at the same indentation in our code. And a lot of times when you're working with any text editor, it'll kind of automatically line things up for you, so keep that in mind. So else doesn't have any other conditions attached to it because we're only going to execute else if none of the conditions above happen to be true. So right now we're saying if you're hungry, print feed me. Otherwise, print I'm not hungry. I'll run this, and right now because hungry was equal to false, we're getting back I'm not hungry. If we change hungry to be true, we get back feed me. What's also important to notice is that I'm just passing right here hungry by itself as a boolean. I don't actually need to do something like this, check that hungry is equal to true, because hungry by itself is already a boolean. And we'll explore that example later on in more detail. So if hungry, print feed me, else print I'm not hungry. Okay, now let's discuss multiple branches using if, elif, and else. So let's look at another example. I'm going to say LOC, which stands for location, and I'm going to set that equal to bank. So I have a location, it's equal to bank, and I'm going to say if my location is equal to an auto shop, I will print cars are cool. Else, I'll print I do not know much. So when I run this, it says I do not know much because the location was bank, and we have location equal to auto shop, print cars are cool, so that didn't execute. So then we have else printing I do not know much. What we can do is check for other conditions using elif. So let's pass in another condition here. We'll say elif, the location, is equal to the bank, then print money is cool, as I'm sure everyone at the bank says. And then we run this, and we get back money is cool. So here we can stack on as many conditions using an elif statement. So we can add in more elifs for more conditions. We can say LOC is equal to store, colon, print, welcome to the store. We run that, and we still get back money is cool, but as soon as we start changing this condition, let's change it to auto shop. We run that, we get back cars are cool. If we change it to store, we get back welcome to the store. And if we change it to something else that's not in any of these conditions, then we'll have the else block code execute. So let's see what that looks like. Let's say we're going to some game, and it says, I do not know much. Perfect. All right, just to drive this point home of indentation and white space, we're going to do one last very simple example, pretty much exactly the same as the last one. Let's define a name. We'll say Sammy, and we'll say if this person's name is equal to, let's say Frankie, we'll print out hello Frankie. Then we'll say elif, we have some other name. If elif name is equal to Sammy, print out hello Sammy. And then typically for your else condition, it's going to be something where none of the other conditions were met. So a good thing to do here would be ask the person what their name is. What is your name? And later on in another lecture, we'll actually learn how to get input from the user. But for right now, let's focus on a couple things here. Note the indentation, and note how if, elif, and else are all lined up with each other, and their respective blocks are all indented. And then we also have this colon at the end of these conditions. So now when I run this, we should expect to see hello Sammy. And if I were to change this to Frankie and run it again, I get back hello Frankie. And if I change this to a name that's not there, like Jose, I get back what is your name. All right, that's the basics of if, elif, and else. They seem pretty simple, and hopefully they were pretty straightforward to you. Later on, we're going to use them to create really nice large pieces of code that can execute more complex tasks. We'll see you at the next lecture. Welcome back, everyone. In this lecture, we're going to discuss for loops. Now, many objects in Python are iterable, meaning that we can iterate over every element in the object, such as every element in a list or every character in a string. And we can use for loops to execute a block of code for every iteration. So I want to focus a little bit on this term iterable because you hear it a lot, especially in Python documentation, and it's kind of a strange term if you've never heard it before. So all this term means is that you can iterate over the object, and that means you can perform an action for every thing in that object. So for example, for every character in a string, you can iterate through that string and then do something for every character. Often maybe you want to print out every single letter in that string or every single character in that string. So that means the string is an iterable object. You can work through it. You can also iterate over every item in a list. That means the list is iterable. And then you can iterate over every key in a dictionary. So the dictionary itself can also be iterated over. So kind of a little funny term there, but just think of it as a way of going through something. So let's go over the example of the syntax of a for loop. So this is the syntax of a for loop right here. Notice that we have a list defined, and then we have a couple of keywords, and then we're performing some actions. So let's focus on each aspect of this syntax. We start off with this statement, and this is just an assignment. We're saying my iterable, we're choosing that as a variable name. This could be my list, my items, my dogs, whatever you want, is equal to, and in this case, we're choosing a list. We're going to see other examples of other iterables in just a second. So we make some sort of assignment. We have a variable name there, and then we're going to say for, so that keyword for, item name. So this is a variable name that you can choose that's going to be a bit of a placeholder for every single item in your iterable object. So in this case, the item name actually represents the numbers in that list. Then we say in, so another keyword there, and then the variable name that you chose, in this case, my iterable. So we're saying for every item or item name in this list of 1, 2, 3, then we have a colon, and then we have some white space, and then we perform or execute some block of code. In this case, we're saying print item name. But you didn't have to actually use the item name. You could have just printed hello 3 times. So we're going to show more examples of that. But that's the basic syntax for a for loop. So let's actually explore these concepts in a Jupyter notebook and try to build a deeper understanding. So we're going to perform for loops for a bunch of different objects in Python. And I think by the end of this lecture, you're going to have a fair understanding of the basic idea of for loop and how to work with them. And this is really where you begin to level up your skills. So before, we've basically just been learning about data types, objects. We haven't really been able to construct anything yet. Once you start learning about control flow and for loops, and later on while loops, and then after that functions, etc., this is where we really start to be able to construct logical programs. Okay, so it's an exciting leap. Let's head to the Jupyter Notebook and get started. All right, let's begin with a simple example. I'm going to create a list called my list, and we're going to set this equal through the numbers 1 through 10. We'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, and then finally 10. And as a very quick note, you should not use list as a variable name here. Notice that it's being highlighted through syntax highlighting. That means list is a built-in keyword, so avoid using just list by itself as a variable name. If for some reason you accidentally already did that, go ahead and delete this, and then just hit kernel, restart, and then restart this, and that will reset all your variable names. What you will need to do is then rerun some cells if you already have stuff defined. So I just need to rerun that. Notice how now it's back at 1, so I've restarted everything. Okay, so I have this list 1 through 10. Now I'm going to create a for loop to iterate for every item in this list. So I start with the keyword for, and then I get to choose a variable name that's going to represent the elements inside of this list. So we're going to say for num in my list, that iterable, colon, I hit enter, and notice now how I have an indented block of code there. So now I can interact with those actual elements. So let's print them out. I'm going to say for num in my list, print num. And then when I run this, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's actually printing out this number for every number in that list. Something I want to make really clear though is that this particular variable name that you chose to represent the elements inside that list, it can be whatever you want. So here I chose num because these are numbers, but I'm going to just make it really obvious by choosing jelly and then saying for jelly in my list, print jelly. Run that again and you get back the exact same results. So again, this variable name can be whatever you want. This iterable can't be, it has to be predefined, but this variable name that's going to represent the actual objects inside that iterable, that is whatever you want. Now I also want to show you the point that we technically don't even need to use this variable name. We can still execute some block of code for every single item in this list, even if the code itself is unrelated to the item. So I can print hello for every item in that list, and we get back hello 1 through 10 times. And again, we can call this whatever we want. Num, run that, and we get back hello 10 times. So keep in mind, when choosing these variable names, you have full flexibility, so you'll want to choose a variable name that is somehow related to the object inside that iterable. Now let's combine our knowledge of for loops with a little bit of what we just discussed in control flow. Let's see if we can print out only the even numbers in this list. So to do that, what we're going to do is start off by saying for num in my list, and then I'm going to add in some control flow to somehow check if the number's even. So I'll say check for even here. This is just a comment. And then what I will do is the following. I'll say if num mod 2 is equal to 0, colon, print the number. So what I'm doing here is I'm saying, okay, for every number in that list, if the num mod 2, so remember that's the remainder when you divide by 2, is equal to 0. So if there's an even number and you divide it by 2 and the remainder is 0, then you can go ahead and print that number. So then when we run this, here we have all the even numbers, 2, 4, 6, 8, 10. And I can add even more control flow by attaching an else statement to this if statement, and then say print odd number. And we can even do some f-string literal formatting, so I can say if odd number, right there, run that, and it says odd number 1, 2, odd number 3, 4, odd number 5, 6. So this is some good work here as far as combining for loops with the control flow from before. Key things to note here is the indentation. So luckily Python is very clean because of the use case of indentation. So everything at this indentation level is inside of this for loop. So this entire block of code is going to execute for every single number in that list. And then we can see that this print num is only going to execute when this if statement is true. And this else indentation is lined up with this if. So we say if, this case, print num, else, and then we print out the odd number. And again, using some f-string literal here to nicely print out that number itself. All right, let's move along. So another common idea for a for loop is to keep some sort of running tally during multiple loops. And later on, we're going to show you the enumerate function, which kind of does this for you automatically. But for right now, what I'm going to do is say list sum is equal to 0. So let's try to get the sum of every number in that list. So I will say for num in my list, I will say the list sum is equal to the current list sum plus the number. And then I'm going to, outside of this for loop, print out the list sum. So when I run this, I get back 55. So this is a good example of indentation and a use case. So right now I have this list sum. So I'm saying my initial sum is 0. Then for every single number in that list, I take my old value for my sum and I add on the current number, and then I reassign that value to list sum. So I do that over and over again for every number in that list. And then at the end of this for loop, once it's done completing, so notice the indentation level here, I print out list sum. Let's see what would happen if I were to press tab here and have this print statement inside of this for loop. Now when I run this, I get back kind of the running tally of this sum. So it starts off at 0, and then once it has this first run inside of the for loop, it gets printed out. So then it has 0 plus 1. Well, that's equal to 1, so it prints out 1. Then we have 1 plus 2. Well, that's 3. Then it prints out 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15, and so on. So now we get the running tally. And it's only until the very end that we see 55. If we only want to see the last result, then I just have this print outside of that for loop. So that's why indentation and white space is so important. So we just saw how to use for loops with lists, but what about strings? Remember, strings are a sequence, so that means we can iterate through them, and we'll be accessing each character in that string. So we'll say for letter in, and let's create a string. We'll say my string is equal to hello world, then for letter in my string, colon, print out that letter. And I run this here, I can see HELLO space WORLD. So that's the way we can actually iterate through a string itself. And technically, you don't need to actually assign a variable name to the string. What you could do is just straight up put the string here. So we could say for letter in hello world, print letter. And we get back the exact same results. And I really want to drive this point home. You can call this whatever you want. So this letter variable name, you can say GHGH, and as long as it's the same thing inside of this, and you run this, you'll get back the same result. And the other thing I want to stress is that you technically don't even need to use this variable. So a lot of times what people do as they get more advanced in Python, for some reason they want to iterate something a certain amount of times. So imagine I wanted to print cool for as many times as there are characters here. So I see cool, 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 cool. What they do is instead of assigning this variable name, they just use an underscore. And that's really common syntax for when you don't intend to actually use that variable name as you iterate through. So they just use a simple underscore there. That way it's a little more readable. Okay, so that's iterating through a for loop. You can also use the same iteration for a tuple. So I can say tup is equal to 1, 2, 3. Then for item and tup, print out the item. Run that, and I get back 1, 2, 3. Now, I want to mention tuple unpacking. So tuples have a little bit of a special quality when it comes to for loops. So if you're iterating through a sequence that contains itself tuples, the item can be used with tuple unpacking. So let me show you what I mean by this. I'm going to create a new list called my list, and I'm going to set this equal to a list of tuples. So here I have square brackets, and I'm going to make some tuple pairs. We'll say 1, 2, comma, then 3, 4, comma, 5, 6, comma, 7, 8. So notice what I have here. I have a list, and then there's tuple pairs as items in that list. So if I check out the length of my list, I have 4 items in it, where every single item is a tuple pair. So let's print out those items themselves. So for item in my list, print out the item. And when I run this, I actually see the tuples themselves. 1, 2, 3, 4, 5, 6, 7, 8. This sort of data structure is extremely common in Python. And later on, we're going to see that a lot of built-in Python functions actually take advantage of this built-in structure and return back tuples inside of a list. And the reason for that is something called tuple unpacking. Right now, we had to print out every single item inside this tuple. But what I could do is the following. I could say, let me delete this print statement. I could do the following. I could say for, and make kind of a temporary variable name that looks like a tuple here. So for AB in my list, then I can print the variable A, and then print the variable B. So note what happens now. I'm saying 1, 2, 3, 4, 5, 6, 7, 8. So what's actually going on here? Well, this is called tuple unpacking, where you kind of duplicate the structure of the items, in this case tuples, inside of this sequence, and then unpack them. So now I have access to the individual items. So if I only want to print out the first item in those tuples, so I run this, I get back 1, 3, 5, 7, because now I'm only printing A. So this is known as tuple unpacking, and technically you actually don't need these parentheses here, so it's a lot more common to see it done this way, with no parentheses. So now I say for AB in my list, print A. Let's see what happens if we print B. We should get back all those even numbers. So that second half, that 2, 4, 6, 8. So again, this is tuple unpacking. And you're going to be using it a lot as you start working with more built-in Python functions, because a lot of things will return kind of pairs and sequences in this manner, where you have a list of tuples. And I want to show you one more example. Let's say my list is equal to a list 1, 2, 3, 1, 2, 3. Well, let's make it some different numbers. Say 5, 6, 7, and we'll do one more with 8, 9, and 10. I skipped the number 4 here, but no big deal. We'll say 4, item in my list, print item, and there are my 3 tuples, but I can do tuple unpacking here. So the way I can do that is make up 3 variable names, separate them by commas. So I can say A, B, C. Notice I don't have to use parentheses, and then I can print out whichever one of these I want. For example, if I just wanted to print out 2, 6, and 9, those middle numbers, I would just say B, and there we go. We have access to B, so just the middle number. So this is really useful when you maybe wanted to reorganize these structures into some other manner, or maybe you only want to deal with the first item in these tuple pairs. Okay, so that's tuple unpacking, and now let's finish off this discussion about for loops by discussing how to iterate through a dictionary. So to do that, we're going to create a dictionary called D. It's going to have K1 as a key value, and we'll have the number 1 as that value. We'll say K2 here, colon 2, and then we'll say K3, colon 3. And then I'm going to, for item in D, print the item. So this is something that's kind of interesting. Notice that by default, when you iterate through a dictionary, you only iterate through the keys. So K1, K2, and K3. If you actually want to iterate through the items themselves, what you need to do is call .items here. And now when you run that, you get back these tuple pairs, K1 with 1, K2 with 2, K3 with 3, which means we can use the same tuple unpacking technique we just discussed. So instead of item, what I can do is say key, comma value, and let's say I only wanted to print out the values. Then I could say for key value in D.items, print out the value, and now I have 1, 2, and 3. Again, taking advantage of tuple unpacking here, because D.items returns back something in this sort of format. And more likely it's this sort of format. We have a key and a value. So we're using the same tuple unpacking that we just discussed, now with D.items. So by default, when you iterate through a dictionary, it's going to be the keys. If you want to iterate through the items, you can use tuple unpacking to grab both keys and values. If you only want the values themselves, what you could do is say D dot, and then call values off of this, run that, and it'll only print out the values 1, 2, 3. The last thing I want to note here is that dictionaries are technically unordered. This is a very small dictionary, so it looks like everything's going in order, 1, 2, 3, K1, K2, K3. But if you have a very large dictionary, there's no guarantee that things are going to be sorted or in any sort of order. So keep that in mind. When you iterate through a dictionary, there's no guarantee that you're going to get things back in the order you put them in. Okay, so now we've learned about how to use for loops with tuples, lists, strings, and dictionaries. This is going to be a really important tool for us, so make sure you understood it well with the above examples. Specifically, make sure you really understand the white space. So probably the most important thing to get out of this lecture is the fact to use this for keyword, any temporary variable you want, you say then the keyword in, some sort of iterable object, either values, the list, or a string itself, as we saw up here, colon, and then in this indented block of code, that's going to execute every single time for every single iterable in that list. Thanks everyone, and if you have any questions, feel free to post them to the Q&A forums. I'll see you at the next lecture. Welcome back everyone. Let's now take some time to talk about while loops. While loops will continue to execute a block of code while some condition remains true. So for example, if we try to relate this to a sort of real life scenario, while my pool is not full, maybe I want my program to keep filling my pool with water. Or if I'm designing a robot with some code, while my dogs are still hungry, keep feeding my dogs. So let's explore the syntax of a while loop. It's actually quite simple. We're going to say while, and then some sort of Boolean condition. So we'll usually have some sort of comparison operation check, and a lot of times it's going to be while some variable is true, or is equals true, then colon, and then a block of code. And that block of code, in this case represented by do something, is going to continue to execute while the condition is true. Now we can also combine a with statement with an else statement if we want. So I can say while some Boolean condition is true, do something else, meaning once that condition is no longer true, or since the beginning it was no longer true, we do something different. Let's explore these concepts with some examples. Let's hop to a Jupyter Notebook. All right, so let's start off by building out a very basic while loop. I'm going to create a variable, say x is equal to 0, and then say while x is less than, let's actually say less than 5, so we don't have a whole lot of printing. We're going to print the current value of x. So we'll say print the current value of x. Lots of different ways we can do this. We'll just do it quickly with an f-string literal. The current value of x is, and then inside curly braces we'll pass an x. Now let's imagine what's going to happen here. Don't run this cell yet. We'll say x is equal to 0. While x is less than 5, I'm going to print out the current value of x. So if I were just to run this, basically I would say the current value of x is 0. And that would happen over and over and over again because x isn't changing. So let's update x during this while loop. We'll say x is equal to x plus 1. So now let's run this and see what happens. I get back the current value of x is 0, then 1, then 2, then 3, then 4. And on that last one, when it's equal to 4, we then say, okay, x is going to be equal to 4 plus 1, which makes x equal to 5, and 5 is not less than 5, it's equal to it. So then the while loop stops running because it's only going to run while this condition is true. Now, if you accidentally have some sort of condition that never becomes false, maybe you forgot this last line of code here and it just ran over and over and over again. So what happens is you get an infinite while loop, and it's a common mistake for beginners to make. I know I've made it myself a bunch of times when I was learning Python. What happens in the Jupyter Notebook is you get a little star here indicating that the cell is still continually running. In order to kind of reset things, just come over here to kernel and either hit interrupt, and if that doesn't work, then hit restart and restart your kernel. Sometimes interrupt won't work because basically the command to interrupt won't get there because Python's using all your computing to kind of continue this while loop. So keep that in mind. If you ever get an infinite while loop, just come over here to kernel and then hit restart, and you'll have to redefine some cells again, but that's the basics of avoiding that error. Okay, so we have the while loop by itself, and as a quick note, this statement of x is equal to x plus 1, we can also write that in the following manner. We can say x plus equals 1. So this line and this line are the same thing. This is just a more compact way of writing it. So if you're ever reading someone else's code and they wrote this instead, that's kind of a sleeker way of writing that same code. Let me run this again. We can say now n2, and we get back the same values. Let's attach an else statement to this while loop. So we can say else, colon, and I'm going to print x is not less than 5. And now when we run this, let's see what happens. We get the current values, so all those other print statements, and then I see x is not less than 5. So once this while condition is not true, because this else is lined up with it, we went ahead and printed x is not less than 5. Now as a quick note, if right off the bat, x was greater than 5, so let's make x is equal to 50, and I run this, then this while loop never executes because this condition is never true, and then we have the else condition execute anyways. That doesn't mean I need it. So if I didn't have that there and I ran this, just nothing would happen because this isn't true. All right, finally, I want to introduce 3 keywords that are really useful with loops. You're not going to be using them all the time, but sometimes you'll need their use cases. And that's the break keyword, the continue keyword, and the pass keyword. Break is going to break out of the current closest enclosing loop. Continue goes to the top of the closest enclosing loop, and then pass does nothing at all. So let's start a little bit backwards here. We'll go with pass, and we can show this actually with a for loop. Might be a little simpler here. We're going to say for, let's make a quick list. We'll say x is equal to 1, 2, 3, and then say for item in x, colon, and let's say we didn't quite know yet what we wanted to do here. We essentially want some filler. If I just have a comment here, and I try running this, so when you attempt to run this, you actually get an error. It says syntax error, unexpected, end of file while parsing. And what that means is Python, because it uses indentation and white space as a crucial part of its code, it expects you to basically have something here. Even a comment isn't enough to fill it. So often what you can do is have the pass keyword, and the pass just says do nothing at all. And a lot of times programmers keep it as a placeholder to kind of avoid a syntax error. Because you can imagine if I'm writing a larger piece of code and I know eventually I want to come up and fill out this for loop, but right now I don't want to deal with it. Let's say I wanted to print end of my script over here. Now when I run this, I don't get that syntax error and I'm still able to print out my script. If I just have the comment, I get an error because it's expecting something to happen after this colon. So in order to avoid that, you can use the pass keyword, and you're going to see the pass keyword used a lot when we start building out functions and methods ourselves, because often when you're programming, you'll create a little holder for a function, but you don't want to test it right away. So you use the pass keyword as something to put in place there, so you avoid syntax errors, and you're also safe because you know pass doesn't do anything. It just says, well, I'll pass this, and I'm not going to do anything. All right, so that's the pass keyword. It does nothing at all. Continue goes to the top of the closest enclosing loop. So let's show you an example of that. And we'll actually use for loops again for this. We're going to say my string is equal to Sammy. So let's have that there. And we'll say for letter in my string, print out the letter. So here we see Sammy printed out. Now what I'm going to do is let's imagine that I actually didn't want to print the letter A for whatever reason. I could do the following. If the letter is equal to lowercase a, colon, continue. And now when I run this, I'm not actually printing out the letter A. So what's happening here? Well, continue basically tells this program to go back to the top of the closest enclosing loop. So here's continue, and we have a loop up here for letter in my string. So if that letter is equal to A, we continue, meaning go back to the top of the closest enclosing loop. Note that we are specifically saying loop, we're not saying some sort of statement here. So that's where semantics can come into play, but what this is saying is if the letter is A, go ahead and continue and go back to the loop. So that's how you can use the continue statement. If you're a beginner in Python programming, it's definitely not something that comes up a lot in your beginning code. It's going to happen that more naturally you'll start using it much later on. So be aware of it, but don't worry about use cases right now. You won't really be using it that often. And then finally, break breaks out of the current closest enclosing loop. So let's see what happens if we replace continue here with break instead. Now when we run this, what happens is instead of going back to the top of the closest enclosing loop, it breaks out of the current closest enclosing loop, meaning it just breaks this loop and stops this loop if that letter is equal to A. So that's actually really useful, especially with while statements. So let's see an example of using break with a while statement. Let me zoom in here just so we can see this clearly. I'm going to do the same thing as before. We'll say x is equal to 5, and then we'll say while, actually let's make it equal to 0 here, just as we did before. While x is less than 5, print out x, and then we'll say x is equal to x plus 1. So when we run that, as expected, I get 0, 1, 2, 3, 4. But let's imagine I wanted to break this while loop if x was ever 2. Then I could do the same thing here. I say if x is equal to 2, at any moment, go ahead and break out of this while loop. Now when we run this, we only get back 0 and 1. Okay, so that's the basics of this break, continue, and pass keyword. So what we covered in this lecture was the while loop. So while some condition is true, execute this block of code. Be careful here because if you accidentally say while and this condition is constantly true, you may have to restart your kernel. If you're running a Python script and you end up getting that error that the while loop is just never closing, you should try Control-C. That typically interrupts. So you can even see here, interrupt, it says Control-C to go to the kernel. All right, then we have the break, continue, and pass keywords. Again, not going to be using these right off the bat, especially things like continue, but we'll probably be using break a little more, and then once we get used to functions, we'll be using pass a little more, and then much later on we'll be using continue. But you should be aware of these keywords now that you understand both for loops and while loops. Okay, thanks everyone, and I'll see you at the next lecture. Welcome back everyone. In this lecture, we're going to discuss a few built-in functions and operator keywords in Python that didn't really fit well into any of the previous categories. However, they're still really important and they're going to really enhance your ability to program with Python. Let's open up a Jupyter Notebook and quickly run through these. Let's begin by talking about the range function in Python. Notice that often we were creating lists that were just a series of integers, such as 1, 2, 3, or 1, 2, 3, 4, 5, etc., all the way up to 10. Because this is such a common task, Python actually has a built-in operator for this, and there's two ways you can use it. One is you can iterate through it, so I can say something like for num in, and then we use the keyword range, and it takes a couple of parameters. You can do Shift Tab here to see the parameters it takes, but basically it has a start, stop, and optional step size. So start is technically also optional. Let's show you how we can actually use these. So if we just indicate a single number, such as 10, and we say print num in range 10, what it's going to do is it's going to generate the numbers from 0 all the way up to, but not including 10. So that all the way up to, but not including, that's very similar to that slicing syntax we saw earlier in the course. So for num in range to 10, print number, and here we see 0 through 9. Now let's say we wanted to actually specify a starting index position for the integers. We could say start at 3, go all the way up to, but not including 10, and then when we run this, we get 3, and then all the way up to, but not including 10. So that's the range operator. And in addition to all this, we can actually have a step size as well. So we can add a third argument for step size, and that gives us the even numbers. So that's taking jumps in steps of 2 from 0 all the way up to, but not including 10. So if we wanted to include 10 as one of those numbers, we'd have to put in 11 there, and then we get back 0, 2, 4, 6, 8, 10. So that's how you can use the range function for iteration. But you'll notice if I copy and paste this into a cell and ask for it to be returned to me, I just get back this range operator. And it's because it's a generator. So if I actually want the actual list of numbers, what I can do is cast it to a list, and then I get back the list of numbers. Later on in the course, we're going to discuss generators in a lot more detail, but basically a generator is just a special type of function that will generate information instead of saving it all to memory. So this is a more efficient way of generating these numbers instead of having a giant list stored in memory. And we'll discuss that in a lot more detail in the generators section of the course. Let's move on to discussing another really useful function called enumerate. And to show you the use case and motivation behind enumerate, let's do an example. I'm going to set a variable called index count equal to 0. Let me zoom in here one level. So I have index count is equal to 0, and then for letter in the string A, B, C, D, E, I'm going to do some printing here. I'm going to say at index, the letter is curly braces. And then I will use dot format here to say index count and then the letter as well. Okay, so what I'm doing here is at index count, the letter is blank. And then what I will do is say index count plus equals 1. So when I run this, it says back the following information. At index 0, the letter is A. Index 1, letters B, and so on all the way until the end. Now this is such a common operation that what we're going to do is use the enumerate function to replicate this. And the reason this is very common is because a lot of times you will want to have some sort of counter for how many times have you gone through this for loop, or what index position you are at in this particular string. And the reason for that is because often people like to do something like this. They like to, let's define word as A, B, C, D, E, and then say for letter in word, print word at that index count. And then we say index count plus equals 1. So what's actually happening in this loop? Well, we're doing the following. We have an index count starts at 0, and we have a word string A, B, C, D, E. Then for every letter in that word, so for every character here, what we end up doing is we print the index value location at that word. And that's the same thing as printing the letter. But oftentimes what we'll end up doing is using this sort of syntax with a list later on in our code. But in order to do this, we need to have some sort of running index count. So when I run this, I get back A, B, C, D, E. Because this sort of operation is really common later on, what Python did is they built in the enumerate function. So let's see what happens when we use enumerate. So I'm going to delete index count here, and I will say for item in enumerate word, print out the item. And now when I run this, I get back, notice, tuples. So 0 with A, 1 with B, 2 with C. So this is basically doing that index count for us automatically in the form of tuples. And as we know, we have tuple unpacking from the for loop lecture, so I could say the following. I could say index, comma, letter, and then I could print out the index, and then print out the letter separately, and then print out a new line using an escape sequence character. So now I say 0A, 1B, 2C, etc., and so on. So this is the enumerate function, and it can take in any iterable object, and what it does is it returns back some sort of index counter and then the object itself, or the element at that particular iteration. The next one I want to show you is the zip function, which is kind of almost like an opposite of enumerate. What it does is it zips together two lists. So I'll say my list 1 is equal to 1, 2, 3, 4, 5. And I'm going to make my list 2 equal to A, B, C, D. Actually, let's just do A, B, C, 1, 2, 3. That way they match up. And then what I will do here is I will zip them together using the zip function. Now, if I just run zip, I don't get back anything. It just says, hey, you have this zip generator waiting for you at this location in your memory. If we actually iterate through it, so if I say for item in zip my list, and then I print out the item, notice back we get back this list of tuples. So previously in that for loop lecture, I mentioned that tuple unpacking is going to be a really useful thing because a lot of built-in functions in Python return back a list of tuples, and this is one such function. The zip function will, just like a zipper on a jacket, zip together these two lists and pair up these items so that they match together. And you can actually do this with more than just two lists. So I could say my list 3, and let's set this equal to some digits here. We'll say 100, 200, 300, and I could pass in this as another thing, my list 3, and now I can see the output is these tuples of 3 items. A common question is what happens if these lists are uneven? Well, we can check that. Let's add in a bunch more elements to the first list. So we're going to say 4, 5, 6 here. Now when we run this, we actually get back the same results. So keep in mind, zip is only going to be able to go and zip together as far as the list, which is the shortest. So it won't give an error, it'll just ignore everything else that's extra. You see here that we iterated through the zip, but if you actually just want to get the list itself, you can just cast it using list. So we can say list of zip, and then we'll put these lists together. And there you go, 1A, 2B, 3C. All right, that's the zip operator. Very useful for zipping together two lists if you want to later use them together using tuple unpacking. So as I mentioned, you could unpack these. So I could say A, comma, B, comma, C, and maybe just print out B here, and I only get back the letters. Now I want to show you the in operator. We've already seen the in keyword during the for loop, but we can use it to quickly check if an object is in a list. I can say is X in the list 1, 2, 3, and it will return back a Boolean true or false. Is it in 1, 2, 3? I could also use it for a list of letters. So for example, let's now say X, Y, Z. And now it returns true because X is in that list. So this is a really nice way to quickly check if something is in a list. So now let's change this to 2 in 1, 2, 3, and it gets back true. The in keyword, it also works on other iterable object types, so it works in strings as well. You can say is A in a world, and it returns back true. This also works in dictionaries as well for their keys. So I could say my key, and then check if it's in a dictionary. Let's quickly create one that has that key, my key, and let's give it some value, 3, 4, 5, and it returns back true because my key is in this dictionary. If you wanted to check if it's in items or if it's in the values, then you could just call that itself. So to show you what I mean by that, let's get back this dictionary. And then I could say, hey, is 345 in d dot values? And it returns back true. If I asked for keys, it returns back false. So that's the in keyword operator. Very useful for quickly checking. I like to use it a lot when working with strings. A few more that I want to show you is some mathematical functions, min, max, and then the random library. So if you ever have a string of numbers, let's quickly create one. My list, 10, 20, 30, 40, and let's go jump to 100. If I ever wanted to know the minimum value there, there's a built-in min function that I could pass in, and it reports back the minimum of the list. And there's also a max function that reports back the maximum value of a list. So keep that in mind, because often it's going to be very tempting to use min and max as keywords, but they're already built-in functions in Python, so you should not use those. And that's denoted by the fact that they show you syntax highlighting there. Okay, let's quickly discuss the random library. So Python actually comes with its built-in random library, and there's a ton of functions included in this library. And this is actually going to be our first example of importing a library. So to import functions from a library, what you can do is say from random import, and if you hit tab here, you should be able to see a big drop-down list of options, and a lot of these are the functions that are available to you inside this particular built-in library. So the one we're going to show you right now is shuffle. So what this is saying is, hey, from that random library that's built into Python, import the shuffle function. And later on in this course, we'll discuss how to download other libraries from the internet. But for right now, random's built in. So now we have this shuffle function, and what it does is it randomly shuffles around any sort of list. So let's create another list, and let's make it in order. So 3, 4, 5, 6, 7, 8, 9, 10. And if we shuffle this list and then call the list again, it's now shuffled or scrambled. And if we run this shuffle again, so notice here I'm going to run that one more time, it's going to reshuffle the list. You should also note that it's actually not returning anything. So if I asked for this, random list is equal to shuffle, that's not going to work because it's not returning anything. So it's going to just say, hey, there's nothing there. And if you check out the type of this, it again says none type. So this is an in-place function, meaning it operates in place on that list. So if I check out my list, now it's still scrambled. Okay, so that's my list, and that's the shuffle function for shuffling a list. There's also a really nice function for grabbing a random integer. So we can say from random import rand int, and that allows us to quickly grab a random integer. So I will say rand int, and what we do here is we pass in a lower range and a upper range. So I can say rand int from 0 to 100, and it returns back some random integer. And if I do this again, from 0 to 100, another random integer. And most likely your numbers will be different than mine because, again, it's random. And because this is returning something, I can save it. So I can say my num is equal to rand int, 0 to 10, and then I can later on use that number. Finally, let's show you how to accept user input, and it's actually quite easy with the input function. So we use the special keyword input function, and then we have the text that wants to show up when we actually ask the user for input. So I'll say, hey, enter a number here, colon space, and when you run this, now Python's asking you to enter a number. So we'll go ahead and enter one. We'll say 50, and there we go. Now it has 50. Typically what you're going to do is save this as some sort of result. So you'll say, hey, whatever variable you want is equal to input. And this phrase, you can say whatever you want. So we could say, what is your name? We run this, and then it says, what's your name? I'll type in Jose. And then later on in your code, what you can do is refer to result, and we get back Jose as a string. So that's the basics of input. The thing you got to watch out for is that input always accepts anything that's passed into it as a string. So let's go back to that number example. So we'll ask the user, hey, what's your favorite number? When we run that, if I pass in 30 and I hit enter there, and then I ask for the result, it's actually the string version of 30. So if I say type of result here, it says, hey, it's a string. So in order to actually cast this or really transform it into another data type, what I need to do is say either float of result to get back 30.0, or if I still want it to be an integer, I can say integer result and it returns back 30. And now it's an actual number instead of a string, because if you just say result, notice here it still has those quotes. So keep that in mind. Input always accepts things as a string, because later on you may want to be using input for grabbing an index position, so you will most likely have to cast it. And you can do this all in one line by saying wrap this in int, and then we will get a favorite number here. So I say 20, and now when I check the type of my result, it's an integer. Okay, so that's the basics of the input function. And those are some other useful operators that we'll be using, especially later on in your first milestone project. You can check out the notebook for more examples, and I will see you at the next lecture. Thanks, everyone. Welcome back. Before we finish off this section and head over to your assessment test, I want to quickly discuss a concept known as list comprehensions. List comprehensions are a unique way of quickly creating a list with Python. So if you're ever in a situation where you find yourself using a for loop along with an append statement that goes over and over again through a for loop to create a list, list comprehensions are a good alternative to this method. So to show you what I'm actually talking about, let's jump to a Jupyter notebook. Okay, let's imagine that we have a string called myString, and we say it's hello. And I want to make a list of every character in this. What you may do is start off with an empty list, such as this, and then say for letter in my string, append the letter to my list. And then after running this, if I check out what my list looks like now, I get back HELLO. So this is something that's really common for beginners to do. They create an empty list, and then they iterate through some other iterable, and then they append whatever object that is or whatever element that is to their list. There's actually a more efficient way to do this in Python, and by efficient, I really mean taking up less space in code. As far as the actual computation, it's about the same, so don't worry about saving computational time using this method. If you find this method too confusing, you can always go back to the for loop. But let me show you how you could do this exact same thing on a single line. What you do is you essentially break down this entire for loop. So I'm going to copy this again here, and then slowly break it down to be in the format of a list comprehension. So first off, all of this code and logic here in some format is actually going to go inside these braces. And we basically reorganize this. We say for letter in my string, we're going to delete all this and then put letter right here. So now we have letter for letter in my string. Cut that, paste it in here, run that, and now we have the exact same thing, HELLO. So what's actually happening here? The logic is essentially a flattened out for loop, because we're going to assume that the only action being taken in this for loop is just appending whatever element you want to your same list. What list comprehension does is it just takes that element for element in some other iterable object, such as another list. So let's show you another example. We can say my list is equal to open and close square brackets, x for x in Word. And then if I check out my list, I get back WORD. And just like a for loop, this is a temporary variable name that you can call whatever you want. So we could call it just QWE, and as long as it matches here, let's make it Word2 so we can see that it's actually working, Word2. So again, it's just element for element in, and then some sort of string, list, or other iterable object. So often what you're going to see is something like this. My list is equal to open and close square braces, and then what I'm going to do here is say x for x in range 0 to 11. So now my list are those actual numbers. So instead of saying x, what I'm going to do is say num, because that's a little clearer to me. So I have this flattened out for loop. Now you may be wondering, well, is this all it can do? And that's actually not all it can do. In fact, you can begin to perform operations on this first variable name. So if I wanted to grab the square of every number in that range, what I could do is perform the operation here. So I'm saying number squared for num in range 0 to 11. So then when I rerun this, now I get back the squared versions of that. So what this is doing is essentially flattening out this for loop right here, where this letter or this number, whatever it happens to be, is basically as if you had done squared here. That's what we're doing when we say squared right here. So you're appending whatever this happens to be. Now you can also add in if statements into this. So let's say we only wanted to grab the even numbers from this. What I could do is say my list is equal to open and close square brackets, and then say x for x in range 0 to 11, and then after this is where you add in the if statement. You can say if x mod 2 is equal to 0. So remember, that's to check if something's even. So I'm saying x for x in this range of numbers, but only if when you say mod 2 of that x, it's equal to 0. And now when I check the result of my list, it's only the even numbers. And I could also do something like this, x to the power of 2 here, and now I only have the square of the even numbers. Now you can do some more complex things, like more complex arithmetic here. So I'm going to show you one last example. Let's imagine we have a list of temperatures in Celsius. So 0, 10, 20, let's say 34.5. And then I wanted them in Fahrenheit. So let's do that. A list called Fahrenheit. I will set that equal to, and then there's some sort of formula for the conversion. And the formula is 9/5 times the temperature in Celsius plus 32. So here I have quite a complex arithmetic arrangement, but then I'm going to say for temp in Celsius. And then when I run that and I see Fahrenheit again, I see back the temperatures in Fahrenheit. So 0 degrees Fahrenheit is 32, or excuse me, 0 degrees Celsius is 32 degrees Fahrenheit. So I'm going to break this down as a for loop just so we can see the connection. This is the exact same thing as me doing the following, as me saying Fahrenheit, set that equal to an empty list, and then say for F-O-R, temp in Celsius, Fahrenheit, append, and then just doing this sort of thing right here. Just grabbing this and putting it in there. So this is the exact same thing, and if I check out Fahrenheit, I get back the same result. So what I would suggest is you basically freeze this video right here and see if you can build out the comparisons between this flattened version for list comprehension and this version for the for loop. Because all we're really doing here is flattening out and getting rid of this append functionality, because it's essentially implied by default when you put it all in this list comprehension. Now often I'm asked by students as they review their list comprehension, hey, am I able to do if-else statements inside of a list comprehension? And the answer to that is yes, you can, but the order is going to be a little different. And before I show you this, I want to emphasize that above all else, readability and reproducibility in your Python code should be the most important thing, not trying to do slick one-liners. And list comprehensions can kind of fool you into thinking you're becoming a really good programmer, when in fact you're writing just kind of really one-liners that are really ugly, and it's hard to read when you come back to them a month later. So keep that in mind. I am going to show you right now how to do it, but I myself typically don't do this because it's really hard to read once you come back to it. But let me show you how to use an if and else statement inside of a list comprehension. So the way we do this is, let's say results. We're going to set that equal to, and the order is a little reversed here. You say x if, and then you have your if statement. So we'll say x if x mod 2 is equal to 0. And then we have our else statement, else do odd. And then we say for x in, and then we can say range 0 to 11. So this is kind of weird because now the order has been totally reversed, different than what I said up here. So that's why I also recommend that you kind of take it easy when you're doing if-else statements in a list comprehension, because it can quickly become unreadable or confusing because the order is different. But when you run this and we check out our results, now I have a list where I have the even numbers, or basically the numbers where you mod 2 is equal to 0, and then the string odd if that's not the case. So that's, you can use if-else in a list comprehension. Notice how the order is now different than just a simple if statement inside of a list comprehension. Also, keep in mind that a month later, when you're coming back to this, it's definitely going to take a little longer to read and understand what you were doing here. So be kind to your future self. One last note I want to show is you can also do nested loops in a list comprehension. This is going to be another topic where I would say take it easy at first because it can become quite confusing. But let me show you what I mean by a nested loop. We haven't actually seen a nested loop yet, so we'll introduce one first. Let's imagine I have my list as an empty list there, and I say for x in, and let's say 246. And then inside of this, I'm going to make another for loop. We'll say for y in, and let's say 100, 200, 300. I'm going to take my list, and I'm going to append x times y. So I run that, and then outside of those for loops, I print out my list, and I get back 200, 400, 600, etc., all the way to the end. So what is this actually doing? Well, it's going to take 2, multiply it by each of these numbers. Then it's going to take 4, multiply it by each of those numbers, resulting in this. And then it's going to take 6, multiply it by each of those numbers, and then result in that. So let me choose a couple numbers here that will make it even more obvious what's happening. I'm going to say 1, 10, and then we'll make this last one 1,000. So when I rerun this code, you can see here 2, 22,000, 4, 44,000, 6, 60, 60,000. Now, there is a way to do this with list comprehension. Again, you're going to sacrifice readability here, but it is possible. The way you would do this is the following manner. We would say my list is equal to, and then we say x times y for x in, and then you pass in that list. So in this case, we're going to say 246, and then we'll say for y in, and then here we'll say 1, 10, 1,000. And when we check out my list, we get back the same result. Now again, definitely be careful with this because this is really hard to read, especially when you're coming back to it later. So it's possible, but I would suggest always try to do readability first. Okay, that's the basics of list comprehension. We'll play around with them a little bit in some of your exercises and projects, but it'll definitely take a while before this becomes part of your normal flow in programming with Python. All right, thanks everyone, and I'll see you at the next lecture. Welcome back everyone. Let's finish up this section by having your statements assessment test. I'm going to quickly go over the notebook in this lecture, and then in the very next lecture, we'll go over the solutions. Let's head over to the notebook. All right, here I am at the GitHub repo for this course. And in order to find the notebook that I'm referring to, it's going to be under Python statements, and then come down to statements assessment test. There's also a solutions notebook, which we're going to go over in the very next lecture. Click on statements assessment test, and then let me quickly go over the questions. So for this one, we want you to use a for statement, the .split method off a string, see if you remember that one, and an if statement to create a statement that's going to print out the words that start with an S. So here I've given you a string, and I want you to use a for loop along with split and if that's going to be able to print out only the words in this string that start with an S. Then I want you to use range to print out all the even numbers from 0 to 10. Then I want you to use list comprehension to create a list of all numbers between 1 and 50 that are divisible by 3. And that's to be evenly divisible by 3. So let me just clarify that. And then I want you to go through the string below, and if the length of a word is even, print even. So this one's a little more complex than what we've seen in these earlier questions. So what we're going to do is use what you know about Python statements, maybe a for loop here, to go through the string and every single word. So remember, you're going to have to use some sort of split on the white space. And then if the length of the word is even, print out even. Next, I want you to write a program that prints the integers from 1 to 100, but for multiples of 3, print out fizz instead of the number, and for multiples of 5, print out buzz. And for numbers which are multiples of both 3 and 5, print out fizzbuzz. So this is a very common question, and it's kind of used as a base filter for some interviewers when they want to know, does this person even really know how to program? So this is a really famous question called fizzbuzz. And then finally, I want you to use list comprehension to create a list of the first letters of every word in the string below. So again, we have a string below, use list comprehension to create a list of the first letters of every single word. Okay, best of luck, and definitely a big hint here is utilizing .split. You're going to need to use that for a lot of these test questions. We'll see you at the next lecture where we go over the solutions. Welcome back. In this lecture, we're going to go over the solutions for the test shown in the previous lecture. Let's get started by opening up a Jupyter notebook. Okay, let's get started with our statements assessment test solutions. The first question wanted us to create a statement that will print out words that start with an S from this string right here. So let's run this cell. So now we have our string defined. So there's our string, and we can use the dot split statement, if you recall from the strings lecture, to create a list. And dot split by default splits on the white space, so now we have all the words right here. So let's use a for loop to iterate through this. I can say for word in st split, and if I just print out the word, I get back the words themselves. But what I want to do is create some sort of if statement that checks if the word starts with an S. So how do I do that? Well, I can actually grab the first letter of the word using indexing. Because these are all strings, I can say word of 0 at index 0, that's the first letter. So I can say if word at index 0, the first letter, is equal to the string S, print word. And there we go, we have start, S, and sentence. Something else I wanted to note here is let's imagine that there was a word here that started with a capital S. So if I say Sam, print only the words that start with an S. If I run this, this actually no longer works because it's missing out this capital S. What I could do is force this letter to be lowercase when I do the comparison in order to compare to this lowercase s. So there's two ways I could do this. I could say if word 0, when it's lowercase, is equal to lowercase s, and then I do grab Sam right here. So that's one way I could do that. The other way I could do that is just compare both a lowercase s and a capital S. I could say if word is equal to s right here, so if this first letter is equal to lowercase s, or word 0 is equal to capital S. And then that's the exact same thing. Typically what you're going to see from a more experienced Python programmer is the call of lower instead of or, because it's less code and it looks a little cleaner. So that's a way you could deal with capital S's if they happen to be in that string. To keep it simple, we didn't have that, but just keep that in mind. Up next, we wanted you to use range to print out all the even numbers from 0 to 10. So that's pretty straightforward, and there's lots of ways you could have done this. You could have just said list range 0, 11, 2, and there we have all the numbers. But if we actually wanted you to print them, you could have said for num in range 0, 11, 12, print out num, and we would have accepted that as well. So either one of these is fine. Main thing I want you to realize is that range, you'd have to say up to 11 if you want to go to 10. And then we have to have 2 as the step size. Next, we want you to use a list comprehension to create a list of all numbers between 1 and 50 that are divisible by 3. So the way we can do that is the following. We'll say x for x in range, and we'll go from 1 up to 51 because we want to go up to 50. So we'll go up to, but not including 51. And then we can say if x mod 3 is equal to 0. So we run that and we get back these results. And this was really similar to other examples we saw when we were printing out all the even numbers. Here we're just checking if they're divisible by 3 instead. Evenly divisible, that is. Next question was to go through the string below, and if the length of a word is even, print even. So let's do that. It's going to be very similar to the first question. We'll say for word in st split, except now the if statement is going to check the length of the word. We're going to say if the length of the word when divided by 2 has a remainder of 0, I will print out the word. Or I will print out even. Doesn't really matter what you do here. We can say print is even, so I'm just using some string concatenation there. So only is even, that is even, with even, etc. So there you have it. The next question is a really common question called FizzBuzz. And that's where we have to write a program that prints out the integers from 1 to 100, except we're going to replace integers with words when they're multiples of 3, multiples of 5, or if they're multiples of both 3 and 5. And there's a bit of a trick to this one, but first let's figure out how to actually print the numbers. We're going to say for num in range 1 to 101, because that actually gives us back all the way to 100. And the first thing we need to check is multiples of both 3 and 5. Often, what beginners will do is they'll make the mistake of checking for 3 first, then checking for 5, and then checking for 3 and 5. But the problem with that is multiples of both 3 and 5 are technically also a multiple of 3. So you accidentally end up printing out fizz when you should be printing out fizzbuzz. So the very first thing you need to check for, logically, is 3 and 5 with fizzbuzz. So we will say if num mod 3 is equal to 0 and num mod 5 is equal to 0, we will print out fizzbuzz. Then we can check for the other cases. So we can say elif num mod 3 is equal to 0, print out fizz, and then we could say elif num mod 5 is equal to 0, print out buzz. Else, remember we want to print the integers, so else we'll just print out the integer. Print the number itself. So when you run this, you get back 1, 2, fizz, 4, buzz, fizz, and if you keep going all the way to 15, finally you get fizz buzz. So the main trick here is to check for 3 and 5 first. That way you don't accidentally trigger one of these by accident. Then moving on to the next question, we wanted to use list comprehension to create a list of the first letters of every word in the string below. And to do this, it's going to be a bit similar to what we did before. We say word for word in st.split, but I just want to grab the actual first letter. So if I were to run this, it would bring me back all the words. I just want the first letter. So here I index for 0. And when I run that, I get back the first letter for every word in the string. Okay, that's it. Take some time to review these. A lot of these are kind of tricky and you have to wrap your head around them at first, but hopefully with this solution review, you kind of start getting the idea of applying and mixing the ideas that we've just talked about together to solve real problems. Coming up next, we're going to go to the next section where we're going to begin understanding things like functions. I'll see you there. Welcome back, everyone. In this section of the course, we're going to be discussing methods and in particular functions. Let's start by briefly going into the details of methods in this lecture. So we've actually already seen a few examples of methods when learning about object and data structure types in Python. And methods are essentially functions that are built into objects. And later on in the course, we're going to learn how to create our own objects and methods using object-oriented programming and classes. Right now, I want to explore in a bit more detail how to find methods and how to get information about them for built-in objects in Python. In the future, we'll explore creating methods. So let's open up a Jupyter Notebook and quickly discuss methods in built-in objects. Alright, so the first thing I'm going to do is create a simple list and say my list is equal to 1, 2, 3. Now we've already seen before a couple of methods that are useful for a list. So we've seen the append method where we say dot append, and we can append a new item to a list. So then when I see my list here, I get back 1, 2, 3, 4. We've also explored the pop method off a list, pop, and if I just hit empty there, it pops off the last item of the list. And now if I check out my list, it no longer has that last item, number 4. What I want to show you now is a couple of quick ways to get the list of methods in Python for various built-in objects. There's too many methods really to go through them, all of them in this course. Otherwise, we'd have hours and hours of video of things that you could just explore yourself, and a lot of these methods you don't use that often. So instead, we're going to show you how you can discover methods on your own. The first thing you can do is in Jupyter Notebook, once you've defined that object, hit dot and then hit tab to see a list of all the attributes and methods available for you on that object. Now the other thing you can do as well is actually called the help function. For example, I'm going to hit tab here and let's explore a function or a method, that we haven't actually explored before. For instance, we haven't actually explored this insert method right here. So I'm going to call insert, and there's two different ways to get help on this. I can do shift tab in the Jupyter Notebook right after this method call, and it will tell me what it is. So it's going to say insert object before index. If you're not using the Jupyter Notebook and you can't do that shift plus tab call, what you could do is call the built-in help function. So if I run the built-in help function and pass in this method, it returns back that same doc string. So if you're using .py scripts, maybe you're in PyCharm or in the text editor, you can use this help function and run this in order to get back the actual documentation on the object. Your third option is to actually view the Python documentation. So let's quickly jump to that. Okay, so here we are at the Python documentation. It's at docs.python.org, so docs.python.org. And in this case, we're looking at the documentation for 3.6. In the future, you may be looking at the documentation for 3.7 or 3.8. But you'll notice here that the first thing we see is a what's new in Python 3.x. So you can click on this and it will take you to this link where it just is almost like a little blog post of the different improvements and things they've changed in the newest version of Python. And as a beginner in Python, there's going to be a lot here that you don't really understand yet. But as you get more and more comfortable with Python, you'll notice that there's a lot of cool things as you begin to kind of update to the latest versions of Python. So here we can see that in Python 3.6, there's this really cool secrets module that allows you to generate secure random numbers for managing secrets. Previously, we saw how there's random number generation, but the secrets module is actually cryptographically secure generation of random numbers. So that's an extra thing they've added in 3.6, and you can explore everything they've added on that link on the main documentation page, What's New in Python. Then there's a tutorial link which kind of shows you the very basics of Python. That may be helpful to you if you want another reference for that. Then there's the library reference and a couple of other links as well as FAQs. So there's FAQs, frequently asked questions, and you can check them out here. General Python FAQs, programming FAQs, design and history, and then a couple more interesting things like using graphical interfaces of FAQs. So I would explore those if you're more interested in that. But the main thing we're here to talk about is this library reference. And it says keep this under your pillow, and for good reason. So when we click on this library reference, this is basically all the information about all the classes, objects, and modules in Python. And a lot of times when you do a Google search, maybe you find a Stack Overflow link. A lot of times in those links, people will link back to the standard documentation here. And as you scroll down, you'll notice it basically discusses the official documentation of everything we cover in this course. So we can see here it starts off with the built-in types that we discussed earlier, such as Boolean types, numeric types, sequence types like list, tuple, range, and then it continues on to talk about exceptions, text processing services, and later on it talks about more advanced things that we're going to cover later on, like collections. Then it talks about the different modules, such as the math module, functional programming module, file and directory access, and you can scroll down, you can see all this useful information about all these built-in modules. So there's a ton of stuff here, and this is kind of the official documentation for a lot of these functions and modules. One thing to keep in mind is that this is not the most readable place to come for answers. You usually want to go to Stack Overflow, where someone has added kind of a nice explanation, but this is the official documentation, and it is pretty good as far as documentation goes for official programming languages. So let's imagine we wanted to go back to that example of using a list object. Well, we could search for it here, and we'll find it here, sequence types list. So there's various sequence types. You click on here for list, and then it says the common sequence operations. And you'll notice that it actually talks about a lot of the operations we've discussed, such as xin, and it gives you the results, so kind of explaining what's happening here, the min, the max, length, indexing, and slicing. It's also all explained here, kind of in a more official way. And if we scroll back up, we can click here on list to go to official list class, and it will take us and explain the various methods. So what sort does when you call it on a list. And it does that for the rest of the object types, and you can also see list implements all of the common and mutable sequence operations. So if you want to know more about those operations, click here on common and it'll take you back to discuss those operations, such as index and count. So this is where you can find a lot more detailed information about the various methods available on objects. As you're a beginner in Python, you won't be visiting this page that often, but as you get more and more advanced, you'll find that a lot of the answers you're searching for are really only found in the documentation. But as you're beginning, I would recommend that you use this help function to quickly find doc strings. And as a reminder, you can use Shift-Tab to quickly get this documentation string on methods and functions. Okay, that's the very basics of methods. Hopefully it was all pretty familiar since we've already discussed methods in the past. Coming up next, we're going to talk about is functions. We'll see you there. Welcome back, everyone, to the main series of lectures in this section of the course for functions. Creating clean, repeatable code is a key part of becoming an effective programmer. And functions in Python allow us to create blocks of code that can be easily executed many times without needing to constantly rewrite that entire block of code. Currently, if we wanted to have a piece of code run twice or call it multiple times, we would have to copy and paste all the lines in that particular block of code and then call it again. So we would have to rewrite that code. Functions will essentially allow us to do this all within one line. So keep in mind that functions are going to be a huge leap forward in your capabilities as a Python programmer. That also means that the problems you are now able to solve after learning functions can be a lot harder. So it's really important to get practice combining everything you've learned so far, things like control flow, loops, logic, etc., with functions in order to become an effective programmer. Now, I've had the experience of teaching lots of students Python at this point in time. And I often see students that once they start learning functions, they sometimes get discouraged or frustrated because the level of problems they're able to solve with functions tends to be a steep incline. I want you to not worry about that. It's completely normal and very common. And we're going to do our best to guide you step by step and make the introduction to functions a very gradual journey. So keep in mind that you should be patient with yourself when learning about functions because it is going to be a huge leap forward in your skill set, and the best way to learn functions is through practice, practice, practice. Okay, so again, just to kind of visualize what I'm trying to say here is right now, the difficulty of problems you can solve is pretty simple. And throughout the course, as we progressed in Python and learned things about basic data types, we were able to solve some simple problems, and then we learned about things like loops and logic, and we're progressing in Python, and the difficulty of problems we can solve kind of goes along linearly. However, once you learn about functions, you're going to see a steep incline in the difficulty of problems that you can theoretically solve with functions. So I don't want you to get discouraged here when you're going to make a huge leap in a very short amount of time by learning about functions. It's really just about taking on a lot of practice problems with functions. So my rules about learning about functions of Python is to be patient with yourself. Take your time to practice the material. You'll notice that this section of the course actually has more practice problems than almost any other. And to start getting excited about your new skills and start thinking about personal projects, because once you learn about functions, it's really going to open a door into allowing you to start connecting Python to what you actually want to accomplish in the real world. Okay. In the next lecture, we'll begin to learn how to create functions with Python. I'll see you there. Welcome back, everyone, to this lecture on the def keyword, which allows us to create a function with Python. Creating a function in Python actually requires a very specific syntax, including the aforementioned def keyword. It also requires correct indentation and proper structure. Let's begin getting an overview of the Python function structure line by line. So here's the first line of an example function, and it all starts off with this def keyword, essentially standing for the definition of the function. And this keyword just tells Python, hey, what I'm about to write is a function. So you have def, and then you have the name of the function. And you decide on the function name, and you should notice this so-called snake casing. So in general, by convention, Python uses snake casing for the name of the function, and snake casing just means that you're going to use all lowercase letters with underscores between the words. And this is by convention, so this means that in general, if you're looking at someone else's Python script, you can easily tell what's a function because of the use of snake casing. Later on, we'll see that when we learn about object-oriented programming, class calls use camel casing. But for right now, in general, by convention, you should use snake casing, all lowercase with underscores between the words. It will still work if you don't follow snake casing, but in order for your code to be readable by other Python developers, you should use snake casing when naming functions. Then you'll notice we have parentheses here. So the parentheses come at the end, and later on we'll see how we can pass in arguments or parameters into the function, where arguments or parameters are essentially just words saying, take this variable and pass it into the function in order to work with it within the function. And then finally, you'll notice a colon, which indicates an upcoming indented block. Everything indented is then inside the function. So after that comes the optional multi-line string to describe a function. This is called a docstring, and you specify a docstring with triple quotes, which essentially allows you to write a multi-line comment. And this code does not get executed. It's just comment code essentially for someone else who's reading this function, or for you at a later date, that will explain what the function is supposed to do. And now you should start noting that everything inside the function has indented. And then you're going to write the code that you want to be executed every time you call the function. So for example, this is a very simple function. All it's going to do is print hello. So if you were to call this function, you would simply say name of function, and in this case, open close parentheses. So the function's executed, and then it takes whatever code is inside the function and runs it. In this case, it will just print hello. So there's your resulting output. Now functions can begin to get more complex, such as actually accepting a parameter or argument, such as name here. So name is just essentially a made-up variable that I decided to use. You can call it whatever you want here, but we'll call it name. And what we're going to do is use this as an argument to be passed by the user. So notice what happens here. Here I have my function, and it accepts this parameter, name, and what it's going to do is say print hello plus name. So that essentially means that name should be a string, and I'm going to concatenate it with hello. So that means when I call my function here, it says name of function, Jose, and then it'll say hello Jose, which means now I can pass in any string I want into name of function, and it should say hello and then that string. Now typically, however, we're going to use the return keyword to send back the result of the function instead of just printing it out. So far, if we take a look at our examples here, we've just been using print inside of the function calls, like print hello or print hello plus name. In general, you're very rarely just going to have a print inside of a function, because you might as well just call print outside of the function. Instead, you're going to use what is known as the return keyword. And return allows us to assign the output of the function to a new variable. Now we're going to have a much deeper discussion on the return keyword later on in the notebook, so keep that in mind. A really common question is what's the difference between print versus return inside of a function, and we're going to clarify that when we actually start coding out these functions within a notebook. But here, let's just look through a very simple example. I've created a function called add function, and it takes in two arguments or two parameters, num1 and num2. And keep in mind that you can call these variables whatever you want, so it's very flexible in the naming scheme. And then it's going to return the result of num1 plus num2. You should also notice here that return doesn't have any parentheses attached to it, unlike a print function. And so return then allows you to save the result to a variable, which print does not. So that means when I call add function 1, 2, I'm saying num1 is 1, num2 is 2, and so it's going to, inside of the function, do 1 plus 2, which is 3. And since it's using return, I can now save that result to a variable. So I can say result is equal to whatever add function 1, 2 returns to me. So in that case, if I were to later on print the result or use it somewhere else in my code, it's the number 3. So most functions, as I mentioned, will use return. Rarely will a function only print, and we'll show you examples of both use cases in the Jupyter Notebook. Okay, let's start creating functions with Python. I'll see you at the next lecture where we're going to jump straight to a notebook. Welcome back, everyone. In this lecture, we'll jump to a Jupyter Notebook and start creating basic functions in Python. Let's get started. Okay, here I am at a fresh Jupyter Notebook. As a quick note, the lecture notebook that goes along with this is called Functions, and throughout this series of lectures when we talk about things like print versus return, adding in logic inside a function, tuple unpacking, etc., that's all within this singular Functions notebook. So it's a longer notebook that's going to have several video lectures attached to it. Okay, let's get started. As we mentioned, you first have to start off with the def keyword. Notice that it starts highlighting the special syntax behind it, and then we decide on the name of our function. For example, let's have a function called say hello. Then we have open and close parentheses and the colon. And then when you hit enter, you'll notice an automatic indentation, which happens after you click a colon in Python. And basically what that means is anything inside this indented block is going to be called when you execute the function. For example, if I say print hello, run that. Then if I later on somewhere else in my code or script call say hello, open and close parentheses, then it's going to execute the block of code inside this function. That means that if I had more complex code, like a bunch of print statements, hello, how are you, imagine for a second that I wanted this all in 3 lines for some reason, then I no longer need to write those print statements 3 times. Instead, I just need to call say hello 1 time. Now note here the difference between calling say hello with parentheses versus without parentheses. If you call it without parentheses, then it's actually not going to execute the function. Python will just report back that say hello is a function. Keep that in mind, that when we're calling functions, in order to execute them, we have to add on this open and close parentheses. So if you see something like this, it means you're not actually calling the function. You need to add on the parentheses. Okay, so the main point of a function is to execute the block of code, especially when you plan on repeating that block of code. And realistically speaking, we're probably going to take some input parameters or input arguments into our function. So let's go ahead and continue. I'm going to overwrite say hello. And then I'm going to say, let's go ahead and call this name, that it takes in some name parameter. And then it's going to print out using an f-string literal here, hello, name. So what is this doing? Well, it takes in some argument called name, and then it's going to insert it right here so that it will report back hello name, which means if I call say hello, and I pass in the string Jose, it says hello Jose. A couple of things to note here. Technically, I can call this variable whatever I want. So let's go ahead and show that. I could call this jelly, and then this would have to match up here, jelly, run that, and it looks exactly the same. So typically what you should be doing is just providing variables that make sense to you. In this case, name makes a lot of sense. The other thing to note here is, let's imagine I forgot to pass in an actual value. So I just said say hello. Well, in this case, Python is going to complain. And the way to read this error is it will say it's missing one required positional argument called name, which is essentially trying to tell you, hey, we need to know what name is as an argument in order to actually execute this block of code. So how can you fix this? Well, one way is just to provide the value as mentioned. Another way is to provide what's known as a default value. And you do this with an equal sign up here, and you can provide some default value. So what this means is if name is not provided, then we'll go ahead and use this default. And in this case, we'll just say equals and whatever you want the default string to be. In this case, I literally just put it as default. So make sure you keep running these cells in order to overwrite your old function code. And then let's call say Jose or say hello Jose. It says hello. And now what we're going to do is leave it blank. Previously, when we left it blank, we got an error. But now that I reran this function definition and run this cell again, it says hello default. So it no longer produces an error. Instead, it will reach in and find the default value for that function. All right, now as we noted in the previous lectures, typically when it comes to a function call, you're not actually just going to print stuff out. Instead, you're going to use the return keyword. So let's see an example of that. I'm going to create a function called def add num, and it takes in two numbers, num1 and num2, and it's going to return their sum. Return num1 plus num2. And one of the most common questions I get from beginning students is, what's the difference between saying print in a function versus return in a function? And the main difference is that return, instead of just printing out the results, is actually going to allow you to save them as a variable. So we'll say add num here, and in Jupyter Notebook, if I were just say something like 1020 add num, notice that I see the result anyways, 30. But because I'm using return, I'm actually able to assign it to a variable. So I can assign it to a variable instead of seeing the result, and then call later on somewhere in my code that result. So let's actually see this between two functions. We will call one print result that takes in two parameters. Let's go ahead and call them a and b this time. And this one just prints out the sum, a plus b. We'll create a very similar function called return result. And this one is going to return a plus b. This way we can actually see the true difference between them. So let's first start off by running this print result function. So I will say print result. I pass in 10 and 20, so 10 plus 20 is 30. And when you run this, notice it prints out 30. You should also notice that unlike before, there is no output cell showing you that a variable is being returned. Instead, it's just printing out the result. So let's imagine that I wanted to actually save the result 30 to some result variable. What I cannot do, since I'm just using print, is the following. If I say result is equal to print result, then Python is just going to print this out, and it's not actually returning anything to this result. In fact, if I check result and try to run it, I don't get anything back, because the type is none type. Because again, print result is not actually returning anything to be saved. It's simply printing an output and then closing off the function. In order to actually do this sort of thing, where I want to save the variable, I would need to return a plus b. So let's see the return result function now. I say return result 10, 20. I see 30 is the output. Note that Jupyter lets you know something's being returned by showing you this output cell, just signifying that it's not being printed, it's being returned. And now what I can also do is say result is equal to return result. And now if I call result, it's actually the number 30. So again, just having print here is not going to allow you to actually grab the result. Now that doesn't mean you can't use print and return together. If for some reason, keep in mind it's not super common to do this, that you wanted to see both the printed result and be able to return it, then you could just do something like this. You could say def, call it myfunc, takes an a plus b. It will go ahead and inform the user by printing out a plus b, and it will return a plus b. Now this is not too common to do this. You usually either just return or just print. Most common just return. But if for some reason you find yourself saying, in my large script, I want to be able to kind of view the results as they're coming in, then you could print and then also return, which kind of allows you to get the best of both worlds, so to speak. So I could say result, my function, 10 and 20, run this. Notice that this print gets executed, but then this return also gets executed. So now result is equal to 30. Again, not super common to do this, but when you're debugging sometimes as a beginner, it is useful to have these print statements within a function, so you can see what's going on internally. Now the last thing I want to point out in this lecture is the fact that we were just saying a plus b in the function. But keep in mind, we weren't actually checking what the data types were. So if I called a function sum underscore numbers, it takes in num1, num2, just as before, and it returns num1 plus num2. Nowhere in this am I actually checking to make sure these are numbers. And if you're coming from another programming language that is statically typed, that is to say you have to make sure and define the data type of a variable before you call the variable, then you may not be used to this. Python is dynamically typed, which means I don't need to specify beforehand what data type I expect num1 and num2 to be. That allows you to program a lot faster, but it also leaves you open to possible bugs. Let me show you what I mean. If I say sum numbers, and I say something like 10 and 20, I get the result I expect, 30. But that can get dangerous when I say something like sum numbers, 10 as a string, and 20 as a string. Since these are strings, the add sign will actually concatenate these together, meaning I get the result 1020, which almost looks like 1020, which is not what I was expecting here. And when you're taking user input, it will show up as a string. So recall from the useful operators lecture that the input function returns a string. So that means if you find yourself creating a function that another user will be interacting with, you should probably be making sure to check the type of the data before returning the result. And we're actually going to have a much deeper discussion on this when we start heading towards your milestone project. So keep that in mind for now, and later on we'll show you different ways of having to deal with this and making sure the right data type is being returned by a user. So keep this in mind for now. Later on we'll show you various ways of potentially addressing it. Okay, that's it for now. Coming up next, we'll show you how to add in logic to internal function operations. I'll see you there. Welcome back, everyone, to this lecture on using functions with logic. We already know a lot of logic statements within Python, things like for loops and while loops, if statements and else statements, and so on. So what we're going to do is to begin combine that knowledge with the ability of a function. So let's get started. We're going to start off with a very simple function that just checks whether or not a single number is even, and we'll expand the complexity from there. Let me head back to the Jupyter Notebook. All right, here I am in the Jupyter Notebook. I want to do a quick recall about the mod operator, which essentially returns the remainder after a division, which means if the mod operator is end up equals to 0, then the number is evenly divisible by whatever the mod operation was. So to give you an example of this, if I were to say 2 mod 2 and run this, then the result is 0, because 2 divided by 2 is 1, remainder 0. If I were to say 3 mod 2, then 3 divided by 2, 2 goes in once into 3, and then there's a remainder of 1. So recall that this mod operator just returns back the remainder after division. So for example, if I were to say 41 mod 40, take it a second to figure this out, basically it should be remainder 1. Since 40 can go into 41 one full time with a remainder of 1. Okay, so how can we use this to check if a number is even? Well, if a number is even, such as 20, then I know that that number, mod 2, should be equal to 0. So essentially, any number I put in here, if I provide the mod operator and it ends up being equal to 0, then I know it's even. If not, then it's not even. So for example, I could do a check like this. I could say 20 mod 2 and check for equality against 0. Because I know if the result of this mod 2 is equal to 0, then I have true, it is an even number. Otherwise, such as 21, odd number, and I do mod 2, set it equal to 0, then that's false. Okay, so let's construct this into a function. That way we can place any number here instead of having to manually type in 20 and 21. We start off with the keyword, def. Call your function whatever you want. I will call mine even check. Notice the snake casing here. We have to pass in an argument. I will call the argument number. This is where you have flexibility on what you want to call it. And then what I need to do is inside of this, I need to say the number mod 2 equals 0. And so what this is going to do is if I say something like result is equal to number mod 2 equals 0, I could return the result, run this, and then I can have even check. And so even check 20. 20 is true because this is true, so the result is true. And then I can say even check on 21, and it returns false. 21 is not even. Now, for beginners, it's really common to separate things out into multiple lines like this. But keep in mind, I don't actually need to save this as a result parameter. Instead, I can directly return number mod 2 is equal to 0. So if I paste that in, this is actually the exact same thing. So if I run this again, I get the same results. So again, it's really common for beginners to kind of duplicate lines when really you can just return something that is the Boolean check. So we have a function that can check if a single number is even, and then it returns back a Boolean, true or false, whether or not it's even. Let's go ahead and check inside of a list. So what I'm going to do here is I'm going to start off a new function, and this function is going to return true if any number is even inside a list. Okay, so again, there just has to be a single even number inside of a list, and the list can be as long as you want, and it's going to return true if that happens to be the case. Otherwise, it will not return anything. So we'll say def, and I will call this now check even list. It takes in a parameter, and now this parameter is going to be assumed to be a list. So we'll say num list. And what I need to do is I need to loop through each number. So we're going to start adding in logic that we already learned about, like a for loop. So I can say the following. For every number in the num list, and recall num list is going to be passed in by the user, I'm going to have another colon here. And notice how now we have different layers of indentation. I have this first one, which is everything inside the function. And now I'm going to have this second one, which is everything inside this for loop. So for number in num list, first let me check if I get a so-called hit on an even number. So if that number, mod 2, is equal to 0, well, I'm technically already done. Since I'm just checking if any number is within a list, then the very first time that I hit an even number, I can pretty much return true. So I will say, whoops, forgot my colon there. If number mod 2 is equal to 0, I'll return true. So note here that I'm going to go through every number in the list, and the very first time I get number mod 2 is equal to 0, then I go ahead and return true. And what I'm going to do is say else, and I'm going to use the pass keyword. And pass just means don't do anything. So let's go ahead and look at the logic here. I pass in this list of numbers. I start going through every number in the number list. If I get an even number by saying if true, then I go ahead and return true here. Else, so let's say this is an odd number, I'm just going to pass. I'm not going to do anything. So notice here, return is actually in the middle of the function. It doesn't always have to go at the end. And in fact, we'll show you in just a second how you can have multiple returns inside of a function. So let's first check that this actually works. I'm going to say check even list, and let's pass in a list that has all odd numbers. Notice nothing is returned. Now let's say check even list that has 2 even numbers in it, and it returns back true. There is an even number there. And let's do a couple of edge cases just to make sure this is working. Let's go ahead and have the first number be even. It returns true. And let's go ahead and have the last number be even. And that also returns true. Okay, so it looks like it's working. So what it's doing is just looping through these numbers until it finds an even one, and then it just breaks out of the function and returns true. And in fact, you can think of this return statement as essentially going to break off the entire function and end the function call. Once you call return, that's it. The function's over. It's not being run anymore. So currently, our function doesn't return anything if there is no even number in the list. Let's say we actually want it to return false. How can we fix this? A super common mistake that a beginner would make is they would simply change else here to return false. However, this is wrong. Why is this wrong? Well, I just mentioned you can think of return as essentially breaking out of this function. So why is it wrong to put return false here when it was correct to put return true? Often beginners make the mistake that all the return statements should have the same level of indentation, but that's actually not true. Because look what's going to happen here. We're going to say for number in number list, and then the very first time that a number is not even, we'll say, okay, in other words, just return false. Essentially saying that this if-else statement is only going to be able to check one number because both conditions will immediately return something. So if I were to actually run this, let's go ahead and run this on, let's say 135. So that returned false correctly, but now let's put in a 2 there. It should return true, but notice it returns false because it's essentially only checking the first number since there's a return call on either condition that the first number has. So that means this return should actually not be here. In fact, where should it be? Well, I want to make sure I've already checked every single number and whether or not it's even by the time I return false. So the return false should actually be in indentation with the for loop here. So what this says is go ahead and complete the entire for loop. If this has completed and we never broke out of the function with this return statement, then go ahead and then return false. So let's go ahead and run this and see if that works. So notice 125 returns true. If I change this to 135, now it correctly returns false. Again, a super common mistake beginners make is they think all the returns have to be indented together. But we can see we really need to focus on the logic of what's happening here. We want to loop through all the numbers first, and we can use these pass statements as placeholders to essentially say don't do anything. And that will be very useful when you have a function that needs or requires multiple return statements. Let's expand this one more level of complexity. Let's imagine that we actually want to return all the even numbers in the list. So I don't just want to say true or false, is there an even number? I actually want to return them. So let's go ahead and start adjusting our check even list. So again, what we want to do here is I want to return all the even numbers in a list. And if there are no even numbers, we'll go ahead and just return an empty list. So what do I need to do here? Well, this code may come in handy, so I'll keep it for now. But what I'm going to do is start off with an empty placeholder list. We'll say even numbers is equal to an empty list. And it's very common at the top of a function call, if you intend on returning something, if you don't have it defined as an argument, that you define it up here as some sort of placeholder. So often you'll have placeholder variables at the top of a function. So here, even numbers is essentially a placeholder for what I eventually will return. And so I'm not going to be returning true or false anymore. What do I actually want to return? I want to return the list of even numbers. So what I'm going to do here is I'll still go for every number in the number list. If I do happen to have an even number, I will append it to my even numbers list. I'll say even numbers dot append, and it's called number here, so I'll copy and paste number. Okay, so again, I'm going through the number list. If I attach an even number, I will append it to my list. Otherwise, I don't want to do anything if it's not even. And then just as before, I want to make sure we've looped through every single number in the number list before I return even numbers. So I'll come back here and say return even numbers. So again, the return here is lined up with the for loop because I want to go through the entire logic of the for loop, and only when there's an even number do I do something. And then I return the even numbers list. Let's go ahead and check this out. I'm going to delete a couple of these. So we'll say check even list. If I say 1, 2, 3, 4, 5, I run that, it returns back 2 and 4. Looks like it's working. If I say check even list 1, 3, 5, all odd numbers, I get back an empty list. Okay, that's it for this lecture. Coming up next, we're going to discuss about returning tuples for unpacking with functions. I'll see you there. Welcome back, everyone. In this lecture, we're going to discuss functions and returning multiple items from a function with tuple unpacking. Let's get started. Now recall that we've previously seen we can loop through a list of tuples and unpack the values within them. For example, let me create a list of tuple called stock prices. And what I'm going to do here is the first item will be a ticker and then that stock's price. So we'll say Apple is at 200, and I'm just completely making up these numbers. Then we'll say Google is at, say, $400. And then finally, we'll say Microsoft, $100. Okay, so we already know that I can actually say for item in stock prices, print item, and it prints out the tuples. I also know that I can do tuple unpacking, which means I can actually individually grab the items from these tuples. So I can say for price, or actually for ticker and price in stock prices, print, let's say, just a ticker. Run that, and what it's doing is it's unpacking ticker and price separately, so I can do different things with them, such as ticker, or maybe I can say print price plus, let's say, 0.1 times price. So I want to see what a 10% increase would look like. So I can run that, and now I can see a 10% increase in the prices. Okay, so that's tuple unpacking. Now we've seen how we can do it with a for loop, but we can also do it with a function. So a function can actually return things as tuples, and then we can unpack the result from the function. So let's go ahead and do kind of a more complicated example here. I'm going to say work hours, and this is going to be a list of tuples that has an employee name, let's say Abby, and then the hours they happen to work that particular month. So we have Abby at 100 hours. Let's go ahead and have Billy at 400 hours, just kind of making these up. And then let's have Cassie, whoops, make sure that's a string, at 800 hours. So kind of extreme values here, but they're totally made up. Okay, so we have these work hours over some period of time. And now what we want to do is we want to see who is the employee of the month or the employee of the year. And the way we judge that is by the employee that has worked the most hours. And we want to return not just the employee name, but also the amount of hours worked. So I need a function that can actually then go through these tuples and then see the name and the corresponding hours and keep track of the name that has the most hours. So how can we do this? I'll create a function called employee check, and it accepts this list of tuples, work hours. And then as I've stated before, typically we're going to have placeholder variables when it comes to logic at the very top of a function. So I'm going to have two placeholder variables. I'm going to have a current max, and I'm going to set it equal to 0. And then I'm going to have an employee, let's say of the month in this case. We'll say employee of month, and that's equal to an empty string. Because at the end, I intend to return a tuple. So I intend to return a tuple that says employee of the month along with the current max, which is the current max hours. So why do I have current max equal to 0, and what is current max going to do? Well, what current max is going to do is it's going to start off at 0, and then it's going to compare each employee's hours to the current max hours. And if they beat the current max hours, then I will reset the current max to their value, and I'll reset the employee of the month to this string. So we have to do a for loop to see this. We'll say for, and here we'll do some tuple unpacking, for employee, comma, hours, in work hours, which recall is this list of tuples. What I'm going to do is I'm first going to check if the hours that they've worked is greater than my current max, then I'm going to reset my current max equal to the hours that that particular employee worked. And then the employee of the month is going to be equal to the employee in that tuple. So what does that actually mean? Well, recall that my current max starts off at 0. So immediately, the very first person I see has beat, supposedly, 0 hours. So that means Abby starts off as employee of the month, and my current max hours to beat is 100 hours. Otherwise, I'll simply pass. So let's go ahead and see what happens when we reach Billy. We see Billy, we extract Billy's hours is 400. Is that greater than the current max hours? Well, in this case it is, because Abby only worked 100. So then I reset the current max, essentially the target to beat, as 400, and then I set Billy as the employee of the month. And I keep going throughout this. So then Cassie is going to end up beating Billy's 400 hours, and then she'll be the employee of the month. And what I'm going to do is return this then as a tuple. So again, here's all the code. Let me go out one level of zoom so we can see this all. Going to run this, and let's run our employee check. And I'm going to run it on my current existing work hours. That's the variable we first assigned. And as we suspected, Cassie won. So let's make sure this is working. Let's go ahead and say Billy worked 4,000 hours. So we run this again, employee check, run that, and now I see Billy 4,000. So again, what it's doing here is it's just tracking who worked the max hours, and essentially who do we have to beat. And eventually what's going to happen is we'll find out who worked the max hours, because no one will start beating this equation right here of hours greater than the current max, which means we never ended up resetting current max, and we never end up overriding that employee of the month. So essentially, once Billy comes in and he hits 4,000, Cassie doesn't end up beating him with 800, so Billy stays as the assigned variable employee of the month. Now we just saw this returned back this tuple. So what we can do is two things. I can either say result is equal to employee check, and if I take a look at result, it says Billy 4,000, or just as before with the for loop where I said ticker comma price, I can do the same thing if a function returns back this tuple. So it's really common to see something like this. I can say name comma hours is equal to employee check work hours, run that, and note what happened. Unlike before where result, if we see it here, is the tuple, I did tuple unpacking, and now I have the name Billy and hours as separate variables. So I can actually perform tuple unpacking with a function call. Now, a really common error is when you're using someone else's function or a function from a different library that you're not too familiar with, maybe we think that, oh, this function also gives the employee's location. So let's see the result here. Let's say name, comma hours, comma location. Now I know for a fact it doesn't report back the location. If you run this, you get an error. And this is a very common error where it says not enough values to unpack. And very common error to get when you're dealing with functions that you don't 100% know what they return. So you notice here, it actually tells you, hey, expected 3 got 2. Expected 3 is basically what you expected. You expected 3 values, but you only got 2. So how do you actually deal with this sort of error? The easiest way is to just assign everything to a single item and then begin exploring that item. And then you can see, oh, I only have those two values and it looks like it was a name and the hours. I don't actually have a third location item. All right, that's it for returning tuples for unpacking. Again, you can review this when we discussed for loops as far as tuple unpacking within a for loop, and you can kind of review this function call in the lecture notebook. If you have any questions, feel free to post to Q&A forums. We'll finish off this lecture series by just creating a very simple function program that essentially shows interactions between functions. I'll see you at the next lecture. Welcome back, everyone, to this lecture on interactions between functions. Typically, a Python script or Python notebook contains several functions interacting with each other. We take the results of one function and often use that as input to another function. What we're going to do is we're going to create a few functions to attempt to mimic the carnival guessing game 3 Cup Monty. And in case you're not familiar with this, it's basically you start off with 3 cups and underneath one of them is hidden a red ball. And then what you're going to do is you shuffle these cups around, have the user guess where the red ball is, and then they're either right or wrong. So our very simple game won't actually show the cups or ball. Instead, we're going to mimic this with the effect of a Python list. So it's going to be a Python list with 2 empty strings and then 1 string that has just a capital O, which will be our ball. And our simple version will also not show the shuffling to the user, so the guess for the user will just be completely random. Our main focus here is to show you how multiple functions can end up interacting with each other and returning objects to each other. Okay, let's get started. All right, here we are in the Jupyter Notebook. To begin, I just want to show you how you can shuffle a list at random in Python. And Python actually comes in with a built-in random module, and we covered this module in more detail later on. But for now, I'll show you just the shuffle function that can come from the random module, and we'll show you how to import it. And we'll talk a lot more about imports later on in the course. But for this case, let's go ahead and make an example list. Let's say it has 7 items in it, and I want to randomly shuffle the list. Well, I can say from random import shuffle. And the shuffle function will actually shuffle a list in place, meaning it doesn't actually return anything. It just grabs that current list and then shuffles it. So we can say shuffle the example list, and then when you call example again, you'll notice that it's been shuffled. So we're going to be using this built-in shuffle from the random module inside of Python within one of our functions. So let's start by creating our simple game. First, I'm going to create kind of our own version of shuffle, which actually returns the example list. Notice shuffle example here doesn't actually return anything. For example, if I were to try to say result is equal to shuffle example and then call result later on, it's actually happening all in place within the example list, so nothing is returned, which means I can't actually do this. So what I need to do is create my own function for this. So say def shuffle, and we can't call it shuffle because that's the same name as the function space and we can't share that namespace. So we'll say def shuffle list, which is going to take in my list. It will shuffle my list, and then it will also return my list. So adding just a little bit of functionality on top of the built-in shuffle. Since the built-in shuffle won't return anything, it just does it in place, and I actually want to be able to return it and use it as a result here. So let's see if this works now. I'll say result is equal to shuffle list. Let's pass in our example. We check out our result, and it's shuffled. And each time I run this, you'll notice it kind of shuffles it in a different way. Perfect. So we have a function that can shuffle this list. So what is our actual game list going to look like? Well, as I noted previously, our game list is just going to be 3 strings, with one of them being essentially a capital O as our red ball, and the other 2 are empty strings. So what the user is going to try to guess is where is this hidden capital O. So eventually what we're going to be doing is calling shuffle list on my list, and then it will shuffle this around, and the O may or may not be in the same spot. Next, we need to create a function that can take in a player guess. So the player, after the list has been shuffled, is going to guess the location. And we won't display where the list is before we shuffle. So what I want to show you is a function called player guess. And this takes in no arguments. Instead, we start off with a placeholder of the user's guess. And the user can guess essentially one of 3 index positions. They can guess it's either index 0, index 1, or index 2. So we start off with an empty guess, and then we'll say guess is equal to input function, and we'll say pick a number 0, 1, or 2. Now, in order to make sure that the guess is actually correct, we could add in some extra code here. Basically, as we mentioned before, we can use a while loop to make sure that the input is correct. So I could say while the guess not in 0, 1, 2, colon, go ahead and keep asking for this input. And then once that's finalized, go ahead and return the integer version of guess. You may be wondering, why are these strings and why are you casting it as an integer at the end? Well, that's because input returns and always returns a string. So even if you type in the integer 0, 1, or 2, it's going to return it as the form of a string, which is why we're checking the string 0, 1, and 2, but I'm returning it as an integer since I will use it to directly index off this list. Let's go ahead and run this so you can see what it looks like. I call player guess, open close parentheses, run this. It says pick a number 0, 1, or 2. If I provide an incorrect value, because of that while loop, it'll keep asking me over and over again until I get either 0, 1, or 2. So if I pass in 1, that's perfect, and then I get the result 1, which I can save. So I could say my index is equal to player guess, run this again, and if I pass in 2 this time, you'll notice that my index is now 2. Perfect. So we just need one more function, which is to essentially combine this list that has been shuffled with the player's guess. So I just need to check that my guess was correct or not. So we'll say check guess, and this is where the functions begin to interact with each other, because I will pass in my shuffled list and I will pass in the user's guess. So that means I should have called player guess and my shuffle list function before calling this check guess function. And so what we're going to do at the end of this notebook is write a little script that essentially calls the functions in the correct order. So we'll say def check guess, and we'll say if my list at my guess index position is equal to a capital O, then I'll simply just print correct. Else, I will print wrong guess, and let's go ahead and tell the user where it actually was by printing out that list. Note, in this case, I don't actually care about returning anything because this will essentially be the last line in my little script. So I have my functions defined, and now it's time to set up a little bit of logic as a final script. So if you're dealing with this in a .py file, it's very common to have a bunch of function definitions at the top, and then at the bottom, you have the actual logic to be called here. So what I need to do is set up my initial list, then I need to shuffle that list, then have the user guess the location, and then I will check against the list with the user guess. So how do we do this? We'll start off with my list, which is an empty string, an O, and another empty string. So the O starts off in the middle. And then what I'm going to do is I will have a mixed up version of this list, and I will call equals shuffle list on my list. So that's step 2. And this is where I'm also going to grab the user guess. So I'll say guess is equal to the result of player guess. And then I'm going to check the guess. So we'll say check guess. And that will pass in the mixed up list along with the user guess. So this is really where the functions start interacting with each other, because I will shuffle and get a mixed list, and then I will get the player guess. And this third function takes the results of those two other functions And this is what's going to allow you to write much more complex code. The fact that you can have separate functions doing separate parts and then interact with each other later on within another function. So you can see here that I'm actually able to write more complex code because I've been able to compartmentalize a lot of these functions and a lot of this complexity to just certain function calls. So this is really easy to read, and then if I ever have a question on what player guess is or what shuffle list is, I can review by going back up and checking my function definitions. So I can begin creating really complex code that is still actually quite readable. So let's run this and see how it works. So it says pick a number, 0, 1, or 2. Let me just input a wrong number to make sure it's still working. I hit 8, it asks me again. Looks like that's working. Let's just guess location, index position 0, see if I get lucky. I have 1 in 3 chance of getting it right. And it was a wrong guess. So notice here, I said 0, 0 is empty string, and it's currently lying at index 2, which also lets me know that the shuffle list is working because my initial list had the O at index position 1. All right, that's it. Go ahead and check out the lecture notebook in case you have any more questions on this. It's kind of set up in a step-by-step manner there, or you can post the Q&A forums if you have any questions. If you're trying to follow along but you're getting errors, make sure you try running our notebook first to make sure you didn't commit a simple typo. Thanks, and I'll see you at the next lecture. Welcome back, everyone. In this lecture, we're going to be discussing two functional parameters that you'll definitely be encountering as you look at other people's code and as you begin to look at open source code on the internet. And those are star args and double star quargs, and they stand for arguments and keyword arguments. Eventually, if you work with Python functions long enough, you're going to want a way to accept an arbitrary number of arguments and keyword arguments without having to predefine a bunch of parameters in your function calls. So let's show you what I'm talking about by jumping to a Jupyter Notebook. Let's begin by doing the following. I'm going to create a function, def, and we'll call it myfunc. And what this function is going to do is it's going to accept two numbers, number A and number B, and we'll put a little comma here, returns 5% of the sum of A and B. So let's go ahead and do that. What we're going to do is say sum, and we need to pass this in as a tuple or a list here, A and B. So it takes the sum of everything in that tuple, A and B, and then we multiply it by 0.05. So then when I call my func, and let's pass in two numbers, let's say 40 and 60. Well, 40 plus 60 is 100, and 5% of 100 is 5. All right, great. Now the question arises that what if I had more numbers or more parameters to pass in? Notice right now that A and B, these are examples of what are called positional arguments. That is to say that right now 40 is assigned to A because it was in the first position or the first argument, and that 60 is assigned to B because it was in the second position or second argument. And notice that when we want to work with multiple positional arguments in the sum function, we had to pass them in as a tuple. The question I was saying was, what if we want to work with more than two numbers? Well, one thing we could do is assign a lot of parameters. So I could say, well, just in case the person passes in C, I'll have a C there, and I'll set it default to 0 just in case they pass it in. That way, just in case they don't pass it in, it's 0, it won't affect the sum, but they can always overwrite it. And what if they want four numbers? Well, then I'll say D is equal to 0 as well, and I'll have D equal to 0, D here by default. And if I want another number, I can say E equal to 0 here, and we'll say E is here as well. And now I still get back the same result, but I can always pass in more parameters here. So now if I pass in an extra 100, I get back 10 as 5% of 200. And if I want 5% of, let's say, 300, then I end up getting 15 here. And I can keep adding, but you'll notice I'll eventually hit a limit up to E, because if I keep adding in more numbers, eventually I'll say type error, hey, it only takes from 2 to 5 positional arguments, but 6 were given. And this is where we can use that star args. It allows us to set this to take an arbitrary number of arguments. So when a function parameter starts with that star or asterisk, what I'm going to do here is say df myfunc star args. What this allows me to do is treat this as a tuple of parameters that are coming in. And then I'm going to say return sum of args, and then multiply that by 0.05. And now I can pass in as many arguments as I want. And by default, what Python is going to do is it's going to take all the parameters that are passed in and set them to be inside a tuple. So we're going to pass in, let's say, 40 and 60, and we get back 5. If I add in another 100 there, I get back 10. And I can keep adding in as many numbers as I want here with no problems. And that's basically the whole point of this star args. And I want to just really bring the point home that if I just print out what args actually looks like to this function, it just looks like a tuple here. So all this does, when it starts with this star term, it says, okay, whatever this parameter is, the user can pass in as many as they want, and it's going to be treated as a tuple inside of this function. And that's really useful for a lot of things. You can loop through it, or iterate through it, or sum it together, or do any sort of aggregation function on whatever this tuple that is being passed in. You should also notice that by convention we use args, but this technically is indicated by the fact that there's that star term there. Args can be any other keyword you want. For example, if I say star spam and I say print spam, it has the exact same effect. Args, that word itself, is an arbitrary choice as long as it's followed by this asterisk or star. Now, by convention, you should always use args. Otherwise, someone else is going to be reading your code and scratching their head thinking, why did this person choose spam? So by convention, by pep8 styling, you should always use star with args. Okay, so that's arguments and an arbitrary number of arguments. So you just pass them in now, and you get to have them as a tuple inside your function. So then you could do something like for item in args, print item, and you get back 40, 60, 100. So this allows you, again, pass in as many arguments as you want, and you get this tuple of arguments to play around with inside your function. Similarly, Python offers a way to handle an arbitrary number of keyworded arguments. So instead of creating a tuple of values, what happens is we use star quargs, which is keyword arguments, and that builds a dictionary of key value pairs. So let's build out a function that utilizes that. We're going to say df myfunc star quargs, and we will say if, let's make a function, if fruit is in keyword arguments, then I'm going to print something like my fruit of choice is, and then here is where we're going to use .format. And the .format call is keywords arguments. We're going to treat it as a dictionary that's coming in. So just like args here, so star args returns back a tuple, what star keyword arguments does, it returns back a dictionary. Meaning, I can grab this, pass in fruits here, and let me zoom out one level so we can see the whole thing. And then I'm going to say else, print, I did not find any fruit here. Okay, so what does this actually mean? Well, it means the following. I can call my func now and pass in fruit equal to apple. And it turns out that it says my fruit of choice is apple. And I can also pass in some other keywords. Maybe I want to say my favorite veggie is equal to lettuce. And Python is no longer complaining. And that's the power of these arbitrary keyword arguments. What keyword arguments now is if we print it out at the very beginning, it's just a dictionary. We see here that fruit is now attached to apple, veggie is now attached to lettuce, and it allows you to call it any way you want. So just like args up here returned back a tuple, keyword arguments returned back a dictionary that you can then play around with inside your function. So now the user is going to be able to define any parameters you want and they're going to be able to call them and use them later on inside of your function. And again, kwargs, that is technically an arbitrary choice. What is really indicating this to be a dictionary once it's inside is the use of 2 asterisks here, or 2 stars. So again, I'm going to change this to something that's to make that really obvious. I could say star star jelly, and let's delete all this and just say print jelly. You notice I get back the same result here. So by convention, you should be using kwargs or keyword arguments here, but keep in mind what's really indicating to Python that it's special is these 2 stars in front of it. And now to end our discussion of arguments and keyword arguments is we can actually use these in combination. So I will show you a simple example of that. You can check out the notebook for another example of this, but we're going to accept both arguments at the beginning and keyword arguments at the beginning. And we'll say the following. We're going to print out I would like blank blank, and I'm going to say dot format, and we're going to grab args of 0, and then we'll say kwargs of, and we'll expect it to be some sort of food item there. So then I can call my func, and I can pass in as many numbers here as I want, so 10, 20, 30, and those will now be accepted inside of the tuple, and then after that I can pass in as many keyword arguments as I want. So I could say something like fruit is equal to orange, food is equal to eggs, and maybe animal equal to dog. And then when I run this, what happens is it takes in the args. So let's print these out so we can really see what's going on here. And takes in the keyword arguments as well. Keyword arguments here. It takes in those arguments, takes them in as a tuple so you can do whatever you want with them. It takes in the keyword arguments, sets them as a dictionary so you can use whatever you want with them. And then you can kind of look for things here and then print out whatever you want. And again, this allows you to take in an arbitrary number of arguments that you don't need to define beforehand. And this is going to be especially useful when you begin to use outside libraries. So right now, at your current stage, you're not going to find a whole lot of use cases for args and keyword arguments, but later on, they're going to become incredibly powerful tools for you to leverage in your own code. But for right now, you should just keep in mind that you have a way to accept an arbitrary number of arguments. The only final point I'd like to make here is that because we said args first and keyword arguments, it has to go in that order. We have to have that list or tuple of arguments, and then after that, we have to have the keyword arguments. What we're not able to do is after this, define an argument without a keyword. Otherwise, Python's going to complain. It's going to say, hey, you have a positional argument which is following a keyword argument. It has to be in the same order you prescribed, which was all the arguments first, then all the keyword arguments. All right, that's the basics of args and kwargs. I hope you found that helpful. We'll see you at the next lecture. Welcome back, everyone. In this lecture, we're going to be discussing some function practice problems. Learning about Python functions is going to increase your general Python skills exponentially. However, this also means that the difficulties of problems that you can now solve is also going to increase drastically. So this is where, as a beginner in Python, you're going to make a big leap in your abilities. So in order to get comfortable with this leap, we're going to give you some practice problems that allow you to get some practice in converting general problem statements into Python code. Previously, a lot of your assessment test exercises have specifically told you what to do, either to use a for loop or to use list comprehension or use some sort of if statement. Now, we're just going to give you a general problem to solve, and then you're going to have to decide what's the best way to solve it. And a lot of times, there's multiple ways of solving these exercises. So we're going to go through a series of function practice exercises, and then after this lecture, we're going to go through the solutions. Now, there are 2 options for this material. You can either try out the exercises yourself and then go through the solutions, or you can treat the solutions as a code-along lecture for more guided practice. So if you're still feeling a little bit uneasy with Python functions, you can go ahead and jump to the next lecture and just code along with us for the solutions. later on in this same section of the course, we're going to have more function practice problems in case you want to try out even more. Okay, so let's go to the notebook to show you a quick overview of what we expect. All right, so here we are at the GitHub page for all the notebooks. Come over to Methods and Functions, click on this folder, and you'll see the Methods notebook and the Functions notebook that relate to the lectures we just went over. And then we have Function Practice Exercises, as well as Function Practice Exercise Solutions, which we're going to go over in the next lecture. Now you also notice that there's Functions, Methods, and Homework Solutions. Those are going to be for later on for additional practice, but right now, let's check out the Function Practice Exercises. So if we click on that notebook and open it, we get back this. And these problems are arranged in increase in difficulty. So we start with some warm-up problems, and these can be solved using some basic comparison operators and some basic methods. And then we have these level 1, and these may involve if-then conditional statements and some other simple method calls. And then level 2 may require iterating over sequences, usually some kind of loop, like a while loop or a for loop. And then we have challenging problems, and these take some creativity to solve, so they're much harder, and you can kind of treat these as bonus questions. So we don't expect you to solve these challenging ones right away. So you notice throughout the questions, basically, there's the section and some explanation as a word problem of the question, and then an example of what we expect it to look like. So let me show you this example right here. It says lesser of two evens. We want you to write a function that returns the lesser of two given numbers if both numbers are even, but returns the greater one if one or both numbers are odd. So we can see here, both numbers are even, 2 and 4 are even, so it returns the lesser one. However, here, not both numbers are even, 2 and 5, so it returns the greater one. So now you have to think of a couple things. How do I convert these word problems into Python code? How do I check if something is even or odd? And we've already talked about the mod operator with the % sign to check if things are even or odd. And then you want to learn about, well, how do I convert the sort of if statements into actual Python if statements? So that's the idea. We want you to convert these word problems into solutions using Python functions. And we have examples here of what the function call is going to look like, what you should pass in, an example of what you should see back out, either true or false, in this case for this animal crackers problem. And we've also went ahead and filled out some cells for you to code in. So those are the warm-up problems, then we have the level 1 problems that you'll go through, and then we have the level 2 problems as well, and then all the way down towards the end, we have the challenging problems. You can kind of treat these as a bonus, you don't have to go through them yet, but try your best on all of these problems. Now I want to make it very clear that we understand you're still beginning and it's basically your first time using Python functions. So if you're feeling a little uneasy, if even these warm-up problems are really hard for you, go ahead and jump to the solutions lecture and watch me code through these problems. It's really going to help you a lot. And don't feel like you're losing out on your chance to test yourself, because later on, if you come back to this, we have functions and methods homework, which is going to be even more function practice for you later on in the course. So we can go through these function practice exercises as code along if you want to. So feel free to jump ahead to the solutions, treat it as a code along because you're going to have more practice in your homework later on. But if you want that extra challenge, if you're feeling up to it, I would really recommend that you download this notebook, try your best to go through it, and then see how you did against the solutions. Okay, we'll see you in the next lecture where we actually begin to code along through the solutions. In this lecture, we're going to code along through the solutions for the previous function practice problems. Let's get started. Okay, let's begin with this warm-up section. And this one was called lesser of two evens. We wanted to write a function that returns the lesser of two given numbers if both numbers are even, but returns the greater if one or both numbers are odd. So here we have our function, and it takes in a number a and a number b. The first thing we want to do is probably check if the numbers are both even, and that way we have an if statement. So we'll say if a mod 2 is equal to 0, so that is to say when you divide a by 2, does it have a remainder of 0, indicating that it's even, and the same for b. b mod 2 is equal to 0. So if this statement happens to be true, so if this condition is true, that means we have both numbers are even. So I'm going to say here both numbers are even. And in this case, when both numbers are even, we want to return the lesser of the two numbers. So we'll say the following. We're going to say if a mod 2 is equal to 0 and b mod 2 is equal to 0, let's check the greater number. If a is less than b, we're going to say result is equal to A. Else, result is equal to B. And then off of this, what we're going to do is say else. So now, one or both numbers are odd. And in this case, we want to return the greater, so we're doing the exact opposite here. If A is greater than B, say the result is A, else the result is B, and then all the way at the end here, we can return the result. Notice the indentation here. All right, so this is one way of solving this problem, just using a bunch of if and else statements. So let's run this and confirm that it's actually working for us. So lesser of two evens, looks like it's returning 2 here. Lesser of two evens, if one of them is an odd number, it's returning 5. Let's make them both odd just to check. And now it returns 7. Great. So this is a viable solution for this problem. However, we can actually clean up this code a lot more. And in fact, there's a way we can run this chunk of code automatically, and that's using the min function. Previously, we saw how the min function can actually return the minimum value of a list. But if we take a look at what happens with minimum function when we pass in two numbers, such as 10 and 20, it actually returns back the minimum of the two numbers that you're comparing. And it works with just two numbers. If you want more than that, you'll have to pass in a list. But it also works the same with the max function. So then it returns the max, either 20 here when you pass in two numbers. In which case, all I need to do is the following. I can say result here is equal to the max of a comma b. And I can then say here, result is equal to the min of a and b. So we've been able to clean this up even further. And now if I run this, let's check to make sure we get back the same results here. So I get back 2, and I get back 7 when I rerun those cells. Perfect. And in fact, we can take this one step further. We can actually have multiple return statements inside here, because once you say return and it gets executed, the function will stop. So instead of saving these as results and then waiting until the very end to return your result, what we could do is just say return min AB over here, and then say return max AB over here and delete this last one. So then what's going to happen here is your function's going to go along and it says, hey, if both the numbers are even, go ahead and just go straight to returning the minimum value between A and B. Else, then go straight to returning the maximum value of A and B. And this is probably the most efficient way to do this problem. We could make it a little sleeker, maybe try to put it all in one line, but this right here is a better solution than what we saw at the very first run. And this is what you're going to see in the notebook. All right, the next question in the warm-up section was this question called animal crackers, where we wanted to write a function that takes in a two-word string and then returns true if both words begin with the same letter. So here I can see level-headed and llama both begin with L, so we return true. Crazy kangaroo begin with different letters, so we return false. So let's build this out. And we're going to do a similar thing as last time. We'll build out all the logic and then see if we can make it a little sleeker by using some keywords. So the first thing I want to do is actually grab the two words. So I'm going to create a variable called wordList and set it equal to the incoming string. And to grab the two words, I can use split. And now I should have a list of the actual two words. So let's just print out wordList so we can confirm this. So if I run this, now I see that I'm getting back a list of two words. And what I want to do is check, is the very first character in this word matching to the very first character in this word? So I could say that my first word is equal to wordList at 0, and my second word is equal to wordList at index 1. And then I want to return is first 0, meaning is that first letter of the first word equal to second 0. So is this first letter equal to the first letter of second? So now when we run this, I get back true, and I get back false here. And we can take out this print statement now to see just the Boolean results. Now we could actually edit this a little bit. In fact, notice here how I'm essentially making two index calls, 0 and then another 0 here, and then 1 and another 0 here. So what I could do is not even bother with this assignment, and instead just grab wordList itself and replace it for first here. and then I could grab word list 1 here and replace it for a second there. And now this is the exact same thing, except it's now using a double index call. So when I run this again, I get back the same results. Something to notice here that I'm not actually checking is just in case these two letters, right now they're both capitalized, and we're assuming they're both capitalized, but maybe one of them is lowercase, and I'll show you what I mean by that. Let's imagine we have crazy cat with a lowercase c. If I run this, it's going to return false, even though they are starting with the same letter. In that case, what I could do is lowercase my text, before the split. So I could say text.lower, and then after that, call the split. So I could either do that in a new line, but Python actually allows you to kind of tack these on one right after the other. So I'm going to do lower and then do .split on this. So now let's run this again. And now we can see that it confirms true because it's making everything lowercase before it actually does the split. And we can see that by printing out that word list. And if I run this again on crazy cat, I notice here crazy has now been lowercased. And it would have worked the same way had we used upper, because then it would have just uppercased the cat there. So it would have confirmed capital C matches capital C. All right, so that's the basics of that animals crackers problem. All right, our last warm-up problem is a little more math-based, and it's called makes 20. And we wanted to know that given two integers, return true if the sum of the integers is 20, or if one of the integers themselves is 20. If neither of these is true, go ahead and return false. So let's check through these three cases. First, we need to check, is the sum 20? So you can say if n1 plus n2 is equal to 20, return true. And then we can have elif cases for the other ones. We can say elif n1 is equal to 20, return true. elif n2 is equal to 20, return true. And if none of these happen to be true, then we can just return false. So when I run this code and I check it, it looks like it's working. So 2 and 3 is false, 20 and 10 is true. And if we do one that sums up to 20, 10 and 10, that also returns true. But as I previously mentioned throughout the course, if you're already checking if some Boolean statement return that actual Boolean, then what we could do is put all of this on a single line. So how do we actually do that? Well, notice it's just a bunch of Boolean checks here. So we can use these comparison operators along with a logical operator such as OR. So all we actually need to do in one line is say return n1 plus n2 equal to 20, or n1 equal to 20, or n2 equal to 20. So let's check out how this is the exact same thing as all this code that we just wrote here. We're saying check if this Boolean condition is true, or this one happens to be true, or this one happens to be true. If none of these happen to be true, then we return false. So this one single line of code is doing the same thing as all of this. And we can check it out by running this, and we get back the exact same results. All right, that's it for the warm-up problems. Coming up next, we're going to go over level 1 problems. We'll see you there. Welcome back, everyone. In this lecture, we're going to go over the solutions for the practice problems that were under level 1. Let's open up that Jupyter Notebook and continue. Okay, the first problem was this Old MacDonald problem where we wanted you to write a function that capitalizes the first and fourth letters of a name. And there's two different ways we're going to show you how to do this. One is with the capitalized method, and then the other is with the upper method. We haven't really shown you the capitalized method yet, except we added a note here that basically what capitalized does is it grabs an entire string and it uppercases the first letter in that string. So let's do it first with .upper, and then we'll show you how to do it with .capitalize. First, we want to grab the first letter. So I'm going to say first letter is equal to name at 0. And then I want to grab the characters in between. So we'll call these in between characters. And those are going to go from name at index 1 all the way up to, let's say, index 3. And then we want to grab the fourth letter. So we'll say fourth letter is name at index 3. And then finally, the rest is going to be name from index 4 onwards. So let's see if this works. We're going to just return first letter with in between with the fourth letter plus rest. So let's see if we actually get the same result there. Okay, so good. We get back McDonald. Now what we want to do is uppercase the first letter, and then we want to uppercase the fourth letter. And now when we run this, we get back McDonald. So this is how you could do this with uppercase. Using just indexing and slicing, you separate it out, uppercase what you need, and then concatenate it back together again. But you can also do this with the capitalized method. And the capitalized method is going to allow you to do fewer slices. So what we could do is kind of separate it out into halves. So we'll say first half of the name is going to be from name from the beginning all the way to index 3. So that's going to be basically the Mac part. And then the rest of it, that second half, and it's not really an even half, I should say probably second part, is going to be from 3 all the way to the end. And then what we could do is the following. I can say first half, and instead of calling upper, I'm going to call capitalize. Capitalize. And then I will concatenate that with the second half and capitalize that. And now when we run this, we get back the same results. So that's how you could use the capitalize method instead of the upper method. And basically what that does is it grabs two strings, this lowercase Mac and this lowercase Donald, and it uppercases the first letter or character in those substrings and then concatenates them together. So that's the old McDonald shown two different ways. Next we have Master Yoda, where we're given a sentence, we want to return a sentence with the words reversed. So in order to do this, what we need to do is a couple things. First, we need to actually get a list of the words. So we're already quite familiar with that now. We can say word list is equal to text.split. And now I need to somehow reverse this list. And we actually know various methods of doing that. So let me show you what I mean. I'm going to say text.split is the word list, and then I'm going to slice the word list in steps from all the way from the beginning to the end in -1, and that's actually going to be the reversed word list. Whoops, let's make sure we don't use a keyword there. Reverse word list, and let's return the reversed word list and see what happens. So notice here, I get back home am I, and then with Master Yoda, I get back ready are we. Now we do want an actual string instead of the list itself. In order to join this list, we can actually use a method called join off a string. So let me create a couple of cells here, that way I can explain how the join method works in case you haven't seen it before. Let's imagine I have a list here of a string A, B, and C. And I want to join this together. So I will call this my list. What you end up doing is you create a string. Here I'm going to have a string of 2 dashes. And then off of the string you say .join, and then you pass in my list. And what this does is it takes the string you have here, and it's going to use it to concatenate as a fill-in between every item in this list. So if I just have a space here, it puts a space between A, B, and C. If I have maybe a bunch of O's, then it's going to put a bunch of O's in between A, B, and C. So a lot of times when you want to join things together, such as words in a list, you can either have it as an empty string, just a blank string to single quotes right next to each other, A, B, C, or we can have a space here and it joins together A space B, C. So in order to actually get this back as a string sentence, what I could do is the following. Instead of just saying reverse word list, I could say single quote space single quote dot join the reverse word list. And now when I run this, I get back the actual string itself. Home am I, and then ready are we. So that's a little introduction to the join method in case you haven't seen it before. Finally, we're going to discuss the almost there, and that was given an integer n, return true if n is within 10 of either 100 or 200. So the way we can do that is by taking note of ABS. So ABS returns the absolute value of a number. So we're going to return and check for the following. we want to check if 100 minus n, the absolute value of that, is less than or equal to 10. So we want to check that, but we also want to check another situation. So we're going to wrap this in parentheses to kind of state that's one thing we're checking. Or we want to check if the absolute value between 200 and n is less than or equal to 10. And then finally, we can return this. So we're just checking, hey, is 100 minus number the absolute value of that? Basically, the difference between that number and 100, is that less than or equal to 10? Or is the difference between that number and 200 less than or equal to 10? And when we run this, we get back the correct results. So this is false, this one's true, and then this one's also true. Okay, that's the basics of level 1. Introduced a couple of new things here, mainly the .join method and the absolute value function. In the very next lecture, we're going to go over the level 2 problems. We'll see you there. Welcome back. In this lecture, we're going to go over the solutions for the level 2 problems in the function practice problems notebook. Let's get started. All right, so here are our level 2 problems. The first problem we had was find 33, which was given a list of integers, return true if this list or array contains a 3 next to a 3 somewhere. So here we can see 3 and 3 are together, so we say true. Here the 3's aren't connected anyway, so we say false. And again here, 3's aren't connected together, so we say false. So if we basically get 2 3's in a row, we know to return true. So to do this, we'll do the following logic. We'll say for I in range from 0, and we actually don't want to go all the way to the end of nums. We want to go to the length of nums minus 1, because we want to go up to the second to last digit so we can check the very next digit. If we went up to the last digit, there would be no next digit to check, which is why we're going to say for I in range from 0 to length of nums minus 1. So this is part of the trick already. And we can say if nums of I is equal to 3 and nums of I plus 1 is equal to 3, then return true. Otherwise, what we're going to do is return false. So notice what I'm doing here. I'm going to run through a for loop that goes through every single index position in this list up to the second to last one. And then what we're going to do, then what we're going to do here is check that number and the number right next to it. So nums of I, and the number right next to it is nums of I plus 1. And if they're both 3, then we're going to return true. If we go through this entire for loop and we never execute this return statement, then we know there are no 3's together and we'll return false. So let's run this and check it out. We're going to copy this, paste it here, run that, and we get back true. Let's check one of the false ones, see if it also works. Put that in, run it, and we get back false. Perfect. Now, the other alternative we could do that it doesn't look as nice as this if statement is to say if nums of I sliced to I plus 2 is equal to the list 3, 3. This is actually the exact same thing as before. It just is, in my opinion, a little less readable, but it is technically a little sleeker because you're just doing one slice and one comparison instead of 2 comparisons. So all this is doing is grabbing slices at a time and comparing them to this sublist 3, 3. All right, let's move on to this problem called paper doll. So for this paper doll problem, we wanted to say, given a string, return a string where for every character in the original, there are now 3 characters. So essentially go along and create 3 of these characters. So 3 H's, 3 E's, 3 L's, another set of 3 L's, and then 3 O's. And this problem is actually not so bad once you figure out the trick is to start with an empty string and then to keep concatenating to that string. So I'm going to say result starts off as an empty string. And then for every character in that text that I pass in, I'm going to grab my current result, so that current string, and I'm going to add on that character times 3. The other thing I could do is say character plus character plus character. So times 3, or 3 characters concatenated together, that's the same thing. And then at the end of this for loop, outside of it, I'll just say return result. And that's actually all you had to do. So the main trick here is realizing that you can continually concatenate to that string. The next question was called blackjack, which is basically using the blackjack card game as a base for the given problem statement. We were given 3 integers between 1 and 11, and if their sum is less than or equal to 21, we just return their sum. However, if their sum exceeds 21 and there's an 11, we get a chance to reduce the total sum by 10. And then finally, if that sum, even after adjustment, exceeds 21, we return bust. So let's check this out. The first thing we'll do is just actually check if their sum is less than or equal to 21. And we can do this by saying if sum of A, B, C is less than or equal to 21, return back that sum. We'll say sum of A, B, C. So sum is a nice built-in function you can use. Alternatively, you could have just said A plus B plus C. So that's the same thing as passing in this list here of A, B, and C. So we'll be using the sum keyword because it's a little more readable. All right, the next thing we're going to check is the second case, which is where we actually have an 11 there. So remember, when there's an 11, we get to reduce the total sum by 10. And then we actually check if it exceeds or not. So something we can do is say the following. Elif there's an 11 in the list A, B, C. So if there's an 11 in there, and the sum of these 3 put together is less than or equal to 31, because remember, we get to reduce the total sum by 10 when there's an 11 there. So basically, we get to check it against 31 this time. Then we get to return the sum. So then we can return the sum of this, ABC, except we're going to subtract now 10 from this. So this less than or equal to 31, basically what we're doing is now, instead of checking less than 21, because beforehand we're able to reduce the sum by 10, that means we get to check against 31. So the other way of doing this is saying sum of ABC minus 10 is less than or equal to 21. So those are the same things. And it's up to you which logic you prefer, whether you prefer to take the sum, then subtract 10, and then check if it's less than or 21, or if you just like to do the check against 31. So that's technically the same thing there. Finally, if that doesn't happen to be the case, then this person has busted, so we return bust. So now when we run this, we get back 18, bust, and then we run that one more time, we get back 19. Okay, let's go to the next problem, which is summer of 69. We wanted you to return the sum of the numbers in the array, except ignore sections of numbers starting with a 6 and extending to the next 9. So every 6 will be followed by at least one 9, and we return 0 for no numbers. So what does that actually mean? Well, we can see here 3 different examples. Here we have 1, 3, 5, so there's no 6s or 9s there, so we return back the sum of all of them, which is 1 plus 3 plus 5, which is 9. Here we get back 4, 5, and then we have a 6, 7, 8, 9. So 6 through 9 here are going to be ignored. So that's the summer of 69. We're ignoring it because, let's say, nothing got done there. So then we just add 4 plus 5, and we get back 9. Here we get 2, 1, and then we have a 6 and a 9. So these 2 numbers plus anything in between gets ignored. And then we see 11 there, and then we get back 14. And we also noted that every 6 will be followed by at least one 9 when you're given in this list. So you don't need to worry about some sort of weird edge case where you just have a 6 and then you're waiting for a 9 that never comes. Okay, so let's get started on this. The way we're going to do this is start with a running total. We'll say total is equal to 0. And I'm also going to create a Boolean value called add. And I'm going to set it to true first. And I will say for num in my array or in my list, while add is on, so while I'm still adding, while that's true, and we start off with true, if the current number is not equal to 6, then I'm going to take my total and I will add num to it. And then I will break out of here. Else, what I'm going to do is set add equal to false. And then lined up with this while loop, what I'll do is set up while not add The other way to say that is while add is not equal to true, if num is not equal to 9, then I'm going to break. Else, I'm going to add, set that back equal to true, and then break here. And then finally, after all of this, outside of this for loop, I'll return the total. So let's run this, and then we'll break down the explanation. Okay, so it looks like we got 9 here, that looks good. We got 9 here, that looks good, 4 and 5 together, ignoring all this. And then summer 69 here, we just get 2 plus 1 plus 11, which is 14. So what's actually happening here in our logic? Well, we have our total, which is 0, that makes sense. And we have this Boolean condition called add, which is equal to true. And basically, by default, I'm going to assume that I'm going to keep adding all the numbers in this list or in this array. So then I'm going through the array, and I'm saying, okay, for every number in the array, if my add statement is true, then I'll do the following check. If the number doesn't happen to be 6, I will say, take the total, add the number in there, and then I'm going to break out of that loop. So I'm going to break out of this enclosing loop, which is the while loop, which brings me back then to the for loop, and I continue along. Then I'm going to say else. So let's say the number was 6, so this doesn't happen to be true. Then I set add equal to false. So in that case, now I'm just waiting for the 9. So I'm right now in the summer 69, and I have to keep going waiting for the 9. So I'll say while not add. If num is not equal to 9, then I will break out of this while not add. Else, I will say add is equal to true, and then I will break. Okay, so this one's definitely a little tricky because we're using breaks here, and we have a nested loop situation. We have a for loop with 2 while loops nested in there. So the key thing to notice here is that this break is only connected to the while loop it's in. And these breaks are only connected to the while loops they're in, which will bring you back to this for loop so you can continue on with the numbers. I would say this is definitely probably the hardest problem, I would say, in this entire challenge, as far as the ones that aren't specifically challenging problems. But even I think that this summer 69 is probably even harder than this first challenging problem. Okay, in the very next lecture, we'll finish off our discussion by going through these challenging problems and their solutions. We'll see you there. Welcome back, everyone. In this lecture, we're going to finish off by going over the challenging problems. And we're going to start off with spy game. Now, spy game at first seems similar to the get33, except in this case, we want to write a function that takes in a list of integers and returns true if it contains 007 in order. And that actually doesn't mean in consecutive order. And we show that by the second example here. So this first example, you can see here has 007 or 007 in order, so it returns true. Now you'll also notice on the second one, it has 2 zeros showing up before a 7, which also means true. So this 007 doesn't have to be consecutive. It can also work like this, 007. And here you can see we have 700, so that returns false. So let's see how we can actually approach this problem. We'll say spy game function, and it takes in some list of numbers, num. So right off the bat, we know we're going to have to go through each of these numbers and do some sort of check. So something that might be good is say for num in nums. And right now we can say pass just as a little placeholder while we think about this. I want to check if 2 zeros show up before a 7. So there's lots of ways we could do this, but one way is to set up a code list. And our code list is going to be 0, 0, 7, and then some extra string. So we'll have X there. And what we're going to do is we're going to go through every number in this list, and if we hit the first item in this list, we'll go ahead and just pop it off. So what I mean by this is if I say for num in numbers, if my current number is equal to the first item in code, what I will say is equal to the first item in code, so code at index 0, I'm going to take that code list and pop off that first item. So what does this actually mean? It means as I'm iterating through this list, I'm checking the number and saying, hey, is this number equal to the first number in this code list? So you can imagine for this first case, eventually I hit the 0, and I say, yes, I have a match, 0 and 0. So what I do is I pop off the index at 0. So that means I pop off this 0. So then the next iteration of code looks like this. We have 0, 7, and then some string, x. And then if I get another match, then I pop off again. So I will get 7 and then the string x. And then if I pop off one more time, meaning I matched 0, 0, 7 in consecutive order, then I'll just have a list of length 1. So notice here we have our length is equal to 1. And you could also just check if length is empty or something like that, but we'll do length equals to 1 just so it's easier to understand. So then here I'll just return is the length of my code after running that for loop equal to 1. So let's walk through this one more time because the code is a little weird at first, but if we break down the logic, it'll make sense. I have this code list and it has 007 and some extra string. And I'm going to go through every number in this list and I'm going to check, is that number equal to code at index 0? If that's the case, then I'm going to pop off the first item in code. So it's first going to start off at 0. That means now code is equal to 07x. So I keep doing my for loop and I check, hey, do I have this number equal to code at 0? So that's this 0 now. If that's true, then I pop it off. And now my code list looks like this, 7x. So I keep going around until I see that 7 and I say, hey, if 7 is equal to that first item in that code list, this 7 right here, then pop off that 7. And if I'm able to go through this entire for loop, and I finally, since it's a list of integers, I have a string here, and it's going to be a list of length 1, then if length of the code is equal to 1, then I know I had 007 or 007 in order. So we can check this out by running this. Let's grab some of these examples, run them. We get back true. Let's run the second one. We should also get back true. And let's run the third one, which should bring back false. Okay, so again, this one's a little more challenging because we had to use an outside data structure and use logic in order to figure out how best to find those consecutive numbers. There's tons of different ways you could have approached this one. Feel free to share your other methods in the Q&A forum. Okay, the next question was count primes, which was to write a function that returns the number of prime numbers that exists up to and including a given number. And by convention, we'll treat 0 and 1 as not prime. So how do we actually approach this? Well, we're going to start off by saying def count primes, and we pass in some number. So that's going to be the integer itself. Now, since we're treating 0 and 1 as not prime, we might as well have a quick check for them. So I'm going to say if that number that the person inputted is less than 2, meaning it's 0 or 1, or it's a negative number, we'll just return 0. So this is our check for 0 or 1 input. Now, if we've not returned yet after this check, then we know we're dealing with a number that's 2 or greater. Now 2 itself is a prime number, and I want to make a list to keep track of prime numbers. So here's what I'm going to do, and this is kind of a clever trick, which is what makes this challenging. I will start off my list called primes with the number 2 in it. And then I'm going to set a variable x equal to 3. And what I'm going to do is I'm going to keep adding onto x until I hit the input number, and we'll check if x ends up being prime or not. So let me show you what I mean by that. So we already know that if we've gone past that if statement, then we're dealing with 2 or greater. And we have here a list. Let me zoom in just a little bit here. We have in a list to store our prime numbers. And then we have some sort of, we'll say x is some sort of counter that's going up to the input num. And we'll say while x is less than or equal to that input number, I'll say for y in range from 3 all the way up to that current number x, and then we'll take step size of 2. The reason we're taking step sizes of 2 here is because even numbers beyond 2, we already know those will not have a chance of being prime because they're even numbers. They're all going to be evenly divisible by 2. So what we're doing here is we have x, which is this counter. And then we're saying, okay, kind of a sub problem here. We need to check if x itself is prime. So x is going through every number up to the input number. And then here we need to check if x is prime. So we'll say for y in range from 3 to x in even steps, because we only want to check odd numbers there, if x mod y is equal to 0, then we know we don't have an even number there, or excuse me, we know we don't have a prime number there. So what we're going to do is add 2 to x, kind of add 2 to our count, and we'll break out of this for loop. So this for loop, all it does is this checks if x is prime, because it's going through every number in range 3 up to x. Remember, x is going then through every number up to the input number. So this is checking if x is prime. We say if that x number is ever evenly divisible by one of these numbers in its range, then we know it's not prime, and we're going to add a count 2 to kind of hop ahead past that even number, and then we'll break out of this for loop because we're done checking if x is prime. However, if we're able to successfully go through that entire for loop and we don't actually end up breaking out of it, then we have a prime number somewhere. So what we want to do is take that prime number and append it to our primes list. And this is what makes the problem challenging, is that you can use a for else statement. And this is something that's unique to Python. Note how my else is actually lined up with my for instead of with my if here. And that's because I have a break inside of my for. So what this else is saying here is if I went through this entire for loop and I never broke, then this else statement is going to execute. And again, this is something unique to Python, the for else. We haven't talked about it before, which is what kind of makes this a challenge bonus problem. So if that happens to be the case, meaning we checked and we never broke out of this, so x actually is prime, we're going to take our primes list and we'll append that x number to it. And then we jump ahead past that even number, so we'll say x is now equal to x plus equal to 2. And after this whole thing's done, we're going to print that list of primes, and then we'll return back what the question's actually asking, which is the length of how many prime numbers there are. So let me quickly go through the logic here one more time. We first check for 0 and 1 input by saying if number is less than 2, return 0. Then, since I know I'm dealing with a number of 2 or greater, I'm going to start off my count of my prime numbers with the number 2 in there, so I can start off with 3. And the bonus of starting off with 3 means I can use a step size of 2, and that's indicated here from range 3x2, as well as when I'm adding 2 to my count of x, if I end up breaking out of one of these for loops, or I trigger that else statement, because then I'm skipping along all those even numbers, which is why we have plus equals 2 here, and why we're taking a step of range 2 there. And then what we're doing is we're going through x all the way up to that number, going to check if that x is prime, and if it is prime, meaning we never broke out of this, we're going to append it to the prime list, and then add 2 to our count, and keep going through this while loop. Then we're going to print all our primes, and return the length of primes. So we run this, and we say count, call count primes here on 100. We get back that list of primes, and we get back the number 25. Now there's a clever trick you can add to this, and the fact is that you actually don't need to check every single number up to x here. Instead, recall that you're actually already storing a list of primes here. So you could say is for y in, and instead of saying range 3x2, you could say for y in primes. So that makes use of those prime numbers you're collecting as you go along. So now it's saying for y in prime numbers, check if x mod one of these prime numbers is equal to 0. And that's how we can do another x is prime check there. Keep in mind, this has to do more with math, I believe, than coding. So if this is a struggle for you, don't worry about it too much. This is more of a challenge math problem than a challenge programming problem, I would say. Especially since this is a challenge problem, it's a bonus, and you're still not quite at the skill level where you can tackle 2 problems at the same time. One is a really hard programming problem, and the other one is a really hard math problem. So this is combining both of those, which is what makes it really challenging. If, however, you really like these sort of problems, what I would check out is the Euler project. That's EULER project. Then it has a ton of these types of math problems that can, in general, only be solved with coding. So definitely check out that website if you happen to really enjoy this one. If you are totally lost in this one because of this heavy math, don't worry about it. That's why it's a challenge problem. Okay, So that's it for these two challenge problems. We also had a just for fun problem. It wasn't really a real, it was just printing out functions that takes in a single letter. So I'll bring that over from the notebook itself. So this was a just for fun, and it's basically where you had to kind of invent a dictionary that would print out these letters. And because of that, we're only able to say A, B, C, D, E here as examples. Everything else you would have to kind of manually print out. But it's just an idea of how you could print out actual graphics using Python code. And we'll get an idea later on using your first milestone project so you can have graphics that you can interact with a user. That'll be for your tic-tac-toe board that'll be printing out later on. Okay, if you have any questions, feel free to post in the Q&A forums, but we'll see you at the next lecture. Welcome back, everyone. In this lecture, we're going to be discussing lambda expressions, map, and filter. Lambda expressions are a way to quickly create what are known as anonymous functions, basically just one-time use functions that you don't even really name, you just use them one time and then never reference them again. To understand why this would be useful and in what context you would use this, we first need to talk about the map function that's built into Python, as well as the filter function that's built into Python. So let's open up a Jupyter Notebook, talk about map, talk about filter, and then we'll discuss lambda expressions. Let's get started. Okay, so we're back here at our Jupyter Notebook. The first thing we're going to do is check out the map function. You can see here, right when I type map, I'm getting some syntax highlighting, so it's green, and that indicates to me this is a built-in function. And as we know, we can use Shift-Tab to check out the documentation string. And you can see here, it expects a func, and that's short code for function, and then some sort of iterable object. You can expand this, and it'll explain a little more about what it does. But the best way to actually realize what it does is to just show you. Since we know it's expecting a function, let's quickly create a function. We'll use our def keyword, and we're going to create a simple function that just takes in a number and returns its square. So we will define a function called square, takes in a number, and it returns that number to the power of 2, or the square of that number. Now let's imagine I have a list of numbers. And my numbers are 1, 2, 3, 4, 5. And what I want to do is I want to apply the square function to every single number in my nums list. Well, one way I could do that is use a for loop, but that may take a while and it's a lot of code. Instead, what I want to do is take advantage of that map function. So the map function, what you end up doing is you pass in the function that you want to map to every single element or item in this list. So then we can say my nums. Now notice what happens when I just run it like this. I get back this kind of cryptic statement which says, hey, you have a map at this location on your computer. So this is a memory location. This by itself isn't super useful. What we need to do is actually iterate through this. So what I can do now is say for item in map print item. And what this does is it generates applying this square function to every single item in this list. So 1 to the power of 2 is 1, and 2 to the power of 2 is 4, then 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. So that's one way to quickly iterate through this. Another way you may want to use this is if you actually want the list back, you can call the built-in list function on your map, and then pass in square and my nums here. And now when you run this, you get back the actual list, 1, 4, 9, 16, 25. And these functions can actually be a lot more complex than just this simple square function. So let's show you a function that works with strings. We'll call this function splicer. And it takes in a string. I'll say it takes in my string. And what it's going to do is it's going to say if the length of my string mod2 is equal to 0, well that means it has an even number of characters in that string because the remainder after dividing by 2 is equal to 0. And in that case, we're going to return the word even, or the string even. Else, we're actually just going to return the first character of that string. We'll say my string 0. So this is a little more complex of a function than we saw up here, but it's going to work just the same way when we map it. So let's create a list of names. We'll say Andy, Eve, and let's say Sally. And then we're going to after we call list, map our splicer function to our names. We run this, and now we get back even for names that have an even number of letters in them, and we only get back first letters for names that have an odd number of letters to them. And now you can see the flexibility. You can pretty much do any function you want as long as it's going to successfully take in the argument or parameter that you pass in with this list or with any iterable object. So that's how you can use the map function. Something that I want to make really clear here when you're using the map function, notice how I'm passing in square and how I'm passing in splicer. I'm actually not calling them to execute inside of this map because map by itself is later on going to execute them. So that means when you pass in the function here to map, you do not add in the open and close parentheses. Instead, you just pass in the function itself as an argument. And that's a really important detail to note here. Otherwise, if you do this, you'll end up getting some sort of type error. It's going to say, hey, you're missing one required positional argument. Or it's going to say something like, hey, we're not able to apply splicer calls to names. And that's because we just want to pass in the function itself. We don't want to execute the function. We'll let map do that for us. That's the map function. And now let's learn about the filter function. The filter function returns an iterator yielding those items of the iterable for which when you pass in the item into the function, it's true. And that just means that you need to filter by a function that returns either true or false. Let's create a function that returns either true or false. We'll create a function called checkEven, and it takes in a number. And all this function does is it returns back whether or not this is an even number. So we will say, as we've seen many times before, return num mod 2 equal to 0. Because when you divide this number by 2, the remainder, if it's 0, then that means that it's even. If not, then we return false, and it's an odd number. Then I'm going to create a list of my numbers, and we'll have it be 1, 2, 3, 4, 5, 6. Now let's imagine I only want to grab even numbers from this list, or I only want to grab numbers that pass some sort of condition based off a function that I previously defined. What I could do is use the filter function. And it's very similar to what we just saw with map. But what map did is map applied this function to every element in that list. Filter, instead, what it's going to do is it's going to filter based off this function's condition. So this function, when you're using a filter, has to return a Boolean, has to return either true or false. And then what we're going to do here is say apply checkEven to my nums. And again, just like last time, if you run this by itself, it's going to say, hey, you have a filter object at this point in your memory. Instead, what we want to do is either transform it to a list so that we get back only the even numbers here, or we can iterate through it. So we can say for n in filter apply checkEven to my nums, print out n, and we see here we've printed out 2, 4, 6. So you can either transform it to a list or iterate through the results on that, the results that this filter function is generating. Now that we've learned about the map function and the filter function, we can learn about lambda expressions and see in context why they're really useful. So what we're going to do is show you my favorite way of explaining the lambda expression, and that's by converting a function step by step into a lambda expression. And then we'll actually explain more formally what a lambda expression is. So I'm going to take that square function we did earlier, or at least a really similar function to it, and define it here. So notice what I have. I have def square num, and I say the result is equal to num to the power of 2 return result. Now if I call square, let's make sure I spell that right. If I call square on a number, I get back the square. What I'm going to do now is slowly, step by step, turn this into a lambda expression. So first off, let's see how we can simplify this. Right now, I'm assigning result equal to num to the power of 2 and then returning that result. What I could do instead is just get rid of this assignment and return num to the power of 2. And if I run this, it's the exact same thing. And what I could also do is actually write this all on one line. And typically, you wouldn't do this because it's bad styling and not by convention, but Python won't actually complain here, and it will let you run this all on one line. Now, we're almost in the form of a lambda expression. In fact, we can easily convert this into a lambda expression through the following manner. A lambda expression is also known as an anonymous function, and the reason for that is because it's some functionality that you intend to only use one time. Because of that, we don't actually give it a name, nor do we use the def keyword. So instead of a name or the def keyword, we replace that with the keyword lambda. So I'm going to get rid of this and just say lambda here. And then we say lambda num colon, and the return keyword is basically, we get rid of that because it's assumed that we're going to return whatever's on the other side of this colon. And there we have it. This is now a lambda expression. And I could, if I wanted to, assign it to square, run that, and then I see square still working. So let me make this to another number. We see 5 to the power of 2 is 25. Now I just mentioned that lambdas are anonymous functions and you typically don't name them. So a lot of times you're not really going to be doing this square is equal to some lambda expression. Instead, you're going to be using it in conjunction with other functions, such as map and filter. So we look up here and we see that earlier when I was using map, I was passing in this square function and applying it to every item in this list, my nums. Now that required me to actually define square fully here. But what if I only intend to use this one time? Do I want to take up space by defining this function here and then having to call it here? What I could do instead is just call a lambda expression. And this is where lambda expressions really begin to shine, and this is why you would use them. I could just say map lambda num colon num to the power of 2, and then apply that to a list of numbers, such as my nums, and then cast that to a list, and we get back the same thing here. Every number in the my nums list has now been squared. Now that we've seen how we can use lambda with the map function, let's quickly check how we can use it with the filter function. So up here we saw that we were filtering using this check even function. So let's start by converting this check even into a lambda expression. We'll come over here, we'll remove the name and the def and replace that all with the lambda keyword. Remove that parentheses and then get rid of return here and put it all in one line, and now we have our lambda expression. Then we're going to pass this into filter along with the list of numbers we want to filter, and to get the results we'll pass this into list. And then we run that back, we'll get back 2, 4, 6, only the even numbers. And lambda expressions can be used for a variety of things. Let's imagine that you wanted to grab the first character of a string. So let's create a list here. Well, we actually have the names list. So we have Andy, Eve, Sally, and we only want to grab, let's say, these first letters. What I could do is map lambda, and I can take the incoming name, and I want to return back only the first character at index 0 of names. And you can call this whatever you want. It doesn't have to be name, it could be X here, or any other variable, just like for any normal function. And let's pass this to a list so we can see the results. And there we go, AES. Now let's imagine I wanted to reverse the actual names. What I could do is say colon colon -1, and then that will reverse the names, just as we've seen with slicing before. You can even pass in multiple arguments into a lambda expression. However, keep in mind that not every function that we've seen up here, for example, this check even or splicer or square, not every single complex function is going to be directly translated to a lambda expression. So you should really only use lambda expressions when you can still easily read it if you were to come back to your code later. And as you get more and more experience with Python, you'll be able to quickly realize what a lambda expression is doing. But in the beginning, it's going to be a bit tricky at first. So if you ever struggle of trying to convert a normal function to a lambda expression, just try using a normal function instead. All right, that's the basics of map, filter, and lambda expressions. We'll see you at the next lecture. Welcome back, everyone. In this lecture, we're going to talk about nested statements and scope. We've gone over already how to write our own functions, and we've even gotten a little bit of practice with them. However, it's important to understand how Python deals with the variable names you assign. When you create a variable name in Python, that name is stored in what's called the namespace. And variable names also have a scope. and the scope determines the visibility of that variable name to other parts of your code. So if you've ever wondered why you've gotten some errors that say something like, this variable is not defined, we're going to explore why that happens and how to fix those errors in the future. Let's get started. Okay, the first thing we're going to do is with a little thought experiment, and then we're going to explore the results. Right now, I'm going to say x is equal to 25, and below that, I will create a function. It's going to be called printer. Make sure you don't call it print, otherwise we'll overwrite the print function. But all this does is it sets x equal to 50, and then it returns x. So let's run this. And now I want to ask you, what do you expect to happen when I say print x? Do you expect to see 25 or 50? So when I run this, I get back 25. And if you had the intuition that it's going to be 25, that's great. And if you had the intuition that it's going to be 50, don't worry, that's exactly what this lecture is here to explain. What I want to show you is if I say print, printer, open close parentheses, so I'm actually running the result of printer and returning the x here, then I get back 50. So when I print out x, I get 25, and when I print out the result of printer, I get 50. So this is quite interesting, but the question we want to answer is, how does Python actually know which x assignment I'm referring to in my code? Am I referring to this x is equal to 25, or am I referring to this x is equal to 50? And why doesn't this reassignment seem to affect the assignment up here when I later on asked for print x? And this is because the idea of scope allows Python to understand and have a set of rules to decide which variables you're referencing in your code. And these rules are a LEGB rule format. So LEGB stands for local, enclosing function locals, global, and built-in. So let's take a look at this. So this is the LEGB rule, and this is essentially the order that Python is going to look for variables in. And it starts off by checking out the local namespace. And these are names that are assigned in any way within a function, such as df or inside a lambda call. And they're not declared global in that function. And later on, we'll see what we mean by declared global that uses a global keyword. So first, Python's going to say, hey, if you call that variable, is it in my local namespace? Then it's going to check for enclosing function locals. And these are names in the local scope of any and all enclosing functions from inner to outer. So you can actually have functions inside of functions, which you're going to see in just a second. Then it looks for the variable, if it still can't find it, in the global namespace. And these are names assigned at the top level of a module file, or declared global in a DEF within the file. Then it looks in the built-in namespace. So these are names that are pre-assigned in the built-in names module. Things like open, range, list, str, syntax errors, etc. Built-in keywords in Python that you see have those special syntax highlighting rules to them. Let's explore what each of these looks like: local, enclosing function locals, global, and built-in. We'll start off with an example of local. So an example of local would be something like inside a lambda function. If we were to say num colon num to the power of 2, this is an example of a local variable. So num right here is local to this lambda expression. Let's now see an example of enclosing function locals. So we'll go ahead and just comment this out. In order to show you an example of enclosing function locals, we first need to create a function and then put a function inside of it. So I'm going to say name at the very top of this. Notice the indentation and say this is a global string. Then I will create a function called greet. It takes in no arguments, and inside of this I say name is equal to Sammy. So I'm overriding that name variable here. And then inside of this function I'm going to say hello, and I'm going to say, hey, print hello concatenated with name. And then I'm going to call hello, and then I'm going to call greet. All right, so there's a lot going on here, especially since there's a function inside a function. So let's break this one down. Here, I have a function called greet, and what it does inside of it, it sets the variable name equal to Sammy. Then inside of the greet function, so notice how all of this right here that I have highlighted is inside of greet because of the indentation. We have def, then the hello function, And inside the hello function, I ask, hey, print out hello name. And right now we have name defined twice, up here as a global, and then over here as an enclosing function local. And after we define hello, inside of greet, I'm actually going to call and execute hello, and then I will call greet. So let's see what happens when we run this. We get back hello Sammy when I actually execute greet. So what's actually happening here? Well, when I execute greet, and in fact we can put this in a new cell so that's a little more clear what's happening. So greet's kind of separate. That greet call is separate from the definition of greet. When I call greet, what happens is I'm calling and executing the greet function. It assigns name equal to Sammy, and then it defines this function hello, and then it calls the function hello. So when you call greet, internally, it's creating this variable name, it's defining this function hello, and then it's executing this function hello. This is going to follow this LEGB rule when we want to figure out, well, what name are you referring to? So first off, we look in the local namespace. So the local namespace, as we just discussed, is within a function. So here in the function, def hello, it's going to say, hey, did I define name anywhere? If it can't find it, then it goes to the next level. So after searching local, we go to enclosing function locals. So we have this enclosing function because this function is inside of this function. And then here, we do find that name has been defined. It's equal to Sammy. So that's the one we choose when we finally execute hello here. And that's why you see hello Sammy. Now let's see what happens if I were to comment this out. So now I've commented out Sammy, and if I run this again, and I run that again, now I see hello, this is a global string. So what's happening now? Well, we're going through the same rules. We first look at local. So when we execute hello here, this hello function says, well, I got to figure out what variable name is. I don't see it defined locally, and now, since this is commented, I don't see it defined in the enclosing function. So then I'm going to go to the next step, which is to look globally. And there it is in the global level. This is a global string. And global is defined by basically having no indentation. It's all the way to the left, either in your script or in your Jupyter Notebook cell. And because it found it in the global namespace, it now says, hello, this is a global string. Let's see what happens if we uncomment this and we say name equals Sammy. So I want to kind of label these right now. This is the global. This one right here is enclosing. And let's make a local one. So local is going to be name is equal to I'm a local. And now when we rerun this to redefine this function, and I call greet, it gets back, hello, I'm a local. Because when you execute hello, that executes this function right here, which says, hey, Python, figure out what is this name variable assigned to. And it immediately finds it in the local namespace right here, name, I'm a local, so that's what it uses. As you can comment these out, it'll look in the next level, meaning the enclosing functions. If you comment that one out, it will then look in the global namespace level. And the only level above global is the built-in function level, which would be something like a built-in function as length. So you should always be careful not to overwrite these built-in function names, and they're always indicated to you with syntax highlighting. And if you're not sure, if you're able to call help on it, and you see some stuff pop out, then it's definitely built in because it already has that information. Finally, to close off this discussion, what we're going to do is look back at our original thought experiment, this assignment of x25 at the global level, reassigning it at the local level, returning the local assignment, but still being able to print out both when we wanted to. We could print out the global one, or we could return that local one and print that out as well. So we're going to discuss local variables as well as the global keyword. So we're going to show you an example of that thought experiment again. We'll say x is equal to 50. And I'm going to create a function that takes in x, and it's going to print, using f-string notation, x is x right here. So let's run that, and let's see what happens when we call function x. It says x is 50. Perfect. Now, also inside this function, I'm going to reassign x locally. So this is a local reassignment. And then I'm going to print, I just locally changed x to, and then we'll insert x right there. And make sure your x variable is lowercase here if it was lowercase there. So now we rerun this cell to redefine that function, and now I see x is 50, I just locally changed x to be 200. Now, outside of this, what happens if I print x? Well, I get back x is 50, even though inside of this function I reassigned it to be 200. And this is because this reassignment is only happening in the local namespace inside of this function. It's not going to affect anything at a higher scope. So this is what scope really is. It's the fact that when you declare variables inside of a function definition, such as what we've done here, those variable names only have a scope local to this function. So that's the scope of this variable x right here when we assign it inside of this function. We have an x here floating around in the global space, but this local reassignment, its scope won't be able to extend outside to another level, which is why, after all, we're still able to print out x here as 50. So let's imagine you're in a situation where, for whatever reason, you actually did want to grab this global x and reassign it to be 200. How could you do that? Well, in that case, we won't actually accept x as a parameter. Instead, what we're going to do is inside our function, at the very first line, we're going to declare the global keyword here, and then say x. And what this does is, instead of passing in x, we're going to declare a global x, and that tells Python, hey, I want you to go to the namespace, jump to the global level, and grab the x variable there. And then what I want you to do is anything that happens inside the scope of this assignment, it's going to affect that global x. So we're going to grab that global x, report what it is. We're going to do a local reassignment, except now it's on a global variable, meaning it will have an effect to this guy up here, 50. And then we're going to print, I just locally changed global x to some other value. Okay, so let's run this again, and I'm going to, instead of having this be 200, I'm going to make it super obvious that we're changing it by saying new value. So x used to be a number 50. I'm going to, when I call this function, reach into the global namespace, grab that x, report back what it is, change it to the string new value, and display, hey, I just locally changed global x. So let's run this. And I'm going to create a couple more cells here using Alt-Enter just so we get kind of a clean slate. So I just ran this, and let's see what happens when I actually call it. So right now I just defined the function. I haven't actually executed it yet. So when I right now say print x, I still have 50 there. Let's see what happens when I execute the function. It says, hey, x is 50, as we just saw, and now it's reporting back, I just locally changed the global x to the string new value. And now let's see what happens when I print out x. It says new value. So using the global keyword, you're able to reach out into that global namespace, and then your local assignments do affect that global variable. Now, because of the power of this global keyword to do that, in general, especially if you're a beginner, you should avoid using that global keyword unless absolutely necessary. Instead, what you should be doing is if you want to grab that global variable and then affect it, you should take it in as a parameter, do the reassignment, and then return the reassignment as an object itself. So let me show you why you would want to do that. So now that I ran that, if I print out x, x is still 50, and then I'm going to say func of x, and then I will say x is now equal to func of x. So x is 50, I just locally changed, and I should have deleted this, it's no longer that global variable, but technically, now when I call x, it's been reassigned to the string new value, because I returned x, and I reassigned the global level x using that function. And in general, this is a much better path to take than using that global keyword. So even though this combined with this is the same thing as the global keyword, it's much cleaner and much safer because you'd have to know that you want this reassignment to take place somewhere else in your code. It's quite dangerous to have the reassignment take place with the global keyword because as you use larger and larger scripts and you have separate scripts interacting with each other, you may accidentally overwrite a global keyword inside of a function without ever knowing it, and that makes it a lot harder to debug. It's a lot easier to debug something like this because there's a clear reassignment happening here, where we specifically grabbed that global x and said, hey, now make that equal to the output of whatever this function is. And later on, when you have your first milestone 1 project, that's the pathway we're going to recommend taking for dealing with certain objects in that global namespace. Okay, definitely a more complex topic, but hopefully it allows you to build an intuition of nested statements and, more importantly, the scope of variables. Thanks everyone, and we'll see you at the next lecture. Welcome back everyone. We're going to continue to test your skills with methods and functions in what we've labeled a homework assignment, but really you can do it whenever. It's a notebook, methods and functions homework. So let's go ahead and do a quick overview of the notebook in this lecture, and in the next lecture we'll go through some example solutions. Let me hop over to that notebook. Okay, here I am in the functions and methods homework notebook. So this is 08-functions and methods homework. And so basically what we want you to do is answer the following questions, and they're pretty much all in the form of a function. So you'll notice this first one here says, write a function that computes the volume of a sphere given its radius. So, in case you don't know that formula, it's 4/3 times pi times r cubed. And what we've done here is essentially we have these placeholder functions with just a simple pass statement. And it's your job to fill out this function, and then you should be able to check it with the second cell and make sure you get a corresponding correct value. So then go ahead and fill out here this function called vol or volume, whatever you want to call it, and then run it to check. Okay. Next one is to write a function that checks whether a number is in a given range, inclusive of high and low. So you should include that high and low number. So for example, we're going to take in the number, low and high, and what we should be able to do is check if 5 is in the given range between 2 and 7. And however you want to return the results is okay with me. If you want, you can print out a statement saying 5 is in the range, or you can print out something like 10 is outside the range. Alternatively, you can just return a Boolean, so it could return true or false. See if you can write it both ways, one that returns this print statement and one that returns the Boolean. Next, we want you to write a Python function that accepts a string and calculates the number of uppercase letters and lowercase letters. So an example string could be something like, hello Mr. Rogers, how are you this fine Tuesday? So we have hello capitalized, M capitalized here, Rogers capitalized, and then T capitalized. And what we want you to do is essentially go through this string and then count the number of uppercase letters and print it out, and the number of lowercase letters and print it out. Now there's two methods that will be very useful for this, which is the isUpper method and the isLower method. You can call this on a string or a single letter and check if it's uppercase or lowercase. I'll let you to figure out the best way to run that. And again, here it is, the function with a placeholder. And when you run this, it should put out an output, something similar to this. Okay. Next, we want you to write a Python function that takes in a list and returns a new list with unique elements of the first list. So for example, here we have the list with repeated 1s, 2s, 3s, and then a 4 and a 5. So we just want the unique elements. So 1, 2, 3, 4, 5. And if you recall from our previous lectures on data types, there's a specific data type that could be helpful for you in order to grab the unique elements from an iterable object like a list. So I'll kind of leave that to you to figure out, but essentially the output should look something like this, just the unique elements. And note, we want it in a list form. After that, we want you to write a Python function to multiply all the numbers in a list. So you have a sample list, 1, 2, 3, and then here -4. And essentially what should be happening here is the output will be 1 times 2 times 3 times -4. So in this case, 1 times 2 is 2, times 3 is 6, times -4 is -24. And this should be able to work for a list regardless of how long the list is. So this should work for a list of 2 items up to, a million items. So make sure your code is robust in that sense. The next question is to write a Python function that checks whether a word or phrase is a palindrome or not. And in case you're not familiar with what a palindrome is, it's a word, phrase, or sequence that reads the same way backwards or forwards. So single words can be something like madam or kayak or race car. If you read those backwards, it's the same thing. Or it can be a phrase like nurses run. And as a quick hint, when you're dealing with the phrases, you may want to check out the replace method in a string to help out with dealing with spaces. You can also Google search how to reverse a string in Python, because essentially what you're trying to do is compare a string against its reverse. So some things to keep in mind. And then finally, this one's a little hard, but we want you to write a Python function to check whether a string is a pangram or not. And there's going to be a couple of things you'll have to check out, including the string module, which isn't exactly something we covered in the previous lecture. So here we want you to expand your capabilities, essentially being able to do a Google search or a Stack Overflow search to compare or grab the full alphabet in Python. And we gave kind of a link here for you to check out, which is the string.ascii_lowercase. So see if you can Google search and figure out what this is doing. But essentially what we want you to do is a pangram is a word or sentence containing every letter of the alphabet at least once. So for example, here we can see the quick brown fox jumps over the lazy dog. And again, notice here we set a hint, look at the string module. This string.ascii_lowercase, if you check it out, and we kind of showed you here what it does, it actually is a string of the entire alphabet in lowercase. One last point I want to make here is, for the sake of simplicity, go ahead and assume there's no punctuation passed into the string here. So again, don't worry about the edge case of punctuation. Assume that the string can have both uppercase and lowercase letters, but no punctuation. All right, thanks, and we'll see you at the next lecture where we'll go over the solutions. Welcome back, everyone, to this lecture where we're going to be going through the solutions for the methods and functions homework exercises. Let's get started. Okay, here I am at the functions and methods homework notebook. The first task we had to do was write a function that computes the volume of a sphere given its radius. So this is a really common task you may have to do if you work in the STEM field or science or technology, where you have to transform essentially a mathematical equation into actual code. And this one's a pretty simple example, so let's go ahead and work through it. What we first do is take the 4/3. So I'm going to, in parentheses here, do 4/3 to make sure the order of operations ends up being correct. Then I'm going to multiply it by pi. Pi can actually be imported from the math module that we'll learn about later with Python, or you can just estimate it with 3.14. So if you wanted to, you could say import, or say from math, import pi. But in this case, we'll just say 3.14. And then we'll also take the radius, and we need to cube it. So for exponents, that's going to be 2 asterisks there. And we could just say something like result is equal to this, and then return result. But this is actually duplicating a step we don't need. We don't actually need to save this as a variable. Instead, we can simply just say return that. So let's go ahead and check to make sure this worked. I run this, and I get back the correct results. Okay, let's move on to the next one. Next one was to write a function that checks whether a number is in a given range, inclusive of high and low. So lots of different ways you can do this. The main thing I wanted you to be aware of was the fact that you're probably going to have to use the range function, and it's inclusive of high and low. And if you recall, the range function is actually exclusive of high. So if I take a look at this, for example, if I say for item in range 0 to 5, print item, notice it goes up to but not including the last number here, 5. So this is actually inclusive of the first lower bound and exclusive of the upper bound. So that means if I'm going to use range and I want inclusive of high and low, I may have to do something like +1 here. And we'll see that in just a second. So let's go ahead and check this out. I'm going to make use of the in operator keyword. And recall, the in operator is a really useful operator. We actually cover it in the useful operators lecture, which just checks for the presence of something in an iterable. So I could say 5 in range 0 to 10, and it's going to be true. Now if I said in range 0 to 5, that's going to be false, because recall that 5 here, when I'm using range, is going to be exclusive. So if I'm going to use a check like this, 5 in range, or num in range low and high, I'm going to have to say high +1 in order to be inclusive of both. So let's see what that looks like. I can say the check num in range, and then what we're going to do here is say low, comma high, +1. Now keep in mind, if I just wanted to return the Boolean as shown here, then I simply return this. I'll say return num in range low, high, plus 1, because I'm checking if this number is within the range between low and high inclusive. That's why I added the plus 1 there. So if I run this, then I have the Boolean check ready to go. If I want some sort of print statement, then I can simply just use an if statement. I'll say if this happens to be true, go ahead and make some sort of print functionality here. So I can say something like, let me use f-string literals here. Let's say num, whoops, is in range of low and high. Then I'll say else print not in range. And you can obviously write whatever you want here, but we run this and we can see 5 is in range of low and high. And if you want, you can keep replacing these with actual low and actual high. So we run that and it says 5 is in range of 2 and 7. And this is just f-string literal printing. We covered that in the print formatting lecture. All right, moving along. Next, we wanted to write a Python function that accepts a string and calculates the number of uppercase letters and lowercase letters. And this is where we're going to have to use a for loop within the function. So I can also make use of a dictionary in order to keep count. So if you feel ambitious, you can also explore the collections module, which is something we cover later on in the course. I'll go ahead and just show you how to solve this given what we already know so far. So the first thing I need to do is figure out something to keep track of the number of uppercase and lowercase letters. So I can have some sort of counter, such as 2 integers that start at 0 and then start counting them, or I can use something like a dictionary. So I'll first show you with 2 separate variables, and then I'll show you the dictionary method. So let's go ahead and say lowercase starts off at 0, and then uppercase starts off at 0. And what I'm going to do is the following. I'll simply say for every character in my string s, if, and this is where the is upper and is lower comes into play. These essentially return a Boolean if it's uppercase or lowercase. I'll say if the character is uppercase, then go ahead and add 1 to my lowercase, or excuse me, my uppercase count. Whoops. So we'll say uppercase plus equals 1, which is the same as saying uppercase is equal to uppercase plus 1. And then I'll have another check here. I'll say elif character is lower, then go ahead and say lowercase plus equals 1. And then finally, if I say else, so for example, I could have punctuation. If we take a look at the result of that, let me add in a cell here. If we have the string question mark and I say is upper, it's going to say false. But if I also say is lower, then it's also false, because technically a question mark isn't really uppercase or lowercase, which means there's going to be a third option here where neither of these happens to be true. And if that happens to be the case, I will simply pass. So I'm adding 1 to the count if it's uppercase, or adding 1 to the count if it's lowercase. If I happen to have punctuation there, I'll simply pass. Once this entire for loop is done, I can print out the results as shown here. So we want to make sure that we align this with the for loop, so our for loop executes first, and I will go ahead and print out the original string. So we'll say original string, and then it was just s, print out lowercase count. That's going to be lowercase, make sure we have an f string there, and then finally print out uppercase count. Uppercase count will then just be uppercase. So we run this, let's check if it works. And it looks like we got the same results. I accidentally flipped this, so it's lowercase 33, uppercase 4, but that was the same as here, uppercase 4, lowercase 33. So it looks like this is working correctly. Now I mentioned you could also do this with a dictionary. If you're dealing with lots of things to keep track of, it might be helpful that instead of all these being separate variables, you just transform this into a dictionary instead. So what I mean by that is setting up a dictionary, so we'll just call it dictionary D, that happens to have key values. So we'll say upper 0, lower 0, and then instead of having lowercase and uppercase here, we simply take the count at that key. So we'll say the upper and D lower. And when you start to get things that are more complex or larger, it becomes really nice just to have this single object you can reference with these key calls. And then we simply need to swap this out, lowercase and uppercase, for D upper and D lower. Make sure you keep an eye on what kind of quotes you're using, otherwise you'll get an error. So since I'm using single quotes on the outside, I'll use double quotes here on the inside. So this is going to be lower, and then in here we'll say this is upper. There we go. So we go ahead and run this, and we get back the exact same results. Up to you, both methods are correct. I personally prefer the sort of dictionary method. Okay, let's go ahead and continue. Next task was to write a Python function that takes a list and returns a new list with the unique elements of the first list. So basically, we just want to get rid of the repeats. Now, there's one very quick way to do this, which is to simply return, if you say set list and run this, that returns the set, which means I can then easily transform that into a list by casting it into a list, and there you have it. This is probably the simplest and most Pythonic way of doing this. However, I do want to show you kind of a more logical and manual way of doing this, just so you can get used to using for loops and if statements within a function. So another way we could have done this is to basically have a placeholder list that then we're going to append items that we haven't seen before. So we'll say for number in that list, if that number is not, whoops, I don't need to say is, not in X. So in fact, let's just call X seen numbers. So if that number is not in the numbers I've already seen, then I will simply say seen numbers append the number. And then once this for loop is completed, I will simply return the list seen numbers. And if I run that, I get back the exact same results. So essentially what I'm doing here is I have this list. It's the numbers I've already seen, starts off as empty. And then for every number in my original sample list, so for 1, 1, 1, 2, 2, and so on, if that number is not already present inside this unique list that I'm building, this seen numbers, then I'll go ahead and append it. And then once this entire for loop is done running, I'll go ahead and return seen numbers. Computationally speaking, this is not nearly as efficient as the previous way we saw. So keep that in mind. Now, next is to write a Python function to multiply all the numbers in a list. Later on, we'll actually learn about things like mapping, filtering, and reducing, which essentially are built-in functions in Python that allow you to do this quite easily. But for now, we'll go ahead and do this manually. So what do I need to do? It's actually a really similar problem to what we had here. We're going to start off with some sort of base case, use a for loop to adjust it, and then return that final thing. So what we're going to do here is start off with total equal to 1. And the reason for that being is 1 times anything is going to be the resulting number. So what I mean by that is 1 times n is equal to n. So 1 times 100 is equal to 100, 1 times 200 is equal to 200, and so on. So then all I need to do is for every number, or every num, in numbers, take my total, and then multiply it by the current number. After that, return the total. So again, because we're using multiplication, I'm going to start off the total is equal to 1. If the ask was to add all of these, then I would have started with 0. So we'll say for num in numbers, the total is equal to the current total times that number. So if I run this, notice I get back same results, and if I want, I can keep adding to this. So if I add a 10 here, notice I get negative 240. So this is going to adjust to however long my list happens to be. Next, we wanted to write a Python function that checks whether a word or phrase is a palindrome or not. So how can we do this? We essentially need to do two things. One, the first one, is remove the spaces from the string. And that's because when it comes to a phrase palindrome, notice this space will technically ruin it if we were to immediately reverse this, because we would get NUR space and then everything else. When going forwards, there's technically no space after NUR. So what we should do is remove that space and then check if string is equals, that's double equals there, so check for equality, if the string is equal to the reversed version of the string. Okay, so how can we do this? Well, to remove spaces in a string, we hinted that you should check out the replace method. So really easy to use here. I'm simply going to say s is equal to s dot replace, and I'm going to replace all spaces, so that's quotes with a space there, with an empty string, so essentially no space. So notice here there's a space on this first one, so it says replace all spaces with nothing, an empty string. And I want to show you what the effects of just doing that are. So if I return s here, and I run this, notice it removed the space from nurse's run. Next step is to check if the string, this one, nurse's run without the space, is equal to the reversed version of the string. So lots of different ways you can do this, but if you Google search how to reverse a string in Python, there's kind of a really famous method, which is to do the following. Check s is equal to, and then the reverse is going to be s with slice notation, colon, colon, -1. So what is that actually doing? S, colon, colon, -1 here is saying, starting all the way from the beginning, going all the way to the end, grabbing the string in a step size of -1. Recall, we can grab the string in various step sizes. So if we grab it in step size of 2, that means you take a step size from the beginning of 2. So it would be every other letter in this string. If I do a step size of -1, that means start all the way at the end and then work backwards. So I can simply return the result of this check. And now when I run this, I get back true or false. So now this works with a full phrase, and regardless of where this space is. So in fact, I can kind of put spaces wherever. This will remove all of them, and this will check if it's actually a palindrome. So note that still returns true. And then finally, the hard one here was to write a Python function to check whether a string is a pangram or not. And you should also assume the string passed in does not have any punctuation. So pangrams are words or sentences containing every letter of the alphabet at least one time. So that's kind of a key word here, at least one time, which means I only need to check if that letter occurs just once. Okay, now there's lots of different ways you can do this. As long as you got the same results as us, don't worry if you did it a different way, but basically you should get true for the quick brown fox jumps over the lazy dog, and false for a sentence that doesn't have all letters of the alphabet. I'm going to show you how you can do this with a simple set comparison. So we'll come back here and we'll plan out what this function is going to do. The way we're going to do this, and keep in mind there's lots of different ways you can do this, is I'm first going to create a set of the entire alphabet. Then I'm going to remove any spaces from the input string. Then I'm going to convert the input string into all lowercase, because what I'm using for the comparison is all the lowercase strings. And then what I'm going to do is I'm going to grab all unique letters from the string. Because recall, I only care that they show up at least once, which means if I have two B's or two A's, I only really care about their uniqueness, that A just happened to show up at least one time. So a nice way to do this would be with a set. And since I'm going to have a set of the alphabet and a set of all the unique letters in lowercase, then I just compare my alphabet set to check if it's equal to my string set from the input. So let's check this out. To create a set of the alphabet, I will call this alpha set and say set alphabet. Next, to remove any spaces from the input string, we actually already know how to do that. It's simply call replace all spaces with nothing. Then we're going to convert them all into lowercase. So that's str1 dot, or is equal to str1 dot lower. And then we'll say str1 is equal to the set of str1. And then finally, we're going to return the check that str1 is equal to alpha set. So let's see what happened here. I created a set of the alphabet with this set, removed any spaces, lowercased everything, then converted it into a set, and now I'm comparing my alpha set along with my string set. So now when I run this, I get back true. And if any of these steps happens to confuse you, a really nice way to visualize things is with print statements. So if you maybe aren't clear what alpha set is, you can simply print it out when you call the function, and when you run this, you'll get to see that entire alpha set along with what is being returned. So you can use that at any point in time. So let's say you're confused what step you're at right after this, you'll simply say print str1, and this is a really great way to learn as a kind of beginner. So now we can see at this point in time, everything's lowercase and there are no more spaces. So I highly encourage you as you're learning to use those sort of print statements to help you kind of debug or understand what's going on in larger functions. All right, that's it. Great job, and I'll see you at the next lecture. Welcome everyone to this milestone project section of the course. We're going to begin this section by going through a couple of warm-up project exercises. We're almost ready for you to begin creating a full interactive Python program. And for your upcoming milestone project, you will be creating an interactive tic-tac-toe game. In order to warm up for this project, we're going to code along with a few exercises in order for you to see how to use Python code to do the following. Grab user input, manipulate a variable in your Python script or program based off that input, and then return back the adjusted variable. So you actually already know all the Python necessary in order to create something like a tic-tac-toe game. However, often for beginners, it's hard to see how to connect all these moving parts and pieces to create something that appears to be an interactive program. So that's why we're going to have just a couple of exercises and short lectures in order to show you just some simple examples of how this can be done. But first, let's just describe what an interactive program does in general. So you have to have some sort of visual representation that your user will see. So for example, here I'm using slides to actually display information. And then if you're building a game, that could be something like a tic-tac-toe board. So in any interactive program, there should be some sort of visual representation that a user can see. And then, in order to update this program, the user has to make some sort of decision and input that decision based off what they visually see. So for example, if you're playing tic-tac-toe, a user input would then be something like choose the top right corner for the O in order to win this game. Then that user input would go into some sort of Python function. Then, inside that Python script or notebook, we update whatever the board variable is, and then we have a new visual to show the user. And then we have the updated visual representation. And essentially, this cycle can happen over and over again in order to have just an interactive running program. So this is a very simple example for a tic-tac-toe board, but essentially, any interactive piece of software you've used follows some very simple logic like this. Now, the actual script that runs that can be extremely complicated based off how many options there are and how complex the calculations can be. But overall, you're just simply showing a visual representation, accepting user input, then having that be updated inside your Python script, and then showing an updated visual over and over again. So, as I mentioned, most programs that are interactive work on this very simple idea. Display something visual to the user, let the user update through an interaction, update the variables within the program, and then those variables are then passed through in order to display the updated visual. So there's a connection there between the internal variables and what the user sees as the visual. So what we're going to do is in the next series of short lectures, we're going to guide you through examples of how to perform each of these individual tasks with Python. Keep in mind, there are many different ways of performing the same task, such as displaying output or manipulating variables internally in your Python script. So I don't want you to feel restricted by the examples we show here as the only way you can do this. These are just simple examples in order for you to kind of connect the dots between what you've already learned and creating an interactive program. Okay, let's get started. I'll see you at the next lecture. Welcome back, everyone, to this lecture on displaying information. And really what we're going to learn here is how we can combine a custom function using a def or def call along with the already built-in print function in order to show something to the user that actually displays like a board game, for instance. So let's go ahead and jump to a Jupyter Notebook and explore more of what I'm talking about. All right, here I am within a Jupyter Notebook, and as I mentioned, we already know that I can print out variables. So if I have a list, something like 1, 2, 3, I can simply print that out. And if I want to print out multiple lines, what I would have to do is have essentially a print statement for those lines. So let's say I wanted to print 1, 2, 3, and then maybe right below it, I also want to print out 4, 5, 6. And let's say right below that, we'll have one more list, 7, 8, 9. So when I run that all in one cell, I get back this display. Now instead of having to call each of these 3 print functions over and over again, what I could do is put all of this within my own custom function. So I'll say def, and let's say call this display. And let's imagine that we have 3 rows of information here. So I'll pass in row 1, row 2, and row 3 as arguments or parameters into this function. And then what this function does is it simply prints out row 1 on top of row 2, which is then on top of row 3. So I've defined the function, which means now I can display it. So let's go ahead and make an example row. And my example row for now, we'll just have it be 1, 2, 3. Which means if I pass in example row for each of these rows, row 1, row 2, row 3, let's go ahead and pass it in 2 more times. So I'll say example row, and I'm just using tab here to complete this. Example row. When I run this, notice now, instead of having to call print, print, print 3 times, I simply call display once, and now it's flexible to whatever variables or parameters I have. And then the last thing I want to show you to kind of drive this point home of the flexibility of showing a display to a user is technically this doesn't have to be a list. This could be a string or any other object. So what I want to do is let's go ahead and make 3 unique rows. We'll say row 1 is 1, 2, 3, row 2, and what I'm going to do here is I'm actually going to have just some empty strings. And we'll have row 3 equal to, and we'll have another set of empty strings here. And in fact, let's just copy and paste this and make this row 1 as well. So we essentially have just 3 empty strings in 3 lists. So now I'm going to change this from example row to reflect row 1, row 2, and row 3. And something to keep in mind is this can go in another cell. So it doesn't have to be in the same cell. I could, in one cell, define row 1, row 2, row 3, and in the next cell then have this display function. So when I run this, I get back these lists with these empty spaces. And what we can do is later on in our program, let's say we've set up kind of a rudimentary tic-tac-toe board, I could say row 2, go ahead and grab the center position, which if we think about this, the center position here of this 3 by 3 is going to be row 2 at index 1 because we go 0, 1. So that means row 2 at index 1, and let's reassign this to be something like an X. And now what I'm going to do is display those rows again. Row 1, row 2, row 3. I run this, and now I see an X here. And this is a very rudimentary way of just taking in inputs and then displaying something that looks like something a user can visually interpret. This is just a very simple tic-tac-toe board. It's not the nicest looking tic-tac-toe board. You can get even more flexible with using things like strings in order to not actually see these quotes. So instead of having a list here, you would just kind of have this be a long string. And then you can add things like dashes in order to make it look even nicer. But this is just a very rudimentary display. And the next step we want to do is to be able to take in user input in order to have something like this, a reassignment of a particular position in a row or a list, be actually specified by the user themselves. So this is just our overall lecture on displaying information in a simple way that the user can understand. The next thing we want to do is be able to accept user input. So we've already gone over the input function in the useful operators lecture. So if you don't remember it, you might want to do a quick review of that lecture. But coming up next, we're going to expand on this idea of displaying information to accepting user input. Okay, thanks, and I'll see you at the next lecture. Welcome back, everyone. In this lecture, we're going to talk about accepting user input. Let's head over to the Jupyter Notebook and get started. All right, now previously we talked about just displaying information through a display function, which is essentially just a little placeholder for multiple print functions. Now what we want to do is accept user input, and I also want to show you just a couple of key things to be aware of when using the input function. Now, we've actually already learned about the input function in the useful operators lecture, but here we're just going to show you a couple more things. So the input function is simply the keyword input, and then open and close parentheses, and what you do is you type out the string you want the user to see. So for example, we'll say please enter a value, and then we'll have a colon and a space. And once I run this cell, what's going to happen is we'll see please enter a value, colon space, and then a little input box. So for example, I can say 2, then it just hit enter, and we get back the string 2. So what I can also do is instead of just displaying the output here, I'll save it as a result. So I'll say result is equal to input, please enter a value, colon space, shift enter to run this, and then when I say 2, we actually don't see the output result because I've saved it as a variable, which means I can now call result, and I get back 2. Now notice that the input function, whatever you actually pass into it, it's going to return a string. So if I check the type of this with the built-in type function in Python, it's str, which is a string type. If I wanted this to actually be some other type, such as a floating point or an integer, what I would have to do is convert it into an integer or floating point. And I can do that with the built-in casting functions, essentially. So I can say result is equal to, and then input, let's say enter value. We'll do shift enter to run this. I'm going to put in 2. And then once I have the result, I can convert it to an integer with int. Open close parentheses, pass in result here, and then we'll say result underscore int is equal to integer result. Run this. And so the type of my original result is a string, and the type of my result integer is an integer. So essentially, this type in Python is also a function that allows you to convert from one type to another. So if I were to check the type of 2.3, for instance, it brings back float, which means float can actually convert to floating point numbers. So if I had a string, for instance, that was, let's say, 3.14, it actually converts it to the number, or floating point number. So keep that in mind that the main thing here is input function is always going to return a string, which means you may need to convert it if you actually need a specific data type within your function. So that's going to be important because if we have something like position index is equal to input of choose an index position, colon space. Later on, I may want to use this position index as part of my list. So for example, we'll go ahead and run this, and we'll say 1, enter. And let's imagine I still have those rows above. So if I scroll up here, recall I have row 1, row 2, row 3, etc. So I have row 1 here, and I do shift enter. Unfortunately, I can't just say position index passed in here. I'll get an error. And that's because the list index or list indices, they must be integers or slices. They can't be a string. So position index here is actually still a string. So really what's happening here is I'm trying to say row 1 and I'm passing in the string 1, which is the error. I actually need to pass in an integer, as we've already seen in the list lecture. So what I can do here is I can either cast position index or convert it into an integer type using int result or int position index, or to do this all in one line, I'm going to say int and wrap the input function around it. So essentially what this does is this grabs your input as a string and then converts it into an integer before assigning it to the variable position index. Let's go ahead and run these cells. I'm going to delete these real quick. So I'm going to do Shift Enter here, run this. It says choose an index position. Let's try again with 2. Hit Enter. And now what's nice about this is the type of my position index is an integer, which means if I take back, for example, one of those rows, let's say row 2, I can now pass in position index and it works just fine. So this is the sort of thing you have to be aware of when using user input, is that Python will automatically pass it in as a string, and in order to use it in your program, you may actually need to convert it into a different data type, such as an integer or a floating point number. Now there's 2 more things I want to tell you before we conclude this lecture. The first one is if you're using some sort of conversion, such as trying to convert an input into an integer, it has to be a legitimate input, which essentially means it has to be something that looks like a normal integer, but it just happens to be wrapped in quotes as a string. So let's imagine that it says choose an index position, and the player types out 2 like this. Well, Python isn't actually smart enough to be able to convert this TWO into an integer directly. So when I hit enter here, I actually get this value error, which says, hey, invalid literal for integer with base 10, 2. Essentially saying, I don't know how to convert this string 2 into some sort of integer. So you have to be careful with that. And what we're going to do later on is actually show you how you can validate user input. So we'll be able to actually check to make sure that this is valid before attempting to convert it into an integer. So we'll learn about that in the next lecture. And the last thing I want to mention is the input function itself can be a little tricky because it awaits a user interaction, which means if you accidentally run it twice, your Python program or script may get stuck waiting for a reply that doesn't actually come. So I want to show you what that looks like. Let's say we have a result here is equal to input, enter a number, colon space. And I do Shift Enter, and right now, notice that there's an asterisk there, and it says, hey, I'm waiting for a result, please enter a number. If I accidentally forgot that I ran this cell, and I kept going down my notebook and tried to run another cell, such as 2 plus 2, this cell isn't going to run until you actually get a result here for enter number. So this is essentially waiting for the user interaction from the input. So it's only until I provide a number here and hit enter that the rest of the cells actually execute. And the other thing to remember, and this is the one that's really tricky with input, is sometimes people accidentally run the cell twice, which means we'll say something like input, enter number, colon space. I do Shift Enter, and then maybe I accidentally click on this cell again, and I'm going to hit Shift Enter again here. And now we're kind of in trouble because I accidentally tried to overwrite that input cell, but that initial input is still waiting for its interaction, its value, which means essentially now we're, for lack of a better word, screwed because we're still stuck waiting on that original input, and Jupyter Notebook has erased that first box because I tried to run this cell again, which now means any other cell, if I try to say, for instance, 20 plus 20, everything now is stuck waiting on that input that I no longer have access to. And unfortunately, if this happens to you, the only way to fix this is to go to kernel and then restart your kernel. You may be able to try to interrupt it, but typically the interruption doesn't actually work. So the best way to fix that is to say again kernel and then restart. And notice here we kind of saw the reloading of that restart. So now that it's been restarted, I can actually run any of these cells again, but the thing to keep in mind is all the previous variables in memory have been erased, and we're starting fresh from input 1. So now if I were to run this 2 plus 2 cell again, notice it's now the second cell. And all the variables I defined above here, such as results and row, they're no longer available to me. It'll say, hey, row is not defined, because in order to redefine everything after you've restarted your kernel is you have to run all these cells again. So you have to say print this, print that, redefine these cells, etc. So you have to keep running all these cells. A quick way to do that though is you can always say cell, run all above, or run all below. So that's kind of a quick little tooltip there. Okay, so often a common mistake for beginners is they accidentally run an input cell function twice, and then you're kind of stuck. So if that happens to you, go ahead and just hit kernel, restart. All right, so we mentioned validating user input is going to be important. So let's go ahead and explore how we can do that in the next lecture. I'll see you there. Welcome back, everyone, to this lecture on validating user input. So we've already seen how to use the input function to interact with a user, and then how to convert that string data type from the input function into another data type, such as an integer. That way we can then use that input for other things within our program, such as indexing from a list. However, recall that if the user passed in something that couldn't be converted correctly, we would get an error. So what we want to explore now is how to further validate that user input to avoid errors for invalid conversions, and instead basically have a while loop that keeps asking the user for input until we get a valid input, and then continue on to the next step. Let's see how this is done by jumping to the Jupyter Notebook. Okay, here I am at a Jupyter Notebook. Recall previously we were playing around with this input function as well as coming back up and then trying to convert inputs. And the main thing to note here is that if the user provides an input which isn't correct for a conversion, such as the string TWO for 2 instead of just the actual number 2, then we're going to get this value error saying we can't actually convert this. So what we're going to do is use a while loop along with checking for the data type in order to not have this error occur, but instead keep asking the user for the correct input. In order to do this, the first thing I want to do is basically take what we have here through the input function and actually make it within our own custom function. So we're going to have def, and I'm going to call this user choice. It doesn't take in any parameters, but basically what it's going to do is say the choice is equal to the input, and then we'll say please enter a number, and let's just go ahead and say maybe 0 through 10. And then a colon space, and then it's going to return, and it's going to attempt to make that choice string into an integer. So we have that, and what we're going to do here is say user choice. Let's go ahead and run it. Again, we're not passing in any parameters. We just run this, and we can see this input function gets called. It says please enter a number between 0 and 10. If we pass in, for instance, let's say 9, hit enter, it returns back the integer 9, not the string 9. Now, there's two problems with this right now. One is that, let's go ahead and run user choice again. I could technically try to, again, maybe provide a string 9. I hit enter, and I get, hey, we have an invalid literal for integer. The other problem with this is I'm specifically asking for the numbers maybe 0 through 10, and I'm not doing any sort of check to make sure that number is actually between 0 and 10. So if I were to run this again, let's say I enter something like 100, I hit enter, the function still works because it's able to convert 100 into an integer, but I'm outside the limits that I wanted. So 100 is outside the limit of 0 and 10. So there's a couple things we have to do. One is to make sure that the data type is valid in order to run this integer conversion, and two, check against the actual inputs I expect. So I can check against just a few inputs, or I can check within a list of inputs. And what I want to also show you is in the actual notebook that corresponds with this lecture, this warm-up project exercise notebook that I have open here, I've added some links for Stack Overflow. So if you just do a Google search for validating user input, so for example, here's a Google search for Python check if input is a number. There's lots of different ways you can do this, and I want you to explore these various methods. And I added a couple links here for specific Stack Overflow posts that answer this sort of question. Basically, how do I check if a specific Python input is a data type? And later on, we're going to be learning about things like try and except statements. But for these sort of simple checks, we actually don't need them. And there's lots of different ways you can do this. Here, there's a more advanced method such as try except, but there's also the isDigit, which returns true or false, a Boolean, depending if this can be converted into a digit. So there's lots of different methods here. So here's another while true with try except. Here's one that's basically a function, etc. And there's another Stack Overflow post that again checks if something represents an integer. And this one's without using try and except. So you scroll down here, lots of different ways. The isDigit ways, starts with, etc. So there's many different ways you can actually solve this question of checking for the correct data type input. The favorite method here that I found in my own research is that isDigit check. So this isDigit is probably the simplest way to do this. So that's what we'll go ahead and do. Keep in mind, it sometimes has errors for negative numbers, but for right now, we'll go ahead and ignore that test case. So we'll assume that the user is going to pass in a positive number. Keep in mind, you should always be careful with assumptions of what a user is going to do because users can often break your program if you're not checking for edge cases. But since we're keeping things simple, this isDigit should be enough for us. So we'll come back here and warm up project exercises, and we'll continue with validating user input. All right, so we already created this function, user choice, and I have two problems with it. One is a user can pass in something that isn't a digit, and two is a user can pass in something that's outside of the range I want. But luckily, I have this choice variable that I can then do checks against. So let's expand this user choice function. And based off that research from Google and Stack Overflow, I'm going to check with the isDigit method that's actually available on a string. So to show you what I mean by that is, let's say some value is equal to the string 100. So I run that cell, and in a new cell, I'll say some value dot hit tab in that new cell, and eventually you'll scroll down and you'll see that there's this convenience method of is alphanumeric, is alpha, is decimal, is digit, etc., is space, is upper, and really what I'm looking for is that isDigit. So I'm going to say some value isDigit, and I would never expect someone to memorize all these methods. Instead, you would do a Google search and Stack Overflow post search looking for the correct method. And if you do Shift Tab here, basically it's going to return true if all characters in this string are digits, which is pretty much exactly what I want. So open and close parentheses, since this is a method call, we run this and it returns true, since each of these is a digit, which means this can actually be passed into this conversion of an integer. So I can say integer some value, I run this, and I get back the integer of 100. Perfect. That's exactly what I want here, since we're looking for basically a whole integer number. So what I need to do is basically have a check to make sure that this choice is a digit. So how can we do this? To basically keep asking the question of the input. Well, what we need to do first is start off with a default choice value. So what I'm going to do is say my original choice value is something that is not an integer. So let's just start with wrong. And technically, this can be anything, any string you want, any variable you want, as long as it's not going to say true for isDigit. So obviously, the word wrong is not a digit. So we start with the wrong choice, and then I'm going to add a little bit of logic here with a while loop. Remember, a while loop basically continues until a condition is met. So I'm going to say while choice dot isDigit is equal to false, meaning currently our choice is not a digit. So while the choice is not a digit, and recall we start off with choice not being a digit, then I'm going to keep asking for this input, which means I need to indent this line in order for it to be part of this while loop. And this is where we're basically being a little clever here. What we're saying is we start off with this string, and since it starts off not being a digit, we're going to keep asking the user for input over and over again in this while loop until we finally get isDigit to be true. And since this while loop will continue to run until we have a digit, then I no longer have to worry about this conversion giving me a value error for something that isn't a digit, because this while loop takes care of that with this isDigit call. So let's go ahead, I'm going to delete these cells below. We'll redefine user choice, and let's see it run now. So it says, please enter a number between 0 and 10. Let's go ahead and pass in something like 2. I hit enter, and notice, because the string 2 is not a digit, so that means isDigit is equal to false, we simply ask the user again, hey, please enter a number between 0 and 10. And I can type in whatever I want here, but until I pass in that actual digit, such as 3, it's going to keep running and asking over again. So this is a really nice way to basically make sure that your user is inputting something that you expect. And as you can imagine, we can basically keep adding in conditions for this while loop with and or calls. Additionally, something we can do is add in an error message just so the user knows what happened. For example, after we get that choice, let's go ahead and just have another little check. We'll say if choice isDigit is equal to false, then I'll just print out a little error message for the user saying, sorry, that is not a digit. So we rerun this again. Notice that this if statement is within the while loop and it's in line with this choice. Basically, after the user gets a choice, we do a little quick check to see if it's false. And if so, we'll go ahead and print, warning the user that, hey, sorry, what you entered was not a digit. So essentially the logic is the same, but we added this little message just for the user's sake. So we'll say user choice, pass in 2, hit enter, and it says, hey, sorry, that is not a digit. And we can keep doing this over and over again. It's going to keep saying, sorry, that is not a digit, until we have something that is a digit. And now the last thing I want to show you to finish up this lecture is checking against multiple possible values. So remember, we had this issue of this 0-10. So basically, I want to make sure that the number is within a certain range. And there's lots of different ways you can do this, but probably the easiest way is to check against a list of acceptable values. For example, let's say my result is just the string wrong value. And I'm going to create a list of acceptable values. So acceptable values, and let's say my acceptable values are 0, 1, and 2. Then I can use the in operator. Recall the in operator was discussed in useful operators lecture, and it basically checks if something is in either a string or a list or any sort of iterable object. So I can say, is my result in acceptable values? I run that and it says false. This string wrong value is not within this list. I can also check for not in. So saying, is my result not in acceptable values? Run that, and that happens to be true because wrong value here is not within 0, 1, and 2. So that means you can add this sort of condition of make sure that the result is in acceptable values along with a condition that it's a digit, or you can have multiple checks later on in order to keep asking in case the user is putting in the wrong value. So in order to do that, we're going to reach a little bit higher level of complexity than we did before, but if you follow the logic, it's actually not too bad. What I'm going to do is scroll back up here and grab this user choice function again, and then paste it down here. And what I need to do is start commenting this just so we can keep track of our logic flow. First off, there's a couple of variables that we need. One are the initial choice, so we have some initial values here. And one is for the choice, which cannot be a digit in order to make sure this loop runs. The other one we want to make sure is if we have some sort of acceptable range. So let's go ahead and say that here, acceptable range. And you can either manually do this, something like 0, 1, 2, or you can use something like range. And since our range is 0 to 10, let's go ahead and say 0, 10. And if you're unfamiliar with the range function, go ahead and check out useful operators. Basically, it just makes an iterable that has the numbers 0 through 10 with a default step size of 1 integer. And finally, we need to have, just like choice, an understanding of whether or not we are within range. So I'm going to say within range is equal to false. Okay, so next step is to actually have the conditions we're checking for. In this case, it's going to be 2 conditions to check. I want to make sure that I keep asking in this while loop when my choice is a digit, so I need to check the digit, or I keep asking this if my within range is false. So basically, while the choice is not a digit, or when I'm not within range, so within range equal to false, then I'm going to ask for this input. And then if it happens to be a digit equal to false, sorry, that is not a digit. And now it's time to use this within range parameter in order to update it to true in case I do happen to be within range. So this is our digit check. And now let's add in a range check. So how do we do this? First, we confirm that we actually have a digit first. If not, we just keep looping. So we assume that by the time we're getting to the range check, that is digit happens to be true. So in order to do that, I'm going to say if the choice now is digit, let's make sure we spell choice correctly. So if the choice dot is digit happens to be true, then let's check if we are within range. So because now choice is digit is true, I know I can cast that string choice as an integer and then check if it happens to be within my acceptable values or acceptable range. And if that happens to be true, then I know I'm within range, so I can update within range to be true. And keep in mind that the double equal signs is checking for equality. A single equal signs is an actual assignment. However, if that happens to not be the case, meaning I'm outside the acceptable range, then I'm going to say else I'm still within range is equal to false. Keep in mind, there's a lot of checks here that you technically don't have to do. For example, choice is digit equals to true. This is actually a Boolean itself, so I could simplify things by actually just saying if choice dot is digit. But for the sake of readability, I'll go ahead and keep a lot of these checks in place and also do things like keep assigning something as false, even though technically it's already equal to false. So this could have just been a pass. All right, so let's quickly go over the logic here that we added in. We have our initial values. The choice starts off as wrong. I have some acceptable range of values. And I'm also going to say that to start off, we are not within that range. So that means there's two things I need to check for. So either of these, if they're false, so if either the digit is false or within range is false, then I keep asking the user for input over and over again. So we first check if it happens to be a digit, and we basically warn them, hey, this isn't a digit, sorry, it's not a digit. And then we check if that does happen to be a digit, then we'll say if the integer choice is in acceptable range, within range is equal to true, else, let's go ahead and say else within range is equal to false, but let's also warn the user, hey, sorry, you are out of acceptable range, 0 to 10. And now we should be able to inform the user whether or not they're with a digit or if they're out of acceptable range. So there's a lot of lines and code going on here, but really take your time, review the notebook, and the logic should make sense to you. We're essentially just checking for two things here. Let's go ahead and run this, and now run user choice. So I'm going to do a couple of wrong inputs here. First, let's try an input that is not a digit. We'll say 2. And it says, sorry, it's not a digit. Perfect. And now let's try something that is out of range, like 100. And now it says, sorry, you're out of acceptable range. Now let's try something like 5. And we're good to go. Okay, awesome. So now we understand how to check if something is the correct data type and to check if something is an acceptable value, which are the two main things you're going to have to be checking when creating an interactive Python script. Coming up next, we're going to bring this all together, just a couple of functions, in order to show you how to create a simple user interactive experience. And after that, we'll set you loose on the milestone project. I'll see you at the next lecture. Welcome back, everyone. To finalize this series of lectures, we're going to build a very simple game, which is essentially just an example of a simple user interaction. So we're putting everything together, and so what this program is going to do, it's going to display a list consisting of just 3 items. Then we're going to have the user choose an index position and an input value. So we're going to have to make sure that that index position is both within the range of 0, 1, and 2, and that it happens to be a digit. Then, once they've chosen a valid index position, we'll also have them choose just a string to input into that position. Then, we're going to replace the value of that list with the user's chosen input value. And we'll also check to see if the user wants to exit out of this game at any time. So we've already have all the pieces needed. We just need to essentially string together the functions that we've already created in order to create an interactive user experience. So let's show you what the actual finished game looks like, and then we'll construct it ourselves using the functions we've already made. All right, here I am at the Jupyter Notebook. I've gone ahead and just copied and pasted some things from the lecture notebook, which are the functions we're going to be creating and coding along with in this lecture. We have one for displaying the actual game, one for the position choice that the user chooses, a second one for the replacement choice, essentially asking the user what they want to replace the current item with, and then a game on choice, which is really similar to the index position choice function, except it's checking to see if the user wants to stop playing. And then we have a little bit of game logic here, dependent on whether or not the user wants to keep playing. Okay, so let's go ahead and run this so we can see what the functions all look like together, and then we'll code it out ourselves. All right, so I run this last cell, and it says pick a position to replace 0, 1, or 2. First, let's try to pick something that's wrong, like 10. And it says, hey, sorry, but you did not choose a valid position. And it's going to be the same thing if we try to do something like 2. Sorry, but you did not choose a valid position. Now let's actually choose a position. We'll say index 1. And then it's going to say, hey, type a string to place that position. So let's just say new. Run that. And now I can see the current list, 0, new, and 2. Would you like to keep playing? Yes or no? Let's go ahead and say yes. And here's the current list, 0, new, 2. Choose a position to replace. Let's go ahead and replace 1 again. And now we're going to replace it with something like brand new. Would you like to keep playing? Yes or no? So it says 0, brand new 2. I'm going to say no to keep playing. And there we have it. Very, very simple idea where I have this variable inside my Python script that the user can interact with. They can choose a position in that list and then replace it with their own value. So let's go ahead and build out this game. There's essentially a couple things we have to do. One is to have a function that can display the game. Second is to have a function where the user chooses a position. Third is to have a replacement choice function. Very similar, we just ask the user what string they want to choose. And then the game on choice, very similar to the previous two, basically asking, do you want to keep playing? So let's go ahead and then build out the game logic. I'm going to make a couple new cells here so we don't see that old stuff. And let's start off by creating the display function. So just as we did at the beginning of this series of lectures, we're going to go ahead and display that game list. How can I do this? Let's go ahead and make an example game list, which just starts off as 0, 1, 2. So my display function is essentially just going to be a print statement. It's going to say display game. It takes in the game list variable. It's going to print, here is the current list. And then let's go ahead and print that game list variable. Run that. Let's make sure this works by saying display game, pass in the game list, and we see here's current list 0, 1, 2. Very simple. And as you can imagine, this could be expanded to any sort of board game that you can display. You could display something like Battleship board games, etc. Okay, now comes the time to get a position choice. And this is very similar to the functions that we've been creating throughout the series of lectures. We'll say position choice. We'll say the initial choice is invalid. So we'll say the first choice is wrong. So how can we do this? Well, for this very simple game, I know that my choice has to be either 0, 1, or 2. Lots and lots of different ways you can do this. If you want, you can follow along with the previous methods shown, but I'm going to make this even simpler by saying, while my choice is not in, because there's only 3 options here, it has to be either the string 0, the string 1, or the string 2, because I know choice is passed in as a string from the input. So I'm kind of simplifying things here, but you can make it more flexible using the functions we've previously shown. And I'm going to say my choice is simply the input, pick a position, 0, 1, or 2, colon space. And let's go ahead and create a little message here. If the choice is not in 0, 1, or 2, and if you want, you could have made this a variable called acceptable values, then I'm simply going to say print, sorry, invalid choice. Okay, so that while loop keeps going over and over again. Once we have a valid choice, I actually want it as an integer, so I'm going to say return the integer choice. Let's go ahead and make sure this works. Position choice. Go ahead and run this. So notice if I type in a string, that's actually not in that list, so that's not going to work. If I type in something like 24, that's not in that list. So there's only 3 things I can type in order to close off this while loop. It's either a 0, a 1, or a 2. So if I say 1, then we're good to go. So that's the position choice, very simple function. And it's simpler than what we've seen before, but you could always expand this to be more flexible, given what we already learned. Next, it's time to choose a replacement. So let's imagine the player has already chosen their position correctly. They need to choose a replacement value. So what do they actually want to insert there? And in this case, we're going to take in 2 parameters. I'm going to take in the game list and the position. So this position choice is going to return position. And then game list will be a variable that I keep sending back and forth between functions in order to update it. So we'll say user placement is equal to input, and we'll say type a string to place at position, and then I'll simply grab the game list at the position previously passed, and then we'll say is equal to user placement, and it could be user choice or whatever you want to call this variable. And then finally, in order to keep passing that game list that's updated to different functions, I'm going to return that game list. So let's go ahead and check this out. We'll say replacement choice, going to choose my game list, and let's say my current position has already been returned as integer choice, so I'm going to pass in, let's say, 1 here. So I run this, it says type a string to replace at position, I'm going to say test. There we go. It returns that game list with 0, test, and 2. Perfect. Looks like replacement choice is also working. And then finally, we want to make sure that the user keeps playing. So let's go ahead and have something that's like a game on choice. And I'm going to copy and paste my position choice because it's so similar to the game on choice. I'm just going to edit it until it works for game on. So instead of position choice, we'll say game on. It's essentially going to ask the player, do you want to keep playing? So the choice starts off wrong, and there's only 2 options for the choice. It's either going to be yes or no. So we'll say while choice not in Y or N, ask the user, do you want to keep playing? So keep playing, question mark, and then we'll tell them that's either capital Y or N. And then if choice is not in Y or N, so we'll say copy that. We'll say something like, sorry, I don't understand. Please choose Y or N. And then finally, if that happens to be the case, then we know they have a Y or N. So I want to return whether or not they want to keep playing. So if the choice is equal to capital Y, then that's a yes, they want to keep playing, which means I'm going to return true, that the game is still on. Else, I'll say the game's over, and I'm just going to return false. So essentially what game on choice does is it asks the player, do you want to keep playing? It accepts either capital Y or capital N, and then returns a Boolean value that corresponds to those letters, whether it's true or false, which means I can use this choice to maintain some while loop. Let's go ahead and make sure this works. We'll say game on choice. Run this, and so it says, do you want to keep playing? If I type in something wrong, it says, sorry, I don't understand. If I type in Y, it returns back true. Let's run this again. If I type in capital N, it returns back false. Perfect. So now I have a function that basically asks the player, do you want to keep playing? and whether or not it's true or false. To finish this off, we simply have to put this all together. So we'll start off with some initial variables. We'll say game on starts off as true, and then we'll have our initial game list equal to simply 0, 1, 2. And so while the game is on, so I can do while game on is equal to true, or since game on is already going to be a Boolean, I'll just say while the game is on. Then I'm going to display the game, which means I have to display the current game list. Then I need to have the player choose a position. So I'll say position is equal to that position choice function we made. Then the player has chosen a position, which means we need to rewrite that position and update the game list. So recall we have this replacement choice function, which takes in the game list and the position. And you should also recall, if we scroll back up here, that replacement choice returns that updated game list, which means I want to actually update game list based off that replacement choice. And then finally, we will display the game again, essentially displaying that updated game list. And this would just keep going on forever while game is on. So let's give the user a chance to say whether game on should be equal to false or not, which is this game on choice. So we'll say game on is equal to game on choice. Perfect. And that's the very simple logic we have here. Let's go ahead and run it, make sure it works. Okay, so here's the current list, 0, 1, and 2. Pick a position. Let's double check to make sure if I choose something wrong, it still works. Let's say if I choose 2, it says, hey, sorry, invalid choice. Pick a position again. Here's the current list. So let's choose 1, hit enter, type a string to place that position. We'll say my choice, hit enter, and now the current list is 0, my choice 2. Let's go ahead and keep playing. So you can see how the functions are being called in order here. Okay, here's the current list, 0, my choice 2. Let's pick 0 position, type a string, we'll say test, hit enter, and there's the current list, test, my choice 2. And I'm say all done playing, hit N, and the loop is finished executing. That's it. Okay, so we've definitely put a lot of pieces together in order to create an interactive Python program. And the main things we have to be aware of is the ability to display information to the user, accept information from the user, validate that information, and then update whatever the user is actually seeing. And with just a couple of functions, we can see that we're able to do that here. Displaying information, getting user information in order to validate that information, then update what we're actually displaying, that game list, and then getting more user information to see if we want to keep going with the program. Okay, you pretty much have everything you need within this lecture notebook and these lecture videos in order to make another higher level jump to program something that is a little more interactive, such as a tic-tac-toe board game. So let's get you ready by explaining your milestone project coming up. I'll see you in the next lecture. Welcome everyone to your first milestone project. You now know enough to actually create a real program. And so since this is your first milestone project, we're going to create a tic-tac-toe game for 2 human players. Let's describe what the game will be like and what approach you should take when tackling on your first milestone project. First off, the basic idea of the game is that 2 players should be able to play the game both sitting at the same computer. And the board is going to be printed out every time a player makes a move. You should be able to accept input of the player position and then place a symbol on the board. So we have these kind of larger problems, and what you should do when you're thinking about this milestone project is try to break these down into smaller sub-problems. And that idea of breaking down the larger problems into smaller sub-problems is why we created a workbook, Jupyter Notebook, for you that you can kind of go through and create functions in step-by-step fashion. Now let's describe the actual idea here of putting keyboard input and converting that into something that corresponds with a tic-tac-toe board. We're going to be using the idea of a number pad. So if you have a larger keyboard, often it has a number pad to the right of it. And we're going to match those numbers to the grid on a tic-tac-toe board. And it's up to you which way you want your number pad to go. On a keyboard, it looks like this: 1, 2, 3 at the bottom, 7, 8, 9 at top. But often on an older phone model, when you deal with the number pad, it goes the opposite way. It has 1, 2, 3 on top, 7, 8, 9 on bottom. Again, totally up to you. The main idea here, though, is that in our mind, we're going to have a tic-tac-toe board over this number pad. And then a user, they're going to, using the input function, it's going to ask them, hey, where would you like to place your X or O? And then they'll provide a number that corresponds to the tic-tac-toe board. And what we're going to do is then print out the tic-tac-toe board with an X at that location. And then the next user is going to choose their number, such as 8, and that will put the next symbol, O, there. So we're going to alternate between X and O, ask the user for the input number, and then place that symbol on the board. And then later on, we'll check to see if someone has won or if there is a tie. Now, since creating your first full program is always a big leap forward, you're going to come out the other end a much better programmer. But since this is such a challenge, we've set up a walkthrough notebook to help guide you along with the functions that you're going to need to create. So let's explore what the game's actually going to look like once it's done. And then once we've done that, we're going to cover a few useful functions and go through the walkthrough notebook and show you just a couple of things to help get you started. Okay, let's jump over to the actual notebook that has the solutions. I'm not going to show you the solutions right now. I'm just going to show you what the game looks like when you run it. Okay, here I am at the solution notebook. I'm pretty zoomed in, so we only see a few lines of the solution code, but there's a lot more code through this. But I just want to show you what this actually looks like and an idea of what the game should look like when you run it. It doesn't have to look exactly like this, but this is the main idea. First, we ask the first player, hey, do you want to be X or O? So using the input function, we can pass in a string, X, hit enter, and then it'll say, hey, player 1's going to go first. Are you ready to play? Enter yes or no. So then we enter yes. And then you can imagine that that's starting some sort of while loop to continue playing the game. And then we have choose your next position. And notice here, we've been able to print out a board. And these are basically just print functions with kind of larger strings. And in the middle of some of these are going to be curly braces. You can't see them right now because they're empty, but they're curly braces that correspond to the index position of some list. And then when the player, using the input function, asks for the next position, let's put in 1. We can see here that we automatically draw an X at that 1 location. And then the next player says, hey, choose your next position. Let's have them choose 8 like we did in the slides. They hit enter, and now we have O there. And then we choose the next position, and so on until someone's 1. So I can say 2 here, and we'll have, let's say 9 for O, and let's make X win by putting in 3. So here we have 3 in a row, tic-tac-toe has been won, and it says, congratulations, you have won the game. And then we ask the player, hey, do you want to play again? Enter yes or no, and let's enter no. Hit enter, and that breaks this cell. So you can see here, there's a little hint here, if not replay. So we can see here, replay some sort of function that was accepting yes or no there. All right, so that's the basics of what it should look like. Let's now hop over to the workbook notebook, explain what that looks like in order to get you comfortable with the idea of lining up these functions. And then we're going to show you a couple of useful things in case you want a little head start on the solutions. All right, so the actual notebooks, if you go to Complete Python 3 Bootcamp, either you've downloaded this or you're at the repo, come over to Milestone Project and you'll see a couple of useful notebooks. One is the assignment notebook. This assignment notebook is just a description of what it is you need to do. It's basically the notebook that corresponds to the lecture right now that you're viewing. And it looks like this. It just says congratulations and a couple of bits of information. The notebook that you're mainly going to be working with is this walkthrough steps workbook. And this notebook looks like this. So this is the walkthrough steps workbook, and this is something we've designed to help you guide you through the functions that you're going to need to create. It has some suggested tools, such as the input function that you've seen before, and then it also notes that if you want the input to be an integer, it may be a good idea to cast it to an integer using int. Then we also have some information about how to clear the screen between moves. This is a special Jupyter Notebook function. There's also kind of a simpler way to clear the screen, which is just to print 100 new lines, and then you can scroll up to view the previous boards. All right, so what does this actually look like as far as a workbook notebook? Well, we've divided up the entire project into steps, which have placeholder functions for you to fill out, and then we have tests for each of those steps. And you can see here step 2, test step 2, step 3, and eventually you go along And at the very end, there's going to be less tests because you won't really need them. And finally, there'll be kind of some ideas of how you should set up the logic for the game. So what does these functions actually look like? Well, for instance, the very first function wants you to write a function that can print out a board. So you set up your board as a list where each index 1 through 9 corresponds to a number on the number pad, so you get a 3x3 board representation. So what this is expecting to happen is when you pass in a board list into this display board function, you actually print out that board. That way, later on in your code, you can actually call this function and it will continually print out the board whenever you want it. So in order to test this function, we have test step 1, where we've created a test board for you, some board that's already full, and then you can say display board. Then the next one is to write a function that takes in player input and assign their marker as X or O. Think about using while loops, and we continue along with these cells. All right, so that's the basics of the workbook. Now, since this is such a big project and it's going to be kind of a big leap forward, what I would recommend you do is if you ever feel uncomfortable, jump to the solutions and treat it as a code along lecture. And then once you're done coding along with that, see if you can come back and independently fill out some of these functions on your own. And that will really help you connect the dots of dividing this problem into smaller subproblems. Okay, so that's the main idea of the milestone project. If you want, right now you can just stop this lecture, go ahead and jump to it. And you can also just open up a script or open up an empty Jupyter Notebook file and see if you can do this all on your own without the workbook. What I'm going to do now is give you a little bit of a head start because I know it can seem very daunting. I know a lot of students, they look at this step 1 and they just get totally stuck. There's kind of this roadblock in their mind of where to actually begin. So I think it's really helpful if you're completely stuck on the idea of how do I even approach this task. I'm going to show you a way you could display the board, and then I'll show you a little bit of step 2 and a little bit of step 3. So these are just hints. It's not the full solution walkthrough. It's just something to help get you started. I'm going to open up this workbook in a Jupyter Notebook and continue on. If you don't want any hints on how to get started, go ahead and just stop the lecture here. Okay, let's go to the Jupyter Notebook. Okay, here I am at the walkthrough steps workbook. I'm going to work through the couple of first steps just to give you a little help pushing you forward through this project. Again, if you want to tackle this on your own to start off with, you can stop watching the lecture. First thing we're going to do is discuss actually printing out the board. So as we mentioned, we kind of want you to set up the board as a list that looks like this. And at first, that test board list or the board list is going to be empty, and we're going to use user input to index this list and then assign it the actual string value. So how do we actually display this board if it's a list? Well, we could just use a bunch of print functions. And I'm going to do a very simple version of the board here, where I'm going to say print, let's say the board at index 1 plus, as a string, some pipe operator, and then the board object at index 2 plus some pipe operator, or any symbol you want really, and then concatenated with board at index 3. And then we're going to copy this and fill out the rest. So we'll say this and this. So 1, 2, 3 is at the bottom. Again, you can kind of reverse that if you want. And we'll have 4, 5, 6 here. And then 9, 8, and 7. And let's run this and see what happens. Whoops, I have invalid syntax. I forgot the plus sign here. Plus, plus, plus. Okay, now when I run this, what I'm doing here is I'm going to print out whatever string is at board 7, a pipe operator, then whatever string is at board 8, another pipe operator, and then board 9. This is not going to look as nice as the tic-tac-toe board I just showed you, but it should work to some degree. So I rerun this, and let's display the board. So I'm going to pass in this list. I run this, and here's my board, XXX000, or 000. And that's the basic idea of displaying the board. And then later on, you can get a little fancier. If you want those horizontal lines, all you need to do is just print out a couple of dashes that maybe look like this. That's probably way too many. Let's just do something like that. And now when I rerun this, you can see how that's slowly starting to kind of affect the board there. And maybe you want uppercase dashes yourself. So maybe you want something like these pipe operators here, start lining them up. And you can start to get really clever with the way this is going to look. So that's the basic idea of just displaying the board. We've taken the board itself as a list, grab the index positions, and then we will print out whatever value is there. Now keep in mind your test board at the very start of the game is going to be probably a bunch of empty strings. So it's probably realistically going to look something like this. We'll say just times 10 here. It's going to look like some sort of empty board. So if I rerun this, it'll look like that. So that's how the board starts off, and then as people start actually putting in X's and O's, it will clean up the board. Now, if you keep calling display board multiple times, you'll be able to see a history of the board. If you don't want that, what you could do is clear the output from the previous board. So later on, you can experiment with running this clear output line, or if you're running a Python script, running this line right here, which kind of prints out 100 new lines. And what this does is because later on during your logic, if you keep asking to display the board, it will show you an entire history of all the print functions or print statements you used to do. What you could do instead is clear the output and then only show the board itself. That way it actually appears to the user that the board is being updated instead of printing out a new version of the board. So you can play around with this to get an idea of what I'm talking about, and you should be doing this before you actually print out the new version of the board. So that's how you could display the board. And I'll give you a couple more hints about step 2. Okay, the next thing we want to do is write a function that can take in a player input and assign their marker as X or O. And we want you to think about using while loops to continually ask until you get a correct answer. And there are a ton of ways you could do this, but I'm going to show you just a quick example way so you can hopefully get the mindset ready. One way is to set your marker as an empty string. And then what we're going to do is keep asking one of the players, such as player 1, to choose X or O. And then once they've chosen, we'll assign player 2 the opposite marker. So how can we keep asking player 1 to choose X or O? Well, we can say while the marker is not equal to X and the marker is not equal to O. So that means the marker is both not equal to X and not equal to O, meaning someone hasn't supplied the correct input. What I'm going to do is set marker equal to the input player 1, choose X or O. That way if the player accidentally puts in a number or puts in another letter, it just asks them for the input again. And then once we have that input, what I could do is say player 1 is going to be equal to that marker, and then we'll have a little if statement here for player 2. We'll say if player 1 is equal to X, player 2 will set that equal to O. Else, player 2 is then equal to X because we know player 1 chose O. And finally, what I could do in order to return both player 1 status and player 2 status for their markers, I can return this either as a list or a tuple. That way I can use tuple unpacking later on. So I can say return player 1, player 2. So let's run this and make sure it works. So I'm going to call player input function here, run that, and it says player 1 choose X or O. So let's give it a wrong answer and see what happens. Okay, let's give it a number, see what happens. So it keeps asking us, hey, choose X or O. So if we choose an X, then it reports back, okay, X and O. So player 1 is now X and player 2 is now O. And the way you can work with this is actually assign them to a tuple. So what you could do is say tuple unpacking in the following form. Create player 1 marker variable, comma, player 2 marker variable, and set that equal to the output of player input. That way, when you run this, and you actually choose a value, O, you can then say, hey, what was player 1's marker later on in your code? And it'll tell you it was O. And if you ask for player's 2 marker, it was X. Okay, so those are a couple things to help you get started. In the next lecture, we're going to go over all the formal solutions, and we'll see you there. Best of luck on your first milestone project. If you ever get stuck or have any questions, feel free to post to the Q&A forums. We'll see you there. Welcome back, everyone. In this lecture, we're going to formally go through the solutions for the workbook for the Milestone Project 1, that tic-tac-toe game. Let's open up the notebook and get started. Alright, here we are at Milestone Project 1 Walkthrough Steps workbook. Let's start with step 1, which is to create a function that can print out the board. And there's lots of different ways you could have printed out the board. You could have gone with a really fancy board or a really simple one that just displays the list. But remember, we're expecting board to be a list. So the first couple things we're going to need is to actually print out the index positions of that list. So it'd be nice if we did something like board at 1 plus, and then some sort of indicator that we have a new column there. So we can do that. And then we'll do board at 2 plus, and then another pipe operator. And then finally board at 3. And then I'm going to just copy and paste this. And now let's change up the index positions. So 7, 8, and 9 on top. And it's up to you if you want to reverse that, but 4, 5, 6 will always be in the middle there. And let's check what this looks like if we display the board. So we run this, we display the board, and right now my test board is blank. So let me copy over the test board from the original workbook. And now when I run this, I get back my board. So this is a really simple version of the board, but it works fine. Now, something to note here is that if I run display board multiple times, so let me call it twice here, what's going to happen is I actually see a history of all the boards here. So in order to avoid that, what we could do is call clear output first. So if I call clear output, and as an alternative, if you're running this to the command line, you can use this print statement we talked about. If I now have clear output, what's going to happen is I only see one version of the board. So this would display the board, and the next time the board gets displayed, so next time you call display board, it's going to clear the output for you. So this is a really simple version of printing out the board, and we can keep it for now. But I'm going to copy over and paste the solution workbook, which is essentially the same idea. It just has a little sleeker bit of formatting here. So if I run this, I get back kind of a more spacious board to look at. It's up to you what you want to do here. Lots of different options. Main idea was to be able to index board and then print it out. Step 2 was to write a function that can take in a player input and assign their marker as X or O. Again, lots of different ways we could do this, but something we definitely wanted to do was to use a while loop. That way we can continually ask until you get a correct answer. So I'm going to set marker as an empty string, basically anything that's not X or O. And I could do this two ways. I could say while marker is not equal to X and marker is not equal to O. So I could do it this way and then say marker is equal to input player 1, choose X or O. And then what I can do is uppercase this in case they accidentally put in a lowercase x or a lowercase o. And finally, I'll return some sort of tuple assignment. So I'll say if marker is equal to X, return X, comma, O. And so the format here, I can write myself a little note. And in fact, this would be a good case for a docstring, is to say that the output is in the form of a tuple with the player 1 marker, comma, player 2 marker. So then when I check player input, the docstring is going to tell me what the actual output looks like. So you can check out the previous lecture for a more detailed version of this. This is kind of a cleaner version. Then we'll say else return O and X. And this allows us then to use tuple unpacking. So if I run this, then I can use tuple unpacking, something like this, to get back player 1 marker and player 2 marker. So I run the input, if I pass in X, hit enter, and I check out my player 2 marker, it's going to be the opposite of X, which is O. And if I check out my player 1 marker, it's going to be X. So different ways you could do this. The other thing I wanted to mention is instead of doing it with not equal to and not equal to, you could have said, while not marker equal to X, or marker equal to 0. So you could have said, while not this case or this case. So different ways to think about it logically. It's kind of up to you which you prefer. Moving on to step 3, we wanted to write a function that takes in the board list object a marker, X or O, a desired position number, 1 through 9, and then assigns it to the board. So what we can do here is say place marker, board marker position, and I will say board at that position is equal to marker. So let's run a test to make sure this actually works. What we're going to do is say place marker. I have right now a test board. So if I take a look at what my test board looks like, it's the one from above, where I have a hashtag first to kind of block out the 0, and then X's and O's. I'm going to say, put in something new there. So let's make it really obvious with a $sign, and then put it at position 8. So I'm going to place the marker, and then display the test board here. So let's run that, and we can see that it successfully put in the $sign at the position we want. And that was just a simple, basically, at that board's position, place the marker there. Okay, step 4 was to write a function that takes in that board list and some marker, like X or O, and checks to see if that marker has won. So we have to ask ourselves, what does it mean to win tic-tac-toe? Well, it means that we need to check in the possible combinations. So we know that there's going to be 3 across. So we need to check all rows and check to see if they all share the same marker. So if they all share the same X's or they all share the same O's. So we need to do that for all the rows. Then we need to do that for all the columns. So that's going to be 3 columns there. Check to see if marker matches. And then finally, we have 2 diagonals to check. Diagonals. And check to see if we have matching there. Now we can use indexing to grab the example rows, the example columns, and the example diagonals. I'm going to show you different ways to do this, and then we'll copy and paste from the solutions because it's a lot of checks. So one way we can check for everything matching on all the rows is the way we showed you in the solutions notebook, which is to say board, let's do the bottom row. So we'll need to check board of 1 equal to the mark and board of 2. Let me make sure I check that right. Board of 2 equal to the mark and board at 3 equal to the mark. So what this does is it goes ahead and checks, hey, is the position at board 1 equal to the marker? Is position at board 2 equal to that marker? Remember that marker is the same that you passed. It's either going to be X or O. So if it passed an X, it's going to say at this position is it X, and at this position is it X, and at this position is it X. If we have this case true, then we know someone has won. It's whatever this mark is, has won. And in that case, we would just return back some sort of Boolean that they've won the game. And then what we could do is wrap this in a parentheses right here, and then have an OR statement, and then check for the next row. So we could say board at 4 is equal to mark, and so on, 5, 6. Then the next one would be 7, 8, 9. And then we could do the same for the columns, and the columns would be things like 7, 4, 1, 8, 5, 2, 9, 6, 3. And then we have the 2 diagonals, which is going to be those numbers, 7, 5, 3, and 9, 5, 1. Now, this is how we did it in the notebook solution because it's a little more obvious what's happening here. But as an alternative, instead of using these AND operators along with checking mark for each individual index position, what you could also do is just check that board of 4 is equal to board of 5 is equal to board at 6, and then finally check that this is equal to the mark. The reason you cannot just do no check to the mark is because if the board starts off blank, then it's going to report back, hey, these 3 blank positions match and someone's already won. So then you have to check it off with the mark finally. So this right here is the same logic as what we saw up here. It's just maybe a little sleeker, a little cleaner. It depends to you what is more readable. But I'm going to copy and paste this from the solution notebook because it's a lot of checks. And if you want to be a little clever, you can make a little for loop for the rows and a little for loop for the columns, and then manually write in the diagonals. But let me copy and paste the solution and briefly go over it. Basically what we're doing here is we're doing that first way I mentioned. We're checking across the top, across the middle, across the bottom, down the middle, and then down the other columns, and then the 2 diagonals. All right, and what we're doing here is then we have an OR statement for each of these possible checks. And then after all of this, we're going to return the Boolean. indicating true or false, has somebody won. So we can have a win check here. Let's define this, win tic-tac-toe, the win check, and it looks like someone did win this tic-tac-toe. So let's actually display the board so we can see that. Display board, test board. So if we see this, definitely X has won in both fashions here, and it returns back true that this person has won. Great. So now step 5, we want to write a function that uses the random module to randomly decide which player goes first. And as we mentioned, you may want to look up random.ranInt. We talked a little bit about it in the useful operator lectures, but let's take a closer look now. One way we can use the random.ranInt is to just pass in 0 and 1 and treat that as what is essentially a coin flip. So we can say the following. We'll have our flip number be equal to random.randInt 0, 1. So this is randomly going to choose either 0 or 1. So we can think of that as heads or tails. And then we'll say if the flip is equal to 0, then we return, let's say, player 1 as they're going first. Else, we return the string player 2 for going first. And there's lots and lots of different ways you could have done this, but this is kind of a simple way with the random.ranInt, or random integer function. So let's run that. Okay, step number 6 was to write a function that returns a boolean indicating whether a space on the board is freely available. So it's going to take in that board, which is a list, and then take in a position, and it wants to check if it's freely available. And for our case, freely available means that that position is currently an empty string. So to do that, what I'm going to say is get the board at that position, and then see if it equals a blank string. And since that's already itself going to be a boolean, we're just going to return that. Then step 7 is to write a function that checks if the board is full and returns a boolean value. True if full, false otherwise. So to do this, we're going to run a for loop that goes for I in range 1 through 10, because there's 9 spaces on the board starting from 1 and then up to, but not including 10. We're going to say if, and then we can call our space check function that we just defined up here. So if space check, using that board at position I, so that's all the positions possible on the board, if space check returns true, then I'm going to, and this is kind of a double negative here, but we're going to return false. So what this means is if I have a space, that means my board is not full, so I will return false. Otherwise, if I go throughout this entire for loop and I don't return false, then I will return true because my board is full. So board is full if we return true. Okay, so that's the full board check function. Step 8 is to write a function that asks for a player's next position as a number 1 through 9, and then uses the function from step 6 to check if it's in a free position. If it is, we return the position for later use. So we'll do the following. We'll say position, and we'll have it be a placeholder at 0 because we know that at index 0, nothing's going on there. And we can say while position is not in the list of possible positions, so that can be 1, 2, 3, 4, 5, 6, 7, 8, 9. And we could have used range along with a list to make that happen. Or that space is not free, so we can say or not space check at board position. We'll ask the player for a position. We'll say position is equal to the integer of the input. Choose a position 1 through 9. And then finally, after all this, we're going to return that position. So all we're doing here is the following. We'll say position starts off at 0, and while the position, if the player for some reason is inputting the wrong number, or if they're inputting a letter, that's going to be this check to see if it's an actual number that's on the board, or it's going to check, hey, is that space still available? And then we're going to return the position once these have been satisfied. So we should only be calling player choice later on after we check if the board's been full. So the board being full is going to be a nice way to check if there's a tie, because if the board is full and nobody's won yet, then we know there's a tie. Okay, step 9 is to write a function that asks the player if they want to play again and returns a boolean true if they do want to play again. So Lots of different ways we can do this. One way is to just say input, play again, question mark, enter yes or no, and we're going to say that's going to be their response. Let's just have that be their choice. And we'll say return choice equal to yes. So here we're assuming the person is actually putting in the correct values. If we get choice not equal to yes, basically they have to write yes perfectly, otherwise we'll assume they don't want to play again. All right, and that's our replay function. Now step 10 is the hardest part, where we actually have to code out all the logic. So this is going to be our largest block of code, so we'll finish this off in the next lecture. We'll see you there. Welcome back, everyone. So finally, it comes to step 10, which is the harder part, where we need to use while loops and the function we just defined above in order to actually run the game. So let's write out a little bit of logic and comments on the steps we need to take. So first off, we're going to need some sort of while loop to keep running the game. And then probably at the bottom of this while loop somewhere, we're going to break out of the while loop on the replay function. So remember, the replay function just asks if they want to play again. So if they don't want to play again, we'll break out of this while loop that continually runs the game. So let's do that right now. At the very top, we'll just print welcome to tic-tac-toe. Tic-tac-toe. And then we'll say while true. And then we're going to play the game here. And finally, somewhere at the very bottom, we'll ask for the actual result of that replay. So we'll say if not replay, break. Because after they've played the game and somebody's won or there's been a tie, we're going to ask them, we're going to call replay and then break out of this continuous while true loop. Again, you should always be very careful with these true loops. There should always be a way to break out of them. Now it's time to play the game. So in order to play the game, we first need to set everything up. And what I mean by that is like the board, who's first. And then the other thing we probably need to set up is what markers they choose. So we'll say choose markers. So those are X's and O's. Okay, so we need to set those things up. And then after that, we'll have some sort of actual gameplay. And the gameplay will probably consist of player 1 turn, and then player 2 turn. So let's start off by setting everything up. The first thing we want to set up is the board. This should be pretty straightforward. We'll just set up a board, and in my case, I'm going to set up the board as a bunch of empty strings, because when I set up the display board function up above, I expect it to be kind of a bunch of empty strings there. There's lots of different ways to do this, and it really depends on how you set up your display board function. But in this case, I'm going to set up my board as just a list of 10 empty strings. And I will say that player 1 marker, comma, player 2 marker are going to be the result of player underscore input. So if we scroll back up to realize what player input was, remember that's one of the very first functions you actually created, which asked what player chose X or O. So we're going to say player 1 marker is equal to X, and then player 2 is equal to O, or the opposite, because we're using tuple unpacking here. So that's what we're running, that very first player input function. So we're calling that all the way at the bottom, and I set their actual markers. That way I can call those variables later on. Then we need to choose who goes first. So I'm going to say turn is equal to the function call, choose first. Remember that was basically that coin flip function. And then let's print out a little report. We'll say turn will go first. So here, if we remember what turn is, choose first actually literally returns just a string, player 1 or player 2. So we're going to use that as the indicator of who's going first. So we say turn choose first, player 1 or player 2 will go first, because turn is that actual string. So we concatenate it. And then finally, once this is ready to go, let's ask if they're ready to play the game. So we'll create a variable called play game, and the input will be want to play. I should say ready to play, really, because we already have a bunch of stuff. Ready to play. So they've set up the players, we decided who's going to go first, and we asked them, are you ready to play? and we'll have them say lowercase y or n. And it's up to you how you want to do this. We'll say if play game is equal to y, then the game is on. So I'm going to create a variable called game on and set it equal to true. If for some reason they weren't ready to play yet, we'll just say game on is equal to false, and that will be it. Okay, so now it's time for the gameplay. We'll assume that game on is true, and then we'll say while game is on. So we have player 1 turn. So let's say if turn is equal to the string player 1. We'll have player's 1 actual turn, and otherwise we'll have player 2 turn. So off of this we'll say else, and this is player 2 turn. Okay, so let's set up the logic on player 1's turn. So what do we actually need to do here? Well, the first thing we want to do is display the board. Otherwise, the player won't know what the heck they're looking at. So we'll say display board, and we'll pass in that board object that we just created. And the next thing we do is, well, let's write out the steps here. We'll show the board. Once the player's seen the board, they can choose a position. Once they've done that, we will place the marker on the position that they chose. And then we just need to check if they won or check if there is a tie. And then finally, no tie and no win. Then next player's turn. So that's the logic of what we're going to do here. And this entire logic is going to be the exact same thing for player 1 and player 2. We're just going to edit the actual variable names. So we showed the board. That's easy. That's the display board function we defined earlier. Now we want to choose a position. That's also pretty straightforward because we actually already have a position function called player choice. So remember that if we call back player choice, and let's make sure we've defined it up here. So player choice was just this one right here where we have them choose an actual position on the map, or I should say on the board. We say position is equal to player choice, and we pass in the board here. And then finally, we're going to call the place marker function, where we take in the current board. We say player 1 marker because this is the player 1 turn, and then we pass in the position they chose, which is defined up here. So we showed the board, we choose a position, we place the marker on the position, and now we need to check if they won. Again, we already defined the function for that. It was called win check, and it takes in the board, and then that player's marker. In our case, it's going to be player 1 marker. And we can display the board. So if win check happens to be true, then player 1 has won. So in that case, we'll display the board and print out player 1 has won. And once somebody's going to win the game, we'll just say game on is now equal to false. So the game is no longer active, which will break out of this while loop. We'll still have this while loop right here asking people if they want to play again, but this while loop of the actual gameplay will now be broken when we say the game has been won. So if we don't have a win, then this doesn't execute, which means we should check if there's a tie. So how do we check if there's a tie? Well, we can check if there's a tie if the board is full. So if we've already checked and nobody's won, then we should check if the board is full. And if the board is full and nobody's won, then that means we have a tie. So we already actually have a full board check, and let's check it up over here. Remember over here we have the full board check function, so we're going to be using that, and returns back the Boolean, true or false. So we'll say if full board check on the current board that we're kind of passing around here, we'll display the board. So this means that someone hasn't won, and else if the board is full, we'll display the board and then we'll say something like the game's a tie. So tie game, and then we will break out of the loop. We could also set game on equal to false, either way. And then we can set turn equal to player 2. So let's actually just keep this game on convention. So instead of breaking, we'll say game on is equal to false. So what's actually happening here? For player's one turn, we display the board, we choose a position, or player one chooses a position, we put that marker on the board, we check if they've won. If they did win, game on is now equal to false, and this entire while loop is over. If they never won, then we have two things to do. We need to check if the board is full. And if the board is full, then it's a tie game. We print out the board, show them what it looks like that is full, and we say game on is equal to false, and this entire while loop is over. Otherwise, nobody's won. There's still space on the board to go. That means it's time for player 2 to go. And we're going to essentially copy and paste all this code because player 2 is going to do a really similar thing. It's just wherever player 1 is, player 2 is going to be, and vice versa. So let's delete these comments here. And now we have this else statement. And I'm going to zoom out just a little bit so we can see the entire logic here. Notice how I have if turn is equal to player 1. That's this entire block of code. Else is now lined up with this if. So else here signifies that this player's 2 turn. And I'm going to paste all the code here. So same thing, I need to show the board. I need to choose a position. I need to place the marker, except this time it's going to be the player 2 marker. So that's a change we're making. And then we want to win check for, again, the player 2 marker. And we display the board. And in this case, player 2 would have won. And we set game on equal to false. Else, we say if full board check, display the board, tie game. And finally, if player 2 didn't win and there's no tie, then we go back to turn being player 1. And that's it. That's player 2's turn. And let's check this out and see if it actually worked. We'll run this code. We'll choose X for player 1. We'll say ready to play. Yes. Choose a position, 1. And let's kind of play this out. We'll keep going like this. And then we should see player X win. So player 1 has won. Perfect. And let's go ahead and play again. Okay, so we just saw how the win works. Now let's run this again and check to make sure that our tie checking is also working. So I'm going to type in O. So player 1 is going to be O. Player 2 will go first. So that means X is going to go first. We're ready to play. Time to choose a position. And hopefully I can actually get a tie here. This is harder than it looks to play against yourself and try to purposefully tie. But I will do my best here. Let's say 2. Let's say 4. And now O is going to block him at position 7. And then X will have him go, let's say, position in the middle, 5. We'll have O block him at position 9. And then X will have him go kind of somewhere useless, let's say 3. And then O will purposefully block off X here. And we'll have him go at position 6. And then finally, we'll have X go in at position 8. And it's a tie game, so the tie check worked as well. And we no longer need to play again, so we'll say no. And that's it. That's the game. All right, so definitely a really big project, but hopefully now that you're on the other end of it, you were able to see how you can use functions to create a larger block of code. Now, if you were treating this as a code-along project, what I would highly suggest is if you just viewed the entire solutions, go back and see if you can now go through the workbook notebook on your own after you've referenced this entire solutions code. It's going to be a really great help to your skills to be able to try to attempt this independently, even if you already watched the solutions lecture. All right, thanks everyone. If you have any questions, feel free to post to the Q&A forums, and I will be there to help you out. I'll see you at the next lecture. Welcome back, everybody. In this lecture, we're going to be discussing object-oriented programming. Object-oriented programming, or OOP, allows programmers to create their own objects that have methods and attributes, and it's a really great way, once you begin scaling your code, to organize your code. So recall that after we defined things such as a string, list, dictionary, or other built-in Python objects, we were able to call methods off of them with the .method name syntax, such as when we were able to call the append method off of a list object, or the index method off of a tuple. These methods act as functions that use information about the object, as well as the object itself, to return results, or edit or change the current object somehow, such as when you called .sort on a list, it went ahead and edited the current list. For example, this includes appending to a list or counting the occurrences of an element in a tuple. So those methods use information about the object and then either return a result or they edit and change the current object in some manner. OOP, or Object-Oriented Programming, allows users to create their own objects with their own methods and own attributes. And the general format is often confusing when first encountered, particularly because of the use of a self keyword. And its usefulness may not be completely clear at first for beginners. But in general, object-oriented programming allows us to create code that is repeatable and organized, and at a certain scale, you're going to need to understand how to work with object-oriented programming in order to make sure your programs themselves are flexible. And when you're working with outside libraries, you'll see how they make use of object-oriented programming in a lot of their code. So for much larger scripts of Python code, functions by themselves really aren't going to be enough for organization and repeatability. Commonly repeated tasks and objects can be defined with OOP to create code that is more usable, especially across an organization. So let's check out the syntax of object-oriented programming, and don't worry about completely understanding everything we show you right now. We're going to take it step by step in a Jupyter Notebook through a series of lectures. But for right now, I just want to give you a brief overview of some special syntax calls that we haven't really seen before. The first one being the class keyword. So the basic way that you define an object is using the class keyword. And that's why sometimes objects are also called classes in Python. Sometimes people like to interchange those two terms. But basically we have the class keyword and then we have the name of the class. And notice here that the name of the class now is following what's called camel casing, where every individual word has that first letter capitalized, which is why we were telling you before to have variable names and function names in lowercase, because classes, those are the reserved uppercase words and uppercase naming schemes. So we have class, and then we define the name of the class. The next thing we notice here is this thing that looks a lot like a function, but it's actually called a method when it's inside of an object or inside of a class call. And here we have def, just like we would with a function, and we have this special method called init method, and it's underscore underscore init, and this allows you to create an instance of the actual object. You'll notice here we have then a self keyword as well as some parameters to be passed. So param1 and param2 are going to be parameters that Python expects you to pass when you actually create an instance of this object. And then what it does is when you pass in a parameter, for instance parameter2, you go ahead and assign it to an attribute of the function. That way Python knows that when you're referring to self.param2, you're referring to the attribute param2 that's connected to this actual instance of the class instead of a global variable called param2. And we'll explain this in a lot more detail because this is a step that is really confusing at first. But again, all we're doing here is we're going to pass in a parameter and then connect that parameter with the use of that self.argument or self.parameter to link it to the actual object itself. After that, then we can have various other method calls. And these look a lot like functions. We say def, the name of whatever you want your method to be, and then you pass in that self keyword again to let Python know that this isn't just some function, it's a method that's connected to this class. And that's why we use the self word, to connect these methods to the class so that when you call something like self.param1, it knows that you're referring to the attribute param1 that's connected to the class itself. Okay, so we're going to explore object-oriented programming in a lot more detail, take it really slowly step by step in the next series of lectures. So if that was all kind of a real quick blur for you, don't worry, we're going to go step by step coming up next. We'll see you there. Welcome back everyone. It's time to actually dive in with Python and use object-oriented programming to create our own objects. In part 1 of this series of lectures, we're going to focus on the class keyword as well as creating attributes for our objects. Let's jump to a Jupyter Notebook and get started. Alright, so let's start off by actually realizing what an object already looks like in Python. If I were to create my list, 1, 2, 3, I would be able to then call the variable my list, say dot, hit tab, and see a bunch of attributes and methods off of this object. And the same thing goes for a set. And we've seen how to create a set using mySet equal to, and then we have this set keyword. And then if I take a look at my set, I can do dot tab and see a bunch of attributes and methods. What we're going to do is see if we can create our own user-defined objects. And everything in Python is an object. So I could say what is the type of my set, and it will report back that it's a set. And I can do the same thing for that list I just created. It reports back that it's a list. So let's explore how we can use the class keyword to create a user-defined object. So these are built-in objects. Let's use class, that's C-L-A-S-S, that's our keyword here for a user-defined object. The class is basically a blueprint that defines the nature of a future object. And from classes, we can then construct an instance of the object. And an instance is a specific object created from a particular class. So we're going to now create the simplest class possible. So I'm going to say sample. Notice how my class name is capitalized. So by convention, for classes, we follow camel casing, which is to say that every word here starts with a capital letter, unlike snake casing for variable names and function names where we had underscores. So by convention, we use capitalized names for classes. So we have class sample word, and I'm just going to say sample here, open close parentheses, colon, and then we'll say pass. So recall that the pass keyword basically just says don't do anything, and it's a placeholder there. If we didn't have it, we would get some sort of syntax error in the file. So instead we have pass, and that's it. We've just created our first class. And all it's doing is just saying, hey, you create a sample class, and that's it. There's nothing else there. So let's create an instance of the sample class. We'll say my sample is equal to, and then we call sample, open close parentheses. We don't pass in anything into it yet. Shift enter to run that. And if I check the type of my sample, you should see something that lets you know that it's a sample type. All right. So what we've done so far is we used the keyword class, created our own sample class. It doesn't really do anything. Then we created an instance of that class by saying the variable name is equal to an instance of sample. And then we can check my sample, and it says it's main.sample. Later on in a future lecture, we're going to discuss what this underscore underscore main underscore underscore keyword actually means. Basically, it's just letting you know that this particular instance of sample is connected to your main script here. All right, so that's the simplest class possible. It's not very useful though, because it doesn't have any attributes. So let's now see how we can create attributes. So inside of class here, I'm going to write 2 lines of code. I'm going to say def, just like we would for a function, except when it's inside of a class, we refer to this as a method. And this is a special method called the init method, which is going to be called upon whenever you actually create an instance of the class. And we always start off with the self keyword, which basically connects this method to the instance of the class, and it allows us to refer to itself. And then we pass in any attributes that we want the user to define. So for example, instead of calling our class sample, I'm going to say that it's a dog class. So dogs have attributes to them, and an attribute is a characteristic of an object. Later on, we'll discuss methods, which is an operation we can perform with the object, but for right now, we're focusing on attributes. So we may be thinking, well, what kind of attributes or characteristics do dogs have? Well, they have a breed. So something we may want to pass is the breed of the dog. And remember, when we had my set and my list, I could do dot tab and then see a bunch of options. Some of these are methods, some of these are attributes. What we're going to do now is try to create an attribute here so that when I create an instance of the dog class, I can hit dot and then see that breed pop up. So let me delete these lines because we won't need them anymore since the sample class won't be used. And then we will say self dot breed is equal to breed. And these 2 lines can be really confusing at first, since this is the first time we see the self keyword and we see the sort of like strange assignment. But I want to run this first and then break down what's happening in these 2 lines of code. So let's run this, and notice my indentation there. Everything's indented a little bit. And let's create a variable. I will say my dog is equal to an instance of the dog class. Now, if I don't pass anything, I will actually get an error. So you'll notice that we actually get an error when we run this with no positional arguments because we are expecting the breed parameter. So what this Python is trying to say to us is, hey, when you create a dog, it's expecting you to pass in a parameter for breed. So let's do that. We're going to say breed of the dog is a lab. And now when we run this, we don't get an error, and I can check the type of this my dog variable, and it says, hey, you now have an instance of the dog class. And if I say my dog dot and then hit tab, I should be able to autocomplete breed. Now the reason breed autocompletes is because right now it's the only attribute. Later on when we add in more attributes, we'll see a drop-down list. But if I run this, it reports back, hey, this instance of the dog class called my dog, its breed is lab. So let's scroll back up here and break down what's going on. Init can basically be thought of as the constructor for a class, and it's going to be called automatically when you create an instance of the class. This self keyword, it represents the instance of the object itself, and actually most object-oriented languages pass this as a hidden parameter to the methods defined on an object. But Python, it doesn't do this. You have to declare it explicitly. And by convention, we use the word self here. Technically, you could write in any variable name you wanted, but you should definitely stick with self. That way other programmers, when they look at your code, it makes sense to them. Now, I want to focus on breed because I found it confusing when I was just beginning that you see breed here 3 times. You see breed, self.breed is equal to breed. And I want to show you something that's not going to be correct convention-wise, but will hopefully help you understand how breed is being worked into this entire object. So what happens is when you create an instance of the dog class, Python is going to call this init method, and it's going to use self in order to represent the instance of the object itself, and then it's going to expect you to pass in this argument, breed. And I'm going to call this my breed. And what happens is when you say my breed here, I can set my breed here, and then you assign the attribute equal to whatever this parameter was. By convention, these 3 have the same name, but I want to show you how changing the name will hopefully make this clear to you what the actual connection is when you pass in the parameter. So I'm going to rerun this. And if I take a look at dog and then do shift tab, and you can also call help on dog, you'll notice that it's expecting my breed to be passed in. So what happens is you pass in this variable for my breed, and then the next step is you take whatever variable was provided for my breed and then set it equal to the attribute .breed or self.breed because this represents the instance of the object itself. So all we're doing when it comes to attributes, which again are characteristics of the object, later on we'll learn about methods, is we take in the argument. In this case, it's my breed, and we assign it using self.attribute name. So that's just the convention of what you're actually typing, self dot, and then you choose the attribute name. In this case, I'm calling it .breed. So let's run this again. Make sure you rerun this cell so we have my breed there. And then I can say my breed is equal to, let's say Sam's a husky now. I run this again, I still have a dog class, and if I take a look at my dog, if I hit tab, I only have breed. I don't have my breed available because my breed was just a parameter name we chose for the argument. So we said, oh, pass in the my breed argument, and I'm going to assign it to self.breed here. And I want to make this even more clear by saying breed is now my attribute. If I run this again, what happens is I pass in again my breed is husky, the type again stays dog, but if I say my dog tab, it's now my attribute, and it happens to be husky. So all we're doing here is you pass in the parameter or argument, and then it gets assigned to the attribute that you can later call on your object. However, by convention, you're just going to use the same parameter name for all 3 of these, which is why you end up seeing something like self.breed is equal to breed, and you pass in breed. This is confusing at first for beginners because they see breed in here 3 times, but you can tell that once you're familiar with object-oriented programming, it's just cleaner to have all 3 of these be the same term. That way you know what's being passed in and where it's being assigned. There's no real reason that they should all have those separate names. So right now, our dog only has a breed, but let's go ahead and give it more attributes. So what else could a dog have? Well, a dog could have a name. And maybe we can say, does the dog have spots or not? So we have a breed, name, and spots. So here we just say, create some more attributes. Self.name of the dog is equal to whatever name you pass in, and self.spots is equal to whatever you pass in for spots. And notice here, what I'm doing is I'm kind of expecting certain data types to be passed in. I expect breed to be a string, I expect name to be a string, and spots, the way I'm thinking about it, is actually going to be a Boolean. So let me have a comment here. I expect the Boolean, true or false, does the dog have spots or not? So hopefully you get the idea here that not every attribute you pass in is going to be a string, but it can be an integer, a floating point, it can be a list, it can be a lot of stuff. So I rerun this, and now let's take a look at what we need to define our dog. We need the breed of the dog, the name of the dog, and true or false, does it have spots? So we'll have the breed of the dog be a lab. We'll have the name of the dog be Sammy. And we'll have spots be false. Sammy doesn't have spots. So I run this, I run that again, I still have that dog class. But now when I say my dog and I hit tab, I see the options. I can see breed, name, and spots. So I can call these, check what the breed of that instance of the dog class is. I can check what the name of the dog is, and I can check, hey, does the dog have spots? And it'll tell me false, it doesn't have spots. One of the issues with Python being so flexible is that later on, when you're a programmer and expecting other people to use your classes, you're going to need to add in some documentation to let them know, hey, I'm expecting strings for breed, strings for name, and spots should be a Boolean. Because right now, I could say something like no spots, and Python's not going to complain here because I didn't do any sort of type check to make sure spots was a Boolean. So if I were to run this all again, there wouldn't be any error. Just when you say .spots, it would print out that string spots. Okay, so those are the very basics of attributes. We'll discuss better ways to have type control to make sure things like spots are Booleans later on in the course. But right now, what I really want to focus on is the basic idea that you use the class keyword, then with capitalized names, you define the name of your class, and the very first method in your class is going to be a special method called the init method. And this init method acts as a constructor, and we have this self keyword, which is a reference to the instance of the class. So that instance of the class is then going to have these dot attributes that you pass in based off what parameters you define up here. And by convention, the parameter name, the attribute name are the same, which means you will see it 3 times. Once when you pass it in, and then once here for the attribute, and once for the actual assignment call. Okay, those are the very basics of creating attributes. In the next lecture, we're going to discuss class object attributes, and then we'll move on to talking about methods. We'll see you there. Welcome back, everyone. In this lecture, we're going to be discussing object-oriented programming again, and particularly, we'll talk about class object attributes. And these are attributes that are going to be the same for any instance of the class, and then we'll move on to discussing methods, which are basically actions that you perform with the object you created. Let's jump back to the Jupyter Notebook where we left off last time. Okay, so here we can see our dog class that we created last time, and we also saw how the user could define various attributes. They could define the breed of the dog, such as lab or husky or golden retriever. They could define the name of the dog, Sammy, Frankie, whatever you happen to call your dog, and then we can define some sort of Boolean variable or even a string, whether or not it has spots. And here we saw we passed in the parameter as the user, and then it got assigned to the attribute over here. Now there may be attributes that are going to be the same for any instance of the dog class. For example, we know that it doesn't matter whether a dog has a certain breed, a certain name, whether or not it has spots, it's always going to be a mammal. So something we may want to do is have an attribute be defined at a class object level. Instead of having the particular instance always say that the dog is a mammal, instead we'll define an attribute above our init method here. So above this special method at the very start, we can define what's known as a class object attribute. And these are the same for any instance of a class. So let's go ahead and define a class object attribute. And what's special about these, since we know it's going to be the same for any instance of a class, we don't use the self keyword, because we know that the self keyword is a reference to this particular instance of a class. But since the class object attribute is the same for any instance of a class, we can just say something like the species attribute is equal to mammal. Now, as a quick note, if you're familiar with biological scientific classification, technically species is the wrong word to use here. It goes kingdom, phylum, and then later on class, and class is actually where mammal falls, but I don't want to end up accidentally using the class keyword twice here. So instead, we'll just pretend that the species of a dog is a mammal. Okay, so that's the side note for biology, but basically what we have here, back to Python, the class object attribute is going to be the same for any instance of a class. So let's test out this theory. I'm going to add this class object attribute. Again, note how I'm not using the self keyword because it's going to be true regardless of the instance. I rerun that cell, and if I call dog again and do shift tab, I still only need to define breed, name, and spots. So let's say the breed is again a lab. We'll say the name, the name is equal to Sam, and spots, we'll say false, Sammy doesn't have spots. So I rerun this, now I have my dog ready to go. It's still a dog, and if I look at .tab here, I can see breed, name, and species. So species, even though we didn't define it, it's always available to us, and this is going to be the same, mammal, regardless of the instance of my dog. So it doesn't matter what I pass in for breed, name, or spots. Because this attribute is not connected to self, it's not connected to any particular instance, so it's a class object attribute. And the way we format it is we have the class keyword, the name of the class, and then any class object attributes, and then you have your special init method for user-defined attributes. Okay, so those are the basics of attributes, mainly from the previous lecture for user-defined attributes, and then we have class object attributes. What I want to do now is actually discuss methods. Methods are essentially functions defined inside the body of the class, and they're used to perform operations that sometimes utilize the actual attributes of the object we created. So you can basically think of methods as functions acting on an object that take the object itself into account through the use of the self argument or self keyword. So what we'll do here is create our first method. So again, methods, unlike attributes, are more like actions. So these are operations / actions, and we can think of these formally as methods. And they basically look like functions inside of a class. And a lot of times beginners ask me, hey, what's the difference between a function and a method? Basically, a method is a function that is inside of a class that will actually work with the object in some way. So let's define DEF, and let's define an action for this dog to take. For example, maybe our dog could bark. And what we're going to do is say self, that way we connect this to the actual object so the dog can bark. And what's going to happen is when you call .bark on the actual dog instance, it's going to print something. And let's have it print woof. And let's go ahead and delete the name. Well, let's delete the spots attribute, so we're not dealing with so many attributes here. I'll delete spots here as well, and I'm going to rerun this. So we'll rerun this cell, and now if we take a look at my dog, shift tab here, it only needs the breed and the name. So let's define a breed for this dog again. We're going to say lab. Notice now I'm not bother passing the actual argument name there and just putting them in order. And then the next one was the name of the dog. So we'll have the name of the dog be Frankie. So I rerun this, and now I have my Frankie, which is a lab here, and the type is dog. And if we take a look at the species, it's still a mammal, and now the name of the dog is Frankie. So one of the key differences between attributes and methods is in the way we call them. Notice that attributes never had open and closed parentheses, and that's because attributes aren't really something that you execute. Instead, it's just something that's a characteristic of the object that you call back. So it's just information there about the actual dog. And I'm going to zoom out one level so we can see everything together here. So as I mentioned, for the attributes themselves, there's nothing to actually execute. Now for methods, that's a little different. And in fact, methods will need to be executed. So that means we need to have the open and closed parentheses when we do a method call. And I'll show you why. So right now I have my dog. And my dog is a mammal, it's a lab, and it's Frankie, and I want my dog to bark. If I just call bark right now, with no open close parentheses, you'll get back something that looks like this. And this basically says, hey, you have this method that's bound to your object, dog, at this location at your computer's memory. If you actually want to execute the bark method, you have open and close parentheses, you run that, and then you get back whatever the actual method does. In this case, it's just printing out woof. So that's how a method works. It's basically just an action that the actual object can take. In this case, it didn't really do anything besides the print statement, but usually methods are going to use information about the object itself. And we know that information about a particular instance of the object could be something like the name. So let's have the dog bark its own name. In this case, we'll say wolf, and here we're going to say my name is, and we'll use dot format here to pass in the actual dog's name. Now, a really common mistake that people do when they're first learning about object-oriented programming is they just pass in name. However, when we're working with objects, that's actually not good enough. What we need to do is reference the particular instance of the dog's name, meaning we need to reference not name, but self.name, because when you pass the name at the beginning, it gets connected to the object through the use of this self keyword. So here we need to say self.name, and that's going to, when you run bark, it's going to say print wolf, my name is, and it's going to say, hey, what is this dog's name? For this particular instance of the dog object, find its name. And it does that through the self.name call. And then we'll just insert it automatically because we only have one curly brace there. So we run that, and we're using print formatting there, which you can always review in case you're unfamiliar with this format call. Again, we'll say lab Frankie, rerun all of this to make sure that the bark operation has been set. And now, when we call bark, it's going to say woof, my name is Frankie. So it's able to actually reference things in the attribute sector. So you're able to say self.name and pass that in successfully into bark. Notice here how we call the self automatically. That way, in case we ever need to reference things, it knows what instance of the object it's talking about. Now, methods can take outside arguments, so we can pass it some other argument here. So we could say pass in some number. So what we could do here is when you call bark, you need to pass in some number. So we'll say woof, my name is blank, and the number is, and we'll say comma number. So note the difference here. I'm no longer saying self.number because number is already being provided for us when we actually call bark. So that means we need to actually pass in a number call. So I'm going to, again, rerun everything to make the changes to bark here. Rerun lab Frankie, rerun this, rerun that. And now my dog, if I hit tab here, it has bark, breed, name, and species. So what we're going to do is call bark. And if I just call bark like this, so let me zoom in very quickly. Let me delete the old line here. So if I just call bark like this, I'm now going to get an error. It's going to say, hey, bark's missing one required positional argument, number. So now this method is expecting some sort of added argument, number, because when this dog barks, it's going to say its name and the number you passed, because I'm passing it in here with number. Again, note here now I'm not using self.number because the user is provided that. It's not referencing some particular attribute for that instance of the class, like the breed or the name. So let's give it a number to bark for us. We'll say 10. Run that, and then it says, woof, my name is Frankie, and the number is 10. And those are the basics of using a method for a class. You say def, the name of your method. Notice now we're using lowercase, so it follows the conventions of a normal function call, except it's inside of a class. And then you pass in always the self keyword, and then you can work with other attributes by referencing them in a self.manner, or you can pass in new arguments that the user provides and reference those as well, no longer needing the self call because it's not connected to a particular instance of the class. It's just something that the user provides for you when they make the call. Okay, so we went over methods right now. I'm going to start a new class just to really drive the point home. So make a couple of new cells here, and I'm going to create a class called circle. So my circle class, let's give it a class object attribute. Now remember, a class object attribute is something that should be true when you have any instance of the class. So for example, I know that pi is going to be equal to, more or less, 3.14, no matter how big a circle is. So I will set that as a class object attribute. So regardless of the instance of a circle I make, I will always be able to reference pi up here as 3.14. So now we create our init method. This is a special method. We always pass in self. So it's very common to forget that when you're first starting to work with objects, but you always pass in self. And now whatever we need to define a circle. So an argument we may need to define a circle is a radius. And just like when we learned about functions, we can actually provide default parameters here. So we'll define a default parameter of 1. So that's a default value for the radius. And I will say self dot radius is equal to the radius that was passed in. And then I'm going to make a method here. So now we have our method. And we'll say this method is called get circumference. And what this does is it has in self, so it can reference the particular instance of the object. And it's going to, no, I'm returning it. I'm not printing it out. I'm going to return the actual circumference of the circle. So if you do a little bit of math, you know that circumference of a circle is the radius of that circle times pi times 2. So 2 pi r is the circumference of a circle. I run that, and let's create an instance of the circle. So I can say my circle is equal to circle. And then when I call my circle here and hit dot, tab, I can have get circumference, and I can actually see here I have pi, and here I have radius. And I actually spelled circumference wrong, but let's actually fix that real quick. Circumference. Now I rerun this, rerun circle, hit tab, and now I see get circumference, pi, and radius. So let's call pi, see what happens. We get back 3.14, makes sense, it's a class object attribute. It's an attribute that's going to be the same regardless of what instance of the class. Then I'm going to say my circle dot, and let's call it radius, and it's 1. So why is radius 1? Because that was the default value I provided up here. What I could have done is provided another value for radius. Let's provide maybe 30 for radius here. And then it would have just overwritten default value. So then when I call radius again, after rerunning that assignments, I have 30. So you can have a default value here, and you can always overwrite it. Okay, so now let's see what happens when we call this method. We'll call my circle, and I will get the circumference, open close parentheses, run that, and it returns back the circumference. In this case, 188.4. Now those are the basics of methods, and I want to come back up here and show you a couple more things that you may consider when working with object-oriented programming. One thing to consider is that if you have an attribute, it doesn't necessarily have to be defined from a particular parameter call. So for example, I can create an attribute for the area. So a circle can have an area attribute, and I can say self.area is equal to the radius that's passed in times the radius that's passed in times pi. So pi r squared is the area of a circle. So I can say self.pi. And now I will have an area when I define the circle. So I can say circle 30, my circle.pi, radius, and if I call my circle here and ask for the area back, I get back the area of that circle. The last thing I want to point out is because this is a class object attribute, I actually have two ways of calling it. I could say self.pi because self references a particular instance of this object, or something people sometimes like to do is actually say circle.pi if it's a class object attribute. So if it's a class object attribute, you can reference it in this manner, which is the name of the class and then the attribute, because you know this is going to be the same regardless of the instance of the class. So you may see it this way as well. And sometimes programmers prefer it this way because if you're reading someone else's code, it's very easy to see down the line, oh, this is a reference to a class object attribute. So it may be obvious here because our class is smaller, but you can imagine if we had hundreds of methods, instead of saying self.py here, it might be nice to say circle.py. That way when you're on line 101 or whatever it is, you can see here, oh, they're referencing a class object attribute at the very top of this class. So you run this and you'll get back all the same results. It'll all work exactly the same. So again, you can use self.py, or to really make it clear that it's a class object attribute, the name of the class dot the attribute name. All right, that's it for the basics of methods. Coming up next, we're going to discuss inheritance and polymorphism. We'll see you at the next lecture. Welcome back, everyone, to part 3 on our discussion of object-oriented programming. In this lecture, we're going to specifically focus on inheritance and polymorphism. And inheritance is basically a way to form new classes using classes that have already been defined. Let's jump to a Jupyter Notebook and see how this works. Okay, so let's begin by talking about inheritance. And as we just mentioned, it's a way to form new classes using classes that have already been defined. And really important benefits of inheritance are the ability to reuse code that you've already worked on and to reduce the complexity of a program. So we'll start off by creating what's called a base class. So this base class is going to be called animal. And it's going to be a very simple class. In fact, its init method isn't actually going to take in any arguments. Instead, all it's going to do is print animal created. So we have a very simple class here. So for instance, if I made an instance of animal, it would just print out animal created because this init method gets automatically executed when you actually create an animal. Let's add on 2 more methods, one called whoami. And all this is going to do is print out I am an animal. And we'll have another method here called eat. And this is going to print out I am eating. Okay, so we can see that if we have an animal here, we can do dot tab and we can ask it to eat. So open close parentheses to actually execute eating and see print out I am eating. And the other one was who am I, and it'll report back I am an animal. This is going to serve as our base class. So newly formed classes can use the animal class in order to inherit some of its methods that you may want to use again. So for example, if I want to create another instance of the dog class, or actually recreate the dog class. So I'm going to recreate the dog class, but I start thinking, hey, a lot of the features and methods of my animal class are useful to a dog. For instance, dogs, they like to eat, so maybe I want to reuse some of my prior work in my new class. The way I can do that is by inheriting the base class, this animal class. So I'm going to pass in animal here. Before we weren't passing anything, but now if I pass an animal, I'm going to inherit or derive from this base class. So this is now known as a derived class because I'm deriving some of my features from this base class of animal. So I'm going to say dog inherits animal, and then in my init call, what I'm going to do is call animal dot underscore underscore init underscore underscore self. So I'm going to actually create an instance of the animal class when I create an instance of my dog class. And I'm able to do that because I'm inheriting from the animal class. And what I'm also going to do is print out dog created. So let me run that, and I'm running that Alt-Enter so I can get a cell right below. So I have my base class of animal, and then I have my other class of dog, which is now going to inherit the methods of the animal because inside my init method, I called animal.init method self. So now let's see this in action. I'm going to say my dog is equal to dog. And I run this, and now I see that an animal is created because when I run this line of dog, this init method gets called, which in turn runs the init method off animal, which in turn prints out animal created. And then after that's created, I print out dog created. But here's where it gets interesting. All those old methods that were available for the animal, who am I and eats, are now available for my dog. So even though inside this dog class, I don't have eat or who am I defined, I'm still able to use them because I was able to derive them from my base class of animal. And that's the main idea behind inheritance. I can now reuse methods that should be common between classes by just inheriting. So I don't need to rewrite all these methods for my new class. Now you may be wondering, well, what if I want to overwrite one of the older methods? Well, that's actually no problem. All you need to do is say def in your new class, and then just make sure to use the same name as the old class method, such as who am I. And now, instead of saying I am an animal, we're going to print out I am a dog. So rerun this to make sure we've redefined it. Rerun my dog, and it still says animal created, dog created. I can still call eat, but now when I call my dog, who am I, it says I am a dog. Before, it would have said I am an animal. So let's test that theory. I'm going to delete this, who am I, rerun this. We'll create our dog again, animal created, dog created, eat. And if I say who am I, notice I didn't overwrite it this time. It'll just say I am an animal. So you're able to overwrite the previous methods of your base class in case you need to. You're also able to add on methods. So, we're going to say def bark self, and then print out woof, so we can add methods and we can overwrite. So let me copy this eat method here and paste it in. And now I'm going to say I am a dog and eating. So I run this again. I recreate the instance of my dog here, animal created, dog created. And now if I call eat, it says I am a dog and eating because I overwrote the original method. I can still call who am I because I inherited from that base class, and it says I am an animal because I no longer overwrote it here. You can add in the method again call and then rerun this. But now I also have bark. So I could say my dog, bark, and it will print out woof. The main ideas here is that all you need to do is inherit from your base class, and now you have access to all these old methods that you wanted. And if you ever want to overwrite them, you can just overwrite them as so, recall that same method name, and then do whatever you want there, and you can always add in more methods. So that's how inheritance works, and let's move on to discussing polymorphism. So we just learned that while functions can take in different arguments, methods belong to the objects they act on. Let's finish this lecture by talking about polymorphism. In Python, polymorphism refers to the way in which different object classes can share the same method name. And then those methods can be called from the same place even though a variety of different objects might be passed in. The best way to explain this is through an example. I'm going to create two new classes. I'm going to redefine my dog class, and then I'll also create a similar cat class. We'll say def init, and the dog just takes in a name, so you can name your dog. So we assign the dog's name attribute to the name that's passed in, and then the dog is going to be able to speak. And in this case, when it speaks, it's just going to return its own name, so self.name, plus we'll say says woof. So when the dog actually speaks, it reports back whatever name you assigned it, and then says woof. And I'm going to copy this, make sure I run this cell, and right below it, I'm going to create a very similar cat class. Same deal if it's init method, you provide it a name, but instead of speaking says woof, we're going to say speak says meow. So almost the same class, except the cat says meow and the dog says woof. Okay, so I'm going to zoom out so we can see a little more of our code. We've defined the dog class and the cat class. Now let's create two instances of them. We'll say Nico is a dog with the name Nico, and we'll say Felix is the variable name for a cat with the string name Felix. So I'm going to print out what happens when Nico speaks. So Nico says woof. Looks like I forgot a space here, so let's clean that up a little bit. Rerun these two cells. Nico says woof, nice. We have a little space there. And then have Felix also speak. Notice here I'm actually executing speak with open close parentheses, and Felix says meow. So here we have a dog class and a cat class. Each of them has the speak method. When called, each object's speak method returns a result that's unique to the object. That is to say, it's unique for the dog to say woof, and it's unique to the cat to say meow, as well as their names are going to be unique to that particular instance of the class. Now there's a few different ways to demonstrate polymorphism. One of them that's pretty simple is with a for loop. So I can say for pet class in, and now I'm going to say Nico and Felix. And what I'm going to do is I'm going to iterate through this list of items. And I want you to notice something here. I'm going to say print the type of pet class. And in fact, I'm just going to say pet, so that way I don't confuse you. So we'll say for every pet in this list, print what type of pet it is. So what type of class it is. And then also print what happens when you say pet.speak. So I run this, and this is an example of polymorphism. So both Nico and Felix share the same method name called speak. However, they are different types here. So notice we have main dog and then main cat. And let me remove this type call. They're both returning a string, but it then should be noted that one of them is saying wolf and one of them is saying meow. So another way to show this, besides iteration, is through a function. And this is probably the more common way to see it being used. And I can say def pet speak. So this takes in some pet. It doesn't really care if it's a dog or a cat, because what it's going to do inside of the function is just take that pet object and then call it to speak. So notice when I say Nico pet speak, it says Nico says woof. And if I were to pass in Felix to pet speak, it would say Felix says meow. So pet speak itself doesn't actually know whether you're going to pass in a dog or a cat. Remember, these are two different classes, and they are pretty similar in our case, but they could technically be wildly different. Dog could have 100 methods, cat could just have these 2 methods, but they share the same method name speak, which means I can leverage that capability by happening to either iterate through a list of these different classes and happen to call the same method name, or most likely I pass it into some function where later on it calls that method called speak. So in both cases, we're able to pass in different objects and we obtain object-specific results from the same mechanism, that same method call. Now, a more common practice is to use abstract classes and inheritance. And what an abstract class is one that never expects to be instantiated. You never actually expect to create an instance of this class. Instead, it's just designed to basically only serve as a base class. So we're going to say the animal class again. And the animal class is going to have an init method that takes in self name. This is the constructor of the class. And we're going to assign animals the attribute name based off what's passed in. And then this base class is going to have speak. However, later on in our code, we never actually expect to say something like my animal is equal to an instance of animal. In fact, this animal class is never actually expected to be instantiated. I don't expect to ever make an instance of the animal class. Instead, this is basically to be only used as a base class. So this speak method, and this is really common with polymorphism as you get into more advanced object-oriented programming, what we're going to do is raise an error. And we're going to learn about errors and exceptions in the next section of the course, but essentially what's going to do is say, hey, we have some sort of error here. So we'll say not implemented error, and we'll say subclass must implement this abstract method. So we run this, and what's going to happen is if we actually create an instance of animal, something which we're not expecting to do, so we'll say Fred is the name of this animal. If I say animal speak, I get back, hey, not implemented error. And this is actually telling me, hey, you're supposed to use a subclass to implement this abstract method. So the reason this is an abstract method is because in the base class itself, it doesn't actually do anything. It's expecting you to inherit the animal class and then overwrite the speak method. So I could delete this line because, as we just said, we never actually expect to use animal in that fashion. Instead, what we expect you to do is call dog and then pass in animal as you construct this dog class. And now you no longer need to have this sort of init method here. Instead, what you can do is say def speak self and then return self.name plus says woof. And we'll do the exact same thing for cat. So I'm going to copy and paste this. And then instead of saying dog, we'll say cat there. And instead of saying wolf, we'll say meow. Run that. I will say Fido is equal to a dog with the name Fido. And I will say Isis is an instance of cat with the name Isis. And now I can print out Fido speak. And now I can print out as well Isis speak, where Isis says meow. Okay, so some real life examples of polymorphism, since these are really basic examples of using the same method name and then also having these abstract methods, is maybe opening different file types. So you may want to have the method name called open, which makes sense. You're going to open a file. But there's lots of actually different files. There's Word files, PDF files, and Excel files. And if you were trying to make a class that could be a base class for opening files, and then you have other classes that would inherit that, maybe a class for opening CSVs, another class for opening Excels, another class for opening Word files, you'd want them to be able to share the same method name, the .open name. So that's a more realistic example, and that's an example of polymorphism, where you can have some function, maybe a general open file function, can take in any of those classes that you have and just call .open on them. And it's up to the class itself to decide what actual type of file is being opened. Okay, so that's polymorphism. Basic idea is you have these two separate classes that happen to share the same method name, allowing you to then call those same method names without needing to worry about the specific class that's being passed in. We'll finish off our entire discussion of object-oriented programming in the next lecture, where we finally go over special methods. We'll see you there. Welcome back, everyone. To finish off our series of lectures on actually working with object-oriented programming in Python, we're going to talk about special methods. Special methods allow us to use some built-in operations in Python, such as the length function or the print function, with our own user-created objects. To get an idea of how this all works, let's jump to a Jupyter Notebook. Let's start off with a simple example. I'm going to create a list, 1, 2, 3, and then let's say I wanted to check the length of my list. Well, I could just call len on my list. What if I wanted to check the length of one of my own objects? So to show you what's going to happen is if I create my own sample class, and it's a very simple class, we just say pass here. I create an instance of my sample, and then try to check the length of my sample. What's going to happen is I get a type error. Object of type sample has no length. And maybe I want to try to print out my sample. So I say print sample, and I just get back the report of where my sample object is located at my memory. Unlike my list, where if I tried to print it out, I would actually get back my list in a string form. So the question arises, how am I able to actually use built-in Python functions, such as length or print, with my own user-defined objects? And this is where those special methods come into play. So special methods, some people also call them magic methods or dunder methods because they use double underscores, work in the following manner. And there's more special methods than what we're going to show here, but for now, these are the main ones you're going to be using. I'm going to create a book class, and we'll say init, and init was the first special method we learned about, and it's special because it's basically called automatically when you create the object. So our books are going to have a title, an author, and pages. And what we're going to do here is say self.title of the book is equal to the title you pass in when you create it. The author attribute is equal to the author you pass in when you create it. And then the pages attribute is equal to the pages that you pass in when you create your instance of your book. And let's imagine I wanted to print out my book. Right now, if I say b is equal to book where the title is Python Rocks. Let's say the author is Jose, and it has 200 pages. If I try to print my book, it just says, hey, you have this book object in memory. What happens is when you call the print function, what the print function does is it asks, what is the string representation of B? So if I try to cast or transform B into a string, what happens is I just get a string version of this report when I print it. Instead, what we can do is actually use the special method related to that string call, which is underscore underscore str underscore underscore. And what this does, if there's ever any function that asks for the string representation of your book class, then it's going to return whatever this method returns, which is why it's a special method. And make sure you use return here, not print. And I'm going to return whatever I want to be printed out. So when I print out a book, it might make sense to kind of print out a lot of things. So we'll use an f-string literal format. I will say self.title by self.author and shift enter here. So what happens is when I'm going to call the print function asks the book object, hey, do you have a string representation of yourself? To which the book object then says, yes, I do, because I have this special str method, and I return this string. Where the string, using f-string literal formatting, I can actually pass in self.title, so it grabs this title, and self.author, so it grabs this author. So let's rerun these cells. And now if I say print B, I get back Python Rocks by Jose. So if I ask for the string representation, it's the same thing. Because the print function, all it does is it prints out what string representation returns back. So that's the special method for strings and printing in general. Next, we can do the same thing for length, because right now if I try to check the length of my book B, it says, hey, object of type book has no length. So as you may have guessed, the special method that goes along with this is len, and we're going to say self here, and then we can return back whatever we want to be printed out when you ask for the length of the book. And here, it probably makes the most sense to just return back the number of pages the book has. So we'll return back self pages. I rerun these things, and when I print these books out and ask for their length, I get back 200. Finally, what we could do is, let's say we wanted to delete a book. What you can do is you can call the keyword del, space, and then pass in the variable name, and that will actually delete that book from the memory on your computer. So if you ask for B again, it's going to say name error, B is not defined. So this is a way to delete variables from your computer's memory. Sometimes you may want to print out a report upon deleting the variable, or you may want other things to occur when you delete the variable. In order to basically specify extra things that may occur when you call delete, you can use underscore underscore del underscore underscore self, and then we can add certain things to happen when you actually delete an instance of the book. So I will say print a book object has been deleted. And then I will say shift run here, or shift enter. Let's define our book again, and let's print out the book. I'll do alt enter here to get some cells below. So I printed out my book. Let's check to make sure the book still exists. Print B, and then to delete the variable, I can say del B. And now when I run this, I get out the extra statement, a book object has been deleted. So when I call B again, it's now deleted, B is no longer defined, and I was able to add a print statement to maybe give the user more information when to use the special del keyword. All right, those are the main special methods that you're going to be using as you're just starting off with Python. You can check the documentation for many more dunder or special or magic methods, but really these are the main ones you're going to be using, especially str and len. So again, str, it returns back the actual string representation, so you can print out user-defined objects. Len returns back the length, so you can return back the length of user-defined objects. And that ends our discussion on object-oriented programming. Let's now test your skills with a homework assignment and a small challenge project. Welcome back, everybody. Now that we've gone over a series of lectures showing you how to work with Python for object-oriented programming, let's test your new skills by giving you a quick homework assignment. I'm going to go over the notebook that contains this homework assignment. Alright, so here I am at the GitHub repo just to show you where the notebook is available. If you go to Complete Python 3 Bootcamp under the Object-Oriented Programming folder, you can find the Object-Oriented Programming Homework notebook, and it's the notebook that's right after that main lecture notebook about object-oriented programming. And this homework assignment has two simple problems. If you recall, during the lectures, we created a circle object, so we could create instances of a circle, and that circle object had a radius. So what you're going to be doing is something similar. We're going to use geometry to create two different objects. We'll have a line object and a cylinder object, or a line class and a cylinder class. Let's go over the first one. So here we have three methods for you to fill out. One is the first special init method. The second is the distance method, and the third is this slope method. So what we expect to be able to do is, given two coordinates in the form of a tuple, so we have xy coordinates, coordinate 1 at x equals 3, y equals 2, coordinate 2 at x equals 8, y equals 10, or really whatever numbers, you'd be able to pass in those coordinates. Remember, they're tuples, and then using that, you'd be able to call the distance method to get back the distance between these 2 points, and the slope method to get the slope between these 2 points. And you can just Google around for the actual formulas for distance and slope, but in case you want to pause your screen real quick, here's the actual distance formula given 2 points. So it's just x of 2 minus x of 1 squared plus y of 2 minus y of 1 squared, and then take the square root of that, where you have y2 and x2 are 1 point, and then x1 and y1 are the other point. So that's the distance formula. And the slope formula, as you may recall, is just y2 minus y1, x2 minus x1. So these are the formulas that you're going to be using, and you're going to take in these coordinates and convert those formulas into method calls here that end up basically returning the result of that formula. And then we have problem 2, which is quite similar to that circle class, except this time it's a cylinder. So what you need to do is, again, fill out this form right here to set the attributes, and then have volume method filled out and surface area. And you can always Google search the Wikipedia page for a cylinder. They have the formulas for the volume and surface area of a cylinder there. So an example output is, given a cylinder with a height of 2 and a radius of 3 units, pass the volume method to actually get a volume back, and then execute the surface area method to get the surface area. And that's basically it for this quick homework assignment. I would say go with problem 2 first, actually, because it tends to be a little simpler than the line class, in case you want a more gradual pacing. Okay, we'll see you at the very next lecture where we go over the solutions. Best of luck, and remember that the coordinates here are being passed in as tuples. We'll see you at the solutions. Welcome back, everybody. Let's now go over the solutions for the homework assignment from the previous lecture. Alright, so here we are. We first had the line class, so let's start with that one. Remember that we're taking in these coordinates as tuples. So there's lots of different ways you could have done this. One way is to create the two coordinates as attributes. So we could say self.coordinate1 is equal to the coordinate 1 that's passed in, and then self.coordinate2 is equal to that second coordinate that's passed in. So this is one way to do it. And then later on, what you do is just tuple unpacking to grab the individual components of these tuples. So for example, in the distance formula, we know the distance formula at the end of the day should look something like this. It should be x2 minus x1 to the power of 2, and then we'll say plus y2 minus y1 to the power of 2, and then this whole thing squared. So one way to do that is just to the power of 0.5. So that's one way to take the distance formula, and in order to get x2 and x1, what we could have done is just tuple unpacking here. I could have said x1, y1 is equal to self.coordinate 1, and then x2, y2 is equal to self.coordinate 2. So you could have done it this way. The other approach you could have taken is just right off the bat, when you actually create attributes, is create an attribute for each of these. So you could say self.x1 is equal to coordinate 1, and then maybe use some indexing here. It's really up to you what approach you want to take. The main idea being that eventually you have to realize you need to somehow extract the actual components of that tuple, either through indexing or through tuple unpacking. And this is something that I wanted you to get practice with, because often you're not going to just pass in single variables into your argument calls. They may be something like a list or a tuple, so you should have classes that are able to work with that. Finally, let's have the slope equation. And we can just copy and paste these lines from up here. And then for the slope, we just return rise over run. So rise is y2 minus y1, and then we're going to divide that by x2 minus x1. We'll run that, and then let's check this out. So we'll say c1 is equal to 3, 2 coordinate, c2 is equal to 8, 10 coordinate. I'll create my line object and pass in c1 and c2 here. And now I'll check out the method calls. We'll say distance, open close parentheses, because we execute that. And that looks like it matches up. And then we say my line, check the slope. It looks like that matches up as well. If you're getting different numbers for distance and slope, given these two coordinates, double check your actual equations here. You may have mixed up x1 and x2, or y2 and y1. So keep that in mind. These should be the results you get for distance and slope, given these coordinates. So definitely check your math if you're not getting those same results. It's really easy to make a typo here or use parentheses in the wrong way. So just keep that in mind as you continue. Now we're going to move along to this cylinder class. So as I mentioned when we were going over the homework, this one's actually a little simpler than that line class. So here we have height and radius. Notice they have default height and radius. What I'm going to do is make those both attributes straight up since they're integers being passed in. So self.height attribute is equal to height, and then the instance's radius is going to be equal to the radius that is passed in. And then we're going to just return the volume equation. The volume for a cylinder, you could have Googled this. It's basically just height times pi. We could have also done a class object attribute there, but I'll just pass in 3.14. And then it's going to be the radius. So self.radius to the power of 2. And notice here how I'm using self.height and self.radius inside these method calls because I need to reference the instance of the object's own height and own radius. I can't just reference height and radius by itself. I need that self parameter. Then for surface area, this one's a little more complicated of a formula. Basically, you have the top and bottom of the cylinder, which is pi r squared. So I'm going to say that the top of the cylinder is pi r squared. So self-radius to the power of 2. There's a top and bottom, so for the whole surface area, I'm going to return 2 times top, 1 for the top, 1 for the bottom, and then plus the rest of the formula, which is 2 times pi times self.radius times self.height. And the formula is basically just grabbing that middle section of the cylinder and then flattening it out so you actually get a rectangle. Okay, so that's surface area. Let's run this and make sure that our results match up. So I'll say my cylinder or my cyl, call the cylinder right here, 2, 3. We'll say c.volume. And it looks like I have an error, name C, whoops, my cylinder, not C. 56.52, perfect. And let's check out my cylinder surface area. Run that, and we have 94.2. Okay, so this should have been pretty straightforward, especially because it's very similar to the circle class. If you're having any issues on this, or there's something that's confusing to you as far as creating these methods, please post to the Q&A forums, and we're happy to give further explanation. I'm going to give a quick overview of what we just did here. So let's start with the line class. First thing we have to realize is that these coordinates are being passed in as tuples, and you have various options of how you want to work with these here. Either you can do the unpacking in your actual attributes, so then you can have self.x1, self.x2, and so on, or once you assign these coordinates, you can do the unpacking in the methods themselves. Again, totally up to you. Then just make sure that you're applying these equations correctly for both distance and slope. For the cylinder, it's a very similar thing. We assign the attributes height and radius, and then we just return back the actual mathematical formulas for volume and surface area of a cylinder. All right, thanks everyone. Again, if you have any questions, post to the Q&A forums, and we're happy to help you out there. We'll see you at the next lecture. Welcome back, everybody. We just had your homework assignment for object-oriented programming, where we had 2 geometric classes that were basically structured, and you just had to fill in a couple of lines in the attributes and methods part of that class object. Now for your challenge, it's going to be a little more freeform, and we're going to have you create a bank account object with a couple of attributes and a couple of methods, as well as some important special methods and self-checks. So let's go to the challenge notebook and explain what we expect you to do. Alright, so here I am at the repo, and this should be the same if you've downloaded the notes, but under the Object-Oriented Programming folder, you should be able to find the OOP challenge. And in this Object-Oriented Programming challenge, we're going to want you to create a bank account that has two attributes, an owner attribute and a balance attribute. And then there's going to be two methods for that attribute: deposit to deposit money to your bank account, and withdraw to withdraw money from your bank account. And as an added requirement, withdrawals may not exceed the available balance. So for this withdraw method, you're going to have some sort of if statement to check, are you drawing too much? So here, we basically only have class account and then pass. So this is a little more freeform because it's going to be up to you to fill out the init method, the deposit method, the withdraw method, and then the owner and balance attributes. So once you instantiate the class with an owner, which is going to be a string, the name of the owner, and some current balance, so some initial balance for the account, you should be able to print out the object. Recall that there are special methods, specifically the str special method, that allows you to print out whatever you want when you call print on your object. So in this case, I have the account owner and the balance. You don't need to format your str method exactly like this, but you should be able to report back some useful information. Then you should also have the owner attribute, in this case the owner is Jose, and the balance attribute, in this case the current balance is $100. Then you can make a series of deposits and withdrawals. So the deposit 50, we deposit and actually add in $50 to the balance, so that should affect the current balance. And then we should be able to withdraw money, and we see withdrawal accepted, so we withdrew $75 from the balance. Now if you make a withdrawal that exceeds the available balance, in this case we try to withdraw $500, you should be able to see funds unavailable as the output. Okay, so that's your challenge for this object-oriented programming assignment. And I quickly want to touch upon this idea of being able to call methods that affect attributes. We haven't truly seen that yet, so I want to show you a very simple example. I'm going to create a class, and this is going to be a simple class, so I'm just calling it simple. And the init method, all we're going to do is say some value here. And we'll say self.value is equal to the value passed. And then I'm going to have a method called add to value, and this will be self, and then some amount. And what this does is it takes in the current value of self, or current self.value, and then it says self.value plus the amount. And this is something that we haven't really done before, because notice here, this method actually doesn't return anything. All it does is it takes the amount that's passed in, and then it adds it to the value. So this is kind of a hint of what you're going to need to do in your bank account class. So I'll say my object is equal to an instance of simple, and we'll say that the current value is 300. So when I call my object value attribute, I get back 300. You can kind of think of this as akin to the balance of the bank account class. And if I say my object and I call add to value, let's say add another 500 to my value, notice nothing is returned, because all that's happening when you call this method is it takes in the amount you passed in. Here it's 500. It grabs your current value, notice the self call, adds the amount to it, and then reassigns self.value to reflect this change. So now when I call in my object value, it's 800. Okay, so that's basically the little example I wanted to show you of how you would actually grab a current attribute and then affect a change on it. And it's up to you if you want to print something like, we just added curly braces to your value, and then you could say something like .format amount. So if we rerun this, I would then get back an actual printed message here, just so I know that it's actually working. Okay, best of luck on that challenge. Again, it's definitely more freeform because we want to push you to that next level where you're able to break down a concept into code. If you have any questions, feel free to post to the Q&A forums. In the next lecture, we'll go over an example solution. We'll see you there. Welcome back, everybody. In this lecture, we're going to go over an example solution for the OOP challenge. Remember, for this more open-ended project, your solution will probably vary than the one shown here, but as long as you're able to get the same results, it should be okay. Let's go to a Jupyter Notebook now. Okay, so let's begin by creating our account class. And I'm going to start off with the init method. We'll say self as always, and we know there's two attributes that are going to be defined here, the owner and the balance. And if we wanted to, we could set a default balance to be set equal to 0. That way we only need to provide the owner. That's optional. And we'll say owner is equal to the owner that's passed in. And we'll say the balance of this instance is equal to the balance that's passed in. Next, what we're going to do is set up our deposit and withdraw methods. So we'll say deposit self, and we're going to need some amount to deposit. So we'll say deposit amount, or dep underscore AMT for short. And what we do here is we grab our current balance and we'll set it equal to our current balance plus that deposited amount. And then what we can do is instead of returning anything, we can just print out added blank to the balance. And we can use f-string literals if we want here, or dot format, whatever you prefer, and then just pass in the amount. Now for the withdrawal, it's going to be a little different, because remember the withdrawal should check whether or not you have enough funds. So that means we're probably going to need an if statement here. So we'll say withdrawal amount, and we'll say if self.balance is greater than or equal to the withdrawal amount, then self.balance is going to be equal to the current self.balance, and I'm just using tab to autocomplete here, minus the withdrawal amount. And then I'm going to print out withdrawal accepted. Else, that means that the balance is less than the withdrawal amount. I'm going to print, sorry, not enough funds. Then after all of this, I want to be able to print out my account object. So I will have the special str dunder method. It'll just take in self. And here we can decide what we're going to return. It's really up to you, but in our case, I'm going to return the owner. So we'll say owner is curly braces, balance is curly braces, and if we wanted a new line to be printed, as we did in the example, we could say / new line. And then you can either use dot format or string literals. If you wanted a string literal, you just put an F there and then pass in the information. So in our case, it's self.owner, and for the balance, it's self.balance. Okay, so remember, you need to return that for the string function. You don't just print it out. And let's try to create an account here and see if we get any errors. We'll say Sam is the owner, and Sam's going to have 500 as their balance. So let's check that we can grab the owner. Sam's looking good. Let's check that we can grab the balance. 500, that's looking good. Now let's see what happens when we print out A. We get owner Sam, balance 500. Let's make a deposit. So I'm going to make a $100 deposit. Added 100 to the balance. Let's print out A again, make sure that the balance has been affected. Great, now we see 600 there. Let's make a withdrawal. A withdrawal of, let's do 600 itself to empty out the account. So that worked out. We'll print A. Our current balance is 0. Now if I try to do one more withdrawal of anything, I should get an error because I have a balance of 0. Or at least I should get a print statement. Okay, sorry, not enough funds. And if I print out A, we can confirm that I have 0. All right, that's all you had to do for this project. Let's do a quick little overview. We set up our attributes so that the instance of owner and balance were equal to whatever you passed in here. We have a simple deposit method. And as a quick note, for these actions of equal to the same thing plus, what you could do as an alternative is instead of writing equals self.balance plus, is just say plus equals. And it's the same thing over here. You could have just said minus equals. So this is kind of sleeker, but it's up to you what's more readable. So you could have done that for the deposit and withdrawal methods. Remember, the withdrawal method needed to have an if statement in order to check that we had enough money in the balance. And then for the string method, we just return back really whatever you want, as long as it conveys the information of the owner in the balance. Okay, you can check out the solutions for more information, and if you have any questions, post to the Q&A forums, and we're happy to help you out there. We'll see you at the next lecture. Welcome everyone to the section on modules and packages. In this lecture, we're going to start off by talking about PyPy with pip install. PyPy is a repository for open source third-party Python packages. And if you've worked with other programming languages, it's similar to RubyGems in the Ruby world, PHP's packages, CPM for Perl, and NPM for Node.js. So far, we've really only used libraries that come internally with Python. And these are known as the standard library or the built-in libraries for Python. Things like the math library. Now there are many other libraries available that people have open sourced and shared on PyPy, and these are also called packages. And we can use pip install at the command line to install these external packages. By installing Python from python.org, or by installing the Anaconda distribution, as shown earlier in this course, you actually have already installed pip. And pip is a simple way to download packages at your command line directly from the PyPy repository. Now there are packages already created for almost any use case you can think of. Python is a hugely popular language and it's growing very quickly. So that means if you ever want to work with Python with some other external use case, maybe you want to make web development with Python. So you would Google around and eventually discover that there's libraries such as Django or Flask for web development with Python. Or maybe you have a more specific use case like working with PDFs with Python or working with Excel documentation with Python. In that case, you can always do a quick Google search, and almost always the links that come up first are either the PyPy page for the package or the package documentation. And we'll show you a little exercise of what a good Google search looks like. So what we're going to quickly do now is show you how to download and install external packages. To do this, we'll open up our browser, but we're also going to be working at our command line. So remember, for Windows users, that means open up your command prompt, and for macOS and Linux users, that means open up your terminal. So let's have a browser open along with our command prompt. Okay, so here I am at my command line, and let's show you how to install a package that's hosted on PyPy. Something you do need to be aware of is that your firewall may block pip from accessing the internet. So if you're on a work network or you're on a work computer that you don't have full admin permissions, you may need to check that or talk to your network administrator. But let's move on, and what we're going to do here is type pip install space, and then here's where you would actually put in your package name. So there are a ton of packages out there. We're going to start with a package that you may already have installed because you've installed Anaconda, and that's the request package, which allows you to request information from websites online. So this is just a general syntax of how you would download a package. Notice here, I'm typing this directly into the command line or directly onto my terminal or command prompt. I'm not actually calling Python first. This is a command line utility. So you hit enter here, and you may get the requirement already satisfied. Most likely, if you installed Anaconda, you already have requests installed. So this is what it looks like when you already have it. What I'm going to show you now is a library that you most likely do not have yet, and that's the Colorama library. And this is just a bit of a silly library that allows you to print out colorized text at your command prompt or at your terminal. So type pip install Colorama, notice the spelling here, hit enter, and we actually already have it installed because I ran this line already. So what we're going to do now is run the actual Colorama external package that we just installed. So what I'm going to do now is type Python, and let's try checking out Colorama. So to do this, it's actually quite simple. All you need to do is say from Colorama import init, and then on the next line, call init. So basically is a bit of an initialization function that allows you to set up depending on what platform you're using. And then what we can do is say from Colorama import, and what we're going to do here is say import for, so that's capital F-O-R-E, which stands for foreground. And then I will create a print statement that says for dot, and then in all caps red, plus, and I will just say some red text, and then hit enter, and now you see I have red text. And we can do that with a variety of colors. So I can say now print for green plus switch to green, and now we've switched to green. So again, just a very simple library that allows you to incorporate color directly at your command line. This is not a library we will ever really be using again, but it's just something fun that you can play with. And you can check out the documentation simply by Google searching Colorama. What I want to show you now, let me quit out of this Python session, is show you how you would actually create a Google search and what kind of things to expect to pop up when you're looking for an external package that you may not know ahead of time. So for example, let's try to solve the problem of trying to work with Excel files in Python and figuring out a package that allows us to do that. So when you're looking for a Python package for any particular workflow, it's always best to start with just a simple Google search. And I know hopefully this seems pretty obvious, but a lot of times the best thing to do, and pretty much everybody does this, no matter how experienced a developer they are, is you just Google search Python package for, and then whatever they're looking for, whether it's Excel, for PDFs, and you should always end up seeing in the top results some sort of link to helpful information. So let's start off with the example for Excel. And as we scroll down, we'll eventually see python-excel.org. And if you click on that link, it actually reports back a bunch of packages that are available. OpenPyXL, XLRD, XUtils, a ton of stuff that you can play around with. So then what you end up doing is you either go to the documentation or you go straight to the download link. And typically when you go to the download link, it takes you to the Python Software Foundation website for PyPy, so pypi.python.org. And here's just official information about the actual package. Depending on how big the package is, if it has more users, it almost always has a separate documentation page, and the documentation will be linked somewhere in the top few lines. So you click here on package documentation, and it will take you to the official documentation for that actual package. And a lot of times they're hosted by readthedocs.io. So now here we see some nice documentation, and what we can do is figure out how to install it from this documentation, or typically what you end up realizing is it's always just pip install and then the name of the actual package. So we know that it's OpenPyXL. Let's now go back to our command line and install it. So then here, back our command line, what we're going to do is say pip install OpenPyXL, hit enter, and I've actually already run this before, but that's how you would install a package from the internet from PyPy. And then later on you could call Python, and then you should be able to import OpenPyXL with no issues. That's the basics of using pip install with Python and figuring out what external packages are a good fit for you. Hope that was useful. If you have any questions, feel free to post to the Q&A forums. Coming up next, we're going to learn how to create our own modules and packages using Python. We'll see you there. Welcome back, everyone. In this lecture, we're now finally going to discuss how to write your own modules and packages. So we understand how to install external packages that people uploaded to PyPy. Let's explore how to create our own modules and packages. And to clarify some of the semantics here, modules, it's really just a .py script. So it's a fancy way of saying, here's a .py script that I'm using in another .py script. So that act of using it in another .py script allows you to call it a module. Again, this is really just semantics, but packages are then a collection of modules. However, there's a key .py script called __init__.py that needs to be placed inside of a folder to let Python know that this collection of .py scripts should be treated as an entire package. So we're going to show all of this through some examples. Keep in mind, since we're dealing with .py scripts here, we're not going to be able to show these examples through the notebook. Instead, what we're going to need to do is use Sublime Text Editor or any other IDE that works with .py files in order to create the scripts and folders. Let's get started by opening up Sublime Text Editor. Alright, so we're going to start off by creating two files here. The first one, we'll save it to the desktop. We'll say File, New File, or we can actually save the one we currently have. Save as, and on my desktop, I'm going to save this as my module.py. So this is the module, and remember all that a module is, it's just a .py script being called in from another file. So let's create that other file. We'll say new file, and this one, we're going to save it also on the desktop in the same location as my module.py, and we'll say my program.py and save that. So inside my module, what I'm going to do is just create a very simple function. We'll say def, and then say myfunc, and all this does is it prints out, hey, I am in my module.py. Control S to save that. And then in my program, this is another .py script, and I want to use the code from my module. So here we can get the idea that if you have a really large script, you're not going to put everything in one giant .py file. Instead, it will be nice to split it up between multiple .py files, which means just split it up between different modules. And then later we'll see how we can aggregate a bunch of modules to create a package. So far, what we're going to do is in my program, say from my module import, and then we're going to import my func. And let me make sure I spell that right. Okay, my_func. And that means I can now call it here. So we'll say myfunc. I'm going to save this, and let's see if it worked by going to our command line. So here I am now at my command line. Remember, I saved these files at my desktop. So let's cd to the desktop, change directory. And now I should be able to call Python, and then call my program.py, hit enter, and I see, hey, I am my module.py. So we were able to successfully call the other function from the other module.py file into my program.py. And this is the very basic way of how you would actually format .py scripts in order to not have everything in a single script. Now at a certain point, even this is going to start to be too much, and now you're going to want to aggregate modules together to form a package, and that way you can have different folders for different packages. So let's now show you how to create a packages. So we're going to come back here to my program.py and my module.py, and we'll open up and say new file, and then we're going to save this, save as, and here at my desktop I'm going to do a few things. The first thing I'm going to do is create a new folder here. In this folder, we'll call it my main package. Hit enter. And then inside of this folder, we're going to create another new folder, and we'll call this sub package. So we're going to be creating lots of files and folders here. So right now we have at my desktop my module.py and my program.py, and I've also created my main package folder, and inside of that I have my sub package. Now, since these are just directories or folders, we need to let Python be able to understand that we want to treat these directories not just as a normal directory, but as an actual package. So to do that, inside both my main package and sub package, I'm going to have to create a file called __ init, init, __ .py. Save that, and make sure you have this init py file in your package. Now, you don't actually need to write anything in this file. It just needs to be there so that when Python goes searching through these packages, it understands that it's not just a normal directory, it's an actual package. So we're going to create one more file. We'll say new file, and we're going to save this. Under sub package, we'll create another __ init __ .py file. And again, this one's going to be blank as well. So we have both of these. Notice here how Sublime's telling us which one we're referring to, this one in main package and this one in the sub package. So we're going to close these. We're not going to be working with them anymore. We just need to have them named there. Okay, so I have my module and my program. What I'm going to do now is say file, new file, and I will say save as, and inside of my main package, and I'm going to create some main script.py, save that, and then what I'll also do is say file, new file, and let's put another .py script inside of my sub package. So we will say file, save as, and inside of this sub package, along with that other init file, we're going to create the following. We will say my subscript.py. So now I have this outside module, some main script inside of that main package folder, this subscript inside of that sub package folder, and then my main program. So what we can do is we can start playing around with this all the way from my program. So what I'm going to do is inside of my subscript, we'll say def, then say sub report and have that print out, hey, I'm a function inside my subscript. Control S to save that. We're going to do a very similar thing here in some main script, and we'll say def. We'll call this report main. And this will print out, hey, I am in some main script in main package. Save that as well. Okay, so let's take a look at the directory right now. We'll say open file just so we can explore this. So at my desktop right now, I have this mymodule.py. We won't really be playing with that anymore, but instead I have this myprogram.py. And we can think of myprogram.py as the main.py script I want to run. And I want to organize my files into packages. So right now we've explored how to actually create a single module, which is just a .py script. And you can imagine we'd be importing from various modules, so various .py scripts, but at a certain point it's going to be too much and we want to organize them into folders. So the way you would do that is you would have packages, which are just directories that have this init.py, so underscore underscore init underscore underscore .py, and that tells Python, hey, this actual directory, it has a bunch of modules in it, so you can call them using a certain syntax, which we're about to show you. So here we have some main script. You can imagine that I could have many more .py scripts or many more .modules inside of this main package, and we can keep going with sub packages as long as they have this init.py, and here I can see my subscript. So I'm going to cancel this, and what I'm going to do is inside my program.py, I've already know how to import from a module, but now let's realize how to import from a package. To import from a package, what I can say is from my main package, I can either import the actual module itself. So remember the module in my main package, it was called some main script. So we'll say some main script. And if I wanted to import from a sub package, what I would do is say from my main package dot sub package, and then I can import some module from there. So in this case, it was called my subscript. So this is now how you can organize not just into a single directory, but you can actually organize into subdirectories as well. And this is the syntax for that. You say dot, the name of that sub package, import, and then import the modules. And if you want, you can go even further and actually import only specific functions. So we'll show you how to do that in just a second, but let's actually call the functions from some main script. So from some main script right here, we want to call the function that's inside that script. So if we click back here, we realize that that one is just called report main. So coming back, we'll say some main script, report main, close parentheses. So we're actually executing the function report main, which is under some main script module, which is under my main package. Then we also want to, if we look at my subscript, that has the sub report. So let's run that as well. We'll say my subscript, call sub report, open close parentheses. So let's save that, and then let's run my program.py at the command line so we can see what happens. All right, so now here I'm back on my desktop at the command line, I will say Python, call my program.py, and I hit enter, and now I see, hey, I am some main script in main package, and then, hey, I'm a function inside my subscript. And that's it. Now you've successfully not only created a module in the first part of this lecture, but you've also created packages and sub-packages. And in general, the idea here is just how do you organize various Py scripts? As you begin to grow better and better in Python, you're going to write more and more Python code. So at the beginning, you'll create a couple of modules. They'll all be in the same folder, no big deal. Then, as it starts getting more and more unwieldy to have it all in the same folder, all you need to do is create directories that have that special underscore underscore init underscore underscore .py file. That just tells Python, hey, this is now a package, and it allows you to run what we see here, this my main package, my main.sub package. Okay, that's the basic idea of packages and modules. If you have any questions, feel free to post to the Q&A forums, and we'll be happy to help you out there. I'll see you at the next lecture. To finish off this section of the course, I want to discuss these two ideas of name and then the string main. So an often confusing part of Python is when you start looking at larger .py scripts that you haven't written yourself, you often see at the very bottom this mysterious line of code that says if underscore underscore name underscore underscore is equal to the string underscore underscore main underscore underscore colon, and then there's a block of code to be executed. So sometimes the whole idea behind that line of code is that when you're importing from a module, you would actually like to know whether a module's function is being used as an import or if you're using the original .py file of that module. So what we're going to do is explore all of this a little bit more, but make sure to check the full explanatory text file that has a written explanation of everything we're going to cover here. What we're going to do basically is just create two simple .py scripts and try to show you the idea behind that if name is equal to main block of code that is usually at the end of larger .py script files. Let's get started. Okay, let's begin by actually creating two new files. We'll create them at my desktop. I will say for this first file, save as, and I'm going to save this as 1.py. So this one is 1.py. Then I'll create a new file, and I'm going to save this one as 2.py. 2.py. Again, at my desktop, so we'll label this one 2.py. So make sure you have those saved. So let's think about what actually happens when you call a Python script at your command line. You go to your command line and you type Python space the name of your script .py. So what's actually happening when you call Python myscript.py, all of the code that's at indentation level 0, essentially something like this, is going to get run. So that means any code that's at indentation level 0 is going to get run, and that would mean that your functions, which are automatically usually going to be defined at indentation level 0, and your classes, also at indentation level 0, are all going to be defined. So unlike other languages, in Python, there's no main function that you call somewhere at the top of your script that gets run automatically. Instead, what happens is, just implicitly, all the code at this indentation level 0 gets run when you call the script file. And you probably have an intuition of that by now, since we've been working through that strategy the entire first half of the course. Now, in Python, there is actually a built-in variable called name. So just like there's built-in functions, this is a built-in variable. And it's quite obvious that it's built in because we have two sets of double underscores in the beginning and in the back of it. So that would allow you to have to really try to overwrite it by accident. So what happens is this variable name gets assigned a string depending on how you're running the actual script. And if you run the script directly, so if I went to the command line and I wrote out Python space 1.py, what Python is going to do, it's going to assign this built-in variable called name to be equal to underscore underscore main. So Python does this in the background. Well, it really does this. It assigns this string to the name variable when you run it directly. And that allows you to have an if block to check if they're equal to each other. So often what you do is something like this. You say if name is equal to main, and then you can do something because you know that this particular .py file is being run directly. And if you ever run something directly of Python, you know this case happens to be true. So what happens is often people will just, at the very bottom of their code, they'll say if name is equal to main, and then they say kind of run a bunch of functions that they defined here. So at top, they do a bunch of function definitions. So function number 1, function number 2, so on and so on. So you can imagine hundreds of lines of function definitions or classes. And then all the way at the bottom, they actually organize their code on what they actually want to execute. And they know that they want to execute it because they say, if this built-in variable called name happens to be equal to the string main, then I know I'm running this .py file directly. So we're going to explore this whole idea a little further. And to do that, we're going to do the following. In 1.py, so let's go back here. This is 1.py. I will write out the following code. I will say def, create a function, and this function is going to be very simple. It will say func in 1.py. So when you call that function, it says func in 1.py. It's just printing that out. And then what I'm also going to do here is at an indentation level of 0, so outside of this function, I will say top level in 1.py. So now I have a function definition as well as a global print statement top level in 1.py. Then at the bottom of this, I will say if, and you'll notice that Sublime Text Editor will actually autocomplete this for you. If name is equal to main, I'm going to delete this. So I have an if block of code here. So if name is equal to main, then I know I'm running this directly. So I will say 1.py is being run directly. And then I'm actually going to line up an else block with this if statement. You don't see this that often. You usually just see if and then you execute all your code. But just to make it clear how this variable is working, we'll also add in an else there. We'll say else print 1.py has been imported. So I'm going to save that, and let's take a look at what happens. I define this function, I print out this statement whenever you call 1.py, and then depending if 1.py is the main script, meaning I'm calling 1.py directly at the command line, I will print this out. Else, that means the variable name was not set to main, and I will print this out. 1.py has been imported. So now let's work with our second file, 2.py. What we'll do here is say import 1, and I will print out at the very top level. Let's print out something like top level in 2.py. And since I just imported 1, let's execute the function that's from 1. We'll say 1.func. And here we're going to have an if statement. We'll autocomplete this. If name is equal to main, I will print 2.py is being run directly. Else print 2.py has been imported. So let's save the changes in both of these and then open up our command line. Alright, so the first thing we're going to do at our command line is actually run 1.py directly. So we run this and we notice what happens. We get that print statement, top level in 1.py, and then we see from that if name is equal to main, 1.py is being run directly. So we can see here that that built-in variable underscore underscore name underscore underscore has been assigned that main string. So Python then knows, and the entire script can know, that 1.py has been called directly. But now let's check out Python 2.py. So now when I run this, notice what happens. I get back top level in 1.py, but now 1.py, its built-in variable of name has not been set to main because it's been imported. So now we get back 1.py has been imported. And then I get top level in 2.py, func in 1.py, and then 2.py is being run directly. So that built-in variable actually allows you to see whether something is being imported or run directly. So that's the idea and concept behind the variable name, and checking if it's equal to main. Typically, however, what you see is people, they don't really do it the way we've done here where they check is something being run directly or not. Instead, if we come back to Sublime Text Editor, what they do is instead of having an else statement here, since they just say if name is equal to main, this is the same thing as saying run the script, right? Because we already know that if this happens to be the case, then someone is running 1.py script directly. So what they do is they define a bunch of functions up here or define their classes. So here's another function, pass. You write some other function, function2, save, and then down here at the bottom, what you end up doing is you just call your functions. So you'll say, okay, execute function2, then execute function1, and then maybe you have a little bit of logic here. But the main idea is that this is more for code organization. You have all your functions and classes defined up here, and then your logic, where you actually execute things, are defined here at the bottom. And this is a really common structure you will see for larger .py scripts, especially when you begin to use modules and packages. Alright, that's the basics of this line, if name is equal to main. Definitely check out the explanation.txt file that goes along with this lecture, and if you have any questions, feel free to post to the Q&A forums. I'll see you at the next lecture. Welcome back. In this lecture, we're going to be discussing errors and exception handling. Errors are bound to happen in your code. Nobody's perfect, and errors are definitely going to arise, especially when someone else ends up using your code in an unexpected way. we can use error handling in an attempt to plan for possible errors that may arise in our code in the future. For example, maybe in some part of your code you try to open up a file. So later on, someone else is using your code, and the user may try to actually write to the file when it was actually only opened with the mode R for reading. Currently, if there's any sort of error inside our programs, the entire script's going to stop and we get back some sort of error statement. We can actually use error handling to let the script continue with the other code and report the error. So even if there's an error, the code will report the error and continue on. Now there's 3 keywords for this entire process of exception handling, and it's the try, except, and finally keywords. And these are all going to have a block of code associated with them. So under the try block of code, that's the block of code that's going to be attempted, and this may or may not lead to an error. So once you try the actual try block of code, if there is an error, you have the except block. And this is a block of code that will execute in case there's any error inside of that try block. Then you have a finally block of code, which is a final block of code which is always executed whether or not there's an exception or error occurring. Let's jump to the notebook and see some examples of how to use these blocks. Okay, let's start off by actually viewing an example of some error that may occur. Let's imagine that we have a very simple function, some add function, takes in n1, n2, and then what it does, it just prints out the sum of them, n1 plus n2. You may be thinking, no problems here, I'm just going to say add 10 and 20, and you get back 30. But let's imagine you have the following situation. You have some variable, number 1, and you set that equal to 10. Then you have a bunch of code, and later on, to get the second number, you ask for it as an input. And let's say number 2 is equal to the input of please provide a number. So it asks us, please provide a number, we say 20, and then what we end up doing is we say, well, let me call that add function again on number 1 and number 2. Hopefully you realize that this is already going to give you an error, because recall that when you call the input function, 20 here is actually a string. So when I run this, it says, hey, you have a type error. So notice here that there's an actual specific exception that Python's trying to tell you about, type error. And it says unsupported operation, type S, for plus, integer, and string. It's basically telling you, hey, I can't add an integer and a string together. I can add 2 integers together, or I can concatenate 2 strings together, but I can't work with both these data types. And this is an example of the type of error you may get while running your code. And unfortunately, let's say I wanted to have a print statement. So let's say something happened, and I run this print statement is never actually going to occur. What's going to happen is I get an error, and that's the end of my script. Doesn't matter if I have hundreds of lines past this block of code, I will still get this type error, and nothing else after it is going to get executed. The idea behind the try and except and finally statements is that even if an error happens, we're going to try to do that block of code, and even if there's an error, we can continue with some more code. So how will we actually do this? Well, we have the try keyword, colon, and then we have the block of code. So this is the code that you want to try. So you want to attempt this code. However, it may have an error. So here I'm going to say result is equal to 10 plus 10. Whoops. There we go. So we know this is not going to actually induce an error. And then what I'm going to do here is I'm going to have my except block of code. So my except block of code is what I want to have happen if there is an error. And this is really common when you're building out larger libraries that other people are going to use. You can have except blocks, so you can print out a more specific message to the user. So maybe you can say, hey, it looks like you aren't adding correctly. So I'm going to run this, and notice we actually don't induce an error. Instead, I can call result here with no problem as 20, which makes sense because 10 plus 10 has no problems. Let's now actually create that error. I'm going to try to add the integer 10 to the string 10 here. Now when I run this, it says, hey, it looks like you aren't adding correctly. Now notice what happened here. The rest of the block of code was still able to execute with the except statement. My whole program wasn't shut down just because I had some sort of error like before. Instead, I tried this block of code and then I said except. And in general here, I can say except if there's any type of error, do this code right here. Now let's imagine that I want a block of code to execute if there is no exception. I could do something like this. I can say else print result, and above that I can say print add went well. So right now when I run this, it just says, hey, it looks like you aren't coding correctly. So this is known as a try except else statement. And what we have here is the block of code we're going to try, and then we have two options. If there is an error in that try block, we run the except code. Else, if there is no error there, we run this else code. So let's fix this and have it not produce an error anymore. We run this. We try this block of code. Since it was successful, we don't execute this except block of code. Instead, we jump straight to else and we say add went well, and we have 20. Okay, so that's try except else, and we can now actually use the finally keyword to have a block of code always executing, regardless if there's an error. So to show this, I'm going to build off of an example where we actually try to write some files. So let's explore this concept of try, except, and finally by working on a new example. And in this example, we're going to try to open up a file. So we'll have some test file, and we're going to start by opening it in W mode. That's write mode, which allows us to either open the file and write to it, or create the file if it doesn't already exist. And then I will say f.write, and I'm going to write a test line to this file. And then I will say except, and here I can either say except colon, and that's going to accept for any errors, but there's actually many types of errors I can specifically accept for. For example, I can try to only accept for this type error. So what happens is, notice above we had this specific type error. What I could do is say, hey, only if there's a type error, print out there was a type error. Then I could try another error that's actually associated with opening and writing files. And if you go to the documentation, you can come to errors and exceptions, and this explains syntax errors and exceptions in general, but you'll notice there's a link here to built-in exceptions, which jumps you to section 5 here of the documentation, and this is actually a list of all the different types of exceptions and errors that may happen. So if you keep calling down, there's an assertion error, there's end of file error, import errors, index errors. Some of these you may have seen before, a lot of them we haven't seen. There's OS errors, recursion errors, overflows, all different kinds of errors that you can specifically try to catch. So in our case, the error that's going to occur when you're opening and writing to files that you don't have permissions to is an OS error. And we're going to print, hey, you have an OS error. You can also say IO error, depending on what version of Python you have. And then we're going to add in a finally block. And this finally block is always going to execute no matter what. So say I always run. I'm going to run this right now. And right now we just get back I always run. So what's actually happening here? Well, we open up the test file, we call write on it. So that all works, meaning I don't have this except block running, and I don't have this except block running. So then I just say, finally, I print, I always run. Now let's actually induce an error by opening it with R. So that's read-only permission. So we should get an error on this line when we try to write to the file. Now we shouldn't get a type error because that's not actually the error we're getting. Instead, we should get an OS error because that's the error that's related to trying to write to a file that you only have read permissions for. So if I run this, I get back, hey, you have an OS error. And unlike last time where we had this except else, where only one of these blocks was going to run, with the finally statement, the except block will run, and then the finally block will run. And this is how you can line up a bunch of excepts to have specific things print for specific errors. What you could do is, let's say you have type error here and you didn't want to memorize all the other types. If you just say except at the end of this, this is going to be all other exceptions. So all other exceptions. and I rerun this again, and it says all other exceptions because it didn't detect the type error or any other errors that we defined. So if you just say except colon, you'll print out that error. Okay, so keep in mind, as you're beginning in Python, you probably won't memorize all the error types, and most likely your blocks of code are just going to look like this: try, except, and finally. So just to reiterate, the try block of code is the block of code you're going to try to attempt. The except block of code is going to occur when there is an error in your try statement. And then you have the option of putting a finally block here that will always run whether or not there's an error. Or you can have an else block of code that's only going to execute when there's not an error. Okay, so let's focus on this one more time here. Right now, there is going to be no error because I will say W there. If I run this, I get back I always run. So there's no error, finally block still runs. We induce an error. We say all other exceptions because I'm just saying in generally except here. It does whatever this block of code says. Finally, it does this block of code. So this finally block, regardless if there's an error, it's always going to run. So let's finish off our discussion here by showing you how to use the try except finally blocks inside of a function that tries to get a specific type of input from a user. So what we're going to do here is the following. We'll say def ask for int. So what this function does is it's going to attempt to ask the user for an integer. So we'll say the following. Try to result is equal to integer of the input. Please provide number. And then if we get an error here, I'm going to say except, and I'm going to print out, whoops, that is not a number. And then I'll say finally print end of try except finally. So I run this, and we're going to iterate on this function in just a little bit. But I'm going to call this function right now, do shift enter. It asks me to please provide a number. Let's give it one, 20. And I just get end of try except finally. It makes sense that whoops, that is not a number didn't print because we were successfully able to cast or transform 20 into an integer. But what happens if I run this cell again, and now I provide a word? Now I know I definitely can't transform the string's word into an integer. So when I run this, it says, whoops, that is not a number, and we get an end of try except finally. So let's see how we can now use a while loop to continually be doing this try block of code, and then except if there's an error there. Okay, so let's see if we can adjust this function so that instead of just ending after you provide the wrong word, we're going to put it inside of a while loop that keeps going over and over again until you actually have a block of code with no exception. So what I'm going to do is say while true, and you should always be careful when doing while true because it basically means you need to use a break statement somewhere to break out of this while loop. I'm going to indent all of this, so highlight it all, hit tab here, and I'll say while true, get this result as the input. Then I say except, whoops, that is not a number, and then I'm going to say continue, just to make this a little more readable as far as the logic of what's happening. Now let's say there is not a error. Then I'm going to say else, so you can actually combine else with finally here. So we're going to try this block of code. If there's an error, I'm going to say, whoops, that's not a number, continue on. Else, meaning there is no exception, that means the user did provide an integer, so I will say, yes, thank you. And now I need to break out of this while loop. So I will say here, break, which remember the break statement goes up to its enclosing loop, either while loop or for loop, and then ends it. So it will end this while true loop. Then finally, we'll say end of try except finally. Okay, so we just put these 4 blocks of code inside our while true, and we're going to break once we say yes, thank you, and we'll have a finally statement that says print end of try except finally. And we can just make it very clear that print I will always run at the end. So regardless if there's an error or not, this finally block of code is always going to run. So we're going to run this, ask for an integer. Let's provide it a correct integer. We'll say 20. Hit enter. It says, yes, thank you, end of try except finally. I will always run at the end. Let's provide it a string. We'll say Q. Hit enter. And it says, whoops, that is not a number. End of try except finally. I will always run at the end. Except we have while true here, and this break hasn't actually executed yet. So we have another chance to provide it a number. We'll say Q. It says, whoops, again. And you can keep providing it over and over the wrong things. Then it's going to keep asking you for input until you finally provide something that can actually be cast as an integer. You say 90, and it says, yes, thank you, end of try except finally, I will always run at the end. So note what's happening here. We're saying while true, try this block of code. If there's an exception, do something, and then continue. Else, meaning there is no exception, you can print some sort of statement and then break. And typically, you're only going to want to break out of this while true when there is no exception. Then finally, if for some reason you wanted something to continue, so a good thing here could be like, I'm going to ask you again, new line. So that's more a realistic example of why you would say finally. So if I run this again, it'll say, please provide a number. We give it the wrong answer. It says, whoops, that is not a number. I'm going to ask you again. Please provide number. And then you can provide it the correct number, and it says, yes, thank you. Now, unfortunately, it's going to say, I'm going to ask you again. So that's why a lot of times people don't like to mix up else and finally statements, but there's the option for you in case you want it. What you could do instead is just get rid of that finally statement and run your code like this, and you'll say, please provide number, Q, whoops, that is not a number, and you can keep doing this over and over again until you actually provide the number and it says, yes, thank you. It's up to you whether you want to mix else and finally blocks, but you can if you want to. All right, that's the basics of try, except, else. Coming up next, we're going to give you an assignment to test your new skills on this. We'll see you there. Welcome back, everyone. Now that we understand how to work with errors and exceptions handling, let's get some practice with a quick homework set of 3 problems. Let's go over the notebook so you can attempt it yourself, and in the very next lecture, we'll go over the solutions. Okay, so you can find this notebook under Errors and Exception Handling. It's the second notebook, Errors and Exceptions Homework. The very next notebook is the solutions. So there's 3 problems in here. The first one is to handle the exception thrown by the code below by using try and except blocks. So notice here we're saying for I in this list of strings, I'm trying to square the actual strings. That doesn't really make sense. So try to use a try and except block to handle this somehow. That's a pretty open statement, so you can just print something like an error occurred and then maybe have something else happen. Basically, just don't have this type error pop up. Problem 2 is to handle the exception thrown by the code below by using try and except blocks as well, and then use a finally block to print all done. So right now we have a 0 division error, so we're trying to say 5 divided by 0. Go ahead and catch this exception and then have a finally block execute. Then problem 3 is kind of similar to what we discussed towards the end of the previous lecture, and it's to write a function that asks for an integer and prints the square of it. I want you to use a while loop with a try except else block to account for incorrect inputs. Okay, best of luck, and we're going to go over the solutions in the very next lecture. Welcome back, everyone. In this lecture, we're going to go now over the solutions for the errors and exceptions homework problems. Let's open up Jupyter Notebook and get started. Okay, taking a look at the first problem, it was to handle the exception thrown by the code here below. So let's copy this and put it in a new cell. If I just run this by itself, we get that type error because we're trying to square a string, which doesn't really make sense. So what we need to do is put this whole block of code inside of a try block. And this is where indentation is really going to matter, because now we need to indent everything in order for alignment. So we have this try block right here, and then we can make an except call. And it's up to you whether you want to say except and catch that specific type error, and then print out type error, or whatever you want. So if I run this, it says type error, watch out. Or if you don't want to catch this specific error, just any error, you don't actually need to say that. You can just say except, and you get the same thing. In this case, it wouldn't be a type error. We could just say something like general error, watch out. Main idea being that you need to put that piece of code inside that try block, have an except line up with it, and then say something. Let's move on to problem 2. This was to handle the exception thrown by the code below using try and except blocks. Then finally, block to print all done. I'm going to copy this, put it back here. And if I just run this, let's confirm that we get an error. Looks like we're getting a 0 division error. So let's put this all inside of a try block. We will say try and indent all of this into the try block. You could also just highlight it all and then hit tab. Then I'm going to say accept. And again, I can either say accept 0 division error or just accept by itself. We're going to print out error. And then finally, we will print out all done. Hopefully this was pretty straightforward. So we say error, all done. And then the last one, probably the most complicated of them, was to write a function that asks for an integer and prints out the square of it. Use a while loop with a try except else block to account for the incorrect inputs. So we're going to copy this. We did something very similar in the lecture. So what are we going to do here is say while true. And it's up to you if you want to say while true or while some condition. So I'm going to say while true, try to say n is equal to the integer input of enter a number. Now, if we have some sort of exception, and we're going to assume that the exception occurs when you try to transform that into an integer, we'll print out, please try again. And then let's print out a new line, and we'll say continue. Now, else, that means there's no exception. What we can do is say break. Optionally, you can have the finally in there, but remember the finally is going to occur every time. So let's run this and make sure this works. So we're going to say ask, shift enter to run that, enter a number. Let's say we enter 10, and it looks like we forgot to actually print out the squared, which is what was asking us. If we come back here, I want to say thank you, your number squared is, so let's do that. And this is going to be outside of that while statement. So once this entire while loop is done running, we should have n ready to go. So we're going to print n to the power of 2. And we can say above that, print your number squared is, there we go. Okay, so now let's try this again so we actually get the results. We'll ask this again, enter a number. We'll say 10, enter, number squared is 100. So that's working. Let's now try to do something wrong. So we'll say A, and it says please try again. We'll say WE, please try again. Let's enter 2 now, and the number squared is 4. Okay, so that's how you can use a while true. So notice that while true is dependent on this break keyword. What you could do instead is say while something like waiting, and we can set waiting to be equal to true. So this is saying like we're waiting for a correct response. You can call this variable whatever you want. So I'm waiting for a correct response. I'm going to try this. I'm going to have the exception. Else, if there's no exception, then I can set waiting equal to false. I'm no longer waiting for the correct response. So that's the same thing, except we're not using a break statement. So we can try this again, make sure that tactic also works. Let's enter the wrong thing. Please try again, enter the right thing, and it works for. Okay, so that's it for errors and exception handling. If you have any questions, feel free to post to the Q&A forums. I'll see you at the next lecture. Welcome back, everyone. Now that we understand how to handle errors and exceptions in Python with the try, except, and finally blocks of code, let's move on to discussing unit testing. As you begin to expand to larger multi-file projects, or you begin to work with a team that's bigger than just yourself, it becomes really important to have tests in place. This way, as you or your teammates make changes or update your code, you can run your test files to make sure previous code still runs as expected. There are several testing tools, and we're going to focus on 2. There's other ones mentioned in the notebook that goes along with this lecture, but we're going to focus on Pylint, and this is a library that, in general, looks at your code and reports back possible issues. Maybe you have styling issues, or maybe you have some invalid code, and it will report back issues with your code. Then we have the unit test library. This is a built-in library in Python that's going to allow you to test your own programs and then check if you're getting the desired outputs. We're going to begin by showing you how to use Pylint to check your code for possible errors in styling. And if you're wondering what I mean by styling, Python has a set of style convention rules known as PEP8, and we'll show you those in the documentation. And then afterwards, we're going to explore how to test our code with the built-in unit test library. For this lecture, we're going to be creating .py scripts in Sublime because that's a more realistic example of how you'll actually be using these programs. You can still use the associated notebook for code. It has a bunch of write file magic Jupyter commands to create the .py scripts. So if you're really intent on sticking with Jupyter, the Jupyter notebook does work for this lecture, but in the actual filming of this, we're going to use the text editor because it's a little more realistic. Okay, let's get started. Okay, the first thing we need to do is install the pylint library. So let's go ahead and do that at our command line. So if you're at your command line or your terminal, if you're on Mac OS or Linux, all you need to do is straight into your command line, don't call Python before this, is just say pip install pylint. Hit enter, so that's P-Y-L-I-N-T. Right now, I already have it ready to go because it came with my distribution of Anaconda. That may be the same case for you, but make sure you run this line just to check that you have it already. Once you have that ready to go, let's go back to our text editor. All right, so here I am at the text editor, and I'm going to create a very simple .py file. So let me say File, Save, and I'm going to save this to my desktop, and I will save this as simple1.py, which is a very simple file. You can save it wherever you want, as long as you're able to call it at the command line. If you're unfamiliar with how to actually run scripts like this, make sure you go back and visit the lecture at the beginning of the course called Running Python Code. Okay, so I will say a is equal to 1, and notice I have syntax highlighting. That means it's registered as a .py file. Then I will say b is equal to 2. Notice my lower cases here. Then I will say print a, and then I will say print, and I'm going to make a mistake here on purpose. I'm going to say print capital B. Even Sublime Text is telling me, hey, I think you mean lowercase, but we're going to ignore that for now. So it's just a very simple script, but there's definitely a mistake in it right here. So as you can imagine, with 4 lines, it's pretty easy to catch this mistake, but if you have a script of hundreds of lines, it's going to be much harder. So do Control S or Command S to save this, and once you have it saved, come to your command line. And then what we're going to do here is say pylint. So notice I'm not saying Python. I will say pylint, and then say simple1.py. Remember that you have to be at the same location as your .py script, and you can view the command line lecture to get an idea of how to move around at your command line. But let's hit enter here and see what happens. Okay, so we actually get back a bit of a report here. And what Pylint does is it issues what is essentially an automated report grading your code. So if we scroll all the way back up here, it says no config file found using default configuration, so you can set more advanced configurations. And we have final new line missing, so we have some issues, and these are styling issues. We have an invalid constant name, but most importantly, notice here, this is an actual error, so it has an E here, and these are the ones you really want to watch out for, an undefined variable B. So later on, it gives you statistics as far as whether you're using functions, method, classes. So if for some reason you want to figure out, well, how many classes do I have? How many functions do I have in this code? And are they documented? Do they have a stylized name that's inappropriate? For example, maybe you accidentally capitalized a function. So this would be giving you statistics on that. Then it gives us raw metrics, such as how much code are there, how many doc strings are there, comments, how much is empty. So if you're working with other people and you demand, hey, every other line should have a comment on it, you could use this to quickly check. Now, whether or not you need that many comments is up to you, but hopefully you can see in more of a management position how these sort of reports would be really helpful, either to give to your manager or to receive as a manager. Then we have duplication, so how many lines have been duplicated. Right now we have 0 because it's such a simple file. Then we see messages by category, so if there's errors, warnings, so here we're actually getting an error. So notice it ran the code and it got an error, and then we have some more information about messages. And these are what kind of messages actually rise up when you run that Pylint report. And here we're getting a bunch of messages. We have undefined variables, there's missing doc strings because it's just a simple file with a huge mistake in it. So global evaluation, at the very end, it's going to evaluate your code. And here we're getting a horrible evaluation, which is negative 12.5 out of 10. So perfect score is 10 out of 10. And here we're doing absolutely horribly with negative 12.5. So Pylint, it's listing some styling issues. It would like to see an extra new line at the end. Modules and function definitions should have descriptive doc strings. Single characters are also poor choice for variable names, so it's kind of complaining about that too. And most importantly, out of all of this, it found that error in the program. So let's try to clean this all up and see what kind of score we can get. And I should note here, it's pretty difficult to try to aim for a perfect 10 out of 10. So don't be stressed if you're not getting a 10 out of 10 on your own code. Sometimes to get something 10 out of 10, it has to be very machine readable instead of human readable. And you always want to balance that if someone else views your code, they're going to be able to read it easily. However, we can definitely make some improvements here. So let's see what we can. Okay, so back at the script, let's see if we can improve this whole thing. Often when you're dealing with a .py script, you're going to want to have a multi-line comment at the top just so other developers can come in and understand what's going on. So here we're just going to say a very simple script. So that should help us score some points with pylint. And then we're actually going to create a function definition. So we'll say myfunc, won't take any parameters. And again, we should give our functions a doc string. I'm going to zoom out just a little bit here so we can see the whole picture. And here we're going to say a simple function. And then let's actually create two new variable names. First is equal to 1 and second is equal to 2, because usually you don't want to use just a single letter as a variable name. And then we'll print out first. And then what we're going to do is we're going to print out second here. And at the end of this, we're going to actually execute the my function. So we'll say myfunc, open close parentheses, execute at the bottom. So notice here the indentation. I'm going to save this, and let's run this again in Pylint and see if we were able to improve our score. Again, most likely we won't get a 10 out of 10, but we should see a big jump from -12. All right, I'm back here at my desktop. First, let's just make sure that our script actually runs. We'll call simple, or Python, simple1.py. You should be able to tab autocomplete that. And we get back 1 and 2. Looks like it's running. Let's now check the score. We'll say pylint simple1.py, hit enter. And now we get back 0 out of 10. So it looks like we still have some issues, but we're no longer getting -12.5 out of 10. All right, now you may be looking at this and saying that it looks like a lot of our problems are with mixed indentation. And if you scroll up here, you'll realize that it's telling you about all these warnings. It's found indentation with tabs instead of spaces. Due to styling issues, especially with different text editors, so let's say your colleague opens this up in PyCharm and you're opening it up in Sublime, someone else is opening it up in Atom, you typically, when you're working for other people, want to use spaces instead of tabs. Now again, this is very much just a styling choice. The code will still run fine. As we just saw, they had no problem issuing that code, but Pylint is going to complain about this issue. And you can check the documentation and say, don't worry about this particular warning. Usually you do want to have it warn about mixed indentation, but you don't want to have it warn about pure tabs or pure spaces. So in order to fix this issue, you can go back to your script. Let's do that now. So here I am at my function, and you'll notice that when I was defining my function, all I did was hit enter, and then that basically auto-tabbed for me. So if I hit delete or backspace right now, it will go back 1 tab. So to fix that, what we can do is make sure everything is defined as spaces. So delete this right here, and then do 1, 2, 3, 4 spaces. And if we do that for every line, I've actually already done that for you. I've actually already done that myself on this script. We've done that for you in the Jupyter Notebook as well. But now you should be able to improve on that. So I'm going to save this. And if you ever have a doubt, are these tabs or spaces, in Sublime Text Editor, you should be able to highlight. And here, it probably won't show up on your screencast, but I can see 4 very faint dots indicating each space. And if you just have a tab, you won't see that. So you'll have to see that on your own screen. But again, it's just highlighting this, then you can see the spaces. And if you have just enter, you'll end up seeing a tab here, just one straight line. So Pylint will complain when you mix those together. So let's save this and go back to our command line. And now I'm going to rerun Pylint on my simple1.py script now that it only has white spaces. I'll hit enter. And it looks like now we're getting much better. We're getting 8.33 over our previous run. And you may got 6.67 after fixing that. I've run this a few times, trying to deal with that white space issue, and this is most likely probably about as best as we're going to get without having to put in a bunch of extra comments and code. Okay, that's really all we need to know about Pylint for our use cases. And in general, when you're just coding by yourself, you won't be using something like this that often. This is really more for when you're working with other people or you're working with really large programs and you have kind of strict methods for yourself to make sure everything is up to some sort of style convention. Again, it's not really useful for just a rating to come back to a single user because you just saw the entire bit of code. Okay, so that's Pylint. Coming up next, we're going to learn about unit test, which allows you to write your own test programs. Notice here that we're basically running a bunch of tests. It'd be nice if we could write our own. We'll see you at the next lecture. Welcome back, everyone. In this lecture, we're actually going to go over the unit test library. So unit test allows you to write your own test program, and the goal is to send a specific set of data to your program, analyze the returned results, and then see if it actually gives you the expected result. So let's actually create two scripts here. One is going to be a simple script that capitalizes text, and then the other script is going to be the actual test script for this. And you're going to need to review object-oriented programming to understand how to use unit tests because you do build out a test class. Let's get started. Okay, here I am at Sublime Text Editor. I'm going to create two scripts. We'll say new file, save as, and on my desktop, I will save the first one as cap.py. So this is the script that's actually going to capitalize given text. And then the next script will say file, new file, file, save as, and I'm going to save this. And technically you can call your test script whatever you want, but we will call this one test underscore cap.py. Save that, and those are both saved right now in the same location. So our cap.py file will be very simple. It'll just have a single function inside of it. And this function takes in some text. And then what it does, it's going to return text dot, and we're going to capitalize the text. So if you don't recall, capitalize method on a string just capitalizes the first single letter. It doesn't actually uppercase everything. So you can check that yourself quickly at the command line, but that's what the capitalize method does. We expect text to be some sort of string. So basically here, we're going to input a string, output decapitalize string. And by capitalize, we just mean capitalize that first letter. I'm going to save this. So cancel, save that, go to test underscore cap, and this is where we actually use the unit test. So when writing test functions, it's best to go from simple to complex, as each function is going to be run in order. So you usually want to test simple things and then later on test the more complicated things. The first thing you need to do is import unit test, and then you're going to need to import any of the files we want. And because these files are both saved at the desktop location, I'm going to say import cap. So that actually imports my other .py script, this cap.py. So I've imported unit test. That's a built-in function. And whoops, let's make sure I spelled that right. It has two T's, so watch out for that. It's unit test, two words in order. Import cap, that's the cap file we just created. And then we're going to create a class. And we'll call this class test cap. And we're going to inherit the test case class that comes with unit test. So we say unit test dot test case. So if this syntax is strange to you, you can review the inheritance lectures in object-oriented programming. But here we're just going to have a list of methods, and these methods are basically going to be run when we test this actual script. So we'll say def test one word self, and this is just going to be set text equal to the simple word Python, and the result is going to be, we'll say cap, and we'll call the cap text function. So what I'm doing here is I'm importing cap, and then from cap.py, I'm importing this cap text function. So I'm saying cap.cap text function, and I will pass in the text, so that's lowercase Python, and I would expect my result to be equal to the following. We say self dot, and we call assert equal. We pass in result, and then we pass in Python with a capital P. And this is the general structure of a test. And when you look at it, it's actually really quite simple. All you do is you create your class to be called at the end. You inherit from unittest.testCase, and then you have a function to be called. In this case, we call it test1, and usually you number them like test1, test2, or you maybe have names that refer to what they're actually doing. So here we could have test one word, and then the next one could be testing multiple words. So here we have text is equal to Python, and then you call whatever functions you want to test off your script. So that way, if someone comes in and they start editing cap.py, and you want to make sure that this function always returns the same thing, you now have this test that will assert that. So you get the result of something passed into that function, and then you say self.assert equal, and you're saying, I need that when this lowercase python gets passed into the cap text function, that it always returns back the capitalized P version of Python. And then we can add in another test. So we can say DEF, and we can call this test something different. You can either number them, or you can define them as far as what they're testing. So maybe we want to test multiple words. We'll say self, and then we'll add in some text here and set that equal to, let's have it be 2 words, Monty Python. And it's basically the same thing here. We say result. So copy and paste that. So I want my result to be passing in Monty Python to text, and then I will say self.assert equal. Let's copy that line as well onto the new line, except in this case, when you call capitalize on this string, what it should do is capitalize the first letter of each of these words. So I should expect to see Monty Python. And at the end of all this, we can say if, and you underscore, name is equal to main. We will call the main function here, unittest.main. So save this, and let's actually now run our test cap. All right, so what we're going to do here is actually run our test code. We'll say Python test underscore cap, and you can auto tab complete that. We'll hit enter, and right now it looks like we're actually getting a failure. So you get this failure report, which is kind of nice. It says fail, test multiple words. It says Monty Python. Notice here how the P is being lowercase, does not equal Monty Python. So now we're scratching our heads thinking, well, what's the issue? Is it my test or is it my actual file? And that actually depends on the situation, but typically you're going to say, hey, I need to adjust my main script so that I make sure my testing works. And a lot of times in larger companies, you'll have someone in the QA department, quality assurance, actually writing these tests to make sure that your scripts work as they expect them to. And if we think about this, the actual issue is, as we previously mentioned, capitalize, all it does is it capitalizes the very first letter of a string. That means that if we take a look at Monty Python, and you may have noticed it as I was writing, that this is actually not going to happen when we call capitalize. And there's actually a different method for this. If I want both these letters to be capitalized, then what I need to do is instead of calling capitalize, there's actually a method called title. And that will then capitalize every single word instead of just the first letter of the string. So now let's save those changes using title and see if we pass this test. So we'll come back to the command line. And now what I'm going to do is run the same thing as I did before, Python test underscore cap. We hit enter and it says ran 2 tests and everything okay. That means you passed all your tests. Okay, that's basically all you need to know about unit testing. So let's go back and do a very quick overview, but the actual idea is very simple. So you have your scripts, and this could be lots of scripts, it could be a single script, and you call functions or classes, whatever you want. And then inside of your testing script, what you're going to have is you're going to import unit test, import any of the scripts you've been working on, create a class for testing. You're going to inherit from unit test case, and then you're going to have methods to test for any situations you can think of. So you'll set whatever variables you need, and then at the end of the day, somehow you're going to call functions or classes, passing in something, you get a result, and then you just assert equal. So you say, hey, is the result I'm getting from my script the expected result? And that's all you have to do. So just be wary of this self.assert equal statement. Notice how it's casting self so that it's actually calling it from that test case inheritance. All right, that's it for talking about unit tests. It's actually quite straightforward, hopefully. If you have any questions, feel free to post the Q&A forums, but definitely take a look at the documentation for unit test. There's a lot more that it can do, but a lot of times, especially as you're just starting out, all you really need to do is create these simple assert equal statements in your class. Thanks, and we'll see you at the next lecture. Welcome everyone to your second milestone project. In this section of the course, since you've learned about object-oriented programming, we're going to test your new skills with another milestone project. Just like we had a milestone project after learning about functions, we now have one after learning about OOP. But first, just like the last milestone project, to warm up, we're first going to guide you through creating a simple card game, and then you're going to attempt to actually complete the second milestone project exercise. So let's talk about your warm-up project, which is just a guided code-along project. To warm up for that second milestone project, we're going to recreate the card game called War, and we're going to do it together in a code-along. Let me have a quick overview of how this game works in case you haven't heard about it. But in case you have heard about it or just need a quick refresher and rather read the rules rather than watch this, you can just check out this Wikipedia link on the actual card game. But as a quick brief overview of how the game War works and how we're going to program it, we essentially start off with a 52 card deck, and then after shuffling the deck, we split it up into two decks. So half goes to one player, half goes to the second player. And now these two players will grab one of their cards and lay it on the table. So for example, we have Jack versus a King. And the card that has the higher ranking wins. And when a player wins this matchup, they take both cards and they go into their deck. And the player that loses is the one that has no more cards remaining. Now there is a caveat here, and that's when you pull out the cards and they happen to be of the exact same value. So here player 1 and player 2 have both pulled out a Jack, and those are equal to each other. This is an instance of war, and that's where the card game gets its name from. So in a war situation, we'll go ahead and then take out an additional set of cards, and this varies depending on what variation you're playing. Some people take out 3 cards, some people take out an extra 5 cards, but essentially the point being is you're going to take out an extra set of cards and set aside along with those matching jacks, and then you pull out a new set of cards. So here, now drawing again from their decks, player 1 now pulls out a Jack, player 2 now pulls out a King, King wins again, and now player 2 has won the war, and so they get all those cards passed into their deck. And these cycles end up repeating over and over again, a one-to-one comparison of cards, and if they happen to be equal, then you get a war, which means you draw another set of cards, basically a pile of 3 for each, and then you draw again. So when you win a war, you win a lot more cards. And this continues until some player has all the cards. So in this case, player 2 has, in theory, 1. Okay, so like I mentioned, that war process can be repeated as many times as necessary in case of back-to-back ties. So you can have like a double war or a triple war. Now, to construct this game, what we're going to do is use Python's object-oriented programming. And we're also going to be exploring how classes can actually be connected to other classes, not just through something like inheritance. So we're going to start off with a card class, which is going to just hold the entities or attributes of a single card, like its suit, rank, and value. And then we'll have a deck class, which is actually constructed using instances of the card class. And then what we're going to do is also create a player class that can then hold cards or hold half a deck of cards. And then finally, this is actually usually the hardest part, is construct these classes in a way and create instances of these classes in a way where we can actually perform the game logic. And in our case, we're not actually going to have a human player. Instead, we're going to just be simulating a game of war between 2 computer players. So the actual playing will happen between 2 virtual agents. All right, let's go ahead and get started. I'll see you at the next lecture. Welcome back, everyone. In this lecture, we're going to begin by creating the card class, as well as some global variables that will be used throughout the project. Let's head to a notebook and get started. All right, here I am at the Jupyter Notebook. Before we begin actually coding anything, I just want to briefly sketch out the logic of what we're going to be doing. So we're going to create a card class, and that card class should essentially just have 3 main properties. It should be able to understand the suit of the card, whether it's hearts, diamonds, spades, clubs. It should be able to understand the rank of the card, 2, 3, 4, 5, all the way to Jack, Queen, King, and so on. And then corresponding to that rank, there should also be an easy to use integer value. So that way later on when I'm comparing one card class to another, or one instance of a card class to another instance, if it's Jack versus Queen, I can simply use the value of something like 11 versus 12, or some sort of integer, in order to quickly decide which card has the higher value. So what we're going to do here is we'll go ahead and create the card class, and then in the next series of lectures, we will create a deck class, which is essentially the 52 unique card classes that come within a deck. So we'll show you in the next lecture how to generate a deck. And then after that, we'll create a player who can then hold cards from a deck, and then we'll start the game logic. But let's start with the first step, which is creating that card class. And this one actually requires us to create a couple of global variables that will be easy to use later on, especially when we create the actual deck. But what I'm going to do first is create the card class. I'm just going to call it card. And then you can use open and close parentheses here. They aren't necessary since we won't be using inheritance at all. Then we'll say def, and we have the instantiation method. Always remember it's double underscores here, so one underscore, another one. We always use self as the self-reference keyword here. And then what I'm going to do is when someone creates a card, what they should be able to provide is the suit of that card and the rank of the card. As far as the value, we don't need the user to actually provide a value because we'll figure that out automatically based off a dictionary of values that we'll create later on. So when you create a card, you give it the suit and the rank. So we'll say self.suit is equal to suit, and then self.rank is equal to rank. And in a little bit, we'll figure out how to actually add in the value. The other method I'm going to provide here is a string method. Just for convenience, if I ever want to print out a card that's easy for a human to understand, I'll go ahead and create an underscore underscore str underscore underscore method or string method. And let's decide what do I actually want to print out if I were to print out an instance of a card class. I'll go ahead and return self rank, and then I will concatenate it with space of space, and then I will concatenate that with a string self.suit. So that basically assumes that suit and rank that I'm passing in are strings. So let's go ahead and run this, and let's create an example of what I would expect a card class to look like. So if I wanted to create the 2 of hearts as an instance of a card class, what would I need to provide? I would need to provide the suit, so that would be something like hearts. And then I would need to provide the rank, so I'll go ahead and provide this as 2. And now, if I have the 2 of hearts just like this, it's going to be an instance of the card class at some location in memory. So that's what we have here. Hey, it's an instance of the card class at this location in your memory. What happens if we print this out? Well, recall when you print something, it looks to what the string double underscore method returns, which in this case should be the rank of suit. So it says this is the 2 of hearts. Perfect. So I also have those attributes, which is the suit. And then if we say hearts here, the rank 2. Now, unfortunately for us, these are both strings. So it's going to be hard to compare one rank to another because I can't really compare the string 2 versus the string 3 directly. I'm going to need somehow to translate this 2 into the actual integer 2. And for that, I'm going to use a dictionary of values. So I'm going to copy and paste this from the actual lecture notebook, but just to give you an idea of what we're trying to do here, is I'm going to create a dictionary where the values will have something like 2 as the key, and then the integer value 2 as the actual corresponding value. So what I'll do here is instead of typing this out all manually, go ahead and open up this actual code along notebook and then copy and paste the dictionary that we have there for you. And it should look like this. Basically, 2 goes to 2, 3 goes to 3, 4 goes to 4, and so on. And then 10 goes to 10, Jack 11, 12. And in our game, we'll treat ace as the high. So you run that, and now, if I take a look at values, and I pass in the 2 of hearts rank, which recall is just this string 2, I should get back the corresponding value integer 2. So now when I run that, I get back 2. Now what's really cool about this is because we're actually defining this at a global level, it's not within a class or not within a function, what I should be able to do is use values within the card class itself. And typically, when you're defining things like a large global variable like this, you'll put it at the top of your script. So just for readability, I'm going to cut and paste this up here at the top. And then what we're going to do here is the actual value will then be an attribute. We'll say self.value is equal to values dictionary, and then we can pass in rank here. So why rank and not why self.rank? Well, it's because inside the instantiation method, we're actually already passing rank. So we expect the person to pass in a 2 or a 3. Also notice that we're expecting this person to pass it in exactly as shown here. We'll get an error, for example, if I said a lowercase t, because values only has this uppercase t. So keep that in mind, that when we're actually constructing many cards, we'll have to make sure that the key value corresponds exactly as shown here. So make sure you run the values dictionary. We will again redefine this card class, and then let's go ahead and now create, let's say, the 3 of clubs. So that's a card class. No, I don't need to actually provide value. It still only uses suit and rank. So we'll say this is the 3, and then we'll say, whoops, actually suit goes first. So we'll say clubs, and it's 3. Run that, and now if I say 3 of clubs, I should be able to see the suit is clubs. Now let's check out the rank is 3, and unlike before, we should now have value. So you run that, and now you get this integer value. And after you've run everything in a new cell, you should be able to hit tab here and see rank, suit, and value as the attributes. And that's essentially what we need for our card class. We have the suit, the rank, and importantly, we have values. So now, if I were to redefine 2 of hearts, let's go ahead and rename this. So run these cells again, print 2 of hearts, suit, rank, and now if I see over here, let me delete this cell, and now I should be able to actually perform a comparison like we would during the game. So I can take a 2 of hearts card's value and compare it, whether it's less than, greater than, or equal to the 3 of clubs value. So run that, and it looks like 2 of hearts is true, less than 3 of clubs.value. Keep in mind, I can't compare directly the card classes to each other because these are card classes. They're not actually integers. I would need to do it with the actual integer value here in order to get something that makes sense. And I can do things like check for equality, false, and I can already begin to see how the card game would work because I should do an equality check to make sure that we're actually not at an instance of war and drawing more cards. Okay, so that's basically it for our card class. Again, we have the provided suit, rank, and then we have this values lookup, which corresponds to this global variable. And you'll see that quite often in object-oriented programming, where a card class can reference either something like a global variable at the top or even an imported library. So for example, later on we'll see that I will import random, and then inside of this card class, because I imported random, I could do something like random shuffle, which we will actually use within the deck class to shuffle a deck. Now the last thing I want to do here is create 2 more objects that will be global variables, and that is a list of all the suits as well as a list of all the ranks. In fact, we can just make them tuples. So what I will do is I will copy and paste these from our solutions notebook or code along notebook. So here we have suits, hearts, diamonds, spades, clubs. It's going to be a tuple or list. I'll save it as a tuple just to kind of iterate that I don't really want to change this. And then we'll have ranks here. So I'm going to copy and paste this from the notebook. You can do the same, or you can manually type this out if you really want to. But here I'll have the ranks. And the reason I have the ranks and the suits is just to make sure everything is formatted correctly when we begin actually creating an entire deck. So what I could do is for every suit, create a ranked card class here. And I want to make sure that these ranks match up the strings exactly as the values here. So just go ahead and run that, and we'll be using these global variables in the next lecture when we create our deck class. And as I mentioned, something to keep in mind is because we're using this values global variable up here, and it relies on rank, that when I pass in this specific rank, it has to match up exactly as the key here. So if I were to do something like have a lowercase 3, for instance, you'll get an error because it says, hey, I can't find 3 as a key within this values dictionary, which makes sense because it's a capital 3. Same thing if you were to provide something like 3 here, run this, you'll get another key error. Now, if you wanted to, you could just have the user or creation method or instantiation method also provide value instead of just suit and rank, but this method basically looks it up for you and makes sure that every instance of the card class is performed or created correctly. All right, so that's it for the card class. Simplest class we'll have in this project. It's just a suit, rank, and a corresponding value. Suit and rank, that really helps us if we want to print out the cards throughout the game, kind of show what each player has. And really, the workhorse here is going to be this value lookup. That's what's going to allow us to play the game logic. Okay, now that we have a single card class ready to go, we have to create a deck of cards for the players to split, shuffle, and play around with. So in the next lecture, we'll see how we can actually create instances of the card class within another class. I'll see you there.